Hey, BB, why do you think the Earth is a cartoon? BB, come walk me through how you know Earth's globe, 'cause I don't understand. I get that somebody told you, right, and then you're repeating it, which is a weird game of telephone.
Hello. I wanna just tell you something. The earth is not flat. The
How do you,
guys, the
what do you,
earth is not flat.
Well, it's not a
how do you,
globe either. There's
Hey
mountains,
bro,
so
hey bro, the
it's not a
earth is
sphere.
not flat.
Because
It's
the
a
sphere
circle.
doesn't have mountains. None of the spheres that I have mountains on them or valleys. Well, that was quick.
They've all been quick.
Irony, right? We say flat, and they go, "Oh, 100%," right? But they say sphere, but it's only just parts of it. Eh, minus the mountains, obviously.
Been pretty quiet in here, actually.
Well, I mean, it's still early in the States.
Yeah, normally we get a few around 5 o'clock my time. All the Aussies come in, but no one came in today.
Well, I figured now this should be European and partly Asian trolls. Their afternoon, our evening.
Yeah, right.
I mean, so far we're 2 for 2 for Asia. Which makes the sky clock and the ground clock work perfect. I'm so glad I downloaded that app.
Which one's that?
The flat Earth zodiac clock.
Oh, yeah.
Oh, buddy, I bought that a while ago, and I don't even think they have it on for sale anymore. It's funny because none of the conversations I have in public with people go like how it does on Discord. I'll show them the clock and they go, "What? What is that?" It's like, this is how Earth looks. No way. Then we'll get into it about water, and the next thing you know, what globe? Paradox. To be fair, I thought they were all subsidiaries of NASA, all the other agencies.
Yeah, could be, man. Could be. Who knows?
Well, if you go to like the Chinese Space Agency's website, or even NASA's, you look at affiliates, connections, right? Site map it, go digging. You'll find that they're all connected in a money trail, and they're all affiliates.
DJ. Yoder. Hello. Yoder.
Yo, what's up? Who saw that Aurora activity last night? Looks like most places in the world saw much more dramatic Aurora activity than where I live, but we still had some. We had some purple fog, looked like purple fog in the sky. I think another flare happened too. Like the sun erupted another flare in the past maybe 12 hours, if I'm not mistaken. So we might see some sustained auroral activity going on the rest of the day today and into tomorrow. Pretty cool. They're talking major earthquakes in California, an earthquake in Illinois, intense snowstorms across the southern latitudes of the United States. So people come in here and say, hey, if the earth is flat, what about the weather? Well, the sun seems to be a big cause of the weather. Sun does all kinds of crazy stuff. It'd be kind of funny if right at the dawn of this artificial intelligence breakthrough, worldwide domination of AI, that the angry sun decided to say F you and blurt out coronal mass ejecta and completely barbecued all of our electrical systems, irreparable for the next 2 generations. That would be funny to me.
I don't think I would mind. I'm pretty good at taking care of myself and growing my food and stuff like that. So it would be a wake up call for a lot of people.
Overnight, man, there would be all kinds of crazy stuff to happen. I mean, people are worried about roaming gangs of Mad Max and the Thunderdome kind of gangs taking over. But overnight, man, there would be people that'd be popping up like water delivery services and fresh egg delivery services, even protective services. We still have all of our books. We'd be able to rebuild and I think become fairly functional in a pretty short amount of time.
Yeah, I agree.
People worry about that kind of thing happening during the winter. Yeah, that would suck. But if it's in the colder climates, at least those of us that are in the northern latitudes, it's actually a blessing because it means like food wouldn't spoil as quickly. The cold climate could actually help you survive. You just have to know how to use it. And I think microelectronics might be okay. So gasoline run generators, you'd still have some of this for a while until you run out of gas, I guess. Solar power might actually be okay. If the circuitry itself is not too big, it might survive. It's a very balmy 15 degrees Fahrenheit here on the upper east coast of the United States. Everything's frozen. There's actually very little wind. Makes it tolerable. What I kind of find ridiculous. Hey, good morning. What I find ridiculous is given everybody's mainstream understanding now of solar storms and the risk of coronal mass ejecta and Carrington events, it's amazing to me that here in 2026, we still don't have hardened electrical grids. And people do the cost benefit analysis, and we've read these reports. It's not expensive at all to harden these things. You basically need to build a wire mesh cage around your transfer stations and maybe do an extra layer of wrapping around your transmission lines. Been all kinds of Pentagon reports and reports from other government agencies discussing this and the need to do it for decades, and nobody's lifted a finger to make it a priority yet. I find that fascinating. It's fascinating to me because it feeds into the other narrative of, well, why bother if the elites really have this belief that the world is going to suffer some major sun-driven cataclysm event? Then why do it? May as well take that money instead and go party, hand it out as social welfare checks, and keep stimulating that economy.
Yoda.
Yo, what's up?
Yeah, we had some crazy auroras in Poland, but we went out. I went out at 1 a.m. and apparently that was about 2 hours too late. And I saw a lot of the footage was crazy, man. Like nothing I've ever seen before. It was absolutely insane what was going on in the sky.
Yeah.
But we didn't see anything. I only went out for about 5 minutes because it was negative 17 degrees last night. Freaking crazy.
It's nuts.
Yeah. But the direction that the aurora's in, we've got like a giant highway over in that direction, which kind of lights up the sky. So, but we still would have seen it if we had gone out 2 hours earlier, because they were even seeing it from the cities that has the most light pollution. Yes, a paradox.
I missed the majority of it too. Go ahead. Sorry. I was out too early and too late myself. Sorry.
Yeah. Oh, you missed them as well?
Yeah, I missed the height of it. I stayed up late and wasn't late enough, and then I woke up early and wasn't early enough. Our friend Endless, who lives in southern Tasmania, said it was intense. Crazy.
Mm-hmm. So this guy Paradox, he's been coming in asking a lot of questions the last few days. He's kind of hung up on pictures from space today. He comes in with new questions each day, but he's posting these pictures from, of Jupiter that have been post-processed beyond freaking original recognition, to try to make it look like the pictures or the CGI images that NASA gives us. I'm trying to tell him, look, this isn't what you see through a telescope. This is hundreds or if not thousands of cherry-picked images stacked upon each other, and then a huge post-processing process basically comes afterward to try to get it to look like what they imagine it should look like.
Right. You know, when those of us who are older remember when NASA did this without computers, and they were quite open and bold about it. They would put very liberally underneath the images artist rendition, and it was just understood that NASA was a gigantic art house. They hired lots of artists, painters, and you were looking at paintings, airbrush paintings of nebula, of planets, and all this other stuff. And then there was the transition to digital art with computers, and it wasn't quite as good as the real artwork that people were doing with paintings. So they would call things like, you know, digital composites, combination of digital and painting, and eventually, like, they went complete digital as the technology got better, and then they started leaving off the image captioning. They didn't apply it as liberally as they did, but I mean, growing up, it was like understood that pretty much everything that NASA puts out is going to be artwork. And it's because their sensors, that the things that they claim that they have pointed up at the sky, whether from space or not, is not producing these images that you see. It's producing spreadsheets of data.
Exactly.
You know that they are kind of doing the same whenever they're trying to describe the condition of some certain planet that is pretty far away from us. You know, like they're measuring the color hues, or you know, like the color density of the atmosphere of that certain planet, so they can know the elements of the are
لا
the
فضحتونا عند الاجانب يا رجل.
So yeah, we had a guy come in through these channels before. He actually pops in every now and then. His name is Itaer, Itaer,
كلهم
a master's degree in astrophysics, and his job is to be a planet hunter. He was telling us about the process and even shared some of the images that they were working with. And he showed us one image of a star, and the image was, no kidding, 9 squares, 9 pixels. And he said from that, we can determine when a planet crosses in front of this star and deduce what that planet's composition is. I'm like, really? Your image resolution is 9 pixels for the star, and you're going to be able to tell me that a planet has a certain atmospheric composition to it of like hydrogen or helium, whatever the hell? Not buying it. Not buying it. At the end of the day, it comes down to the cosmic distance ladder, and not just for ascertaining the distances and sizes of these stellar bodies, but also for ascertaining their composition. That's also based off of a whole ladder of logical leaps. And if you can knock out the first rung, which we do with measurements of flat Earth, then the whole rest of it comes down, exposing the whole thing as one gigantic pile of scientific fraud.
Yeah, exactly. That's exactly what it is. Even a lot of the imagery people are seeing, they genuinely think that it's a photograph, like a regular snapshot from space that's been sent back down to us from, say, the Hubble
Yeah.
telescope or something like that. They think that it's got a camera on it and they're taking photographs and sending them here. It's not quite what's happening, guys.
I feel like there was sometimes they were about it, like they were transferring data they get from the telescope, which is not imagery, and they're transferring that, you know, using the data to some image, and they told they are doing this. It's not some secret, I think.
Connection issues. Mic check. Mic check. Hello. This is crazy. Like, what if the sun is
Can
messing with
hear, bro.
people's connections? Oh, you
No, we
just
got-
came in. Like, it was lagged. Holy shit. I think it's funny too. We heard like last week that a bunch of satellites might be deorbiting. And then a few days later, the solar storm happens, which nobody could have predicted. And solar storms, and they're this intense, they say they can cause satellites to tumble.
Sorry,
into
but I don't want to interrupt. How can I go out? I just.
What do you mean you don't mean to interrupt?
I want to go out. How?
What do you mean go out? Out of what? It doesn't even make sense.
Out of this session.
Click
What?
the red phone at the bottom of your screen to disconnect the call.
Okay, thank you.
Does your husband have you chained up in the house? What's going on?
That's funny.
Man, Sharia law is a real bitch.
Yeah.
If you want to go out, you should probably find out how you got in. If you clicked on 24/7 Flat Earth, maybe you should click off. Just saying.
I think what happens a lot of the time is people are being annoying in a different VC, and then they send them here. So they just pop up here, not meaning to have joined it, just because someone
True.
actually moved them here. I think that happens quite often, which
Yeah,
is annoying.
yeah,
I might actually
it is
have to
annoying.
get that have a chat with Vivek about that. Stop
I
that.
have to say, DJ, I think they learned that trick from me because I was doing that when moderation tools weren't working for me. For some reason, for a long time, even though I was a mod, my mod powers weren't working, so I just boot people to other rooms. I stopped doing that like weeks ago.
Oh, I would do
But
it
I've
every
noticed-
day. Except on a I would do it every day, except on a computer. I can only move people to let me check. Oh wow, the option's back to move people anywhere. Hold on.
Yeah.
Oh no,
Yeah, it was
so I
like
can
that.
only move other
Mhm.
people to events or FE stage, that's it.
Mm.
But on a phone I can send people to anywhere. Send the annoying people to the vegan chat or something.
Yeah.
Perfect.
So we are considering the Flat Earth Discord to be an exile.
Joke's on them.
Yeah.
Yeah.
All right. I got to go into the office, so I'll be on listening mode.
Okay. Yeah, I won't be on much today. I'll be in listening mode. And hello to whoever just said hello.
That's
Charlie?
me, Charlie. Yes, sir.
Ah, good to see you, brother. Hope you're good today. And welcome anyone else that's just joined. We got Vitali. Welcome, Vitali.
What's it named Flat Earth Discord?
Oh, because we have a server called Flat Earth Discord, 24/7 Flat Earth Discord. That's the server that we came from, and we were invited to have a channel based off our server in this server. Because the owner of this, yeah. So we have.
What is the server about? What is the server about? Like, do you actually believe in the flat Earth, or It's just the name.
No. This is where we actually discussed the topic genuinely of the globe Earth or the flat Earth.
Okay.
We analyze empirical evidence.
Oh, so what are the
Yeah.
evidence so far? Because I don't like. So I believe in what science has proven us so far. So what would you do to, like disprove?
Right. Yeah. So we all were in the same boat as you. We all thought that, there was some scientists that had proved that the Earth is a globe. And
Yes.
some people started making extremely long distance observations and doing extremely long distance laser tests and being able to see things that should be far, far, far beyond the curvature of the Earth, completely hidden by the curvature of the Earth. And then more and more of this footage started coming out. Okay, and people started saying, hey, how can this be explained if the Earth is a globe? And it turns out there is no explanation for it. So that kind of got it started back in sort of 2015, 2016.
Right.
I mean, it repopularized the topic.
Mhm.
So essentially, Nikon, a camera company, they brought out a range of cameras called the Coolpix P900. And it's basically like carrying a telescope around in your pocket. And you can zoom huge distances. It's got 83x optical zoom. So people would go to the shoreline at the ocean and they were able to zoom in on things that were, say, 20 miles away, 30 miles away. And then after calculating how much curvature would be over that distance, the things that we could see should be hidden behind hundreds and hundreds of feet of curvature. Right? So that's a small explanation of some of the things we talk about. And a lot of people have a misconception about what flat earthers actually claim. Like, we don't claim to know the shape of the Earth. Flat's not a shape. Okay, we're not claiming to know the size of the Earth. We're not claiming an object. We're not claiming that Earth's a flat planet or anything like that. Okay, flat is the description of a surface. And in this case, we're talking about the surface of water, which covers most of the Earth that we know about. So when we test the surface of the water, there's no curvature.
I mean, can I ask something in these terms?
Sure.
I mean, when you start talking about there is a claiming or some like footages that is showing the Earth having no curvature. I mean, like there's a lot of videos leaked saying otherwise.
Yeah, and we analyze them honestly and go over them and see what they have to offer. Once you look into it, you're going to find that there actually isn't any videos that are what's the word? So repeatable by people here on the Earth, able to be validated. I mean, if you're talking about seeing curvature from something like NASA moon landings or something like that. Okay, that's faith
No, I'm not
based.
talking about that.
What are you
I mean,
talking about?
like there was literally footages of about the same case when you're looking to some certain ship, like in the water or the ocean, and you're zooming into it, you would find like the half of the chip, like into the water. You're only seeing the half of the top of the chip only.
Right, but that only happens very occasionally. I mean, and if you have only certain conditions present. For example, if you have ocean swells, which are waves out in the ocean, okay, super common. But if something is physically blocking the ship, like the ocean swells, then the bottom, even the bottom half of the ship could be missing. And then sometimes we have atmospheric effects that can cause that to happen as well. It's somewhat of an optical illusion due to the way that the atmosphere is behaving, due to the temperatures and pressure gradients on that particular day. So these have very logical explanations, even mainstream explanations. Most of the time, when a ship goes out, it's just going to get smaller and smaller and smaller until it gets too small to be able to resolve anymore. And then you can't see it anymore. And it looks like it's gone beyond the horizon because you can still see the horizon, but you can't see the ship. But then you can zoom in and you can see the ship again. I can show you some footage if you want to see this being done.
Yeah, I've been actually exposed to these type of things before. Like I'm not following any like a strict point of view in these terms, but I'm just searching. So
Yeah,
as I
yeah, yeah.
told you, both sides having like proofs, so it's kind of frustrating to pick
Well,
some
they
certain
don't
point of view that
actually.
just.
Yeah, they actually don't. Like, if you wanted to try to find something specific that you think's a proof from the globe side, I'd be happy to go over it. Because the boat going over the horizon argument. I mean, we can show you exactly why that video would look like that, and it would have nothing to do with the Earth being a globe. Okay, we can replicate that on a small surface, on a flat surface, right, on a small scale. Show you the exact same thing happening, proving to you that it's not because of the Earth curvature. Okay, you can find some cherry-picked image where you can only see half a boat. Okay, then we're gonna start
Yeah,
asking questions about it. Okay, what was the ocean swells on that day? And people will say, "Oh, I don't know." They just found this one image. Like, say, "Okay, what's the height of the observer?" "Oh, I don't know." "What's the distance to the ship?" They don't know that. What's going on with the
yeah,
refraction? Have you counted out things that could easily explain this on a flat surface? And they haven't.
yeah.
So it's a pretty weak argument. The ship's over the horizon, but I can see why people would think it's a logical argument, and I can see why people maybe back in the olden days before they had good quality technology and a good knowledge of optics and light, why they would have thought that, okay, I can see a ship and it looks like the bottom of the ship's missing, therefore the Earth might be a globe. I can see that logic, but it's not very logical once you actually analyze that argument. And now we have amazing technology. We can zoom back in on that ship and see the whole ship again. Not if it's disappearing bottom up, but if it's disappearing how they normally do by getting smaller and smaller and smaller.
Yeah, I guess you're saying. So what about the thing that one of those technologies are the personal telescopes? So you're literally able to see like the other planets around you in the same galaxy are having like a curvature shape, which is like a globe or circular or whatever you guys call it in English. But
Yeah.
so it's actually a thing that is related only to Earth, which is being flat or being like a not in a sphere shape, or is it just like as any other planet, and every planet having like different conditions.
Yeah, so Earth is not, we're not saying the Earth is a planet. We're not saying the Earth's a flat planet. I can understand
Yeah.
why you come up with that argument, because people get taught that the Earth is an object in outer space. Okay, that you've got this big giant vacuum of space called outer space, and then you've got all of these big round planets and suns, and that we're on one of those. Okay, and then you hear about flat Earth and you think, okay, they must be claiming a flat planet in outer space. No, that's not what we're claiming here. We would say that we all see what we see in the sky. We see round looking lights in the sky. Call them what you want, stars, planets, that's fine. Okay? But the Earth doesn't share any characteristics of those things. There's no reason to think that because something else is a certain shape or has a certain appearance, that the Earth also must be like that thing that you can see in the sky. Right? That's a celestial body in the sky. The Earth is absolutely not. Okay? If it was, it would have similar characteristics of the things that you're looking at in the sky. For example, if we see the moon and it looks round. Okay, the Earth doesn't have anything in common with the moon or any other planet or star or anything like that. Okay, the Earth presents itself as a flat and stationary plane, kind of like the floor or the system of the foundation of the system that we live in. Right, not as a spinning planet through the vacuum of space. That's a story. That's a concept. It's a belief system that people have. It's not reality. When that's what we're testing, really. I mean, we're testing for the characteristics that would have to be present in nature if the Earth was that spinning ball, and it's not, because the curvature's not there.
Yeah, like there's like other thing that is been crossing my mind lately, like in terms of having like there's elite people knowing the truth about it and just not letting the other people know about it. I've been thinking, why we're having like huge powers going against each other. Let's say this Russia in the east and U.S. in the west. Aren't these guys are having like like a benefits from exposing each other? So where they're not exposing, like the I don't know, like how to call that, like the claimings or the hypothesis that the other side is doing.
Yeah, no, Putin just recently had all of NASA's footages analyzed through advanced AI technology, and it concluded that the imagery from the moon landings was fake, was not genuine. And then we also had the head of the Russian space agency, forget what his name was. Okay, but he said that NASA absolutely faked the moon landings. We've had recently a Russian cosmonaut interviewed, and he said if anyone tells you that they've been to space, if any man has been to space, they're lying to you. So yeah, there's they're not going to broadcast this on the mainstream news. This is something that's not going to be allowed to be broadcast. So these are things that you need to look into on the side. But also at the end of the day, I mean, they share a space station together. If they're such enemies, why do they say that they have their own sections on the space station? And then recently when Sunita Williams and the other guy said that they were stranded on the space station, who went to the rescue? The Russians said, "Oh, we're going to be the ones that rescue them from the space station." So it seems like it's all a big charade. It's a big show. I mean, I think the world's a bit of a stage, to be honest, as a whole. That's just my speculation.
I mean, like the same thing is going for Russian government. I mean, like they're supposed to have been in the moon before the U.S. So when they're denying the whole thing, they're denying their like trip to the moon or whatever.
Yeah, well, I mean, their footage looks even shittier than America's footage. So, I mean, I see governments more like mafia, to be honest. They're like the enforcers of the rules and the regulations on the specific part of the earth that they govern. Okay, and mafia doesn't really tell on mafia. Mafia is not going to ring up the FBI and say, "Hey, this other mafia gang is selling drugs in this neighborhood." They don't do that. So I'm not sure. They could be working together, but look, at the end of the day, we like to rely on actual empirical evidence, if you know what I mean. So actually going out and testing physically for the curvature of the earth, rather than why would these people lie? How could these people not say that the other person's lying, blah, blah, blah. Okay, that's all irrelevant if we can go and measure the actual earth. It's kind of like if someone tells me they're 6 foot tall and their friend also tells me they're 6 foot tall. They show me some diagrams, some pretty pictures of them standing next to something that says, "Look, this guy's 6 foot tall." And then I go and measure you. Okay, and you're 5 foot tall. It doesn't matter about all of the stories and the pictures and blah, 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 and the conspiracy behind it, right? I've directly measured you. You're not 6 foot tall. So it's the same kind of thing. It's like if you have 20 miles of water along the surface, you have to have 266 foot of curvature because of gravity, because of the way gravity works. Everything gets pulled towards the center of the globe. So you have to have that 266 foot of curvature over 20 miles. That means that if I'm standing on one side of a 20-mile body of water, I shouldn't be able to zoom in across the surface of the water and see my buddy standing on the other side of the body of water 20 miles away. He should be hidden by hundreds of feet of curvature. But I can zoom in and see my buddy. I can see the shoreline. I can see his feet standing on the ground. Okay, that's not possible on a globe, and that's the kind of evidence that we're going with, empirical evidence.
Interesting, actually. So
yeah, it is interesting. The more you look into it, it starts to really make a lot of sense. Okay, we have really clear, high definition observations over huge distances, consistently showing that the curvature that would have to be there, it's just not there. Probably thousands at this point, thousands and thousands of different types of observations, ranging from laser tests using high-powered laser transits, radio wave
Yeah.
propagation, using infrared cameras to see huge distances, long distance observations using high-end zoom optics, all sorts of different tests have been done. And then when we go looking for empirical evidence from the globe side, people just want to talk about pictures from NASA, or like why would they lie, or what about eclipses, or what about stars, the way the stars move, or it's always taking the conversation away from anything that any of us can validate empirically and just talking about things that we see up in the sky.
So it's kind of a way to try to deal with the thing that you have in your pocket rather than just making some hypothetical nonsense about something that you're not having access to.
Yeah, exactly. It's about but it's about not believing what we get told essentially and checking what we're being told. It's okay, these people are telling me this is a fact. Okay, we're going to go and question them and say, okay, how do you know it's a fact? Where's your empirical evidence that backs up your mathematics? Okay, so they tell us that the radius value of the Earth is 3,959 miles, or 6,371 kilometers. Okay, that's the radius value. Now, we'll say, okay, how was that established? Who measured that? And then show us what they did and show us how they did it. We want to see. And then they're like, oh, well, actually, they, and then they'll go, oh, well, they don't really know. So then they'll either say they don't know if they're honest, or they'll go on Google. They'll be like, and they'll start Googling it, trying to Google their information on the spot. And then Google will come up with something like, oh, it was an ancient Greek called Eratosthenes back in 240 BC who measured a shadow angle on a stick and blah, blah, blah. And then we can start digging into that. And we find out that that's, it's not a measurement. It's, you can't even prove that this guy even did it or even existed in the first place. He didn't write anything down that survived. And even if he did do what he did, he makes a whole bunch of assumptions and then he just makes calculations based off the assumptions. So it's not empirical evidence, it's assumption-based calculation. And it kind of stems on from there. It's like, okay, so we can throw that one out. Who else did it? Who was the first person that did it, or anyone who did it throughout all of history? And what you're going to find is the more you look into it, the more the globe is just a theoretical mathematical concept rather than being something that actually exists in reality.
Yes. I mean, it's kind of interesting, like the photo that Sitter Phyllis sent. I mean, like, does that show an enough, like distance to show the curvature, like based on the rules that NASA has given us, or the measurement
Yeah.
of Earth?
Yes.
I mean,
So yeah, let's
it's
go
like
over
a
the math. Let's go
small
over the
chunk,
math really. Exactly, it's a small chunk, and this is what people don't realize. We can just use their own mathematics and just check. Okay, so we know that that windmill farm that he's zooming in on, that's a certain distance away from the shoreline. It's called Rampion Windmill Farm. Okay, and the closest tower that you can see on the left, the windmill, okay, that's 8 miles away. And then the one on the right, that's 11.2 miles away. So over that distance, there has to be well over 100 foot of curvature. That means that the horizon should be at a certain distance depending on the height of the observer. So I'll put the math into the side chat real quickly. It's pretty easy to follow. I'll explain it. Okay, 1 second. So basically, look, just to make it really easy, if we talk about one of the windmills, the one on the right, that's the furthest one away. The bottom 52 feet should be hidden behind the horizon. You shouldn't be able to see it. 52 feet, that's like a 5-story building. If the Earth were a globe.
That's a
It's a,
huge.
it's a huge amount. Okay, so this is first thing I'm going to show you is this. This is a photograph of the windmill towers. Just a close-up photograph, just so you can see what it looks like. Okay, these things are giant, and
Yeah, I got you.
So when it's low tide, we can see the black paint at the bottom that's stripped off. Okay, and then this is from the zoom footage. This is from 8 to 11 miles away, depending on which tower you're looking at.
Yeah.
Okay, we can see
I know.
the whole
Aren't there
thing.
like? Yeah. I mean, like, aren't there a chance that every windmill is having like a different height they're standing on? There's some, like something in the bottom of the sea they are standing on, which is higher than the average, like bottom of the sea or the ocean.
Oh, it doesn't matter what the. Okay, so water just conforms to whatever shape the container is.
No,
So
yeah. I mean, like, it's not actually about the water. It's about the wind turbines. So whenever you're having like a metal rod, which is a simple thing, is standing in a high point in the bottom of the sea, it's different from the same metal rod standing in the absolute bottom of the sea without standing in a rock or whatever. You know what I mean?
yeah, but we can still see the bottom touching the water. We're not talking about whatever's happening under the surface. It doesn't really matter. Okay, the windmills are all the same height above the surface of the water, but we shouldn't be able to see the bottom touching the water. If you know what I mean? Like, yeah, have a look at this diagram, because it
Yeah,
doesn't
I mean,
matter.
it's
It doesn't matter
literally,
how.
it's
It doesn't
literally,
matter
yeah, I got you.
if one's deeper or one's shallower underneath the water,
I mean, I just
because
noticed it is actually, like referring to the blackest boat is actually having the same height. So the black, I think it's kind of a sea green plants or whatever, or it's like a marking.
what's that?
I mean, like the black, like you see the yellow part of the wind turbines.
Yeah. So it's low tide, okay, and it's usually originally they were completely yellow, okay, but the salt water has stripped off the paint. Okay, so
Yeah, I
yeah,
got you. I mean, like,
have a look at this picture.
yeah,
Right,
okay.
look at this one. This shows you. This is what it looks like at high tide. Okay, you can't see the black bit. Okay, and then when
Yeah,
the water goes down, you can see the black bit, just because
yeah,
the salt
I got you.
strips the paint off. Okay, and that's how we can know that we can see the bottom of it. We can see the base of it touching the water. You shouldn't be able to see that. You shouldn't be able to see any more water past the horizon. The horizon is the maximum distance you can see the water. Have a look at the diagram above it. Okay, that little yellow dot,
Yeah,
that's the maximum distance that you should be able to. That's where the horizon would have to be on a globe.
which is considered to be what distance in units?
2.29 miles, which is
Good.
3.4 kilometers. Right, that's why we have the windmill farms there, because they're like distance markers. Right, so here's the math. This is a screenshot from an Earth curvature calculator. Okay, these are. You could just go to Google. You can type in Earth curvature calculator. They're all the same formulas. Okay, so you put in the distance to the object. That's 11.2 miles. Okay, that's the windmill tower. It's 11.2 miles. Then we put in the eye height level, 3.5 foot height. Okay, so he just sets his camera up on a tripod, 3.5 foot above the surface of the water. Right, that means the distance to the horizon should be 2.29 miles away. Okay, that's the maximum distance that you can see the water. That's the line. So the definition of horizon is the line in which the sky and the ground appear to meet. Okay, you can't see water beyond the horizon, because on a globe, anything that goes beyond the horizon should be hidden behind the curvature of the Earth, depending how high it is. So the water obviously has to be lower. So the water, you shouldn't be able to see any more water. And then anything behind that should just be popping up from behind the horizon. So you should be able to see the windmill towers behind the horizon, but the bottom portion should be hidden, right? The bottom 5 stories, or 52 feet, 16 meters should be hidden. But we can see the whole thing. And we have we have a lot of these observations. We have much longer ones as well. Right? Ones where we can see a distant shoreline 21 miles away. There's 293 foot of missing curvature in that observation. That's a skyscraper of missing curvature. So this is the main argument. If there's no curvature, then you cannot have a globe. It's impossible. It also debunks gravity, because gravity gravity dictates that water has to be curving at a certain rate.
Yeah, I got you. Does this change anything when you're knowing that they are not telling you that it's a complete sphere? It's actually something like a egg shape. Like you're having like a uneven dividing for the mass of the Earth. So you may be having like a lot of long distance flat spaces, and you're having like a short one. So it's not uneven. It's uneven. Sorry.
Well, no, because that's why we're using the surface of water. Okay, so the surface of the water is level. So on a globe, level means an equal distance from the center of the globe. Okay, that's what sea level means. Okay, and then when you hear about something being a certain elevation, they're talking about it being a certain elevation above sea level. So Mount Everest is like 29,000 feet or whatever it is, 26,000 feet above sea level. Okay, so they're referencing the medium tide, right? The tide comes in, the tide goes out. Okay, when it's at the middle, that's what mean sea level would be. They average that out over a bunch of years. So water is level, whether it be on a globe or on a flat Earth. Okay, that would have slightly different meanings, whether it's globe or flat. So level would just mean flat, according to us. Flat water, horizontal water. On a globe, it means it's all the same distance from the center of the globe.
Yeah, I got you. That's pretty logical.
Yeah, so anywhere on the Earth, if you have 20 miles of water, it has to be curving by approximately 266 feet for the Earth to be a globe and for gravity to be real and all that kind of thing, according to the mainstream. Like, you can't have a 20-mile body of water that is flat. You might be able to have 20 miles of land that's been leveled out and flattened out.
Yeah, that's because it's a solid mass, not a liquid mass.
Exactly, yeah. That's the difference. That's why it's best to do these observations over water, or over, sometimes we do them over frozen lakes as well.
Yes, that's cool.
Yeah.
There's actually a type of content that is worth of searching for, because it's really interesting, and knowing exactly is not having any benefits for you in the long or the short term, but it's kind of like cool to think about there's a hidden truth or hidden from you.
Yeah, and it opens up a lot more questions. Once you start looking more into it, you'll start questioning all sorts of different things.
I mean, like the most extreme part you could ever reach is like there's a lot of people who's higher than you in class trying to hide things from you, which is, we know they are doing this in a way, like in a way, if they are hiding, like the truth about Earth for just doing this, there's a lot of different reasons rather than just hiding the Earth, So they are doing it, and people knew that, like the elite or like the people who was in a high class are doing these things all the time, rather than they having the technology to describe a thing like Earth shape or whatever, or maybe like in the Unchained Days, they were doing the same thing.
Yeah. I think they think of us like, like sheep.
Maybe, yeah.
They want to keep, control, power, and knowledge is power as well. So what they consider divine knowledge. But I think most people, when it comes to just people in general, scientists, university professors, teachers, people that work in the government or the military, for example. I think they genuinely believe that the Earth's a globe for the most part. They're not deceiving
Yeah.
anyone. They're just memorizing and regurgitating textbook information. That's how they get into these positions, especially professors and teachers, right? They're the people that are the best at parroting the information from the textbooks to the next generation. And their professors
Yeah.
also weren't lying to them either, right? It's just kind of like hand me down information, mistaken as
Yeah.
fact.
And just because they are not testers, they're basically passive learners and just they're transferring the ideas without chicken.
Yeah, that's a nice way to say it, kind of like
Yeah.
parrots. They don't really know, they haven't tested what they're saying. I mean, they're just kind of repeating information or repeating things that
Yeah.
they learnt. It's memorization and regurgitation. That's what the education system has essentially become, right? You get rewarded not for really questioning things, but for memorizing things. And if you can have a good
Yeah.
memory and you can remember all of the answers, and then you put them down correctly on your test, then people will say you're smart. Oh, you're little Johnny's smart. He got all of the questions right. All he did was memorize them really well, and he was able to remember the answers, and he put them down on the test. And he probably didn't question a lot of what he was repeating there. He just was regurgitating.
Yeah. It's kind of like the branch of education you're told and is making you like the perfect example for the perfect employee rather than just having like a branch is teaching you like the real things about the natural events or
Yeah,
the thing that is happening around you naturally or nature overall. So I'm kind of I'm working as a teacher, like, but I'm having this, like kind of uh I don't know, like enlightened mindset of this thing that I know exactly that you're like training people to just pass the exam, nothing else.
yeah, exactly.
Yeah.
And that's why when it comes to the people that they choose for like high military positions and things like that, they don't necessarily know um, all of the classified information. They're going to pick people
Yeah.
that are really good at following orders and being loyal, keeping their mouth shut, and doing what they get told to do. And that's how you're going to get a job as a high position in the government or in the military or their other branches, if you know what I mean.
Yeah, I got you. Like, I can
Not that you're
confirm
like,
that
I'm not
because
saying you're like that. I'm not saying you're like that, and that's why you got picked as I mean, you chose to be a teacher because you that's your career path. That's cool. That's an awesome job actually. And I'm not saying that teachers are bad or anything like that. But there's a curriculum, and you're supposed to follow the curriculum and teach the kids what the curriculum tells you to teach them.
yeah, exactly. I know what you're trying to say. I got you. So, but like the thing is about the high rule military rules that these guys are getting, like hired, and so I can confirm that because we're having the same here. Like the lowest grades that you're getting, like it's around like 50% of the grades, or maybe like 60% of the grades. It's enough to get you to the military schools or the military universities. Like even we're having like something like called like defense ministry. So to join this ministry, the only requirements are being graduated from the faculty of defense, which is like the faculty for or some branch for the ministry for you guys having in the U.S. Something like that. So whenever you having like the one of the most major rules in the country, having like of the lowest grades, it's a pretty like fucked up.
But yeah, absolutely. The Master Dave was asking about tides. How does flat Earth account for tides? Now, people get taught a very simplified version of how the tides work on a globe. People think that when the moon moves overhead, the gravity from the moon's pulling the water up a bit, and that's what's creating the high tide. Okay, you can look up the diagrams and things like that, but once you actually dig into it a little bit, it makes absolutely no sense at all. And even NOAA.gov, right? They even say that the position of the moon has absolutely no relationship with the tides, right? And then we have two high tides every day, right? Obviously, the moon isn't passing two times in a day. Okay, and then we can have high tide on one side of the globe and another side of the globe and everywhere else simultaneously. So we also have places that have crazy tidal nodes. Some places in the ocean, like around the Caribbean, and all sorts of other random little places that have zero tides at all. Like there's no high tide, no low tide. It doesn't change. And then there's other places that have 50-foot fluctuations in tides. So once you have a look at the tidal node charts and things like that, it's extremely complex. There isn't a good explanation, in my opinion, for it. And I think there's a lot of things that people don't know properly. The globe side admits openly that they have no idea when it comes to what the magnetic field's going to be doing. And all sorts of things could happen, and they cannot accurately predict it. So there's a lot of things that people claim that they know a lot about, especially when it comes to tides or things in space or whatever we want to call space, right? The lights in the sky. It's a lot of guesswork. A lot of it relies on theoretical models and things like that rather than empiricism. But what we can confirm is whatever's going on in the sky, whatever's going on with the tides, it happens above a surface that we can validate isn't curving. Anyone can double check this as well. It's pretty easy and inexpensive to do, right? To find the byproducts of the curvature that would have to be there. Okay, things being obstructed behind the curvature. Doesn't happen.
Perfect explanation, DJ.
What's up, Plain Truth? How's it going?
Good, good. How are you?
Good.
Great.
I tell
Never seen
myself
it.
I'm just gonna log in and listen. I got a ton of
That's what
work
I
to do.
told myself, yeah, but then something comes up and you have to talk a little bit. But it's good.
Yeah.
It's been a good morning. We've had some good discussions already. You never hear anybody shout out to the kids, "Kids, get out of the pool, the moon is coming over us." It's funny that the Globers actually think they know everything. We know how tides work. No, you don't. You have no idea at all.
Yeah, even the teachers that teach them that at school, if you were to question them about the things that I just mentioned, they would be absolutely lost. Quite often they say like, "Oh, I don't know. This is just what I'm told to teach you guys. I'm not
Yeah,
a scientist.
I
Go
wish I
ask a
could go.
scientist."
I wish I could go back to school again and just have the knowledge I have now and be able to ask all the questions I
Oh
wanted to.
yeah, you'd be pissing off your teachers big time.
It would be glorious. BMW, welcome to the chat.
What does BMW stand for?
Actually, sure. Isn't it Benz, Mercedes? No, no, it isn't.
I have no idea. I never even thought about it until just then.
Some kind of a German acronym for the car, I think.
Yeah, probably. Well, he's gone. CO. Welcome.
You guys already get the BMW Bavarian Motor Works. Go ahead.
Wow. Learned something new today. Thank you, Dave.
Bavaria.
And they build BMW. They build BMWs not on a globe. Go ahead. I got to say real quick, as usual, DJ, another very good, concise explanation of what we're doing here, basically. There just ain't no curvature. It's not a ball. It's not our fault. Sorry.
Yep. Yep. It's painful for them to hear, I know. They don't like us talking about the curvature or the earth. They want to talk about the sky. But it's always going to come back to that curvature. Has to be there if you want to have a globe fantasy.
So you got anybody new on here right now? Doesn't look like it. Or is until.
No, it's just the usual suspects.
We got Silent Euphoria and Ron. And we have Matador. We were speaking to Matador already. And Asymmetris, welcome. All right, so Yoda has just posted in the side chat. We have the National Ocean Service, NOAA. Okay, so their article says, are tides higher when the moon is directly overhead? And the answer is, high tides do not coincide with the location of the moon.
Image saved. Thanks for posting that, Yoder.
You know, that whole tide thing, you guys just don't understand selective gravity, because the moon, it like ignores lakes and stuff, but it pulls on the oceans. Come on, man. You don't know the story.
Yeah.
Yeah.
You just have to accept that selective gravity stuff, and you're on the globe, no problem. There you go. It makes light do weird things to make everything look like a ball and all that stuff. So you're all good.
You have to accept a lot of stories if you want to be a glober. Or a flat earth denier, as I call them. Because we're the default. It's a great conversation starter at parties, by the way. Are you a flat earth denier?
Yeah, that's a good opening line. So you think bodies of water actually curve and stay in a curve? Tell me about that.
Good one. Well, maybe we have some listeners over on YouTube who'd like to come over and talk to us. I can read your chat for a little while if you want to interact. Or if you want to come talk to us in Discord, we can promise we will trigger your cognitive dissonance. That's always fun. But let's see what YouTube has to say. I get my other phone.
Hello, hello.
Hello, how are you?
Did they leave?
Yeah, we're scary.
Just wanted to say hello, I guess. Welcome, KC. Good to see you, man.
Welcome, KC. Hello, mate. You all right?
Yeah, good, man. Good. Yeah, we're just chilling out in here waiting for some globe evidence, which we already know you don't have. So, hope you're good.
I don't think you're going to find it either, but I'll wait around.
We do have some comments over on YouTube. Freemason Trash says, on today's milk carton yet again, missing any globe proof. Call if ever found. That's funny. Thank you, Freemason Trash. Sticks and stones may break your bones and falsely tell dum-dums it's globe somehow. From Freemason Trash, listener on YouTube right now. Thank you for your comment. And we have Benny Light saying the VC panel is waiting for evidence to reject. That is correct. We're waiting for some people to come in here so we can pick their so-called evidence apart. But usually they don't bring evidence, they bring claims without evidence. And if you claim something without evidence, we can dismiss that without evidence. Yoder is posting something interesting here. I think I'm going to read that for the listeners over on YouTube. All right, testing, switch to voice activity. All right, here we go. In the chat, there is a couple of establishment of ports, some facts posted by Yoder. Types of very long period waves that move between the oceans in response to forces exerted by the moon and sun. Yeah, these are the globe claims, right? The interval between high water and the moon overhead varies by 0 to 12 hours, Yoder says. So they have observation. They look around nature for an explanation, and when they find something, they say, aha, that explains it. But so LH2O says, shout out to Flatsmacker's playlists. Very well curated YouTube channel with a lot of mirrored videos from deleted channels. All right, yeah, we'll give that a shout out here. And Benny Light says, you're free to deny all the evidence you want. Thank you, Benny. We're going to try to dissect any evidence that someone is willing to give us. Hasn't happened yet, but we'll certainly have a look at it. If someone posts a video or something like that to us, we always watch it. I can tell you the opposite doesn't happen quite as often. I post a video that's 20 minutes long, and they answer after 5 seconds. That video is debunked, blah blah blah, and they haven't even opened it. Freemason Trash on YouTube says, go show us your evidence, Benny. Coward. Have a little bit of a back and forth in the YouTube channel right now. Good. That's how it should be. That's how it should be. We're waiting for Globers to come in and give us some evidence over here on Discord. And I bet we're going to have a few good ones today as the day passes. Charlie Handsome says, evidence, my 4th grade teacher. Yeah, that's a guy actually came in yesterday and used that as his evidence. So that was funny. So let's see. Freemason Trash on YouTube says, go show us your evidence, Benny. And Benny says, I don't bid to give it to you. I don't know what that means, Benny. Bead. B-E-E-D.
So the horizon presents itself as horizontal. If somebody makes a claim that there's curvature there, the burden of proof is on the one making the claim. The natural observation is a horizontal horizon. Therefore, the burden of proof is on anybody claiming that there's curvature.
Yeah, 100%. It's the default. So, I mean, if you claim anything else than what you observe, you will have to show some evidence for that. Benny Light on YouTube says, it's your responsibility to find it. Whatever it is he was referring to. But so, Al H2O says, funny, when I seek, it measures flat. Yeah, it is funny. I mean, they show us pictures from space, right? These round balls with water and land and all kinds of stuff on them and clouds and everything. And as soon as we try to confirm that shape down here by measuring over water, we quickly find out it's absolutely 100% flat. So it cannot be a ball. So you're right, Pots OLH2O.
They should be thanking us, right? We didn't have any burden of proof, right? We have objective reality. But because we're such nice guys, we actually went out and did their job for them and tested for the curvature. And they're not happy with the results because the curvature that they blindly believed was there isn't there.
Yeah, they should be thanking us. We are doing their job for them.
Real quick, to use the tired poker analogy, it's like every time they got the winning hand, but you ask them to put it on the table and all they got is stories about their hand that they can't show you. You know what I mean?
Exactly.
Right.
Yeah, I sometimes like to refer to it as the on my unicorn fallacy, which is not really a fallacy, but I guess it should be. You know, everything relies on the unicorn they're saying that they have, but they don't ever show any evidence of the unicorn itself. It's like, on my unicorn, when I'm on my unicorn, this happens. It rains diamonds on Uranus and blah blah blah, everything on my unicorn. Eclipses, blah blah blah. Okay, show us the unicorn, which would be the curvature. No, it doesn't exist.
Yeah, it's the good old affirming the consequent fallacy, isn't it?
Yep. Well, yeah, I mean, it's just blind faith in a story that they get told, essentially. Unless anyone here in the chat has measurements, some kind of measurements, observations, whatever, of a globe Earth. Specifically, a large body of water curving over distance. That would be, that would kind of be what's required if you want to have a globe.
Yeah, they always ask us, if we send you out on a rocket in space, would you then believe it's a ball? They never want to do the measurement that's easy to do. They want to do some impossible shit.
Yeah, quite often they'll just be in a mocking, arrogant tone. They'll be like, "What? So you guys are too scared to go up to space?" Or something like
Correct.
that. Why
Just
don't
go
you
to
just build
space,
a
bro. I
just build a
promise, man.
rocket
Just go to
ship?
space.
Yeah,
Yeah.
just build a rocket ship and go up and check, unless you're scared.
It would make no difference to me whatsoever because phenomenon such as Snell's window exists. So even if I went to a high altitude and saw some phenomenon like that, that would not be convincing to me. Not in the slightest.
What if you went far enough away and it was just blue marble?
I would just say optics because Snell's window exists. You'd have to show me measurements for curvature because otherwise I will not care.
You could digitally enhance that Snell's window picture there and turn that into a blue marble. AG.
Yeah. That's what I'm saying. So
If you squint, it looks like one.
Yeah, that's what I'm saying. So high altitude footage is absolutely meaningless. I want measurements of curvature.
Yeah, that's the gold standard, isn't it? That's what we want. Consistent, and not just one. We're gonna need consistency, repeatable. Like we've got thousands and thousands of tests. I'm convinced that the Globers also have gone out and made thousands and thousands of observations, but they're not releasing the results because they don't match up with their globe.
It's kind of hard when you have 1,000 different versions of a fisheye lens. All of them have different distortions to it. None of them line up. In one, Africa's small, in another one, it's huge. Same thing for America. Florida might take up the whole entirety of one side of the sphere, and then in the next one over, it's this little tiny spot. Zero consistency.
Yep.
Oh, who's our geodesic expert in here? We have a claim by Benny Light on YouTube who says measurements of Earth are made by geodetic surveyors and others who are interested enough to make measurements in their free time. Your rejection of those measurements are irrelevant.
Yeah, they don't do that. They,
Exactly.
yeah, they later on use mathematics to convert their measurements, their plane measurements, into a spherical coordinate system. Look it up. Go look it up right now. That's exactly what they do.
The WS-84, right?
Yeah, I think they use a different one in some places as well.
So they measure it flat and then they apply their little formula to kind of put it on a globe, right?
Yeah, exactly.
You guys know that Bendy guy in the chat's a long-term anti-globe troll. I mean, anti-flat Earth troll.
Benny
Anyway.
Light. He is a lightweight for sure. Benny Light, you heard the explanation here from DJ, so you can stop using that argument. I know what they do, he says. Well, if you do, you weren't forthcoming with that they apply the formula after the measurements have been done. But we appreciate your comment, Benny. Good to have you guys interacting over on YouTube a little bit today, since we have no Globers in the chat right now here.
Well, real quick, we've been joined by Tron. Hello, Tron. That was a weird movie from the 80s.
It is the 80s, yes. That's true.
Do you think you live on a ball, Tron? It's okay if you do.
Honestly, I do. I was just curious, you know.
Okay, talk to DJ and his guys then.
I don't intend to take part too much in discussion. Just
yeah, you're right, man. Well, welcome.
Okay, we're not going to force you to talk. I was just asking a question. Go ahead, guys.
Yeah, no problem. Yeah.
All right, I'm gonna just read a little bit out about plane surveying, just really quickly. Okay, so when surveyors go onto the field, they do plane surveying, full stop. They are not measuring angles from the center of the Earth. They are not bending tapes around a ball. They are not observing curvature directly. A typical workflow looks like this. A total station or a theodolite is set up on a control point. Distances are measured with EDM using straight line pass through the atmosphere. Angles are measured between visible targets or prisms. All measurements assume straight lines and flat geometry over the working area. Every raw observation is Euclidean. Horizontal distances are treated as straight. Vertical angles are referenced to local level, defined by gravity at that point, not to a planet center at that stage. There is no spherical math anywhere. The survey closes its loops, balances its traverses, and checks for internal consistency in the plane geometry. Only after all of the plane measurements are complete does geodesy step in, and this happens for one reason only. Right, large agencies need many local surveys to fit into one reference frameworks, so maps line up, borders match, and databases agree. To do this, they apply a mathematical surface and a reference frame called a datum. This process is essentially local plane coordinates are computed first. Those coordinates are then transformed into latitude and longitude using a chosen reference surface. Map projections are applied afterwards to display everything on flat maps again. This is not a measurement of curvature. It's a coordinate conversion. The same plane data can be converted into multiple datums with different results, which should immediately tell you this is not a physical observation but a modeling choice. If the Earth's shape were directly being measured, there would be not dozens of incompatible datums, all needing the same transformation parameters.
Good information right there for you, Benny Light, over on YouTube. It's funny how we always have to educate the Globers about their own model, so-called model. Yoder asks Benny a question in the chat. He has said, which came first, Ben D. Light? Deflection of the vertical measurements or spherical excess measurements? See if he answers. It's a trick question, though. It highlights the circular logic in geodesy. Oh, look, okay, let's see. Oh, Benny is answering DJ with a sarcastic comment. Oh, look, the genius DJ has found that all geodetic surveyors are doing their jobs wrong. And that's all he had to say about that.
Doing their jobs wrong?
You
No,
read from the manual, didn't you?
Yeah, I'm reading straight from online sources, right? This is the mainstream. Okay, and I got a little bit more to read here as well. So engineering and cadastral survey typically surveys typically work from tens of meters up to a few kilometers. Control networks use sightlines of 5 to 20 kilometers when terrain and refraction allow. Classic triangulation sometimes pushed 30 to 60 kilometers using towers or heliotropes, still relying on line of sight and atmospheric conditions. Beyond that, the atmosphere completely dominates. Refraction, temperature gradients, and pressure layering overwhelm any geometric assumptions. This is precisely why surveyors rely on statistical adjustment and standard refraction coefficients instead of claiming they are directly measuring the shape. No surveyor stands on one end of a 100-kilometer line and measures curvature. This is not operationally possible at ground level, even if the Earth was a globe.
All right, we got another comment from Benny about that. He says, you're too chicken to confront geodesic surveyors outside of the safety of Discord. Dude, we've had geodesic surveyors on here, and we don't mute them or ban them or anything. We talk to them, and they are you know, they're confirming what DJ just said. Isn't that right, DJ?
Yeah, absolutely. You know who the pussy is? The guy that's not able to actually come in here and talk in the VC where we're
Yeah,
having this conversation.
the YouTube chat skanker. Benny
Yeah, a
the
little
Benny
YouTube
Light.
chat skank. Too gutless to come in and actually debate.
That's right. Come over here, Benny. We'll talk
Bring
to
it
you.
on. Bring it
face
on,
to
Benny.
face.
We're waiting for you, bro.
I'm actually happy that he's interacting over on YouTube because he's getting flat smacked there by Freemason Trash. I haven't read his comments, and also we're commenting a little bit because we have a little low supply of Globers over on Discord right now. Potso H2O. Man, you have such a bad, not bad, but a difficult username to pronounce. I'm just going to call you Pots. He says, Bendy be like, catch me outside. How about that? Yeah. Well, I mean, Benny, if you wanna join Discord, we can have a normal conversation with you.
Okay, so Yodo has also posted a video in the side chat, which is describing what I read just now. So it's from the YouTube channel Geodesy Digital Academy. 3-3 reduction, physical reductions. So if anyone wants to learn more about that and validate what I was just reading out from the mainstream, they can go ahead and look into it.
Yeah, and you guys on YouTube, you can see the link in the chat, and you can maybe copy it somehow. I don't think you can actually copy it, but I can't paste links there either. But you can search it on YouTube. It's going to come up. 3-3 reduction, physical reductions. Freemason Trash says you're still too scared,
تمشيوش
Benny.
تحولوا ولاد القحاب.
What was that?
تحولش.
Someone hot miking.
Yep. I think it's from people moving people that are hot miking into our channel from other channels, to be honest.
Benny Light is strawmanning us. He says, if you've proven geodetic surveyors are doing it wrong, why are all industries of the world still using their data?
Okay, there's a whole video about it in the side chat there. So here's a diagram from the video. Okay, reductions. All processes to convert the measurements at the surface of the Earth to counterparts on the ellipsoid. Physical reductions, geometric reductions, and there's a diagram showing exactly what they do. So they're taking local plane measurements and they're later on mathematically converting them into their model.
Yeah, that's how they do it, Benny.
Yeah, these are only tiny differences as well. Over these distances, it's not a huge difference that they have to make.
Do you know that they have a button on the total stations that's called auto level, which does this automatically, kind of puts it on the ball, their measurements?
Yep.
If you don't turn that off, you're going to get ball measurements.
Yeah, absolutely. And the whole accounting for refraction by just completely guessing and having something called standard refraction, which literally begs the question of a globe, right? That's absolutely retarded. Completely retarded. They have absolutely no idea what's going on with the refractive index at all, right? And then they're begging the question with a 7/6R formula that presupposes a globe Earth, presupposes a vertical temperature gradient and refractive index gradient. Absolutely ridiculous.
Benny says, and those converted measurements are used by everyone all over the world. Yeah, Benny, look, we could, if first we claim that the Earth is, let's say it's shaped like a unicorn, then we create math to put those measurements on the unicorn. Of course, it would work. Isn't that right, DJ?
Yeah, exactly. You could You could convert these onto any coordinate system, no matter what shape it is, and it's still going to work. This guy doesn't understand the absolute basics.
He says, if they are wrong, it should be super easy to prove that outside the comfort of Discord.
The comfort of Discord. Wow, what a cope.
It's comforting sitting in YouTube because we can't, that's comfortable, I guess. Anyway, Benny, we have proven it outside of Discord, outside of the comfort of Discord as well, right? We talk about it here a lot. YouTube, TikTok, Twitter, X, whatever. Face-to-face debates with Globers over on Modern Day and so forth. So it's proven every day. Our claim is that the surface is flat, and we have very good and reliable and reproducible evidence for that.
So
Multiple
I think
thousands.
what they're wanting to do is branch out, and that's going to happen this year, and that's going to piss you off even more. Once you start seeing our videos popping up on TikTok and X and Instagram and Facebook and YouTube, okay,
Right.
getting huge amounts of views, that's just going to piss you off even more than right now. So yeah, just remember what you just requested, right? And stay tuned. 2026 is going to be a fun year.
I got to tell you this, DJ. I had some fun yesterday over on TikTok because TikTok are not used to empirical flat earthers. They're used to the more of the esoteric kind, the ice wall people and beyond the ice and stuff like that. Those kind of flat earthers. So when you when you talk to a glober there, it's like talking to a baby. I mean, they have their arguments are all set up around strawmans. So it was a lot of fun, and they're not used to it, but they're going to wake up real quick when we start branching out to those platforms.
Oh, I can't wait. I've got it all set up. Actually, I shouldn't be talking on here because I'm watching OBS tutorials today.
Dude, you got to join TikTok at some point and
Oh,
go
I've got
into
it.
one.
Yeah, I'm set up on there now. I'll
And
be
just
cross streaming on multiple different platforms. It's going to be
be
great fun.
crushing. It's actually it's a dopamine hit for sure. I almost feel a little bit bad for them, but they need to learn the ropes and they need to get used to it. They haven't seen anything yet. They're living in their own little caged dream world where the globe is real and they never met anybody from 24/7. Rude awakening is coming. That guy, Dr. Blitz, is over there as well. But yeah, that's a good idea. We should post some content over there. All right, we have a question in the chat. It's a big one. It almost looks like it's something ChatGPT posted. What he's saying? Ring laser gyroscopes built on different continents measure the same Earth rotation rate of. Okay, yeah, that's totally ChatGPT spit out. Lucas, do you want to talk to us in chat instead, in voice chat instead? It's a pretty long post you have there. Well, if we have no Globers who want to talk, I guess I'm going to have to read it. Ring laser gyroscopes built on different continents measure the same Earth rotation rate of 15.041 degrees. That's not true, but anyway, but only the component projected by latitude, and the sign reverses between hemispheres. On a flat, non-rotating Earth, what physical mechanism produces a Sagnac phase shift effect? I added the word effect that scales exactly with latitude, matches Earth's sidereal rotation rate to 5 decimal places, and reverses direction south of the equator. Provide the governing equation.
It does. Just tell him it doesn't.
Yeah, it doesn't.
He's got no proof
that's
of that.
what I said. Yeah. He doesn't have any. You're gonna have to show us a citation for that, Lucas.
Yeah, not even a citation. We want to see demonstrations.
Yeah, and ChatGPT doesn't count.
Right. It's funny. I've talked to ChatGPT and Grok so many times that I can recognize an argument coming from that thing. No human is that specific either about the rate. 15.041 degrees per hour. Yoder says, show me one such example. The sensor data. You bozos don't realize that the Sagnac effect is reproduced by rotating the light table like Wheel of Fortune. Something the RLG isn't doing. Ring laser gyro is what that stands for. Good comment there, Yoder. Appreciate it. I think the YouTube people are appreciating that I'm reading your answers here. And there's the Wheel of Fortune. This is what the Sagnac effect table is doing.
Welcome, Mr. Bombastic.
Hey, what's up, guys?
What's up, man? Welcome to the channel.
Thank you. Where are you guys from?
All sorts of different places. We got people from Sweden, Australia,
Let's go,
America, Canada.
Okay.
Yeah, the whole Earth is flat. Everybody knows it.
Oh, so you guys believe the Earth is flat, basically?
Well, we don't need to believe. It's not something you would need to believe in. It's something that we can all experience and then test empirically.
Well, you can all perceive the Earth as flat, right? But that doesn't make it is flat.
Right. So that's when I said go out and test it empirically. Just the perception, the physical perception, like what we experience. Yeah, that's not the proof. That's just the baseline. That's where we would we would all experience that as the base axiom for our reality. And then we would have to actually go and test it, because on the globe, right, they tell us that you experience the Earth as flat and stationary because it's so big and you're so small, blah blah blah. Okay, but then we go and actually test for the byproducts of the curvature, and it's not there.
What I mean, it's not there. You have gravity.
Yeah, gravity would
Physical
mean
laws.
that the gravity would mean that the curvature would have to be there. So if we're talking about the surface of water, for example, like a large body of water, because of gravity, the water would be curving at a specific rate around the globe, and that's what we would be testing for. So yeah, it would also
it
debunk
does
gravity.
curve.
Yeah, that's what I thought as well. But then when we go and test it, okay, it's not curving.
But that's why you can see boats disappearing.
I
bottom first.
saw one of those tests in the documentary, and it failed.
Oh yeah,
You can
the
see boats disappearing
Netflix.
bottom line first, and then the top part of the boat disappears, basically.
Well, most of the time that doesn't happen. That will only happen if you have a physical obstruction like ocean swells, or if you have an inferior mirage. Most of
It
the time,
wasn't
what
water.
happens
It was on land.
on land, you're talking about a
Mhm.
Netflix mockumentary.
I don't know. It was Netflix or YouTube. I don't know.
Yeah,
Or
Behind the
BBC. I have
Curve.
no idea.
Was it a dopey-looking guy with a flashlight?
That was one of them. So,
Yeah. Okay. So,
so he was a
which
paid
one are you?
actor.
No, he's just a gullible moron that got tricked into doing a mockumentary about flat Earth.
So he was an actor. You said, okay.
Well, he's not a flat
But I have a
earther.
question, because everything that we see in nature, right, corresponds to the idea of the Earth being a globe.
Okay, like
Oh,
what? Okay,
Like,
how do you?
for example,
give us.
do you want like scientific arguments or simplistic arguments
No,
that
Sure.
anyone can see?
Yeah.
what you said,
Dude,
yeah, what you,
DJ, have him give us scientific arguments for it.
yeah. Let's
I
start
mean-
with that.
I mean, you can see, for example, star patterns, right?
Well, that's not the Earth.
So you
And
just
that's
don't count
scientific.
it as evidence because it's not the Earth.
Yeah, so that's something that you would see happening in the sky. We're talking about the actual surface of the
So I
Earth.
mean, it's happening in the sky.
Yeah, so if we're measuring the surface and it's not curving, whatever's happening above the flat surface doesn't make the surface start to curve.
So
But you can deduct
why
something based on
why
the
can't you
movement.
see the North Star from Brazil then?
Because it's too far
Brazil.
away. It's too far away. Okay,
No,
the
it's because the
angle.
North Star
No, he's
corresponds
asking.
to the axis of
Okay,
rotation of the planet
No,
in the
wait,
North
okay,
Pole.
wait.
You two need to choose
Don't
which one of
talk
you.
over everyone.
Yeah, Bombastic. Maybe we're gonna talk to Tron for just a bit. So pop yourself on mute. We'll get back to you.
Okay, then.
Thank you.
No.
All right. So
Now, I had another question. I just was curious. Like,
well,
is there?
okay.
is
Did you
there
want
a
the answer to your? Okay.
No,
This
but
is the
wait.
thing. Hold on a second. Just before we get too far ahead of ourselves, if you ask a question, make sure you want to hear the answer to the question, because you just asked a question and then you don't seem to care about the answer. You just want to ask the question and then move to another question.
All right, answer the question then. Yeah.
Okay, because when you move away from something, okay, it gets lower and lower in your field of view. And then as it starts to get lower to the horizon and converge, due to the way our perspective works, you're looking through a shitload of atmosphere, which is thick, over distance, and you can't see forever through it. That's why we can't see even stars on the horizon, or even a few degrees above the horizon. You can't see them because you're looking through the thickness of the atmosphere.
But that would only be the case if the atmosphere is curved.
No, that would be the case in any atmosphere because it has dust and pollution and gas particles and fog and mist. Okay, and it has a certain opacity to it. It's opaque. It's not perfectly transparent. So you can look up like what's the maximum visibility rating anywhere. Okay, for me it's about 20 kilometers.
Mm-hmm.
That's the distance that you can see. You know, the maximum distance.
So the firmament is.
No, I didn't mention firmament. I
The
mean,
firmament. What the stars? What is that then in your world?
No, I didn't. I don't know how the sky works. I didn't claim a firmament.
So there's no consensus on that.
No, I don't think anyone knows exactly how the sky works. But what we can agree on as flat earthers is that there's no curvature over the surface of the Earth.
So there's no consensus either among you how big this flat Earth is.
Well, how big it is? Yeah, flat's not a shape. Okay, so we're not claiming to know the shape of the Earth or the size of the Earth. That's not the claim on the table. So yeah, there's no consensus.
Why has no one with today's technology? Why has no one flown as far as possible?
Yeah, how come no Globers done that either? No Globers have even kept going south.
They have done it.
No one's ever kept going south.
They come back to the same spot.
No one's ever done it north to south. Okay, so east to west. Okay, east and west are circles. So you could do east to west circumnavigations. Tons of people have done that. Okay, you could do that on a globe, or you could do that on a flat surface. But what you couldn't do on a flat surface is do a north to south circumnavigation. And it just so happens that nobody has ever done that. Okay, if you could go down any line of longitude. Okay, and then keep going over Antarctica and come back up around the other side of the globe and debunk flat Earth. Okay, but no one's ever done that. No one's ever just kept going south that we can confirm.
Oh, wait. Okay, just let me think this through. So if on a flat surface you start at point A, you start in some westward direction. First of all, how do you know where's west and north? But anyway, let's just ignore
We're going to
that.
be using a compass.
Okay, how does a compass work in your worldview?
It's not my worldview, it's just in general. Okay, so it's going to point towards the North Pole.
And how does that work?
You have a magnetic field.
Okay, at least you believe in that. Okay. But anyway, so on a flat surface, you go from one point and you just go in any direction.
Okay, well, in a straight line, you mean?
Yeah, we're talking a straight line. Yeah.
Yeah, but nobody's okay. So I understand theoretically that sounds like a great idea to test it, but in reality, that's just not possible, and nobody's ever done that. It's not logistically possible to do such a thing.
What? But you can fly around the Earth.
Well, you
in a
can
straight
go.
line.
It's not a straight line. Like
It's
if
not a straight line because
No.
no one has that much fuel, of course. Yeah.
Yeah, but not even close. Like you can't even find me what's the furthest distance someone's gone in a straight line, and then obviously you're going to need to be able to navigate through ocean currents if you're on a boat, or jet streams and wind gusts and wind currents if you're on a plane. Okay, and then you're going to have to use either the stars or you're going to have to use a compass to try to navigate. Okay, so east and west are circles around a north pole. So you could go east to west and come back to where you started, whether it be flat or whether it be a globe. But what you wouldn't be able to do is go north and then come back to where you started on a flat surface, because it would be away from the North Pole.
But what you said, that would imply that this flat Earth has an end.
No, it doesn't imply it has an end. It may well have an end, but we're not making claims to things that we haven't validated and can't validate. What we're talking about is flat Earth, meaning in the context that large surface areas, such as that of a large body of water, isn't curving as it would be required to be doing if the Earth were a globe. For example, a 10-mile lake or a 10-mile section of the ocean would have 66 foot approximately of curvature over that distance. And we can test for that, and it's not there. Just as an example.
So when a 16-year-old girl from Australia sails around the world, is that a lie?
No, you can have a look at the path that she took, right? She's not doing a path that would be dependent on the Earth being a globe.
And by the way, she went from port to port, not just got on the ocean and came back in 150 days and just looking like I'd been on a boat the whole time with a beard and all that.
Yeah, think about this, right? Just hypothetically, just say you had a giant lake and then you had islands in the lake. Okay, and you gave the islands different names. Okay, and then you went from one island to the other island, call them continents if you want. Okay, you're going from here to there, and you could go all the way around the lake, visiting different locations to get more fuel or whatever you want to do, and then come back to where you started again. Let's just hypothetically say there's a big magnet in the center of that lake. Okay, that's where your compass would be pointing to. So you could go east to west around the lake, use your compass to navigate and come back to where you started. But what you're not going to be able to do on that lake is go south and then come back to where you started again if you continue going south. That wouldn't work. That on a globe, if you were on a globe lake, sure, you would be able to do that, and you would go around and then you would come back to where you started again, but no one's ever done that.
Okay.
Yeah. It's not a gotcha. It's just something people, just need to wrap their head around, that it would work just fine on either, but no one's ever done the north-south thing that would debunk the flat Earth.
Okay. I watched this film, Fly Me to the Moon. It's a funny film, about the the theory that the Apollo missions were really just faked in a studio by a
That's
film
a theory.
director.
That's a theory.
It's a
I thought that was
conspiracy
proven.
theory.
I thought that was proven already. I thought the theory was
It's not proven.
going to the moon is just a theory.
Okay, so you guys here then. What happens when a rocket goes up in the sky? Where does this rocket go? It just bounces off a dome?
Oh,
or
they go
what?
up. They kind of turn sideways a little. Then they go out of your view, and then you don't see them anymore. You tell me where they go.
Yeah, then they end up retrieving them out of the ocean.
Well, that's true. At some point they come down, the capsule, but not the rest of
No,
they drop off the
no.
rest of the
The
cargo.
rocket that you see go up comes down lands in the water, and then NASA's recovery fleet goes out and grabs the shells of the rocket sections and brings them back because they're made out of material that allows them to come back up to the surface. They're just buoyant enough that they'll float.
In the 60s, they didn't have the technology. Now they have a technology where the
No, in the
rockets can
60s
land
is when
again.
they developed it.
They dropped it. They just dropped the tanks. Okay.
Is that all you got then? Rockets.
So what was the proof that the Apollo missions were faked?
No
Is
proof
it
they
because
went
you
there.
don't see the stars in the
proof that they
photographs?
didn't go there is the proof they didn't that they didn't go there. They didn't prove anything.
Naylor?
So one
Naylor, if you
argument
pop
that
yourself
when
on
you
mute,
look at
please. Sorry,
photographs,
Naylor, can you pop yourself on mute, please? Naylor, can you pop yourself on mute, please? You're hot micing.
Yeah, we'll just mute her. Where is she? Okay.
one argument I heard is because you don't see the stars in any of the photographs that they supposedly took on the moon.
There's no stars in a studio.
Yeah,
but
Tron, that's come on. The moon landings is kind of Santa Claus for adults at this point, and it's not on us to prove that it didn't happen. It would be on you to prove that it did happen, and you wouldn't be able to do that because all you could do is say,
No,
"I
it's
saw
to
these
prove
videos and
for
images," but you
most of
can't verify.
the world population to prove it didn't happen.
No.
There's only
It
how
would
many
be
flat
on-
earthers in the world?
No, it would be on the person claiming that in the 1960s, 3 men from America flew to the light in the sky called the moon and played golf on it. That would be for you to prove. And how would you do that? Would you
They're
tell
gonna
us to
fly there
watch
soon again.
TV? Oh, so you're going to appeal to the future. That's a fallacy.
No, next
that's
month they're gonna fly around the moon.
That's
that
what
would
I
be a
heard.
fallacy.
I heard guys at work yesterday talking about it, and I had to walk in the other room and punch myself in the face, so I didn't say anything. What do you think of that?
Yeah, how do you know any of those images or videos are real, Tron? How did you verify them?
Because in the 60s they didn't have technology to create such
Yeah, they were
images.
making sci-fi movies in the 60s. Look just the same.
Just check the side chat quickly. This is claimed to be actual footage from NASA.
Oh yeah, is that real, Tron? That one the DJ posted, is that real?
That shot right there.
Yeah, is that
That
real?
would have been that wouldn't have been possible in '69. You know why? In '68 there
Yeah,
came
it's
a
stop
movie,
motion.
2001: A Space Odyssey.
Yeah, it's models. And it's models. You think that looks real?
That doesn't
Come
look
on,
like
Tron.
a model. Model shots don't look like that.
Look at how it's moving, Tron.
That's from NASA.
Yes, that's supposed to
space,
convince me.
That's
now?
your space maneuvers, dude. That's your
Wait.
NASA space maneuvers.
Tron, do you think that's a spaceship on the moon? Is that what you think?
Yes.
Oh wow. You guys just willingly delude yourself. That's the sad thing.
There's nothing sad about it. It's
Yeah,
not.
very
It's not
sad.
something. It's not
It's
something
very
that
sad.
if
Okay,
makes
so
my
how are you
life
going to
better
prove
or
to
worse.
us?
So it
How
doesn't
would you
really
prove
matter.
to us that that's real and that's a spaceship on the moon?
I don't know what to prove. I don't have to
Okay,
prove anything.
we'll dismiss it then because it looks fake as shit.
Oh, that's okay. You believe that. I believe that.
Okay, that's fine. So that's fine.
We
So let's
could-
stick
we could-
to
we
let's
go on
stick.
with our lives.
Okay, well, let's stick to verifiable evidence. So if we don't just use unverifiable claims from the government and cartoons like this, how do you
So,
prove
but
the Earth is a globe? How do you prove it?
so you don't believe the
No, it's not about me
outside the
believing.
flat
I
Earth
said, how do
exists
you
anything?
prove it without just relying on unverifiable claims from the government? How do you prove? How do we, in this call, prove that the Earth is a globe?
I never thought about having to prove it. To be
Okay,
honest.
see, that's the problem. This is why you believe in it, because you've never thought about how could I actually prove this. You've just believed the videos.
No, I believe because I believe the photographs are real.
Yeah, you believe images and videos that you can't verify. That's the
He
problem,
believes
Sean.
2001: A Space Odyssey actually did happen because it's photographs and film.
Yeah, we've got videos of Bigfoot, Tron. You believe in Bigfoot?
Yeah, they had computers
No,
talking
2001
to us.
is not real.
They had
That's a
computers
film.
talking to
Oh,
us
it's a
back then.
film. This is a film, Tron.
Yeah, they had Hal in the Apollo, but they didn't tell you about that. Hal turned the spaceship so we can land on the moon. Okay, guys, here we go.
Yeah, so now that you're thinking about it, Tron, how could you prove that the Earth is a globe without relying on government
I'm not
images
thinking about
and
it. I
videos?
actually came here for a laugh, but I'm trying to have a
Okay, but
conversation.
now you've realized that we don't just believe
I
baseless
know.
claims and
I
cartoons. So
know
how can we
what you
prove it?
people are like. I just wanted to
How could you prove
have
it?
a conversation.
Okay, so you're saying you couldn't prove it. You could only just believe the videos and images the government gave you.
Right now, I never thought about having to prove it, so I
Okay,
can't
well,
give
now
you
that
a
you're
straight
thinking
answer
about
now.
it, you've realized that you can't prove it. Is that right?
Right at this moment, I can't prove it now.
Okay, cool. Well, at least you're honest. Yeah, and if you think about it
But
longer,
right in this moment,
you will
you
still
can't prove
realize
either
that
that
you
the
can't
Earth is
prove it.
flat.
Yeah, it measures flat.
But you can't prove it right now.
Yeah, you can go out to a lake or a
No,
shoreline and you
right
can
now in
do a
this
long
call,
distance
the same argument you
observation.
gave me. You can't prove
No,
it to
no,
me
no. I
right now.
mean, like, you could go out and do something on Earth. I'm not saying you have to, like, do an experiment at your desk right now. I'm saying if you were to go out into the world, into reality, what experiment or measurement could you do to prove the Earth is a globe?
Well, the experience that you talked about, like on the lake, but you
Yeah, they
said
would
many
just
of
prove
those.
it's flat,
But
though.
when they
I'm asking about
fail,
the
you
globe.
say they are not real flat earthers.
So is
they
that what
are
you would do to
marked.
prove it's a globe? You would measure a lake.
Well, that's one way to prove
Okay. Could you
the
show us a
archaeology if
measurement
the
of a
math is
lake?
correct.
Okay, could you show us the measurement of a curved lake that aligns with the globe?
I can't. I would have to look it up. I don't know it.
Okay, well, that's fine. You've got Google in front of you. It wouldn't take you long, would it? Just
What,
look
the
for.
curvature of the Earth,
Yeah. Just type in curvature of the Earth measurement and then give us the measurement.
I'll just ask ChatGPT. It's easier.
And it has to be a measurement of the curve, right? Not an assumption, and then you just calculate the assumption. We want an actual measurement. You understand?
I'll see what it gives me. 1 second here. 1 formula. What the hell is this? Okay, well, that's not one answer. I can one sentence, man. Because it
So
gave
no
me
one's
the
measured
formula.
it? There's not a guy that it says this guy measured it on this date doing this?
Well, it gave me the formula. That I don't know where the formula comes from.
Yeah. We know what the claim is, but we want to see that being measured in reality, because when people go out and measure it, it doesn't match that formula. It's just flat. So if you've got a curvature one, we'd like to see it.
But you know how big the supposed globe is?
Yes, we do. Do you?
By heart, no. It's a long time ago.
Okay. So well, we do. So
I
we're
think
probably in a better
I think the
position.
circumference is like 4,500 kilometers or something like that. I have no idea.
No. See, you don't know the first thing about the globe, so how could you know about it? We know more about it than you do.
I'm Catholic, but I don't know the Bible by heart. No.
All right, so
I
the globe is
forgot.
like a
Oh,
religion.
hey, Cyclone,
the-
he's from the religion that basically
Yeah,
started
yeah.
this.
See, now you're getting it. The globe is like a religion, like your Catholicism.
No, it's not. No, I came.
Yeah.
Look, I came on the server and I saw this channel and thought, oh my god.
Yeah, yeah. And now you're
This could be fun,
realizing, oh my God, I just have a
but this is not
religion
something I
based on
go around
government
thinking
space
about every day.
cartoons. And now you've realized you've just got a religion based on government space cartoons. There you go.
What do you mean?
Created by the Catholic religion.
They look. When Galilei came around, the church punished him because he said the
No,
Earth is
no, that's
round
just
and
what
the
you were
Earth is in the
told in
center.
school. That's just what you were told
It's
as
a
a child.
story, dude.
Don't worry about that. He didn't measure a globe either.
You believe the Earth is 4,000 years old?
No, we're not talking about the age of the Earth. Did you say the globe? There is no globe, so why would we believe that?
You're not a creationalist either, though. Then
What do you mean?
a creationalist.
What do you mean by that?
You believe in evolution?
What's that?
Okay.
No, define
Okay,
it.
what?
Define it. Do you believe in that?
I asked you what you believe.
Well, we're not
No,
talking about beliefs
I
here. We're
just
talking
believe.
about
This is what I was
we like
taught. It doesn't mean
science
if I
here.
believe
We
it or
like
not.
science here, not belief. Do you have any science for your claims?
What claims? I asked you what you believed.
The globe.
No,
The
we don't
globe
want to do
claims.
beliefs here. I believe in Santa Claus. Do you believe in Easter Bunny?
No, I don't believe in Santa Claus.
But you
I
believe in
do.
evolution.
I understand what I said believe. That's what I was taught. That's not belief necessarily.
Yes, it is.
Right. Did they
You
give
don't
you
have
any
any proof
evidence?
for it.
Did they give you any evidence for that?
Look, I was in school like 30 years ago. I don't remember what they taught me
Okay,
then.
so they taught you wrong. Now we're telling you the truth. Now what do you have to say?
What truth? What truth? You did that
Earth is
evolution
flat.
doesn't exist? No. I
Yeah,
asked about
evolution is
evolution.
fake too. Evolution is fake too. Yeah, so they were wrong. So now that we're telling you the truth, what do you have to say about it?
So the Earth in your worldview is
No,
not
it's not in my opinion.
4.8 billion
It's
years
measured
old.
flat.
No, I'm talking about the age now.
No, we don't care about the age. You can't verify the age of the
Nobody gives a
ground.
shit about the age. Only you guys. Only you guys are concerned about how old the Earth is now.
Come on.
So is
well,
there
come
a
on.
creation myth
Can you not look for
in
that
flat Earth?
curvature? Listen, we asked you about the curvature. Can you not give us something for that?
No, I'm not a scientist.
Right. Okay. Well, then there you go. There's no curvature. Earth is flat, as far as you can tell.
Maybe, yeah, but so what is the
Yeah, that's
creation
it.
myth in flat Earth?
Well, we're not giving a creation myth. We're just pointing out it measures flat, so it can't be a globe. That's it.
But the Earth is flat, but
Yeah.
it came
Yep.
it came
Yeah.
from somewhere or not?
Earth is flat.
Oh
Yeah,
yeah,
of
for
course it
sure.
has to.
Yeah. Yeah, dude.
Yeah, from where then?
Well, how would you
Who
figure that
knows?
out?
Okay, so you don't know. So there's no consensus there.
No, you don't
There's
have
no-
anything.
It's not.
You don't have any consensus either.
We're not appealing to a consensus. We're just
But there's
pointing
no
out
consensus
how Earth
among you either
measures.
how the flat Earth looks, apparently.
Well, yeah,
Hey,
it looks
Tron,
flat and motionless.
Tron,
Go
did you
outside.
know a Catholic priest invented the Big Bang Theory? Did you know it was a Catholic priest? He came up with the theory that everything blew up from nothing. Did you like that? Is that how it works? You just invent the thing, and then that's the truth?
I thought it was Stephen Hawking.
No, he's the one. He likes black holes.
Man, you
Remember?
got a lot of research
Like
to
some
do, Tron.
Edwin
You'll-
Hubble came up with the Big Bang, bro.
Yeah, you guys,
No,
you
you
guys
got
have got
that
a lot
wrong,
of work to do.
Stephen Hawking was the one, the black hole at the start of
So we're not going
time.
to talk about him because he was just an actor.
All right,
Yeah,
so
Okay.
Tron, can we just draw a line under it then? You don't have any evidence for the Earth being a globe. Is that?
I never came in here to present evidence. I just wanted
No,
to.
no, I'm not saying you did. I'm not saying you did. I'm just saying now that we've established that you don't have any evidence that the Earth is a globe,
And
we can
neither
just draw
do
a line
you.
under that. Yeah, I know there is no evidence for Earth being a globe, so
Okay,
of
so
course we
there's.
don't have any.
So what's the point of discussing anything? No one has any evidence.
Because the Earth is observably and measurably flat. We're just pointing that out to people.
So you do have evidence.
That it's flat,
You
yeah.
just said you
Not that
don't
it's a
have
globe.
evidence.
No, I said we don't have evidence that it's a globe, of course, because
You don't
it's
have,
not.
but what's the evidence that it's flat? apart
Do you
from
want
those
to see some? Do
experiments.
you want to see some?
Sure,
If I
because
show, if I post you
I'm
some, if I post
about the
some,
flat, about the
are you
flat,
actually
yeah.
gonna engage with
Hey,
it,
Jack,
or are you
why
gonna
don't you
make some
calm
excuses?
down? You don't hear people talking, Jack?
Sorry, but I just want to share.
No, shut up. So Tron, if I post some evidence, are you actually
I
going to
just want give me
engage with
just
it,
one.
or are you
Don't
gonna make some
overwhelm.
excuse and not deal with it?
Just give one link, and I'll read it.
Okay, there it's in the chat. It's a video. You can watch it.
Let's see if I haven't seen this one, but yeah.
Yeah, and then explain to us how a laser can hit a target 30 miles across a lake on a globe.
Where was this?
That'll be your homework. It's all in the video. You can take some time and have a look at it. Gather your thoughts.
Okay. I can't do that right now on ad hoc.
So over that distance of 28.6 miles, if the Earth were a globe, there should be 437 foot of curvature. That is essentially the height of a giant skyscraper building that would be about 43 stories high.
Sorry, I need to translate it into metric first.
Okay.
143 meters. Okay, I can
Yeah.
understand that.
It's about 40 kilometers, maybe?
You say 470 foot. That's what I wanted to understand.
437. Yeah.
37. Okay.
Yeah. So
133 meters. Okay. Yeah.
So
I
in
can
all of
understand
these
that.
observations, there's hundreds of feet of curvature missing. Sorry, not using metric. Between 50 and 100 meters of curvature missing consistently from these observations. Zero curvature being detected.
Kootenay Lake. Okay.
Welcome to 24/7 Flat Earth Discord. Please try to remain civilized and cordial. Gravity is not a force.
I guess the conversation died. I'm reading a little bit of chat here while we wait for someone else to bring something up. This is funny. Paradox says in chat, dinosaurs aren't fake. They have evolved to chickens and other birds. You know, how it's so insane to me that you can just say stuff like that without even thinking about how you're going to prove that. Like, it's like I'm saying unicorns lived 5 billion years ago. They were blue and pink and they had wings, some of them. And they later evolved into Bigfoot. I mean, or something like that. It's just so crazy when people start a sentence with, a claim that can't be proven. Why do they do that? It's so weird. But yeah, we can talk to you in VC, Paradox. People often ask me also, what will change in my life if I become a flat earther? Well, first of all, you're going to start questioning claims like those. 10 billion years ago, the Earth was covered in ice. You're going to be like, all right, how do you prove that? Well, before you became a flat earther, you just shrugged and said, oh, 10 billion years ago, the Earth was covered in ice. And then you went on and did whatever you were going to do. So that's something that changes. Paradox says, wait, I'll be there in 30 minutes. Fair enough, Paradox. Appreciate that. Yeah, we'll have the popcorn ready. It's story time. So get your popcorn and your brownies and milk out. Looking forward to it. Dinosaurs evolved into chickens. All right. Professor Triangle said, an asteroid hit the flat Earth, and that's what flung the dinos into space. Dinos live in space now on other planets. Yeah. I mean, it's as good a story as anything. Globers and their stories.
Hey, Nyla, you're unmuted, but you have some background sounds coming from your microphone. If you could please pop yourself on mute or ask questions if you want to.
Yaga Bruno says, people are hypnotized by Jurassic Parks and Star Trek. None are scientifically proven. Yeah, that's right. You know, I was the biggest Star Trek nerd ever before I became a flat earther. But after I realized Earth was flat, I couldn't watch it anymore. I just couldn't. Now it's been a few years and I'm back to I'm enjoying it again as fiction.
So all those bones, they're all fake.
What bones are you talking about? The ones you see in museums?
Okay, if when you start like that, I already know the answer then. So that was my question. This is all
Yes.
a
Yeah, they're models. They're
global
models and reproductions. They're not even claimed to be
conspiracy
the
theory.
real bones.
No, you simply said, so the bones are all fake, right? And then I was clarifying if you're talking about the ones in museums or which bones you meant.
Yes, I
meant
sold him
dinosaurs,
that
but because you were
the
talking
ones
about
in
you were talking about
museums.
dinosaurs.
I told you the ones in the museums are fake, so you're going to have to suffer now. You're going to have a headache.
Hello?
So that's the answer. The dinosaur
Yep, they're made
bones
of
are
wire and plaster in the museums. Yeah.
okay.
Hello?
Hello, welcome.
Yeah, thank you. Am I audible?
Yeah, you are audible.
Yeah, it's my first time here. I am so confused about it. What's going on there? So,
Don't be
can
confused.
anybody? Yeah, I'm confused about this. What's going on there? Anybody say the Earth is flat and dinosaurs are not like this? I'm too confused. I randomly joined this group when I opened my Discord, so I randomly joined this. I don't know where, how, but I am there. And now I am enjoying it. Your conversation is gonna good, but I am still confused.
That's all
That's
right.
okay.
It's a new topic for you.
All of the globe believers are confused. It takes time. Just listen and you'll learn.
Okay, it's about what history or what type of discussion that you people are doing.
I think we're waiting for Tron to tell us how a laser hits a target 30 miles away across a lake. You managed to figure that out, Tron?
First, I need to understand all that. Okay, I don't know anything about lasers, so yeah, give me some time.
It just shoots a straight beam of light.
Because I know what it does,
Okay.
but
There you go.
anything I say, I also need to prepare myself for what you probably will say.
Well, what would you
to
say?
refute it? I'm not done yet. Okay, just give me some time.
Take all the time you need.
Can I get 30 seconds to talk Nayla? Bring her up to speed. Nayla, can
Okay.
you hear me?
Yes, yes.
I want
Yeah,
to
I
show
can
you.
hear you.
Yeah, you came in during the discussion where we're talking about laser tests, but I like to explain how we came, how that. Yeah, I like to give you some context. So you think you live on
Okay.
you think you live on a globe, right?
Yeah,
A
glow.
ball.
No, I am on Earth. Earth, and Earth is a planet. And that eight planets, sun, moon, it makes our solar system that we are
Right.
exist.
Are you able to
Yeah.
look at the chat?
Okay, give me. Yeah.
Do you see the picture I posted?
Yes.
Do you see that ball there?
Yeah.
Does it look like
Yeah,
does
yeah.
it look like pictures that you have seen before and they told you this is where you live? Right?
Yeah.
Do you know what all the blue stuff there on the ball is?
Sorry?
Do you know what the blue stuff, the blue color on the ball, do you know what that is? The blue.
Yeah, the blue is color water. It's
Yes.
water.
Yeah,
If I might
exactly.
be not wrong.
Yeah, no, it's water. It's water. Exactly. So do you notice something weird about that water? It curves around the ball, right? But we always seen water being,
Yes.
yeah, that's a little bit weird. So here's the thing. They claim that this is where we live, and they have told us the size of this ball. The radius is 3,959 miles.
Yes.
So we can do some math to figure out how much water needs to curve over distance. And that is what we're talking about with the other guy. We have done laser tests over 10 miles. Earth has to curve 66 foot, you see. So if you take a laser,
Okay.
and go to the beach of a 10-mile wide lake, and you put that 1 foot or 30 centimeters over the water, right? And then you shoot it to the other side, it should end up 66 foot in the air if Earth is a ball. The problem is that when we do these tests, it ends up 1 foot over the water on the other side as well. But it should end up 66 foot up in the air. That's as high as it's like 20 meters or a 6-story building, right? But that's not the case. So that's where
Okay.
we're at in the discussion. And someone posted a link further up to a laser test where they shot the laser 28 miles, and it ended up a few foot over
Okay.
water. So
Oh,
that's why
interesting.
we
Interesting.
say That's why we say the Earth is flat, because Earth is covered by a lot of water, so it cannot be a ball because the water does not curve.
Yeah, yeah,
All right, you caught up to speed. Now, if
I
you have any
got it.
questions, perfect. Yeah, you seem like a
Yeah, I
smart
got
woman.
it. Thank you. Thank you so much.
No problem.
Okay, thank you.
Nyla, which country are you from?
Yeah, I am from South Asia, Pakistan.
Ah, okay, cool, cool. I was just trying to guess where your accent was from, and I couldn't do it. So thanks for that.
So sorry for this.
No, it's okay. It's okay. Well, thank you for joining the channel. It's good to have you here.
Thank you.
Abdu, hot miking. All right, does anyone have any questions, or does anyone have any arguments to support the globe Earth?
If the Earth is a globe, how come it's measured flat?
Shit, it's a bit of a problem, I think, because it would be impossible for a globe to measure flat.
So what would be correct? Saying it's a globe, or do you go with the measurements? I mean, how do you pick?
What about eclipses?
I can make eclipses with a ruler and an orange.
What about time zones?
China has one time zone. They're either super small or time zones are made up.
How can it be daytime in Japan if it's nighttime in America, though?
Whoa. So
Yeah.
the sun moves across the sky. I know you guys don't know this stuff, but it actually moves if you pay attention to it. You can
So why would they
see
all?
it.
Why would they all be lying?
Who's lying? People don't lie that the sun's moving. They see the sun moving. They tell
What
you
about
it's moving.
black holes?
Yeah, I don't know anything about that. That sounds made up.
Checkmate. Fluff.
Good one.
Wait, so the sun is moving, but if the Earth is flat, the light spreads evenly across the flat Earth because
How
it's
far
flat.
does light go? How far does light go? Forever?
No, it doesn't. But
Oh, there you go then. So nope, it doesn't go forever. So it doesn't have to light up everything because it doesn't go forever. Okay, we got that solved.
no,
What's
look
their-
on so on the flat Earth, where's USA and where's Japan? It's in a circle, right? It goes around.
No, we're not
Where's
claiming that.
Japan? I have never been there, so I've never investigated.
So you're
how
basically
I'm gonna
saying,
get
like,
Japan.
so you gave me the argument that like light does. That's true. Light falls off at some point. Yes, true.
Okay, so there we
Like
go.
just like the sun.
The end.
No, it doesn't end
Yeah.
because show
do you
me a
mean?
map of your worldview.
Oh, I don't have a map. I use Google Maps when I drive.
Show me a map
Or whatever's built into
according
my
to
iPhone.
what
I
you
either
think the
use the
world looks
iPhone
like.
maps, the ones that are built into the iPhone, or I use Google Maps. It depends. If I'm in, depends on what car I'm in.
So how does
Yeah.
that work?
It would be great if you
Cell
if we could
towers.
get $1 trillion in funding and a fleet of ships and planes,
but
and then
Google
we could go
Maps.
and make you a map. Google Maps is just a projection of a spherical coordinate system stretched out into a Web Mercator projection with a whole bunch of
Yeah.
incorrect sizes and distortions, and it's just a coordinate system.
True,
That's all
but
that
how
is.
does it find where you are?
Using the
A
coordinate
bunch
system.
of cars drove around. You didn't probably never seen a Google car driving around with cameras
I've
all
seen,
over
but
it. But
how
yeah,
does
but
it
that
know
drives
you are?
around and gets its coordinates and takes pictures so it can give you those. That's how it does it. Isn't that
How does it
amazing?
know where you are
And then
exactly?
when the planes fly over, the next height up, when the planes fly over, they connect those GPS coordinates to those pictures. And then when they go a little bit higher from a higher plane, they connect those GPS coordinates. And then that's about all you get. Everything else turns into a cartoon.
Are you
how
talking
does your
about
phone
how does
know that when you're driving from point A to B, where you
Yeah,
where
okay,
you
because
are
you're getting
exactly?
signals. You're getting signals. You're getting signals from towers.
From where?
It's going to triangulate your position.
Doesn't your car have Wi-Fi in it?
Doesn't use Wi-Fi, use GPS. And
Well, you guys are way in
the
back in the
network.
Stone Ages. Even my crappy car has Wi-Fi.
My car is old, man. I don't need a new car. Waste of money.
There you go.
Well, it's true. Cars are depreciating.
They just use the
objects.
Wi-Fi signal. They're allowed to use it for free. What do you think of that?
So you're just getting a signal. You're just getting a signal.
In the forest.
Wi-Fi signal.
No, nothing works in a pine forest. Where I live is Ohio, and we have pine trees all over the place. So once you're in pine forest, you got no signal.
Okay, in the middle of nowhere, away from a big city, there's Wi-Fi signal everywhere.
For us, now there is. Never used to be, but now there is.
It's not Wi-Fi. It's 5G or 4G.
And
Wi-Fi is a network between electrical devices.
And still has to be converted to an IP address. Still has to be converted to an IP, so we can call it Wi-Fi.
Is this the globe proof that we were looking for?
No, I was answering to something else that someone brought up.
Okay.
Well, there's no proof. There's nothing anyone can say to prove this to you because
so why do so many people believe it if there is no proof?
No, but no. Why do you need to prove anything or disprove anything? You just live your
because
lives.
you're making a claim about the physical geometry of the surface of Earth, so why can't that be proven? Do you know what the claimed radius of the globe is?
Yes, I know what the radius is.
Of the globe?
I know about how, according to how they say the diameter of the Earth is.
3,959 miles in radius, yeah?
Well, there you go. You see, that shows me the commitment. You know more about these things because you learn these things by heart.
So has that ever been measured?
By someone with a ruler? No, because it's impossible.
Well, in any way?
I don't know how he came up with that number.
Yeah, well, this is the thing. See, if you want to know whether or not this is true, you need to figure that out. Because it's never been measured.
Like, I live my life, man. I'm happy, man. I just...
yeah, that's fine. I'm glad you're happy. No one's trying to make you unhappy, but you're kind of acting like the Earth is a globe, and we know it's not. So we're just pointing that out, and
you don't know because you can't prove it either. Just like how I can't prove.
Yeah, the laser test. Remember? That's why we sent it to you.
Yeah, I looked at it, but
okay,
anything I say, you will have an answer.
So how does the laser
answer already?
Okay, so how would you say the laser hits the target 30 miles away?
I don't have the time to prepare for this like you did.
You don't have to prepare for it. Just be honest and tell us your honest answer. The laser shoots a straight line, right? It shoots a straight line from the laser to the target. Yeah?
Yes, I can
get
that far,
okay.
yes.
But on a globe, that's not possible because there's supposed to be a hump of curvature in between it.
I can't explain that because I don't know anything.
I know, that's what we're saying. You can't explain it on a globe because
I'm sure it's explainable. It's that
it doesn't work on a globe.
Have an answer. I'm just saying, even if I spend time to come up
there's
with
no
argument,
answer you can
already
give.
have
It doesn't work on a globe.
You already
it doesn't work on a globe.
so much time. You're just talking over me again. You already
Yeah.
have an answer to everything I say anyway.
You
because
haven't.
you already
Well, you've not
spent.
given. You're not giving us an answer. Well,
No,
you're not responding to it at all. So what? How can you
I don't
say
have
that?
an argument right now. Yeah, I can probably ask ChatGPT, and you probably have an answer to everything it said.
What do you think ChatGPT would say?
It doesn't agree with you.
Well, and how does it say that the laser hits the target if there's a curve
And
in the
how
way?
do you verify ChatGPT is right, dude?
Well, that's no. Well, look, you see, but that's the thing, you know. You say one thing, you have an answer for that, but then how
Well,
do I
our
know
answer's
what you
simple
say is
though. Our
correct?
answer's
Who,
simple
where,
though, and
because
it makes sense. Our answer makes sense because lasers just
well,
shoot a straight line, so the laser is shooting the
that
target
makes
a
sense.
straight
Yes.
line across the lake. That makes sense.
Honestly, what to do is look at reality. You don't got to just listen to what we're saying. You just got to look at reality, what it is. There's a claim of curvature, right? If you're living on a ball, the ball is going to curve. It's not going to be straight, because that would be flat. So if you go horizontal, which is straight, they claim that if you keep going straight, you will be flying into free space. The light will shoot into free space, and it wouldn't wrap around. It wouldn't be parallel to any surface. So, which meaning that there will be no surface beneath it, right? So, if you put something on the surface, right, and you shoot a laser going straight, the laser should shoot flying into free space 30 miles away, because
What?
the target, wait a minute, hold on, because the target is on the surface that is supposed to be curving underneath it. And the laser should be shooting past it in free space. So
What is a
how
laser? What is
glow?
a laser?
Oh
Laser
my
is
god.
listen, the point is that the laser is a light shooting horizontally. If it's shooting horizontally, which is straight in any manner, on a ball, it should be shooting into free space. So it should not be hitting targets 30 miles away connected to a surface. Because that means that the
On
laser
this
is
flat
shooting
Earth,
straight. Right. Did that mean that the laser is
you
shooting
guys do. You have said there's air and you have an atmosphere on this flat Earth. Yeah.
straight?
He's ChatGPT'd it. What did
I just
Uh-oh.
well,
ChatGPT tell you,
let's
Tron?
see if I just want to test if you
What
actually
did it
can.
tell you? Did it say the bendy laser is bending around the curve that you've got no evidence for?
Ooh.
No, this is not about the curve. This is just say that this experiment doesn't
When you look at the
Oh,
disprove.
curve,
it
because the
doesn't
laser is
disprove the curve that there's no evidence for. Well, yeah, it does, because according to the globe, there's curvature in between the laser and the target. You wouldn't be able to hit the target.
A laser is not a straight
and
line,
you
though.
won't hit the
Wait,
target.
no. But so why do builders and surveyors use lasers to level surfaces?
On short distances, not on 30 kilometers
Okay,
or
so
miles.
well, yeah, but that's why you get a powerful laser. Like the military use lasers that can go like 100 kilometers.
They
But
do.
they don't use it though to disprove the
Yeah, they do
curvature of
line of
the Earth.
sight targeting. They do line of sight
And
targeting from ships.
the Navy use harpoon missiles to shoot straight to at least 100 kilometers.
Yeah, so this is all over a flat surface, Tron. Just like in your
Yeah.
PFP and in the Tron world, you know how it's all flat and everything's moving over a flat, like, surface? Just like Tron. You can
Yep.
understand it like that.
Just like that. Just like that grid.
Yeah, it's all a grid.
But
But that's science fiction.
can you have the laser? Wait a minute. Can
Yeah,
you have
well, it's funny because
on the
actually the
globe?
globe is the science
He's
fiction.
gonna change his his picture now,
But
Cyclone.
I'm gonna say,
Why isn't
can you
Tron
have,
on a ball?
right? How can you have a
Because it's
laser
inside a
on the
computer.
ball? But can you have a laser on the ball pretty much shoot straight and still hits its target when the ball is supposed to be curving either underneath, or it should be a physical hump at the horizon?
You guys spend so much time preparing these
Yes, we've
answers. Yes.
spent a lot of time, so you should listen to us.
Have you done this experiment yourself, though?
Yeah, we synced it ourselves. Yes.
You have such a powerful laser?
Yes, we synced it ourselves. I actually looked at it with a baller. He called himself Jesse.
I know it's tough
Okay.
to come to grips with, Tron, when you've believed in the globe your whole life. I get it.
That's okay. After this, I'm gonna make myself some food and then go on with my life. So don't worry about that.
Until the next time you go to the beach and you look at that flat horizon and you go, damn, it is flat.
So you have
That's
a belief.
okay. I haven't seen
I
the
mean, there's
beach
nothing
in
there's nothing
years.
wrong with having a religious belief, bro. Ain't nothing wrong with that. I mean, everybody have. They call it
I
helio.
don't believe in God. I'm not a religious person now.
Well, you is a religious person. You believe in a ball.
You're a heliocentrist, right?
Heliocentrist?
You
That the
you
Earth
don't
is
have
the
no.
center of the universe? No.
The God.
No, heliocentrist, that's like the sun. Helios.
Yeah,
He's the sun god, isn't he?
yeah,
The sun is not
that's
the center of the universe either. No.
Well,
That's
no,
not what
but
you think,
you
brother.
go. So you're not heliocentrist.
Oh, in the solar system, yeah.
Oh,
Well,
yeah.
that's what
So
I was taught.
Helios
I
is the
haven't been
sun
in
god,
space.
right?
yeah. Helio is
Yeah,
literally the sun
Apollo.
god.
Yeah. So
Apollon as well, yeah.
that would be that would be like a religion.
Yeah, you don't have any evidence of what you're talking about, so it's a religion. You just have a belief.
It's
I
sun
don't even know
worship.
why
What did we talk? We
You know
talking
what's
about the
funny,
sun.
Tron? You know what's funny, Tron? Basically, what they've done is these are like old school sun worshippers who have updated their sun worship to some kind of modern, faux scientific cosmological philosophy,
But you
and
have a
they've
sun in your
convinced a
flat
whole
Earth.
load of people that it's science when actually it's just old-fashioned sun worship. You might as well be going to the top of the pyramid and pulling some guy's heart out of his chest.
I
But you
mean, it
have a
was
sun
really
in your flat
what
Earth that
what's
gives you
you know what's
light
funny about
and
it?
heat.
It's really what science was actually created to debunk people that just believe things.
But you have a sun in your flat Earth that gives you heat and light, right?
It's not our flat Earth, Tron. It's the Earth that you live on. It's the one that you go outside and you
Answer the
see the
question.
sun. That's the flat Earth. Yeah.
In your worldview, there's a sun that gives you light and heat.
That's not a worldview. That's an observation of
Just answer the
reality.
question, yes or no.
It's not a worldview. It's reality. You go outside, you see the sun.
Okay, but
Yeah.
you have a sun that gives you light and heat.
Yeah.
And
But why
do you
does it
know
go
where the sun
down?
physically? Do you know where the
So
sun physically works?
Just
so the
perspective.
sun. So
It's
how does
like
sunset and sunrise work
it's
for you
like
then?
you know if you're at the end of a long road and it's got street lights on it, why do the street lights look like they get closer to the ground the further away they are?
Yeah, why is
Okay, so
that?
you're using perspective. Okay.
Well, I'm not using it. That's just what it is.
But
That's
why,
what it
if you
is.
stand at the same spot, the sun moves, you don't move?
Because the sun is moving.
Duh.
But
Did
why
you
does it move
realize that?
around?
Why does the sun move? Is
So the
that your
sun moves
question?
in a straight line for you.
Well, the sun
The
moves
sun is
east to
moving away.
west through the sky every day, doesn't it?
Yeah, the sun is moving away.
Why doesn't it move in a straight line then?
Why do
According
it
What do you
to
have
mean?
to? Why do it have to?
no, but look,
Just moves east to west. I'm not saying it's moving in a straight line. It's moving east to west.
but it should be in your. Otherwise, it would look
There's no
like it does.
should. There's no should, Tron. There's
But
just what does it?
you
What is it
see when you stand
observed?
outside,
It's not
you
a question
stand
of
this whole
should
day.
or could, Tron.
Are we,
Listen, it's not a question of should or could or would. It's a question of what is it observed to do.
Okay, you stand
Okay,
outside the whole day. You observe the sun.
and you see the sun moving. Yeah,
It
Tron.
rises in one point
do you or
and
do
goes
you not
down.
see
And
the sun? Do you or do you not see the sun moving as in changing position?
yes, of course, that's what I'm saying.
Okay, so
Okay, so
Tron.
But
the sun's moving.
So the sun. So we're
but it
saying the sun
rises
is
and
moving because
sets.
we observe the sun moving. So do you agree the sun is moving?
No, it's not the sun that's moving.
Right. So you see the sun moving, and you say the sun is not moving.
No, it's us who are moving.
But you only observe the sun moving, Tron.
Well, I believe the sun that we move around the sun, so of course the sun
Yeah,
will
but
move
that's
for
just
us
your belief,
observably.
Tron. This is what we're saying. See, we're going with what's observable in reality, and you're going with what's not observable or experienced in reality.
But
Yeah, that's
okay, let me go with you. Okay, let's
the
say the sun
religion
is
again.
moving, not the Earth. Okay.
That's what you
So
But
the sun
why
experience.
does
is
it
Yeah, so let's
look?
go with that.
Why does it still look if you stand in the same spot the whole day?
yeah,
Why does it
why is
still
it
move?
still look? No.
Just let me
Because the
talk. Why
sun,
does it still
so the
look?
sun is
The sun
moving.
rises and sets though.
No, it
So
just moves across the sky.
right, so the sun is moving.
No,
That's like
it
the inner
rises and
light.
sets. It does. It's not moving from east to west. It goes up and down
It don't
on the
go east to
horizon.
west. According to you guys, it actually do go move from east to west. Actually,
Yeah,
It
but
doesn't
it
go up and
goes.
down on a globe, that's for sure.
Yeah, but explain why. How does that optically work then? If the Earth is flat.
How come a plane looks like it's going to
No,
crash when it's
answer that
flying? How
question.
come a plane looks
Answer
like it's
answer
going
the
to crash
question.
when it
hold
flies
on.
away from you? Yeah, when
Answer
it
the
flies
question.
away from you, how come a plane looks like it's going to crash? Can you answer that?
We literally just answered it though. Like you just said, oh,
But
perspective.
you're
And
not.
then,
No,
wait a minute, hold
what?
on. We answered it, and you just said, oh, perspective. And then when we explained it to you, you just rinse and repeat what we answered, and then you're going to ask the question all over again. We just answered it. You don't even have a response to it. What's the response?
A
Because
plane
if the
is moving
response
from
is,
right
oh,
to left
perspective,
into your view. The sun seems to be moving in a circular fashion, though.
yes, east to west.
No, circular fashion. It's not
East to
entering
west.
your view
East
field
to
from
west.
left
The sun
to
rises in
right.
the east. The sun, so-called, rises in the east and sets in the west. East to west. And we're not making claims, and flat earthers is not making claims about sun positions. That's what you guys do. We making claims about the earth's surface, which requires measurements.
Yeah, Tron, I'm
So
just
if you,
saying we all observe and experience the sun to be moving, not the ground. So I'm not going to assume it's the ground just because a textbook said so.
right, unless you got some proof of that.
Yeah, I mean,
But
unless someone can measure the ground moving, causing the sun to move,
yeah,
which they can't.
do
I
you
never
have any?
experienced Earth's rotation.
Okay. So when
Are
you
you on
stand on a mountain,
ChatGPT right now?
what's that?
You on ChatGPT? Are you?
No, right now I didn't. On
Yeah,
this
you're
topic,
on
I didn't
ChatGPT.
ask ChatGPT. I'm just trying to visualize in my head how that's supposed to work. But okay.
Visualize what in your head? How what's supposed to work?
Your argument with the plane and the sun, how that proves.
Well, the plane, he was just talking about perspective. You know, in perspective, everything converges to the horizon, yeah?
Right.
Yes,
Yeah, so when something
that's
gets
basic
further away
geometry.
from
Yeah.
you, it appears to converge to the horizon. When something comes towards you, it goes over your head. It appears to get higher in your field of view. It's just
That's
perspective.
like Rayleigh's criteria. So it's like
And light doesn't travel forever, so eventually, when the sun gets far enough away from you, you'll no longer receive its light, and someone else on the earth is receiving its light, and it's daytime there, nighttime for you.
it's pretty obvious.
So how does that work? That day and night cycle on the flat
Just
Earth.
the sun's movement over the earth and its light relative to your position.
But how does the sun move over that flat Earth?
Well, good question. So, how would you test the mechanism of the sun's motion? Could you test it?
Looking
Yeah,
at the
because
movement of shadows.
in order for
No,
you
that
to
would
test
be
it, you would
looking
have
at
to have
it.
a sun.
That would just be looking at it. That wouldn't be testing its mechanisms.
No,
Yeah,
you're
yeah,
measuring it. You're measured by the movement of the
You
shadows.
could measure its motion and its apparent position in the sky, but that wouldn't tell you its mechanisms that's causing it to move, would it?
this is an apparent position in the sky.
Fucking hell.
But still, using your airplane example, that would imply that the sun is moving in such big fashion that it moves far away from your vantage point, and then it does a circular movement to come around again to start at the same spot it started the day before.
Well, whether the movement is circular or not, I don't know, because I'm not in a position to track the sun in its full cycle. But yeah, it's in a cycle, so it comes back and it repeats the cycle annually, right? And has done for thousands of years. Same with all the stars. All the luminaries, the
Thousands?
sun, the moon, and the stars, they move in repeated cycles and have done for
Yes.
as far as has been recorded, which is, yes, thousands of years.
Well, you see,
Am
but
I
it's
wrong?
not a system, though.
It is a system. The entire Earth, including the luminaries, are a system.
So what are those then?
Well, again, how would you verify what they are?
Okay, but what is the concept? There's no system. There's no concept of a system there.
What do you mean? We're not talking about a concept.
There's no model. What is the complete model then?
Model of what?
Of the flat Earth, apart from the Earth is flat.
You can't model, you can't scale model reality.
In
How would you do
idea,
that?
conceptually, how does
Yeah,
that
but
even work?
if you like, let's say, right, you could scale model a car because you have full access to the entirety of the car. You couldn't scale model reality because you don't know the full size of reality. You don't know the full size of every
But you see the
aspect of
moon,
it.
you see the stars and the
Yeah,
sun.
you see the
What are
moon, you
those
see the
then? What
stars.
are those?
What do you mean, what are they?
What are they for you?
Like, what are they made of?
Yeah, what are they? Are they just paintings on the firmament, or are they actual objects in the sky?
Well, how would you verify what they are?
No, I'm asking what you believe.
Well, I'm asking. Well, my question to you should be
What do you believe?
demonstrative of my understanding of it. You cannot verify what they are.
I don't want to verify. I just want to know what you believe.
Well, why would I believe something
So
when
you
I
don't believe
can't be
anything. So there's
verified?
no complete model. You just believe the Earth is flat and everything
I didn't
else is
claim
not
a model.
provable.
We're not talking about a model. We're talking about the physical, measurable Earth. That's the surface, the
And
ground
everything
beneath our
else,
feet.
there's nothing beyond that.
No. Well, what do you mean there's nothing? There's the sun, the moon, the sky, and the
And what
stars.
are
We
those
observe
then?
those. Well, how would you verify that?
No, so again, so
Yes.
there's
So
nothing beyond
I'm
that.
not.
You can only prove the Earth is flat, and then there's nothing.
Yes. We
Everything
prove
else
the
is
Earth is
just.
flat, and then when you realize the Earth is flat, you realize that the story you were fed about the moon, for example, being a big spinning ball of rock, is also untrue. So then you're left with speculating on what the moon is, and how would you verify that speculation?
You fly to them.
Ah, okay. So how do you fly to the moon? Please tell me.
With a rocket.
With a rocket. Okay. So when are you going to do that?
They've already done it.
They've
Oh, you
already
don't
done
believe
it.
that?
Who's already done it?
Oh, you don't believe? Yeah, I know where you're
Oh,
going with
okay.
that.
So it's just a story that we have to believe.
You see, by again.
Quick
Right.
question.
So we're back to belief.
Quick question. Dude, have you heard Elon Musk talk about going to the moon? He said you have to have like 15 starships full of fuel and you have to refuel it in orbit to get there. So how did they get there on only one
I never
tank
heard
of
him
fuel?
say that, because he wants to fly to Mars.
Yeah, we have NASA scientists saying they have to refill it 6 times. There are different stories here, so what's going on with
Show me
that?
those NASA scientists
Yeah, I'll look
saying
it up
that.
for you. I'll look it up for you.
But that should be a simple math equation, knowing how much fuel is in one of those SLS rockets.
Yeah,
When they depart
they
Earth.
did this. Yeah, they did this. Sorry, I didn't want to interrupt the convo. You go on again. I'm going to look
I'm sure
up the
that can be
sources for
disproved
him.
because I can't believe they used the right math then.
Yeah, I'll send you some links. But
Well, listen, I'm not
continue the
claiming
discussion.
what the sun, moon, and stars are made of. If you want to make a claim about that, then go ahead. But you would have to provide some evidence for that.
There is evidence, but you don't believe the evidence. But so, end of story there. But you don't
Believe
so there's
what
no
evidence?
model.
Believe what evidence?
You don't believe NASA is
I don't believe
correct.
what?
You believe NASA is a conspiracy. The
No.
government trying to hide the
NASA is
truth.
a propaganda agency. They're an intelligence
So
agency,
what
aren't they?
what is the point of
What's
telling
the point?
people the Earth is a globe? What benefit
Well,
is there from that?
to make you think that the Earth's a globe, and look how well it's
But
worked.
what benefit is there? If there's no
Maybe
economical
they want
benefit,
to
why would they
control
do
what
it?
you. Maybe they want to control what you think about reality.
Well, just like what Trump does every day.
That's a
Well, I
fallacy.
guess so. Why does Trump want to do that?
Because of money. Why does he want to have Greenland?
Oh, okay. So
Because
maybe they like money. Maybe they like power and control over
but what
people's
money
minds.
is there from pretending the
Well, let's
Earth
see.
is a
How much
globe?
money did NASA make? Was it $70
Not
million
much.
a day?
How
8
Not
much?
million a
much.
How
day.
much spending
70
is there?
million a
Military
day.
spending compared to NASA?
You say $70 million a day isn't much.
It's
You must
not
be
enough
quite.
to.
You must be quite loaded.
But yeah, $870 billion on military. Why?
Okay.
Why
What does
that doesn't
military
make
have
sense
to
then?
do with
So you would.
NASA?
What is the
If you
point of not
if you were getting
believing
a
the
chunk
Earth
of
is flat?
$70 million a day, you'd say, well, that's not much because on
But
this other group are
why
getting
you don't have
way
an answer
more
to
than
that?
that.
What is the point of that?
I would take a fraction of that.
Yeah, some people like money and controlling people's minds.
For what? To what end?
Well, I don't know. You'd have to ask them because we're not them.
That's a fallacy.
Then
Appealing to
what?
motivation.
Then what? NASA, the elite? Or
Yes,
who's them?
NASA are giving you bullshit stories about the globe and space. Yes, that's true. Why are they doing this? Could be a whole host of reasons. Are we them to be able to tell you exactly what it is? No. I could give you some pretty good speculation, but I don't think you deserve it.
I don't think you have any good speculation. But money
Yeah, we
would be
do. We do.
a good argument. But yeah.
But it's not an argument. It's not an argument. See, the argument was that the laser hits the target 30 miles away, and you know that's a good argument because you couldn't come up with any even attempt at an explanation for how that would work on a
Not
globe.
myself, but ChatGPT
Not
came with
yourself,
good
not anyone.
explanations.
Listen, we've been doing this for years.
Yeah, exactly. I know. Yes, exactly. You've been committed to that.
And ChatGPT can't
It's the
either.
same reason
They
why
can't explain it either. They can't explain it either, Tron.
It's the same reason why Muslims know the Bible better
had
than most Christians.
astrophysicists, we've had PhDs, we've had all kinds of people through
Yeah.
here. None of them can tell us where the curvature is either.
Yeah, that should be like that's the foundation of
Where it is, it's like you have to find it. Okay.
Yeah, you have to find it and measure it, but no one can, Tron. No one ever has. Isn't that weird?
That's the foundation of your entire claim.
It's not my claim. I never.
Okay, good. I'm glad you don't believe in it, Tron. Good for you.
Tron,
I didn't come up with this claim. It's not my
pasted,
claim.
I know you didn't. It was just a story told to you.
For you in the chat. 16,
But you tell me a story as well.
It was 16
No, I'm not telling you a story, Joe. Tron, I'm saying you can go outside and see this for yourself.
Exactly, and I see. I don't see what you see.
You see a flat horizon. You experience a motionless surface, same as all of us. You experience the sun moving, same as all of us.
Do it feel like you moving?
But already there, I'm not on the same page as you with the sun moving.
Yeah, you do. You are. You experience it. You believe something else, but you directly experience what we experience, which is the sun moving.
It doesn't prove
not the
the
ground.
Earth is flat.
I mean, we act.
You experience. You experience it flat. It doesn't matter what you believe.
Yeah, we asked you earlier, do you see the sun moving? You said, yeah. Now you're saying that's different.
Yeah, but your argument for why it rises and sets with perspective doesn't really make sense.
Well, why doesn't it make sense?
Because the scale, because a plane moves into your view field. And if a plane comes from left to right, it's the same effect. If it comes from right to left, it's the same effect.
You already agreed with this perspective. Things converge towards the horizon line.
Yes,
over
but
distance.
the sun doesn't work for me.
Same thing.
No, it's not the same thing.
Well, why would the sun be any different?
Well,
The
yeah,
sun is in that location.
Why wouldn't it be the same thing?
So why is the sun a different size depending on where you stand?
You guys, astrophysicist says that the sun is in the apparent location, that you actually not seeing the sun. You're looking at the sun dead light. So why wouldn't that work?
Seeing what?
You guys, astrophysicists, people like Neil deGrasse Tyson and other astrophysicists that agrees with him, said that you're not actually looking at the sun when you look at the sun in the sky. The light that you are receiving from the sun, because it's so many miles away, if the sun was to disappear, you would still experience that light for some years, and then the sunlight will eventually go out because you are looking at the sun dead light. So
So
the
you
sun
would
moving away, wait a minute. So the sun moving away, right, where you no longer being able to see that, why wouldn't perspective work for that?
just to correct that up a little bit, it would be 8 minutes, not years. It would be 8 minutes after the sun disappears, you would stop seeing the light.
Yeah, whatever he said. Well, Neil deGrasse Tyson said 8 years. He got a whole
Hey,
short about it.
Soapy,
It's
maybe
not
you can help
8 years,
Tron
man.
out.
That's not
We're
even. That's not
looking.
true.
Tron wasn't able to provide, or Tron wasn't sure what the evidence was for Earth being a globe. Soapy, do you have any evidence?
Well, like, what do you want me to like try and touch up on for the
So,
Earth being a globe?
okay, so what we're looking for specifically is empirical evidence. So things that we realistically, as members of the public, could go and verify, measure, observe ourselves. So we don't want
Okay,
just to
so
rely on images or videos from unverifiable sources like NASA. We want empirical evidence. Anything like that?
yeah, I know what you mean. I know what you mean. You guys talked about the sun and the Earth moving east and west. So could you like explain that to me one more time so I can just like quickly touch up on that? Because I low key like zone out a little bit and I'm not
Yes.
like
Just
fully
talking
paying the
about.
conversation.
The sun
All right,
stuff.
all
I
right.
mean, you have no evidence on the ground that we're talking about. No direct evidence.
He just wants to
So
know.
like,
All he wants to know is how the sun moves. It moves from east to
or
west.
not
It rises
Or
necessarily how
in
the
the east,
sun
oh,
moves,
that's
but
west. Rises in
so
the
like,
east, that's in the west.
I mean,
if I'm not mistaken, what I heard earlier was you guys don't think the Earth moves.
No,
we
the Earth's
don't know
not
what.
moving. The
may,
sun moves.
Yeah,
may I
we
say
don't.
something?
Could one person talk here? Like, I can't listen to three people at the same time. Thank you, appreciate it. But I'm asking, so like, you guys don't think the Earth moves?
No, the Earth is stationary, bro.
Okay, wait. So hold on, real quick. If you take a ball that rotates, I'm trying to think on how to put this
Begging the question.
because you can.
You don't have a ball to use for an example first. You need to measure the globe, measure the ground, and say, "Oh, it is a ball." Then you can use a ball as an example. But if you
Yeah,
can't do that,
you need a symmetrical ball.
yeah, you need to
Begging the
measure
Or
something first to determine that you are actually standing on a ball, don't you?
Here's
Don't you need to measure the ground first to determine that?
Me, this with the whole thing I've been asking.
Yeah,
Or
Soapy. Here's this will
May,
this will
may,
help you out. This will help you out, Soapy. So, do you know what the claimed rate of curvature of the globe is over the surface?
I do not currently.
Okay, so they say it's about 8 inches per mile squared. This is based on a 3,959 mile radius ball. I'm sure someone in the chat can post the table, which gives us the geometry of the ball. So over 1 mile, it's 8 inches, 10 miles, it's 66 feet, blah, blah, blah. Okay? So there is a geometric curvature that is claimed of the surface. Now, what we're asking for is where has that ever been measured? Because when we go out and try to measure it, it's just measuring flat, no curve.
So, if I'm not mistaken, the human eye does see to a degree 2 miles until it's not rendered. If I'm
Right,
not
okay,
mistaken.
but now that we're in 2026 and there's all kinds of technologies, who in all human history has measured this 8 inches per mile squared of curvature drop over the
I could
distance?
not tell you that question.
Well, is it something that you could look up? I mean, you got Google in that, no?
Yeah, but
may I
Because
just inject?
that's where we need to start, right? Because any argument that you make about the global, there's gravity, there's satellites, NASA, all this, that's all going to assume that 8 inches per mile squared a drop. So we need to see that measured first. That's
May I
step
inject
one.
quickly?
That's step one of the globe. No, Tron, you were speaking for a little bit. Let's give Soapy a chance here. Unless, Tron, you found that measurement, because we asked you the same thing like an hour ago, and you didn't give it
One
to
last
us.
thing about the sun. You
No,
mentioned
we're
it.
not. We're onto the surface curvature right now.
But you
You
were
can
wrong
ask
there.
your thing about the sun later on. We'll
But you
come
were
back
wrong
to
there.
it.
You all guys are wrong on that.
No, we're right. Remember, Tron, because there's no curvature.
A plane gets smaller,
Just like your
right?
Tron games. No curve.
The airplane example, though. It's
No,
just
not
two
the
sentences,
airplane
okay?
example. Airplanes aren't measuring
Just two
curve.
example. Just
Airplanes,
two
okay,
sentences,
we're going to
man.
talk about airplanes. Pilots treat the Earth as flat
The
and
airplane example. It
when they
gets
fly,
smaller the farther away it gets from you, right?
as does any object.
Not the sun.
Yes, also the sun.
The sun doesn't get smaller when it
Yes,
suns.
it decreases in angular size. Yeah. So, Soapy,
Okay.
anything for that curve measurement?
I don't have anything on curve measurement. But what if you take the Earth rotating? It undergoes centripetal. I don't know how to say it. Centripetal acceleration,
No,
whose
see,
magnitude is calculated using a equal v to the second power
hold on a
/r.
second. Before you get into the details of the calculations, that rotation that you're claiming assumes that curvature. We're going to need the curvature first.
Again, I could not grab the.
Okay, well then we can't really just
curvature.
assume it and then talk about an assumed rotation on top of the assumed curvature that we can't prove. You see the problem?
Okay.
Yeah.
I mean, like, I don't know why I'm in this conversation. I just corrected that light moves. No, that the sun would just be gone after 8 minutes
Yeah, but
due
that,
to
I mean,
distance and
that's
light
just a story you've been told as
refraction.
well. That's just a story you've been told. So we don't have any curvature, we don't have any motion of the Earth. The sun is moving, the Earth is not. That's it. Okay, good chat. Glad we're all on the same page.
No, you're wrong. The sun doesn't change size, but if you believe that,
Oh,
fine.
the sun
No,
doesn't change
it does
size, does it
change
not?
size. Yeah, it does. It changes.
You see it with your eyes.
But
You can measure that.
let's see. Someone can post some examples in the chat.
Oh, you just got to put a solar filter on a camera, and you can do it with
All
the
right, yeah,
time lapse.
yeah. Give me your examples. That should be fun.
Oh, all right. So, are you going to be a flat earther if I go get you an example?
No, not no.
Oh, well, then why would I waste my time?
If you see the,
because I'm wasting your time here. Because here it's just fun. I just want to see how you prove that
so
the
you're
sun.
just here to waste our time.
You just no, but you prove. You said that the angular size changes with the sun, but that's not.
Okay, when you see that, what are you going to say next?
I'm sure that can be disproved too. Let me just look at it.
You're already saying it doesn't happen, but if it does, I'll come up with an excuse.
My old dude posted it at 55 minutes after the hour.
What the fuck is this video?
He could see the future, guys. He already knows.
Oh yeah, so
what is this
55
video
minutes
even?
past the hour. That seems to be getting smaller, wouldn't you say?
They are zooming at the same time.
They're zooming at the same time. Doesn't look like it. The rest of the image is static.
Zooming.
There's no movement
They're
of the
zooming,
hills
man.
or the land.
Well, nobody's zooming.
There's no zoom in that. What are you talking about?
Bro,
Look at the beginning. You see the edge
The
of
sun's
the
zooming
ocean.
away. That's
No,
about
there's-
it.
If it was zooming,
come
that
on,
hill that you
get
see on the
the fuck
right,
out of here, man.
Tron, if it was zooming, that hill that you see on the right wouldn't stay the same the whole frame.
I'm looking at the second video.
Oh no, you're ignoring the first one. I got it.
No, the one above it. It's the GIF that we're talking about, the sun changing size.
Give me something in HD quality, not this pixel.
Okay,
Oh,
DJ,
he's got another
56
excuse, the
after the
HD
hour.
quality.
That's HD quality.
Okay. I do want to cut in, but I do
DJ
not want
posted
to cut
another
you
one.
guys off.
Okay, what about this one as well that I just posted?
Don't give me GIFs. Give me the original video.
Don't give me GIFs. Why not the GIFs? What's wrong with the GIFs? It's the GIF that keeps on GIFing.
The GIF still does work as a movement that the sun is moving, but Yeah,
And it's
it's not
appearing
going to
to
be
get
any different
smaller
in
in
a
angular
in an
size,
actual
isn't it?
video.
The thing that Tron said definitely
He
doesn't
wants the,
happen.
he wants the original film. He wants the original footage.
Yeah,
Guys,
Okay, wait,
give
so
me the
We gotta
freaking
go wake
camera.
up the guy. The
Okay,
guy's
just give it.
sleeping. We gotta go wake him up, get his actual his actual memory card, and give him the copy so he can look at it, because that's not good enough.
So there you go, Tron. You just got debunked again. Come on,
wait,
dude.
wait,
Well,
wait.
I'll
So
debunk it.
let
Just
me,
give me a second. Just give
can
me a
I,
second.
Wait a minute,
guys, can I cut into here real quick? You guys said there's no curvature, like at all.
Yeah,
Like that's just what I'm understanding. You, that's what you guys
correct.
said.
Correct.
Okay,
Yeah,
so
no
wait.
exponential curvature. Yeah, no exponential curvature that comports to the radius value. That's right.
All right. So like, what if we take an example of you going to like sea level, like the exact point of sea level,
Gave it
and
away.
you no. Listen,
The speed.
You listen. You go to the exact point of sea level, okay? You watch the sun set, and then you go up to a higher
Oh,
point
I
than
know
sea
what's
level,
happening.
Okay,
and
but
then you
just
watch the
quickly,
sunset
bro.
again.
Just quickly before we continue this, is the sea level level then?
Yes.
Okay, well level is flat, so there you go.
it just proved a flat Earth, bro.
No, that's not. No,
Yeah.
you're just
Oh
missing
Yeah.
what I'm
my
trying to
God.
Yeah.
ask. You're
Do you
Yeah.
again.
understand
You're.
language?
So it
I
doesn't really
do
matter what
understand
the sun
English,
does
but
above the sea
No,
level.
not you.
The
The other guy.
sea level would be flat.
no, you're not listening to what I'm saying. Okay, you're just like throwing into a
I
point mid
did. You said you
interruption.
see
Okay.
the sun, then you go up a high building and you see the sun again over a flat sea level.
Yeah. Welcome to the flat Earth. Get your
Yeah, that's what we're
t-shirts.
saying. The water's all flat. It's level.
Okay.
Okay?
It's not flat because
Good
the
stuff.
ground
Yeah,
underneath is not flat.
remember, because of the laser hitting the target 30 miles because it's flat.
No, I don't forget that, man.
No, forget that. Forget that. Tron, how can we forget that? The laser hits the target 30 miles away because it's flat.
You can never forget that.
You want to do like a
Well,
Men in Black mind eraser trick? Forget what you've seen.
yeah, but laser is a light. It can be influenced by air, by the atmosphere.
Oh, but not by a curve, right?
Really?
What has that to do with curve? It just
Well,
means
because
the measurement in
that's
that
what we're
video
pointing out.
cannot be
There's no
correct.
curve because according to the globe there should be a curve blocking the laser from the target. That's the whole point.
Yeah.
But
It's
it
supposed
doesn't
to be.
happen
Oh
because
yeah.
there's no curvature. Just like in your Tron game. I want you to remember next time you're fantasizing about your Tron world, that's like the Earth.
That's inside a computer. That's not the world.
Oh. Yes. See, that's what we're looking for. This is sometimes it's not even the people we're speaking to whose minds break. It's just like casual
My mind doesn't break,
listeners.
man. His
It's kind of
reaction is
already
what
broken,
most
Tron.
people think about
It's
here,
like when
but
you were like, the sun doesn't change size, the sun doesn't change
it
size, and then we
doesn't.
showed you one clip, and you're like,
I
that
just
doesn't,
don't know. The
that's zooming
problem is
in.
you already spent
That's
time.
not HD. I want the guy's
You
memory
spent
card.
so much
That one
time
doesn't count.
finding these
That one's not
evidences.
real. You guys made that in paint. I mean, you're just making things up at this
I
point.
don't know. Because I on the spot I don't have all the events because I don't spend time
I know,
learning
Tron. I
about
know,
this.
Tron. But that's like me saying, that's like me
No,
coming up
but
to you
if I
in
have
in a subject
time,
that
I
you're an
can
expert
debunk that
in.
too
It's
because
like
there's
me coming up to
explanations
you,
for that.
Tron. It's like you saying, "Hey, this is the case in Tron. The Tron world, this happens. This car can go this fast." And I'm saying, "No, that's not true." And you're saying, "Well, I'm an expert in Tron. I've spent years researching Tron." And I'm like, "Well, I've never looked into Tron really, but you're wrong because I just believe the yellow car is faster than the red car." That's like what you're doing. You don't know anything about it. We do. So why are you arguing?
You know about
Yeah,
the evidence that you bring
it
up.
is getting to that point though.
You
Why
know
is
about
you
the
arguing?
evidence that all the Globers
It's
bring up.
like I said earlier. It's like Muslims know so much about the Bible
No, it's nothing
because
to do
they
with
like to
Muslims.
argue
It's to
about
do
it.
with geometry and science, Tron.
Yeah, it is getting to the point of why
Just
is you
give
arguing?
me a minute, okay? I'll find an answer why that
Dear
explains that.
ChatGPT, please help.
Yeah, about ChatGPT. Let's see what you
Save me,
say to that.
ChatGPT. Save me.
Why is you even making an argument? You haven't even studied none of
ChatGPT
it.
says that NASA says that Earth is a globe. Therefore, Earth is a globe. Come on, Tron.
Yeah, you got to do better than that, bro. Like if you don't know it for
What
yourself,
ChatGPT says the sun isn't moving, therefore my eyes are wrong.
No, this is not about the Earth moving or the sun moving. This is about
I know, but it's all the same, Tron, isn't it?
how the sun works on the horizon.
You've been convinced to ignore your
Because what you
senses.
see there, I've never seen it with my own eyes.
You've been convinced to ignore what you experienced in reality in favor of a cartoon from
Have you
the
seen
US
this effect
government.
with your own eyes with the camera?
Yes.
What?
We all see
I
the
have.
sun move.
Have
have.
you done? Have you
We
done
can post
your
a
own,
ton of videos for you of people doing
No,
it.
have you done it yourself?
Yeah, I've watched thousands of
No,
sunsets.
have you done
not?
it yourself? With the
Have you
camera?
not seen the sunset?
Most flat earthers have done this. Yes.
Yeah, Tron, we've
Have you
been
ever
to the
seen the
beach.
globe with your own eyes, Tron? You ever done that?
We've seen sunsets.
No, have you
I mean,
taken a video like that with your camera?
we have videos that YouTube haven't not deleted most of them.
Have you done your own time lapses?
Hold on. It's 2014. Flat Earthers has videos tracking the sun. Many of them.
Have you made your own time lapse and
What, are
experienced
you
that
saying that these
effect?
videos are fake or something? They're fake videos?
No, I'm just asking. No, but have you done it yourself, this experiment? Because this is a simple experiment. You can do it with a smartphone.
Why haven't you done it, Tron?
Yes,
No,
I've
I
done
never,
it before.
I've never done it
I
with
have
time
done it
frame.
before.
Time
Yes,
lapse.
I have done it before. Yes.
Only you.
You asked if any of us done it. I
Then
answered you.
Then
Yeah,
show me
I've
your
done
video.
it.
Does it show the exact same effect
That
as
was
those
like
gifs?
5 years ago, dude. I don't know where that shit's at. Which
Ah,
computer?
okay.
Yeah, you'll see all sorts of crazy things happening on different days due to the weather conditions. When you watch the sunset, sometimes it looks
So
like
what is the
sun
explanation of
sets
that then?
above the horizon. Weather conditions can alter the way you view things when they
Why?
get closer to the horizon. Like we have things like green flashes and all
But why
sorts
does
of
that
crazy
sun
things.
move like that in those examples then?
What are you talking about? Why does it move like what?
Like in those examples, because you
Due to
cherry pick
perspective,
those.
things
you
converge.
cherry pick those.
No,
Why does it in one
things
of them it looks
converge
like the
into the
sun is
distance.
moving away almost?
Yeah, that's what we see.
Oh, it looks like it's moving away. That's weird.
Yeah, Tron, you would get the answer if you just be quiet. You got to let the person answer the question.
Yeah, you're
Why
the
does
not
student,
even
the
remember?
just
sun
that.
look like it's moving
What?
away?
Yeah, well, not only that. I mean, do you even know what the sun is, Tron? Can you really speak any knowledge on what the sun is and what you're actually witnessing when you see it go overhead and when you see it set? I mean, what could you possibly figure out about it?
Not more than you then, if you just look at the evidences from your eyes.
What you could put your hands on and what you could test, right?
Would you prefer we used our imaginations, Tron?
What test? It gives it emits heat and light. Okay, we can agree on that.
Cool.
Yeah, basically what we experience on here on Earth, right?
We keep trying to talk about the actual empirical evidence over the surface of the Earth. You guys keep bringing up the sun and things like that. We never brought up the sun as an argument.
Because there's no model. You just
You don't. Yeah, we just debunk your silly model that you think you have.
But
right?
you don't
With the
have a
curving
model to debunk.
Yeah, we don't need a model. You're right.
Yeah, if you have a Ferrari, you don't need a
curious.
model Ferrari, right? If you
I'm
have
just
a
curious how
horse,
the
you don't
world
need a
works
model
for you.
horse. You just have
I'm
reality.
just curious how the world works
Tron,
apart from
you're
it's
not
flat.
curious. You're not curious. If you were curious, you would be acting curious and asking genuine questions. You're trying to argue for your
I asked
globe belief.
you.
No, but you're asking it.
How does the
You're
sky
trying to
work
argue
in a
for your
flat Earth?
globe belief. It's like you're upset that the Earth isn't a globe. So now you're trying to
How does the sky
say, well, it
work
can't
in
be
a flat
flat
Earth?
then, when in reality it obviously is.
Why would the sky need
check
to
it out.
work?
We have to know how the sky works because we measured the Earth flat. Because the Earth is measured flat, people have to know how the sky works.
Yeah, we've done the Earth bit, right?
I have one
We
question.
figured out that the Earth is flat. Maybe you guys can figure out what's going on in the
How
sky.
does time
How
work
about you guys
then?
do some? Why don't you guys do
Can
some
I
work?
can I
We have to
ask
do
you guys
everything for you
one
guys.
question?
What's up,
I have
Sophie?
one. All right. So, do you know exactly how far away the sun is from the Earth?
How would you
No,
measure that?
How
So
would you
you
measure
don't know. Like,
No,
it's
we
a
don't
Do you
genuine
know,
question.
Sophie?
Measure
Sophie, do you know?
How fast does
That's
light
Tron,
travel for you?
chill. Sophie,
That's no. I'm asking so I can do calculations on how fast light moves versus how far the sun is away from the Earth.
No,
Luck
you
with this
can't
one,
know
guys.
then,
Enjoy.
because I tried to do
But you
that
can
about
measure how
40
fast light
years ago,
travels.
dude, and I didn't have the answers then, so you don't have them now.
But you
Right.
can
You
measure
don't know.
how fast light travels with a laser, for instance.
Only
And
one way. It's two-way speed of light. You can only measure two ways, so we don't have a one-way speed of light.
How's that going to help you determine the distance to the sun anyway?
Anyway, Tron, what you're experiencing right now is cognitive dissonance, and my advice is to just sit back and listen for a while and take it all in before you continue arguing. You know?
You're throwing shit at the wall and hoping it sticks. That's kind of what's happening here.
It's good content
I
for us.
know,
But
that's why I came for a laugh, because I know that's how it is. But
yeah, you constantly saying you don't know every time we push you to something. You constantly say,
you
"Well, I
don't know
don't know."
either. How many times you deflected with a question because you don't have an answer?
We haven't deflected at all. We only just answered yours and asked you one, and then you say you don't know, and then you tell us we don't know.
You only know what you want to know because you spent time. You're committed to this. That's cool.
Yeah, we committed to how the Earth is measured flat. Yes.
What's wrong with knowing the things that we're committed to knowing?
There's nothing wrong to be committed to anything. That's cool.
Yeah, we know the arguments and reasoning behind this argument, right? You're in the Flat Earth Discord channel, right?
I
and
know.
we're
That's why I'm here.
experts at this topic, which
I
involves
know.
knowing a lot about the globe and knowing a lot about what the flat earthers are claiming as well. And then
Yes.
we're trying to show people empirical evidence and see what empirical evidence they have as a counter. And
But
then
you
we're trying
always
to
show
come
the
to a
same.
No, I could
that's-
sit here. I could sit here for the next 20 hours showing you observations that you've never seen once in your life that are impossible on a globe. But then if I ask you for one, you're not going to be able to show anything.
But why does it prove that your Earth
That's
is
the
flat?
challenge.
Because there are certain characteristics that would have to be present for the Earth to be a globe, and they're not present. Consistently not present, and there's no evidence that they exist in the first place outside of a theoretical mathematical construct, which is the globe.
Why then can't you travel to the end of this flat Earth?
We're not claiming to know the shape or size of the Earth. Flat's not a shape. You guys are claiming to know the shape and size of the Earth. When we test it, we can't find any curvature. So it cannot possibly be what you think it is.
Traveled then? Tried to
Nobody
travel.
even from the globe side has continued going south and come back around the other side of the globe to where they started. So even the globe earthers haven't done what you're suggesting we should do. There's also the Antarctic Treaty, which makes it extremely difficult to travel past 60 degrees south, and it's also extremely hostile in the far south, obviously. So as far as we know so far, no one's kept going, and we're not even saying that that's where an edge is. We're not claiming that the Earth is a specific object or anything like that.
You can go around the South Pole.
You can go around the South Pole. Okay, who did that?
No, I'm just technically you can do that, right?
That wasn't. You didn't say it wasn't a question. Now it's a question. Oh, I don't know. No, I'll say no.
No question. I'm just questioning. So the South Pole on your model goes around.
I don't have a model.
So let me keep up. What do go around the South Pole mean? What do you mean by that?
No, I'm just trying to picture this model of yours.
No, it's just the Earth is measured flat. That's how it's measured. That's how you experience it.
So there's the continents, and then there's the South Pole, and then there's nothing, or what is there?
Audio chaos, bro. My microphone is messed up, so every time you talk over me, it's going to cause audio chaos. Listen to what I'm saying. When I'm done talking, then you can respond. Is that fair?
Yes, go on.
Okay, great. We're not claiming a model. We're not claiming a model in mathematics. We're claiming an observation that we all can experience. We're claiming observations that we see because we're talking about a concrete noun. Now, we do use mathematics in the sense of geometry, but the only thing that is required whenever we're talking about the Earth's surface is the Earth's surface. That is the direct reasoning that we're using, and that is the only direct reasoning that we actually need. Now, you guys claim a model because you guys have all of these so-called scientific claims and mathematical claims to them, which means that you have a mathematical model that requires a physical observation to back the mathematical model. You can't simply say the math works and the science makes sense, so therefore the model works. Therefore, the model is true. The model needs the physical observation that we all can experience and see in order for the model to be true. It's the physicality of the physical natural world which validates the model, not the math. So you saying that we don't have math or a mathematical model, or saying we don't have a motto, like you keep saying, but we have the physical proof and observations of what we're saying, which is called measurements of the surface, that don't mean anything. It's not a rebuttal because we're not claiming a mathematical model. We're claiming the physical aspect of a physical earth. And this is what we see, and this is how we can prove it with observations.
I was talking geographically. How does this world look for you? Where's
Flat.
Africa? Where's Japan? Where's the North Pole?
Top
Where's
of
the
Africa.
South Pole?
Yeah, these locations are given by coordinates, right?
Yeah, but how would that look then? You can travel to the
Well,
south of
it would look,
Argentina.
yeah, it would look however you map those two set of coordinates.
Yeah, but why haven't you done all that yet?
But we have. We just happen to use a spherical coordinate system.
So how does this flat Earth map look like?
What do you mean?
Well, it depends. So listen, you're confusing coordinate references with reality, with terrain. What Regjo's been trying to tell you is that terrain measures differently than how the coordinate reference system is applied. That's all.
But you need a map though. You need to know if you want to look up where Tokyo is. How is that?
Yeah, we use a spherical
situated?
coordinate reference system. Works just fine. There's no problem with that. Now, is it accurately representing reality? No. When we make the measurement, like Regjo was saying, we find a discrepancy.
And why is there no accurate flat Earth map then?
Well, that's wrong to say. There actually is. The entire British national grid system does not use spherical coordinates, uses flat coordinates. So you just don't know what you're talking about, okay? And you come in here all smug.
No, but what does that? Where's that map then? Show it to me then.
You want to see it? Okay, Google British national grid system. It's part of the UK Ordnance Survey.
Ask him if he's going to be a flat earther if you show him the evidence, because I asked him that the last time. He said no. We showed him anyway, and he just said, "Nah, you guys made all those pictures up." So if you give him a map, he's going to say you made it up.
Yeah, he is.
The grid system, okay, yeah, but where's the complete map? That's on a UK.
Oh, you want to pay for a complete survey? You want to maybe pony up more riches and wealth than the King of England?
Yeah, because
so the shape of the countries, you agree with that then?
For a second, you will be asking us to do more than the King of England.
Well, then someone did a lot to
Okay, but the globe ain't do nothing but take flat Earth measurements, right, using elevation angles, and create and calculated their own radius value using the ellipsoid and the geoid. So you're actually asking us to do more than what the globe did, because the globe ain't do nothing but put a mathematical model to physical measurements.
I'm just asking how this flat Earth looks. If you would look at it from the top.
Just told
down.
you. What you mean? You're looking at it up and down. You live in it. You don't have no choice but to see how flat Earth looks. What you mean? That's why we asked you the questions earlier. Do you feel yourself moving around?
So you basically say you take this globe and you spread it out on a flat table, and that's your map, basically. So you accept the shape of the oceans, the shape of the countries.
We're not claiming any shapes, and you seem to not be getting it.
I'm asking you, if you go to the coast of England, you walk around it, you see what the shape is of the coast.
Okay. You walk around on the flat. You walk around 2D on the map.
A map is 2D, yeah, isn't it?
Yeah, it is. So you're talking about you. So you were discussing flat already.
No, I'm just saying
Let
how
me
it looks.
let me ask
So
you this, Tron. Tron, do you understand that when you go outside and you use your coordinate system without the sky, you have no coordinate system? You understand that, right? Like you can't just look at the ground and say, "Hey, this is 35 degrees north latitude." You realize that, right?
on a smartphone, I don't know, man. I get it from
On a
satellites and
smartphone,
the
how did they
network
do it
towers.
before that? How'd they do it before that? All they did was transfer that map into the smartphone. Don't be stupid.
Yes, but your position doesn't come from that. It comes from
Your
GPS
position
signals
comes from your observation of the sky. It has to
and
do with your
triangulation.
perspective and what the stars look like to you in your location.
Right.
That's it.
Actually, that's where all the ground positions come from. Actually, it do.
Yeah, but a smartphone doesn't think like that. It uses triangulation of some signal.
Triangulation of the stars in the sky, celestial bodies. It's called celestial navigation, bro.
What, the sun, the stars send a signal to my smartphone?
No, they all have recorded mathematical ground positions. They call them math points using the ellipsoid correct.
But how can it live determine your position?
What do you mean? My position is that the Earth is measured flat, and that's what they do.
He's saying that satellites in the sky determine your position. He's being stupid.
No, but how does it work then? When you enter an address in Google Maps, it tells you, oh,
Yeah,
you're going to
they
be there in
took the
15
same
minutes.
math from the same perspective, and each person has their own perspective.
But how
and
does
they
it know
use
how
that
fast you
coordinate
go?
system on the satellite system. It's not that hard to figure out.
But how does it know how fast you go?
Hold on, Tron. Do you think they're using satellites to get the
I'm
coordinate
asking
system?
you how it works for you. How does it know how fast you go and how far you have gone already?
No, there's a way that it works. I'm asking you how you think it works. Do you think
No, explain it to me then.
How do you think it works?
Network towers and satellite, and then triangulation of those signals.
So they're using the triangulation of the satellite itself, or they're using the triangulation of something else,
And
like
network towers
latitude.
as well.
Listen to what I'm asking you again. Are they using triangulations connecting to the satellite itself as a celestial body, or are they using something else that they call it the celestial body, such as LAD?
What celestial body? Satellite is not a celestial body.
It's not exactly. So they are using latitude, longitude, right?
Yes.
Right.
But not for your live position though.
They are using a DAC system, right?
Okay.
He probably doesn't know
Yes.
that. You know what? GPS
Yes.
uses Earth-centered, Earth-fixed, ECEF. Do you know what that is?
Right.
For GPS, ECEF is a coordinate reference system used by the receivers. This is a flat coordinate reference system. It's a flat square. Every GPS receiver using ECEF delivers their local coordinates as a flat square. And you think it's a globe.
GPS stand for?
Well, you think it's connected to
this is not an argument for it to be a globe.
Here's what it stands for, okay? Global is also a word that could just mean universal or all-encompassing.
This is not an argument for it being a globe.
What's not an argument is how GPS somehow proves that Earth is a globe. GPS will deliver you coordinates. Will deliver you coordinates and distances in accordance to any coordinate map system that you choose. Flat, bowl-shaped, dinosaur-shaped, moon-shaped, or globe Earth-shaped.
This was not even an argument for it to be globe or not. I just want to understand how this map
Why'd you
works
bring it up
for you? Because
yeah,
I want
well,
to understand
some
how
of us
this
actually
flat Earth
understand
looks.
how it works.
Now,
Do you know that GPS satellites also don't inherently know where they are, that they're told where they are by ground stations?
Yes, but I just wanted to understand how this map looks for you.
He just told you
It
a flat
depends.
Earth.
How
Listen,
the
it
continents
depends
are
on the
laid out.
coordinate reference system you use. Like I've been saying, you can make the map look however you want. If you choose a different coordinate reference system, you'll have a different outcome. Have you seen all the different projections of a globe?
Yes, but if you go outside, England is where it's always going to be if you look at it, right? No matter what
really.
map coordination system you use.
Not really.
I'm
It
just
depends on what map you're looking at.
so like 500 years ago, when they didn't have all these technologies, they drew these maps by hand
20 years ago, they said they had sea creatures in the damn sea.
by the observation.
Okay, we'll find out. By flat Earth is going to look a bit different than the globe. We can actually see that with the UK Ordnance Survey that was 15 minutes per hour.
I understand
The
that.
British
I
National
just
Grid
want
System,
to-
when overlaid onto a globe, the lines, the meridians don't line up with latitude and longitude. The meridians and the latitude don't line up with globe latitude and longitude.
So why
So if you're going
has
to take positions on a coordinate system and fix them to those coordinates, regardless of their true distance and orientation, you're going to have a different outcome every single time. Everyone knows this.
why not strap a camera to a weather balloon and then take a photo?
Yeah, why don't you just tell us what's really on your mind and say you want to see flat Earth from outer space? You want to see a space pizza, right?
Well, that's what you believe in, right?
No,
Okay,
we don't believe flat Earth is a space pizza, for fuck's sake.
Oh, you don't.
Can I just,
You believe the Earth is infinite?
No, we don't believe that. Jeez, dude, you have no fucking clue, do you? It's because you're not listening.
No, but you didn't tell me how it looks. Then for you, you don't know how it looks, and you don't care about how it looks.
Well, how do you know how the globe is supposed to look? When NASA shows you an image of the Earth from outer space and you see the globe, how do you know it's supposed to look like that?
Who
said it? Okay, guys.
No, why don't you answer the question? How do you know the globe is supposed to look like what NASA shows you?
Because I know how cameras work.
You know how cameras work.
I have the same camera they have on the ISS.
Yo,
You had the same, like what? Like Don Pettit's camera that he takes in the cupola?
No, a Nikon Z9.
Now, is that camera mounted to the outside of the ISS?
No, they take it both from the outside when they're in suits and from the inside as well. Yeah.
Tron, the ISS.
You're so full of shit.
Tron, the
Yeah,
ISS.
but how does the flat Earth look?
No, you're so full of shit. You can't take that Nikon and put it in outer space.
Why not? Of course you can.
Yeah, because all the seals will off gas in the vacuum, dumb shit.
You idiot, man! Because of course it's modified. I'll show you a picture how it
the
looks.
lens will get distorted and warped due to the temperature. The thing will become effectively useless within seconds.
Of course, it has a heat shield around it, man. Oh my god.
A heat shield? It's freezing cold, dumb shit.
What kind of heat shield? What's the name of the heat shield? What's the chemicals used in it?
All right, guys. I just wanted to retract something for Reg Joe, real quick.
Well, why don't you guys stop lying?
I'm not even with Tron, bro. I have nothing to do with Tron, Yoder.
Thank God for that, right?
So, Reg Joe, you said that this.
Bro, you're kind of lying right now.
Reg Joe.
Earlier. Well, what is it, bro?
I was not supporting Tron at all. I just got brought into a conversation that had nothing to do with me. I want to do fact check. So you said these astrophysicists said it would take 8 years for light to.
It would take 8 minutes. I misspoke, bro. 8 minutes. I got you. You done?
No. That's not what I'm saying. I'm so yeah.
You done? I misspoke.
No,
it's 8.3 minutes. I got you.
Okay, but that's not what the point is I'm trying to get on either. I'm not saying it would be 8 minutes. So from what the position that Professor Triangle PhD gave me, light would reach the Earth from the sun in 0 seconds.
Perfect.
No, it won't. It will last for 8 minutes, like they said, bro.
Oh, he asked me how far it is, and I gave him Matthew's measurement for the sun. So he calculated using Matthew Learns, the professor, the glober, his measurement to the sun.
I used your measurement. I'm so confused.
That's a glober's measurement.
That was a globe, man.
If you read back and you see what I say about it, so try 3,400.
3,400, yeah.
Matthew got somewhere around there or something. I'm not on that computer, so I'm working.
My thing is, how would you verify that?
So what does that have to do with anything now that it takes 0 seconds?
Yeah, and how
He
would you
said,
verify that?
"What do you mean? How did I verify that?"
How would
So
you
what the
verify? Because
So
you
you
said
guys,
hold on, Reg Joe. I want to know what the speed of light has to do with light arriving. What does it have to do with the Earth being flat or not?
I like have no idea, but you guys brought it up at some point, and I was just like curious on. So
Wow.
No, he was talking about angular size and all this and that, and say perspective wouldn't work. But if you're trying to claim a position, a physical position to the sun, bro, how would you verify?
I just used what professor gave me. I can't verify anything.
I mean, how did he verify it?
I
He
got it from
used a
Matthew
professional
Learns.
gloves. He said this like 5 times.
So
Yeah,
he
one
didn't.
time Matthew Learns went out to a flat Earth meetup with Flat Earth Dude, and they sat down and they triangulated the distance to the sun based off of flat Earth measurements and based off of globe Earth measurements. And those were the flat Earth measurements that Matthew Learns came up with.
They use calculations. So I mean, what measurements?
It was just an angle to the sun, and then based off of like parallax.
What if they would
That's
have
it.
got 700,590 miles? What
You
is
wouldn't have
the
known the difference.
difference? Why we need to know about the speed of light reaching the Earth? Why do we care?
Brother, I do not know. You guys originally brought it up, and I just
No, we don't bring that
that's
up. Somebody else
my
brings that stuff
stupidity.
up. Yeah, not flat earthers. We don't give a shit.
Well, Trump brought it up. He was saying
Someone
like
brought it.
when for.
So since you like doing math, maybe you should be able to calculate the distance of a person standing on a beach should see where the curve starts, where that horizon starts, if that's the curve of the earth. You should be able to tell us where that starts.
I'm a blind guy, so I would probably see less than what you would see standing on a beach.
No, it's just a measurement, like you said. You should be able to calculate that.
I like to do
So,
calculations. You take a ball, you take a radius that it's supposed to be, you put somebody standing on it, you draw a line from their eyes straight out till it touches tangent point on the ball. What's that distance?
I could not tell you off the top of my head.
try no, try.
Hmm?
I mean, we did just go over the laser test, so try should know.
Hey Tron, you want to see my flat Earth map?
See you what?
My flat Earth map.
Yeah, is there a map? Yeah, I'm curious.
Okay, hold on. There you go. There's my flat Earth map in the side check.
What is that? That's the stars.
Yeah, it's a map of the sky. That's how we design our maps.
Okay. So how does that show me where the countries are?
That's how flat
Well,
Earth
the
is
countries.
navigated.
Yeah. Go ahead, Yoder.
Yeah, I mean, so the reason why people use the stars is because when you're out at sea, there's no other land-based reference points that you'd use. So use the stars. And typically what navigators do is they would whip out their astronomical maps, and ahead of time they would plot waypoints. A waypoint being where a star is at a given point of time in the future. And they would basically assume that there's a position directly underneath that star at that particular point in time. So they take a map of the stars and they draw waypoints from star to star to star to star, and they note the time and direction and speed and everything that they need in order to get from waypoint to waypoint.
Yes, that's how they sailed 500 years ago.
Yeah, well, it's how they do it today. It's actually how GPS works.
Uh-huh.
Right, because you can't have latitude and longitude without stars in the first place to derive them from.
Yes, that is true. Yeah, of course, that's the foundation of everything. Yeah.
Right. So the foundation is actually the celestial sphere, which if you believe in a globe, you don't even believe that there is a celestial sphere. You know, it's a model, right? A conceptual model, because it's based on the assumption that the night sky functions like a ball and that starlight is effectively infinite.
And that functions on the assumption that you believe all the images are fake.
No, I'm just giving you the the geometric assumption here. The geometric assumption is that the sky is a ball. And you can use the sky in other shapes than a ball.
The sky is a ball?
Effectively,
Yeah,
what
the
they
celestial
did.
sphere. Infinite volume.
Sorry, Yoder. I just wanted to say real quick. Effectively, what they did was they took the celestial sphere and they plastered where we live on the inside of that sphere. That's all they did.
Right. So one of the things they'd have to have true is that there is 69 miles per 1 degree of rotation, angular displacement around that celestial sphere. And nobody's ever been able to validate that that's true.
Yeah. But
And whenever it's wrong, they just make a correction for it.
That's right. They have. They actually first started getting it wrong in the 1730s. They had a big debate and a problem because they noticed that the angular rate of change and the distance traveled was not uniform, was not the same everywhere with every star all over the Earth. So the celestial sphere started to look lumpier and lumpier with higher precision. But they wanted to preserve the celestial sphere because they wanted to believe so badly that Earth was a sphere. But then that got fucked up too. So now we have a potato Earth. They call it a geoid.
Okay.
Yeah, and it's all to preserve the idea that Earth has to be a sphere because the way they conceived of the stars is being in a field that's a sphere.
Because you
There are other
believe
ways to
all the
conceive of the
images are
stars.
fake.
There are modern star trackers that don't use a celestial sphere and work independent of what Earth's true topology is.
Or you believe all the images of the planets are fake.
I need evidence that these images are what they say they are. The provenance. I want to know how they were taken, who took
What
them. I
about
want to be able to
telescopes?
validate their means of being taken.
What about telescopes?
You can't see Earth from outer space with a telescope on Earth.
The images they take.
Like I said, I want validation that the equipment they used was where they said it was used at the time it was used and operates in the manner of use. You have no way to validate any of this.
You have no way of not validate it, you know?
Why should I automatically accept everything that people say? Should I auto-believe
You don't
everything?
have to, but that's because doesn't mean it's wrong.
I have an objective moral duty not to automatically accept everything as true that I'm told. Don't you?
No,
are you going to
not for
abdicate
myself.
yourself of your mind's critical
I
ability
believe
to
those
think?
photos are correct, real. but it doesn't.
I know you do. I used
help
to
you.
too until I looked into it.
No, you didn't look into it, but you've seen a telescope
I
in
did
real
look
life,
into it. I tried to independently validate that these images are taken where they said it was, and it comes back to trust me, bro. And a lot of inconsistent stories with how the technology works.
Of how a telescope works?
No, of how the platform for the telescope works.
He's focused
what
he's
platform?
focused on telescopes. Dude, I have a P900, 83X is as good as a telescope, can take great pictures. What's the difference what you use?
You can't take
platform
pictures
being
of
the satellite.
Andromeda. But you know how lenses work, and this whole argument you
Yeah, we do. But do you know how satellites work?
No, we're talking about the camera on the ISS.
Yeah, do you know how orbits work?
Yeah. Or at least
Really?
how I
So
was
if I
taught
want to
it.
query a satellite or the ISS, I have to conduct what's called magnetic field line tracing, and I have to analyze the occupancy rates of the magnetic flux tubes of force to make sure that there are no collisions. Do you know what any of that means?
No.
Well, it's on NASA Goddard Space Flight Tracking Center that's how to query satellites.
And that proves what?
That you don't know what you're talking about. You think you do, but you don't.
But what does
Nobody knows
it
what
prove?
this shit means.
How does it prove that those images are fake and the satellites don't exist and ISS doesn't exist?
It proves that people have cartoonistic concepts with how this technology supposedly works, and you go to the source, it says different things than how people think that this technology works.
Doesn't matter what I think. How does it prove that
it does?
it's
But
not
you
correct?
have this Santa Claus belief in orbits when NASA doesn't even believe in this shit.
And the thing, Tron, is that even if we grant you that the pictures from space are real, when we try to confirm it down here by doing these laser tests over water and we find out that the water is flat, we can't confirm those pictures.
You can't confirm those pictures.
No, we
No,
can't
this
because
is
they show us a lot of curve, right? They show us a ball and they tell us the radius of that ball, 3959 miles, right? And then we go out and try to shoot the laser 10 miles over any water, any lake, right? And it ends up 1 foot over the beach on both sides. There is no
But you don't
curve.
believe those images are real in the first
They
place.
can't be, I mean, we can't confirm that curve down here. We tried.
No, that doesn't disprove if the images are real or not.
No, the pictures, I can grant you the pictures, that's fine, but they're using some kind of wide angle fisheye lens or something, because the curvature from that height is imperceptible.
I know how wide angle lenses look. That doesn't look like a wide angle
it's called
image.
barrel distortion, right?
That's why you never have an image of the ISS of the whole Earth.
Oh, yeah, I've seen the ones that show 50% of it, and it looks like a big ball, and they push that to people. On X, you can find tons of posts with that ball, right? But it's unrealistic because you cannot see more than 3% of Earth from that height. So they're fooling people into think they're living on a big ball, right? And when we try to confirm that ball picture from space, we cannot find it. We cannot measure any curve over the water.
Also, it depends what lens they use and what
yeah, and they do use fisheye lenses. We have a space guy in here, Josh Ingersoll, who works for Amazon with their rockets and their space program. He tells us that the cameras they use, they have this kind of distortion and they show curve. He actually went to some meetings and tried to get them to use cameras that doesn't distort as much, right? But he hasn't been able to push that through. Look, they are fooling people. I don't know if they're doing it on
So
purpose.
the images are real then, you're saying?
I'm saying the image can be real, but they can't be that much curvature because it's imperceptible from that height. You see?
Even if you don't use wide angle, the Earth wouldn't be flat.
We have those kind of pictures. We posted a video from a weather balloon before. It is completely flat, 125,000 feet up.
The last picture, that's not flat. Look at the line, man.
Well, that's around the same height they claim as the ISS, right? Doesn't look like the amount of curvature you see from the ISS, does it?
What camera was used, though?
Okay, which camera would make a curved line flat?
And what line?
From all angles of the
this
frame.
Looks like a 360 camera. Look at the.
That's going to flatten out the globe, is it? from all angles within the frame, right? So you could have
Yes.
the you
Yeah.
could
Have
have
you ever
you could
used a
have the
360
horizon.
camera?
Yes, I have. Okay, so we can see the horizon at the top of the frame, the center of the frame, the bottom of the frame, and it's always just looks completely flat from all
It
of the
doesn't even
main
look flat.
cameras.
Look
From
at the
all of the
line of
main.
the Earth. It's not completely flat.
Oh, okay. So what's the 360 camera? Why did you bring up that point?
But look at the second picture. It doesn't even look that flat. You see the line? It's not completely flat. Are you blind?
Yeah, I didn't say it was completely flat.
I
said it contradicts. I said it contradicts what
No,
you're
it
seeing
doesn't
from
contradict,
the
no.
ISS. In
It's a
fact,
360
in
camera.
fact, the ISS footage, right, contradicts how much curvature you would see from 400 kilometers height. And also, the horizon is way above the center of the frame, which on a wide-angle lens, or just about any lens, you're going to have
It's not
barrel
a wide-angle
distortion, and
lens.
it's going to have that effect. Now, you would only see 3% or 2.9% of the surface of the Earth from that height. Not enough to see that much curvature.
And now, even on that picture, you see curvature.
Which picture?
The one that was posted in the side chat.
Oh, that's curvature, is it?
Look at the second image.
Yeah, really. Okay,
That's not
so
a straight line.
Mm-hmm.
And it's a 360 camera.
Okay.
Both
So
of
that's
them are
accurate. It's
360
showing you an
cameras.
accurate representation of how much curvature you should see from that height. Is that what you're
Not
saying?
the second one.
Which one? Which one's showing the correct amount of curvature?
None of them, because those are
Oh, okay.
distorted images.
So we can't confirm anything because of the lens distortion in all of these images.
Yeah, well, that lens distortion does not correspond to the distortion of your eyes. That would be a 50
Correspond to the
millimeter
distortion of your
lens.
eyes? No, it doesn't correspond with the curvature that would have to be present if the Earth were a globe. That's
But
what
it's
it doesn't
present there.
correspond with.
On the second image.
Is that the right
that
amount
line-
of curvature? Is that the right amount of curvature that you would see from that
But
height?
even there, it's present.
What's
Cont,
present?
we agree with you that cameras can have barrel distortion, right? And China's space agency obviously
I'm talking
isn't
about
using.
barrel distortion.
Yeah, the
The
China
eyes
China
correspond
picture.
a focal
Listen,
length of 50
listen.
millimeters.
Listen,
No, they
the
don't.
China agency, the picture from China, it doesn't display as much curvature as the NASA pictures does, right? So they are using different lenses.
Yeah, obviously.
That's all we can see from these pictures.
Okay, but now with that, you actually now you don't even say the pictures are fake anymore. You agree those pictures are real.
No, we're showing you that there's differences in what we're seeing from what's claimed to be the same height. Okay,
Because
we're
of
seeing
different
all sorts of
cameras,
contradictions.
different distances,
Yeah,
different
obviously,
lenses.
obviously. So there's all sorts of different cameras being used, which produce all kinds of different effects. Right, so it would be inconsistent
sensor
to
size
say, "Oh,
also
this
has
is
an effect
this is
on
the
it.
curvature of the Earth." Okay, you don't even know what focal length any of those cameras are.
No, exactly. We don't know that.
Yeah, so why are you making specific claims about it then?
I'm just saying all those has an effect. The sensor size, the lens, and
What
the camera
lens?
itself.
You don't know. You just said you don't even know what lens it is, or what sensor size it is, or what camera's being used.
I'm just
So why are
saying
you just
those three
making
have
shit
an
up right
effect.
now?
No.
Yeah, of course. That's what we're
But you
saying.
can't-
So
but
you're
these
seeing
images don't
different
disprove
lenses,
or
different
prove
sensor
anything.
sizes. We're not presenting this as proof of anything. You're saying that you can see the curvature from the ISS footage. Okay, all of the horizon shots from the ISS footage in the live streams is way above the center of the frame. Okay, you don't know what
has it
lens
got
is
to
being
do?
used. Okay, it doesn't align with how much curvature you should see from that height.
No, what has the position of the horizon in the frame has anything to do with that?
Okay, well, you seem to know a little bit about how lenses work. So if you have lens distortion, okay, let's say we have a horizon line that's completely flat, just hypothetically. Okay, when it's in the center of the frame, it's going to look completely flat. As soon as it goes above center of the frame, it's going to start distorting convex. As it goes below the center of the frame, it's going to go concave. This is how
That's not
lenses
true.
work.
Depends on the quality
What?
of the lens as well.
No, it doesn't depend on the quality.
It depends.
Oh
on
my
the,
god,
it
you don't know what you're
depends on the
talking about.
You don't know what
Do you
you're
wanna
talking
see
about.
me
I
here
have
being a
lenses
camera
like,
guy and he doesn't even know.
Yeah,
if
he's
you
not
have
a
a
camera
if you have a
guy.
lens that costs $400, it's going to have more distortion than a lens that
Oh,
costs
so
$4,000.
Oh my god, okay, so you just proved you have no idea what you're talking about. It's to
You
do with the
don't.
focal length of the lens, okay? If we're using an
Well,
8
that
millimeter
too. No,
lens or
you're
something,
talking
it's
about
to do with how
distortion
wide
has
of an
nothing to do with
angle.
focal length. The wider
Yes,
it
it
gets, the more
does.
distortion
Oh my
there is
god, bro.
to the edges. Of course, yeah.
Yeah. So if you're using an action camera like a GoPro or something like that, you're going to have a lot of lens distortion. If you're using a rectilinear lens, you're going to have minimal lens distortion, whether it be a cheap action camera, okay, or an expensive action camera, or a cheap rectilinear lens or an expensive rectilinear lens, you're still going to have the same effect. It's based
But
on the
up
focal
there
length of the lens.
on the ISS, they're not using cheap action cameras. They're using Nikon
I didn't
cameras.
say they were. You don't. Okay, so what's. Oh my god, bro. You just admitted a minute ago that you don't know what lens they're using.
How big is the sensor of an action camera compared to the Nikon Z9?
It's got nothing to do with the sensor.
That's not.
This has
of
got to
course it has
do
to
with. No. What do you think this lens distortion means? We're talking about.
That's
We're
how
talking
lens
about
works. Yeah, of
a
course.
line being distorted. We're not talking about quality. Right? We're not talking about resolution. We're talking about lines being. Lines not being what they actually are in real life.
Yes, exactly. Yeah.
Okay, so you could use a $5 lens, or you could use a $5,000 lens that's at, say, an 8mm lens. You're going to get crazy lens distortion on either of those.
No, that's not true.
Oh my god! All right, bro. Dude,
it will never be a complete straight pattern. Of course not.
I used to sell lenses for a living. I did 15 years of
an
product
expensive
photography.
lens will have less distortion than a cheap lens.
You don't know what you're talking about.
We can agree on that. Can we agree
Tron,
on that?
Dude.
Tron, I think you are experiencing the syndrome. Everything
no,
a flat
answer
earther
that.
says is
look,
wrong,
shut the
right?
fuck up, man. I answer
But
that.
listen,
Does
you're getting
an
triggered
expensive
now,
lens
bro?
have?
Take some deep breaths.
Spiraling.
Take some
Man,
deep
look,
breaths.
you sold lenses, man. Let me finish the question.
Just have a look in the side chat. We've got some examples of some lens distortion. We'll just calm down, bro. Calm down. Relax.
Do different lenses have different amount of distortion?
Of course.
Okay.
I just said that. I just explained that.
No, you didn't. So.
Yes, I did.
A $5,000 lens has
primarily
less
due to
distortion than a cheaper lens.
Not necessarily. No, you could use a cheap rectilinear lens that costs $20 off AliExpress, and it's going to have less lens distortion than a low focal length lens that's $20,000. Right? It's not to do with how expensive the lens is. The lens doesn't have the sensor in it either. It's in the camera.
Yes, because a lens that has more glass in it has less distortion than a lens that has less glass in it.
Oh my god, go look this stuff up before you make a fool of yourself on the YouTube live stream.
What you look
This
it
is
up,
just
man.
silly. Like, who are you trying to fool right now?
Why do photographers
either you believe
buy
your own
more
bullshit right
expensive?
now, or
Why do photographers buy more expensive lenses?
because they give you a much nicer looking image.
Less distortion.
No, what do you think? We're talking about barrel distortion. We're talking about the distortion.
Yes.
Yeah, we're talking
We're not talking about
yeah, we're not talking about image quality.
I'm talking about barrel. Look.
We're not talking about pixels, man.
Let me find an example, okay?
We're not talking about pixels.
Oh my god.
I'm not talking about pixels, man. Let's take.
You are talking
Nikon,
about pixels.
Let's take two Nikon lenses now, wide angle lenses, two price classes, and you'll see they have different amounts of distortion.
Oh, okay, show me the difference. Make sure they're the same focal length. Okay, get two prime lenses, say 18mm prime lenses,
no
expensive. Huh?
Look.
What? What did you just say? There are no two what?
Nikon at this moment has a 12 to 24mm lens. Okay, that's the expensive one. And it has a second.
I just said prime lens. Do you know what a prime lens is?
It doesn't have two prime lenses. You know, there's no two price classes there.
Really? Are you sure?
Well, let's take that example. Let's take a prime
I'd
lens
divert
from
to a
today.
different topic if I were you.
Let's take
researching on the spot.
This is
let's
crazy,
take a prime
bro.
lens. Look, let's take a prime lens from 2026, and let's take a prime lens from 50 years ago.
All right,
we'll
what's
see
about unverifiable information on top of it.
Yeah.
No, but why? Because the optic quality improves.
Oh, really?
The manufacturing improves.
Yeah, we're not talking about optical quality. We're talking about lens distortion.
Then
due to the
distortion
focal
has to do with the optical quality. You just agreed.
Oh my god.
It's not just
There are
that,
two
man.
lenses.
Hey, what's the difference between a rectilinear lens in a wide angle
Wide
lens.
angle.
Why does that disprove what you just claimed?
What is the difference between a
I don't know.
rectilinear
I'm
lens
not an
and a wide angle
encyclopedia,
lens?
man. I don't know anything by heart like you guys do.
Oh,
All right,
But that
bro.
so
doesn't
you
disprove
don't
what I'm
understand
But
the
he's
saying.
arguing. But he's arguing about things that may or may not be on the freaking International Space Station, which is the most hilarious part to me. Like, dude, do you know what's going on up there? You know what you're talking about? No, you just have a belief system, and you're sitting here arguing on behalf of it, making assumptions upon assumptions. It's pretty laughable.
Hey, I got a question for you. Have a look in the side chat. Okay, can you see how the horizon's distorting as the camera pans up and down? Is that because, would that happen less if this were a more expensive lens? Or is this to do with the focal length of the lens?
No, that's a wide angle lens. You see it
No, did
because
you,
of the
what
rope.
was my
The
question?
rope-
What
the
was
ro-
my question? Were you listening to me?
It's because it's a wide angle lens. So yeah, focal length. Yeah.
Yeah, if this was a more expensive wide angle lens, would this line distort
That
less?
extended fact, no, it would be diminished. But
Okay,
no,
so
not,
so
not
that's
in
what
this
we're
specific
talking
case.
about here. So the price of the lens isn't going to change the side effects or the byproducts of the wide angle lens, which is the distortion of straight
In
lines.
this exact example, no.
Okay, well that's what the whole point is of this.
But how does that prove anything?
This isn't about proof. This is about lines being distorted. Okay, when we take high altitude footage. Okay, and it doesn't
And
prove
still shows a
anything. Either way,
curvature.
it doesn't show curvature. You
What?
dumbass.
Look when it's in the center there.
When it's in the center.
Yeah. What?
Oh my god, how can you not see? What height do you think this is?
I don't know.
It's a
How
weather
should I
balloon.
know that?
It's a weather balloon. We don't know. Okay, so this is a weather balloon. And from that height, you wouldn't even see the curvature of the Earth, even if the Earth was a globe.
But why do you see it there then?
Because there's lens distortion.
No, not when it's centered though.
That's what distortion is, dude. He just told you when it goes to the top of the camera, it looks convex, and when it goes to the bottom of the camera, it looks concave.
Yes, but when the line is in the middle, in the center, what is it then?
Yeah, in the middle, it's not going to be distorted. You're right. And you never see a camera on the ISS where the horizon is in the middle of the camera. That's what we've been saying for the last 10 minutes.
How would you know where the middle of the horizon
Because you can
to know
see
where
it
the
in the
middle is?
video.
Yes, and there I see a curve.
You wouldn't see a
Because
curve
it's not
from
in
that
the
height.
center.
You wouldn't even see a curve from that height.
No,
Actually,
but
in
the
fact,
one-
even
the weather balloon one.
even from in the weather balloon one, okay, weather balloons can only go up to about 120,000 feet maximum before they pop.
But why do you see a curve there then, when it's in the center there?
Because of the lens. Okay, and you don't know if
No,
it's in
the
the
line is in
center.
the
You
center,
don't know if it's being cropped in post production or anything like that. Okay, you have no idea how someone might have cropped it when they put this little video together, and even from double this height, and then some. Okay, even your own globe astrophysicists, like Neil deGrasse Tyson says, you don't see curvature from even double this height of a weather balloon. You do not see the curvature of the Earth from that height. It's like being 2 millimeters off the surface of a beach ball. Do you want to see clips of your own scientists saying that you would not see the curvature of the Earth from this height or even higher than this, double this height?
I believe that, but you're just cherry picking
Okay.
examples. Still a waste of time.
Yeah, so it's a waste of time claiming that you can see curvature when you've got a whole bunch of lens effects to take into account. That's all. Okay, so it's inconclusive. It's inconclusive. I can show you rectilinear lens footage from 120,000 feet where it pans around 360 degrees and shows a completely flat horizon. I wouldn't use that as proof of anything, because even if it was a globe, it should look flat from that height anyway. according to the mathematics. Okay, there's Neil deGrasse Tyson in the side chat in What Plain Truth posted, and he's talking about the Felix Baumgartner space jump, where he went up and he jumped from 129,000 feet from a capsule. Okay, and people were saying, "Oh, look, you can see the curvature of the Earth." So that pisses him off because it's inaccurate. So he was doing a little talk about it, and he said, "This is deceiving. They're deceiving people and trying to make it look like he's higher than what he really is, and that you would not see the curvature of the Earth from that height. It's a fisheye lens."
Yes, okay, I can buy that. Yeah, that's fine.
Okay.
I'll
So
agree on that.
even from
But
300,
still doesn't.
yeah. So even from double that height. So look, as high as we can get to validate, we don't see any curvature. It just looks like a flat horizon. So it's not proof. I'm not saying this is proof that the Earth's flat. It's just like the base axiom. It's what we all experience as our reality. Even if you believe the Earth's a globe, you experience the Earth as flat and stationary.
Wait, okay, so
Mm-hmm.
you probably have an answer to that too.
Of course.
Well, why don't you ask?
Yeah, you can ask.
That's why. That is why I asked how the flat Earth looks. So when you fly from Osaka to New York,
Mm-hmm.
you daylight changes, right?
Yeah.
Most people, when they fly from Osaka to New York, they fly over the Arctic Ocean.
And Tron,
Still,
did you?
light changes, right? Light changes, right?
Yeah. So look, let's say the sun is much closer and much smaller than what they tell us in the globe model. Okay, and as the sun takes a particular path throughout the year over the surface of the Earth, as the light from the sun pushes away from the sun, we have the inverse square law of light. So every time you double the distance, it quarters the intensity. And as that light quickly diminishes as it moves away from the source of the light, it also has to push through the thickness of the atmosphere, right, which absorbs the light. Okay, so it only has a limited amount that it can push through the medium. Here's a good example. We have a thicker medium like water. If you have midday, it's midday, and you just go down 200 meters into the ocean, you can't even see the sun. You can't see any light from the sun. It's pitch black because the light, the medium absorbs the light from the sun. Okay, the same thing happens in the medium of air, but it's less dense than the water, so it's going to happen over a greater distance. Okay, so if we have a closer sun, the light attenuates, we have the inverse square law of light. Works perfectly. And sometimes you can see the sun. Sometimes you can actually see the sun from the United States and Japan at the same time.
And Tron, did you know that the astrophysicist Brian Cox, he actually went up in a fighter jet and they followed the sun from darkness and it was daytime again. So if you follow it in a jet, you can follow it and you can have daytime the whole time if you want to.
Yes, because you're above the clouds.
Yeah, so light attenuates through a medium.
No. What he said, he can do that because they're above the cloud.
I can post a video for you. You can see it. They start out in when it's darkness and they go and catch it.
Are you Swedish?
Catch up to it. Yes, I am.
I thought.
That was a good guess.
Well, I live in Sweden, so I recognize it. No,
Yeah, flat earthers all over the world, man. Wait about 6 more
well,
hours
but
and you'll start
primarily
seeing.
in the United States, though, I would say.
Wait about 6 more hours, you'll start seeing Australians come in.
Hey, I'm Australian, Marty.
But you're not in Australia, bro.
What's your
But
next
yeah,
question, Tron?
yeah, but but if you fly high enough, of course you will see the sun all the time because you're moving across the
There's
surface.
really cool plane footage, and it looks like people are flying out of the daylight into the darkness. There's
So,
some cool videos of that. It's a trip.
but
Doesn't prove anything either way, but
no, it doesn't. No, but just trying to understand. So, if you look at a video like that, how can you see clouds and ground underneath or water if you keep on flying in one direction, or does the plane change direction?
no, the plane just stays at say 30,000 feet, and then you go up to 30,000 feet, and then you fly over the flat plane in the plane, and then you land at the destination. You take a flight corridor, and that's it. It's super simple. In fact, aerospace engineers treat the Earth as flat and stationary for all of their calculations when they design aircrafts, and pilots are also trained to treat the Earth as flat and stationary. There's actually tons and tons of pilots, military, commercial pilots, and so on, that are flat earthers, and there are extremely long videos with interviews of them talking about flat Earth.
Hmm.
And even a globe earther pilot, right? Someone that believes the Earth's a globe, but they'll always admit as well that yeah, you don't see the curvature from a plane or anything like that. We just treat it as flat and stationary. And most of them will say, yeah, I never even thought about accounting for curvature. I never thought about accounting for rotation or anything like that because it's just not something that they do throughout their careers.
I'm just interested how this flat Earth looks. I
Yeah,
can't wrap
so are
my head
we.
around it.
Look, we can only get so high up into the air, and we can only travel so far. So we don't know, unfortunately.
Well,
We
you
can't
don't
get
know because you don't know. You think those pictures are fake.
No, we can't validate those pictures. So whether they're fake or real, you can't validate the pictures. It's just going to
But
be something that's faith-based. But what we can do is we can invalidate the pictures by doing surface measurements over and over and over again and showing that there's no curvature here on the actual surface.
But riddle me this then. If so, let's assume the Earth is not curved in any way. Those pictures still show a finite world.
What pictures? The Apollo astronaut pictures, like from the Apollo mission, you mean?
So you think the ISS is real, but not the
No,
Apollo
the
missions.
ISS is only 400 kilometers up in the air.
The
And you would
ISS
only
is in our
No,
atmosphere.
I asked you if it was real.
Yeah, so I just said it's 400 kilometers up. This is what they're telling us. Okay, so if it is at the height that they're telling us, that's you would only see 2.9% of the surface area of the Earth. Okay, it's hardly anything. It's not even enough to distinctly see the
I
curvature of the
understand
Earth in
that.
your
I
field of
understand
view.
that.
Uh-huh.
So you believe? So you said what they're telling us. So you don't believe the ISS exists?
No, I don't believe that anything is in outer space, in a vacuum of space orbiting around a globe, because we've invalidated the globe. And outer space goes against natural law. Okay, it directly goes against gas laws, right? A huge list of gas laws, second law of thermodynamics as well. So you can't have a gas pressure system like we're breathing right now, okay, and all of these oceans stuck to the outside of a ball inside a giant space vacuum. They tell us that we're in a big 10 to the negative 17 torr space vacuum.
Hmm.
Yeah, so you can't have gas to have gas. You know what an antecedent is?
Have they proven this on Earth? On Earth? No, I don't know. I don't
So
read up on all these
when
things.
when we try to test these things on a smaller scale, it doesn't work, right? Obviously, you can't have water sticking to the outside of a ball, or you can't have gas inside a vacuum, or water inside a vacuum. Okay, but they'll tell you that we can't test it on the Earth because you would need something the size of the Earth to be able to test it. So it's always going to come down to faith and trust me, rather than things that you can actually check. But you can invalidate it by checking things that we can easily check.
But you can't invalidate what you just said because you don't have a model big enough to
No, you can't validate
experimenters.
the globe claim, right? We can validate everything that we're saying
We're talking
because
about the
it
vacuum
works.
now.
Yeah, so we can make a vacuum chamber and we can show you that you can't have gas in a vacuum chamber and you can't have water in a vacuum chamber because it boils straight away. Okay, so you can't have these things.
But you
So
said
everything that we're
it
saying
doesn't
that we can
work.
demonstrate, the globe explanation doesn't work, but everything that we're telling you matches all of the gas laws and matches the demonstrations. I can show you a demonstration right now.
But
So
you
plain truth.
said the experiment with the gas doesn't work because you need something the size of the Earth to prove it or disprove it.
Yeah, that's what okay, all right. Just let me explain it. Okay, so the globe explanation isn't able to be demonstrated. Okay, they tell you that you would need something the size of the Earth to be able to demonstrate it, so you can never demonstrate it. Everything that we're telling you, we can demonstrate it. Okay, so here's a demonstration in the side chat. So have a look at what Plain Truth posted. Okay, so the bottom chamber, that's a gas pressure system. Think of that representing the gas pressure that we're all breathing right now, 14.7 psi at sea level. And then the top chamber is a vacuum. Think of that like outer space for this example. Okay, there's a valve in the center that's acting as a physical barrier. Now, as soon as you hit play on the video, he'll turn the valve and you'll see what would happen if we have a high pressure system adjacent to a vacuum. And what will happen is entropy will take place and the high pressure will instantly try to fill the available space, which is the vacuum. That's what would happen, right? That's gas law.
If the
and
space is the same size.
You could do it on any size. I can show you different ones. It's just high pressure goes to low pressure. This is it's a natural law. Like if I stab a hole in a car tire, for example, obviously the high pressure is going to rush out violently of the car tire because it's trying to fill the available space. That's what gases do. In saying that as well, you wouldn't be able to have the pressure in the first place inside the tire because gas pressure requires a container. It's actually in the definition of gas pressure. It's like the prerequisite or the requirement to have gas pressure in the first place. Just like you need cow to have a steak, or you need people, you need parents to have a person. It's an antecedent. So you need to have a container to have gas pressure. But they're telling us that we have a gas pressure system that doesn't have a container and that it exists within a giant space vacuum that's 100,000 more times powerful than any vacuum chamber we can create here on the Earth.
But what maybe, if that's exactly what's happening, maybe the atmosphere is leaking, but space is so damn big you don't notice it, like a tire.
Yeah, they do say
example.
some leaks. Yeah, they say some leaks into space, but it, show us even just being able to have that gas pressure system inside a vacuum with only just a little bit leaking. It's silly to even suggest such a thing would be possible, because obviously on a smaller scale, it's not going to work. That's not how gases
But that doesn't
behave.
disprove the bigger scale.
There is no proof of the bigger scale.
No, but there's no empirical disproving. Of
Cool. So it's just a So it's just a.
Well,
it's just a concept. It's just case. No, it's not. No, because we can back up. Okay, so all of the gas laws. Okay, and the definitions of gas particle movement, the definition of gas pressure.
With that, I understand that. Okay.
It all backs up what we're saying, and then you guys have a claim that goes against these fundamental laws of nature. Okay,
you guys,
and
not
you're not
me, man. I'm not a scientist. I haven't done
No.
experiments.
Globe earthers in general, right? That's what they believe. Okay, so the globe side, I'll say that instead. Okay, so the globe side claims something that goes against natural law happens. And we're just asking them if they can prove their claim. Okay, and they can't. So you believe their claim, and that would just be faith. Okay, because you just said you're not a scientist.
By going up in space.
Okay, so you can never go to, you're not going to be able to check that. You're just always going to have to rely on faith.
Well, yeah, but the same goes for you, because you did a small experiment, but that's not the scale. It doesn't scale down.
Well, we're not
automatically
claiming to
and
know how the
disprove it.
sky works, right? But we can check that whatever's happening above us is happening on a flat surface because there's no curvature. This has been tested thousands of times, and the results are consistently showing zero curvature over any distance that's testable. So whatever's happening is happening above a flat surface. We know we have gas pressure. That's like having a steak, right? We don't know exactly what color the cow is or where the cow is or anything like that, but we have the antecedent. We have the requirement, right? So we know we have the gas pressure. So to have gas pressure, as far as anyone can test, you need to have a container. It's literally in the definition of gas pressure.
I'm just understanding. So everything in the world is only the way it is if you can empirically prove it
If you want
with
to
your own
claim it,
eyes.
yeah, if you want to claim it as a fact.
So DNA, you can't see DNA, but how do you explain that
I
people look
don't make
different?
any claims. I haven't studied DNA, and I don't make any claims about it. This is a flat Earth channel.
No, but this connects to the way you think about the world.
Well, I don't know. I'm not claiming facts about DNA myself.
No,
personally.
this was an example.
I don't think
The
anyone
way
else.
your worldview
Okay.
works
Yeah.
is you need what is right in front of you, and if it's
No, we're
not right in
talking
front of
about
you,
physical reality. We're talking about physical reality here. We're talking about
what's right in front of you?
yeah, we're talking about large scale areas that would have to have curvature if the Earth were a globe. It's actually a false analogy to compare something like DNA to water curving over a huge
It's
distance.
the way of thinking. That's what I'm getting at.
Yeah, so I don't know anything about DNA.
And anything you can't prove or disprove with an experiment with your own hands,
No.
basically doesn't exist.
No, I didn't say that.
Yeah, no one's saying that. Why are you trying to insert belief systems into people
So the
through
sun
implication?
might exist then.
What might exist?
The sun as a celestial body, not a light.
Oh, nobody's denying
in
that
a
there's a
dome.
sun in the sky. Yeah, we all see the sun.
But
It's
what is the
definitely-
sun? Is the sun
I don't know
three-dimensional?
how. Okay, I don't know what the sun is because I can't. If I said I know what the sun is, you would say, "Well, how do you know that?" And then I wouldn't be able to provide you with empirical evidence. So I don't know what it is. I see it, right? We see at the path of the sun. Okay, it's something that it kind of works like a big clock in the sky. All of the celestial bodies all move like clockwork. They go in cycles and they repeat for all verifiable history. Okay, it's responsible for for daytime, nighttime, seasons, pressure systems, all sorts of things, heat. But exactly what is it? Exactly how far away it is? I don't know that. Okay, we don't claim to have a replacement for every single claim that the globe side makes. We're not claiming a model. We're not even claiming to know the shape of the Earth here. We're just testing the globe. Okay, and we all experience the Earth as flat. And when we test it, it checks out that there's no curvature. So there we go.
So when you look up at the sky, you see the moon, you see the sun.
Mm-hmm.
They look to you like discs.
That's literally what they're called. When people talk about the disk of the sun or the disk of the moon, even NASA refers to that as a disk, but I don't think it's a disk as in like a CD disk. Okay, I don't know what it is. It's a light in the sky. It's awesome. I wish I had more of it right now because it's freaking freezing here in Poland.
But if it's not a disk, it's not two-dimensional then, maybe.
No, I don't think it's two-dimensional. I have no idea what it is, but yeah, I wouldn't think it would be two-dimensional.
So
I don't think the Earth is two-dimensional either.
If you take a photo of the moon with you can take a photo with a good lens or a
tons of
telescope.
footage. Yeah, my own footage of the moon.
To me, it looks round. You would explain it. The light fall off doesn't prove it's round. Is a globe or
round
or a disc.
It looks round to me.
I mess.
No, it looks spherical to me.
Okay, that's what I was getting at. Yeah,
Yeah,
I
yeah.
used to
But
know
just
it.
because, like, okay, just if something else is spherical, I'm not saying that I know it's perfectly spherical or anything like that. It looks spherical to me. I can't check exactly what it is. It looks like half a sphere when I look at it. Um, but I think there's a lot of mystery behind it as well. Also, that doesn't mean that the Earth has any characteristics that would be comparable to the moon. Like if I go out into the forest and I see trees off in the distance, that doesn't mean something else that has no characteristics of a tree should also be a tree. Okay, so the Earth is, I like to think of the Earth kind of like the foundation or the floor of the system that we live in. And then the things that we see in the sky, they're different to the Earth, they're celestials.
So, how does the ebb and flow work then in your worldview?
Kind of like a big self-contained ecosystem, kind of like a vivarium. Do you know what a vivarium is?
No, just give it to me in layman's term, in one sentence.
Self-contained ecosystem, a complex dynamic system. There's nothing lay about it.
What dynamics are influencing it?
Okay, we have pressure
Geometry or what?
systems. Well, we have the water cycle. We have all these different complex cycles. There's nothing simple about it. It's an extremely big, complex dynamic system with all sorts of processes. Okay, it works similar to how you have like a terrarium or a vivarium, where you have an enclosed system that's self-contained, and you have nitrogen cycles and water cycles, evaporation, rain, temperature, pressure cycles, the heat sources are causing the wind and the waves, and then we have the magnetic field. It gets super complex, and I don't know how to. I don't claim to know how the entire system works.
But what you
What?
just
What?
said
Yeah.
already, you gave me an idea of your model works if this Earth is enclosed.
Yeah, because to have gas pressure, you need containment, and this is how a enclosed system works on a smaller scale. So, if you want to have an ecosystem, you need to have a container. For example, if you take away the container and put the ecosystem into a giant vacuum chamber, for example, everything's going to die really quickly.
So why can't you measure how high this container is?
Okay, so we can't get anything up past 120,000 feet. Okay, that's the highest that we can send up a weather balloon before it pops. And then there's something you should probably look into called the Outer Space Treaty as well. And it's actually illegal for anyone to send up anything past a certain height without government approval.
And that is why rockets are fake.
No, I didn't say rockets are fake. Why would you? No, I didn't say that. No one said that. No, rockets are
Not you,
real.
maybe,
But if you want to send, okay, so if you want to send up an amateur rocket, okay, so the record that any amateur has sent up a rocket is about 350,000 feet.
Yeah.
Not even high enough to see the curvature of the Earth. Now,
I'm not talking about the curvature.
they
I'm
had to
talking about
get
this
they
dome.
have to get a whole stack of permits just to be able to send it up to that height. Amateurs aren't allowed to do that. It costs a fortune, and you have to go through a whole process just to get permission to do that. So we can only get up to a certain height to check things. You're not allowed to film above a certain height. That's also illegal. They say for like national security purposes and things like that. It's all outlined in the international, the Outer Space Treaty, the OSP Treaty. Oh, sorry, OST.
Okay, so it's the flat Earth, and there's a dome above it.
No, I didn't say there's a dome. I said that we have
how,
gas pressure.
How are the gases contained?
Yeah. Okay, so it doesn't strictly mean that there has to be a dome. Although there may be a dome, I wouldn't know that. All I know is that
otherwise the gases fly away.
Okay, why would it have to be dome shaped?
Doesn't have to. It can be square or rectangle. I don't know.
So some kind of containment would be required to have gas pressure. Okay, like that's like me. I could be eating a steak. And
I understand that. You don't have to repeat yourself.
Yeah.
So, but this.
Okay.
I just want to understand how this world functions in your imagination.
I know. Well, I'm sorry, but we can only test what we can test. We can only know what we can know, and there's a lot of unknowns.
So there's a lot of assumption too, even in your world.
If we're going to assume something, we're going to say we're just speculating. Okay, don't take it as fact. It would just be a speculation based on maybe on a calculated guess or educated guess or something like that, or what happens on a smaller scale. But there could be something about the way the sky works. Okay, because if like the sky is crazy, there's all sorts of crazy electromagnetic stuff going on up there with shooting lights everywhere, and you look at it through night vision and you see all sorts of crazy stuff going on up there. So much we can't see with our eyes. So I don't know how all of that works. I can't test it. It's awesome. It's amazing. But we can validate that whatever's happening up there is happening above a surface that there's no evidence it's curving.
Okay, but you have no idea how this surface looks, if it's round or disc or square or rectangle, if it ends or doesn't end.
No idea. I would say like Earth shaped if it's a shape. So I mean, if you think about, people always think it has to be like a stereotypical geometric shape, but I mean, like what shape is a tree? What shape is a lake? Every single one is a different shape. So I would say that the Earth is whatever shape the Earth is. It's Earth shape. But I don't know that. Like that's something that we can't validate. Unfortunately, it would be great to have a God's eye view, but we can't achieve that.
So even if there's this containment, you never ask yourself what could be there beyond that.
Of course. There's tons of speculations too. People, there's tons of videos speculating about these kind of things, but in here we try to keep things empirical because, on Sundays we have speculation Sundays where people will talk about things like that. And they're just speculating about, okay, maybe there's more land or something like that beyond. If you go further south, maybe there's more land that we haven't discovered or we don't know about. Who knows? Okay, so that would all just be speculation. That would be in the speculation basket, which is fun to speculate, but it's just speculation at the end of the day.
But it's kind of convenient though, because you always say, "Oh, we can't go to the edge because treaties are stopping us." But you can sit in a boat in Argentina. You go eastward, and then in my idea, you will end up in probably Australia or something, and you go further, and then you end up at the same place. Technically,
yeah, that would happen on a flat surface. Okay, let's give you an example of.
Not really, because then because you can't go round in a flat surface. If you start
Of course you can. Of course you can. Picture a big, just for a hypothetical, okay? Just picture a big round lake, and you've got continents, islands, right? Islands in the lake arranged exactly the shape of the continents in different places in the lake, okay? And you've got a North Pole in the center. Okay, you've got a compass, and you're in one of the islands, and let's call it Argentina. Okay, and we want to go east. We're going to go, all right, the compass is pointing north. We're going to go east. And to stay east, you're going to have to keep correcting. And you're going to make a big circle around the flat pond, and you're going to come back to where you started again eventually. Because east and west are circles around a North Pole.
Hey, DJ, how are you?
So the continents are arranged in a circular fashion on this.
No, I didn't say that. I specifically said this is just a hypothetical, so you can get an idea. Look, old dude gave you an example of exactly what I just gave you, just as a hypothetical.
Yeah. No.
Just as a hypothetical. I don't know the exact layout.
Arranged in that way.
Yeah, I don't know the exact layout of the place that we live.
If they're not arranged in circular fashion, it doesn't work.
What doesn't work?
What you just said. You can't go from point A and end up at point A.
Yeah, it doesn't have to be in the center. The North Pole doesn't have to be in the center.
I'm talking about the North Pole.
So your compass is just going to point to wherever the magnetic north point is. Okay, and then if you want to go east, then you're just going to be doing a circle around wherever that north point is. It doesn't have to be a particular shape. It doesn't have to be in a particular place in the middle or anything like that.
If the continents are arranged in a circular fashion, yeah.
Who said that?
Then what you said works. But imagine they're not arranged in a circular fashion.
I didn't say they are arranged in a circular fashion.
No, it has to be the way you are explaining it.
No, it doesn't. I'm just telling you
Draw
that you
it.
can go.
Take a piece of
No,
paper
this
and
was
draw
the
it.
argument. Yeah, there's literally a diagram of it in the side chat.
I
Okay, so
see it.
you don't have to. Okay, so do you think that you can go east and come back to where you started on a flat surface?
No, you can't. If
Do you
they're
think that?
arranged, not arranged in that way.
No, no, no. We're not. We're just talking about in general. Can you do it? Is east a circle, or is east a straight line?
It doesn't work unless the surface moves.
Answer the question. Is east a circle or a straight line? It does work.
East is a direction, okay? Yeah. It's
Yeah, is it a circle or is it a straight line?
No, it's not a circle.
It is a circle. Okay, this is where the problem is. This is where the confusion lies. Let me show you a diagram. I made you a diagram.
I know, but that
Globe Earthers
doesn't
get
work on
confused
your
about
flat
this.
Earth.
Yes,
That's
it
what I'm trying
does.
to understand. Look.
Okay, you don't think
have
that
a
east
flat-
and west are circles. Go on ChatGPT right now and say, are east and west circles?
And Tron, even on a basketball, you hold it in your hand and run your finger over around it in a circle. You're still traveling in a circle. This works on both flat surfaces and balls.
Only
even.
if the continents are arranged in circular fashion.
No, they can have any layout there. They can be a square underneath your finger. You just go around the square.
I was talking about if you.
What are you guys talking about?
Well, we're trying to teach Tron how cardinal directions work at the moment.
Oh,
if you start at point A.
What's
go
point
east.
A? Where's point A?
Argentina, okay? Let's take Argentina,
Okay,
the south point
yeah.
of Argentina, yeah?
Mm-hmm.
And you go east.
Uh-huh.
East according to the compass that we use. So of course,
Yep.
so that's one direction, okay? You follow that
Okay.
compass as far as
Mhm.
possible. Let's just
Yep.
assume, yeah.
Mm-hmm.
On and if they are in a circular fashion, you will end up at the same point if you just go on that straight
Okay.
line east.
And who did that to confirm?
No, I'm just asking geometrically. That's right, yeah.
Okay, is that what would happen on a globe? Is that what would happen on a globe?
If you follow that same exact line, yes.
Okay, who did that to confirm that that's what would happen?
No, I'm not
and
saying
that you
no,
would come back. So it's
of
just a
course,
hypothetical.
This is no. I'm trying to understand how this world looks. That's what I'm getting at.
Okay, we don't know how the world looks because we're
Well,
just
that's
used to
convenient, you know,
navigating.
but that's kind of convenient. Okay, you can't see how the world
truth.
looks.
It's the truth. You think that you know how the world is spread out, and you're just
But
giving
you know
me
how
hypotheticals.
you know how the countries look, how they're shaped.
Okay, I don't know how. I didn't check how the countries are shaped. Did you?
But there's a way. Theoretically, there's a way to empirically see how they're shaped.
How?
Right? Yeah.
How did you do that? How would you
by
do that?
walking them and
Really?
following
Who
the
did that?
coastlines.
Okay, who mapped that out?
I'm not saying anyone did that, but you could do it, right?
So all hypotheticals. How convenient.
How convenient you as well. Because
well, I'm
you
not
could
claiming
measure.
to. I'm not claiming to know.
You can
right?
measure
Are you
the
claiming to
distance
know?
from Edinburgh to London, right?
Okay, and why would that not work on a flat surface?
No, I'm talking about the way the world looks, not if it's flat or not.
Well, just doing that trip from Edinburgh to wherever, that's not going to make you a map of the world.
No, I'm just saying, man, you can measure these things.
Okay,
just because
you can go from point A to point B, and you can get an approximate measurement of how long it took to get there.
So do you mean to say that the maps we have can be wrong?
Yoda
we
was
don't know
explaining.
We don't know how the countries look in actual fact because you don't believe anyone.
Yeah, look at the map that Plain Truth just posted in the side chat. That's the main map that people use. It's called the Mercator projection.
I know the projection.
Okay, well, you know that all the continents are the wrong sizes, right?
The sizes, but I'm talking about the shapes. I didn't say size.
Okay, well, who cares? How does the shapes of the continents dictate whether the Earth's flat or a globe? It doesn't really change anything, does it?
But you don't believe that they look
no, I
like
said
that, maybe.
No, I didn't say that. I said I haven't confirmed it for myself. I don't have any. So I could say Australia looks approximately like that. I don't know. It probably looks something like that. No, I don't know. How would I know that?
I could be wrong because you didn't yourself.
Might not be exactly that, but it might be.
No, probably it won't be because it changes through geography.
Okay. What's your point?
The point is you don't know how the world looks, and you don't care.
Yeah, I didn't claim to. I told you that straight away.
Nobody does.
Yeah, you think
Tron,
you do.
you can look into the coastline paradox if you're really interested in how to measure countries. We can't do it reliably. Nobody knows.
Well, photos have been taken from space on the, so we know how the
Yeah,
countries look.
we did do that. NASA even
But you
said
believe,
that
so
they
you
took
believe
flat
those photos
pictures
are
and they
real?
wrapped it around the ball. I mean, you can
No,
take
forget the
pictures
globe.
from
I'm not
high
talking
up, right?
about the shape anymore of the damn planet.
Which
I'm
photo?
talking about.
Which photo? Pick a photo.
There's no photo. I didn't
Well,
post any
you just
photos.
said you don't believe the photos. Which photo are you talking about?
No, I'm talking about the shape of the countries. There are photos of that.
What does the shape of the countries? Why does the shape of the countries only work on a globe?
No, I'm talking. Oh my god, I'm not talking about the shape of the damn planet anymore. I
Okay,
don't
so
care
it's
about
it's
that.
just
I'm
irrelevant. It's
talking
just an
about-
irrelevant point. Like
No,
it's
I'm
completely
talking
irrelevant.
about how this flat Earth looks.
We just
But you
went
know
over
how
all
the
of
countries
that.
look.
No, I
because
don't.
they're photos
I'm
from space from
told.
that.
I'm told that this is what the countries.
So
really?
you don't
So
believe
you don't
the
think
photos from
you don't
space
think they
are
had
correct?
You don't think they had maps before they went to space, bro?
Yes, and how did they draw those maps?
Okay, they used to. Do you know how they make maps?
They drew by hand because they visit these countries and they
That's not
drew what they
what the
saw.
maps. That's not what the maps that we use now are. That Mercator projection. Okay,
I
all
don't
of
care
these
about the projection.
projections that you're using. Well, which map are you talking about?
I'm
Which
talking
map?
about how
Post a
how
map.
do
Which map are you talking about then?
today how can no I'm not no map. I'm talking about how photos show that Africa looks like, or England, or
Okay.
North America, right?
Okay. Yeah. What about it?
So, but you believe? Do you believe those photos are real?
Which photo?
Oh my god! Any photo from space.
No. There's no such
They have
place
to be
as outer
specific
space,
ones,
bro.
man. They have to be specific pictures that you're referring to.
Yeah. Show us.
Right. Yeah, there's high altitude plane footage, right? There's high altitude airship footage. I mean, there's all types of different footage. There's high altitude balloon footage. So you'd have to be a little bit more specific when you're talking about images. So, yeah, of course, there's authentic images taken from high altitude. All different types of altitudes.
Yep.
All different individuals taking those photos.
Not enough to see a continent, though. That's for sure.
Not at once. No, of course not.
You'd have to stitch images together, wouldn't you?
Yeah. Okay. Yeah. Let's go with that. Yes, you stitch
Okay.
images together, and then you can get
All right.
An image of, say, Africa or Europe, right? Okay.
And you're claiming that the pictures are coming from space, are you?
No, not space. They're not that high up.
Okay. Well, what are you talking about? What specific
Now
method
I'm
are you
talking
talking
about.
about?
I want to know. I just ask.
Mm-hmm.
You only
you
only care
so
about
Tron, real quick. Let me just ask you this. So obviously you have distinguishing landmark features, right? When taking images of the surface of the Earth, right? But when you're over the oceans, what distinguishing features would you use to comparatively figure out where am I going to stitch this image with the following image that I'm going to take as I move away from this area, right? So there's no way to accurately stitch that together, right? And how many square miles and all of that. How would you get an accurate representation of the surface of the waters as well? So you could get a really good gauge of distance between one shoreline to the next visible shoreline.
same technique like when you take a panorama shot with your smartphone or camera. Right? You travel along a line the same height. You take a bunch of photos, one after the other, and then you stitch them together.
Where would you make the scene? How would you differentiate what part of the water your first image stopped and the second image started? What part of the water would you stitch together? Like, how would you differentiate exactly?
Well, I understand what you say. Yeah, and that's true. But let's say on that day it's cloudy. You use the clouds then. You don't have to see the water to know there is no landmass underneath the clouds. Necessarily. Huh?
And then to what end, right? Like, what are you going to learn at the end of all of this after you stitch all these images together? What type of system are you going to utilize to handle all of this data, right? How are you going to stitch this huge thing together with all of this data? You'd have to
There's
use
something called Photoshop.
yeah, you need a really huge like storage
That's
base,
no
right?
problem,
You would
man.
need that.
That's
Oh
available.
yeah.
There's enough data centers.
Okay.
That's the least of the problem. And
Okay.
I'm just curious why you care so much about that the world is flat or not flat,
Not about caring.
but
It's just
not
about understanding,
about
right?
why no, not about how it actually looks. If it's flat, how might it look? And there could be ways to figure it out.
To what end, though? To what end, though?
To understand that some of the things we talked about, like east to west.
Well, what's it? All right. So back to east to west. Let's think about this. Let's think about this, Tron. So let's say you're looking at your compass, right? Your compass is pointing north, and you say, "I want to go east." So you draw a right angle to the east, right?
Mm-hmm.
And now you start heading straight east. Now, the moment you check to dead reckon with your north again, right? So you can continue to go east after you've traveled a certain distance. If the north is a line connected to your point, you're going to have to continue to turn. You're not going to be able to continue on that right angle east and wind up in the same spot. It act like you're connected to like a maypole with a rope or twine. So
Yeah.
you're going to have to turn. You're not going to be able to keep that right angle and just keep going that direction because you'll eventually be heading south. You won't be heading
You'll always
east
be
anymore.
in a right angle towards north, though.
No, because you have to keep dead reckoning to the north. Every time you go to check, if you stay on that path, when you go to check your compass, you're going to have to turn to correct, or you're going to be going
Yeah, I
off
understand what
course
you're saying.
relative to your north.
But every time you check, your position relative to north will be and east will be a right angle. And the moment you check, right?
Well, no, not if you'd been traveling in that same direction that you checked a long period of time ago. Like that's the thing, the long distance travel to go. So the longer
Well,
the
with
distance you travel in
GPS,
that direction without correcting, right? You're gonna
yes,
go
you're
off
right.
course.
Yes.
That's what I'm saying.
Yeah, of course. Yeah, that's logic. I agree with you on that. Yes, of course. And then what were you gonna get to with that?
No, just to make sure you understood, because I wasn't sure if there was some confusion earlier when you were having that
He's
conversation
literally, he
with
said
DJ.
east and west are straight lines, which they are absolutely not. I even told him to go and Google it or check on
From your
AI.
from your point of view, it is.
No, it's not. It
Oh my
isn't.
god. From your
Okay.
point of view, I'm saying.
No, not from your point of view. Okay,
If I
look
look at the
at this
compass
globe in the
now,
side chat. Okay, look at these planes that I drew.
yes, and each of those
Yeah.
points are in a right angle to north.
Those planes are going around in a circle, which is east. East is a circle. If the planes were going in a straight direction, they wouldn't be going east.
I'm not saying straight. I'm not saying straight. I'm saying that
Literally said
if you
straight.
measure, no. Oh my god.
Yeah,
Every time you look at the compass,
rough being a, yeah.
Every time you look at the compass, it shows you north, but your
Yeah.
eyes looking east. In that very moment, that point and that east direction is 90 degrees to north.
So you have to keep turning. Yeah, so you can't go in a straight line. You have to keep turning the wheel to the left to stay going east.
But the direction doesn't change. Yeah, the line you're driving will not be straight. You're correct with that. That's not what I meant.
Okay, and you don't think that you could do that on a flat surface?
No, that's not what I meant either. I said that implies that the
Bullshit.
continents are in a circular fashion.
No, it doesn't.
If they're not, you would fall off this flat Earth.
No, it doesn't make any. What you just said makes literally no sense whatsoever.
It
doesn't
works
matter where
because-
the. Okay, look. Let's say
I know,
let's say we have a square lake.
It works
say we have
because you accept the North Pole is a
Is what?
magnetic center, and that's
No, I didn't say that. No, straw
that's
man.
what you believe.
No, it isn't. Right? I never said that. Don't tell me what I believe and try to strawman me. That's dishonest. That's actually not what I said. What I said is that your compass will point to the magnetic north. Wherever that may be, that's where your compass is going to point. And then if you want to go east, if you want to go east, then you're going to go in a circle around that north point, whether you be on a globe or on a flat surface. You disagreed with that. I didn't say it's in the center or anything like that, and that the continents are aligned in certain positions or anything like that. Okay, you could have a little lake with a magnet in the center and put continents anywhere you like throughout that water. Okay, it doesn't change the fact that the compass is going to point to the north, and if you want to go in, it's due east, due west. You're going to go in a circle around the north point. Doesn't matter where the continents are placed. Makes no difference to how the compass works.
So I guess, I understand. Yeah, so that's how the world looks. And so you took this globe, you flattened it out with the North Pole in the center.
No, I didn't say the North Pole's in the center.
Works.
Oh my God. I just told you.
The magnetic
hey,
north.
You're just being... No, I didn't say it's in the center. It's not even in the center on the globe. It's not in the center on the globe. The geographic...
So you have an idea how the world looks.
The magnetic field doesn't align with the globe, right? The North Pole, that's not where the
yes, I know.
Compass points.
It's off of 2 degrees, yeah.
A bunch.
Okay.
It's drifting, and there's 2 magnetic poles in the south. There's 2 south poles. One's out in the ocean.
Yeah, but the compass doesn't care about those, okay?
It doesn't care. Yeah, look, the magnetic field lines on the globe go all over the place, right? There's crazy anomalies. Look up a chart of the magnetic field lines on the globe.
I agree with you on that, but...
Yeah, it doesn't align with the globe, right? I'm just going off basics of how cardinal directions work. It doesn't mean that that it's at the center, that the North Pole is at the center of the flat Earth. I never said that. Please don't straw man me with that.
You don't know how the flat Earth looks then.
How many? What do you think? What have I told you 50 times already about that? What was my answer the last 50 times you asked?
You can't prove it, and you don't care either.
Well, no, I can't prove it. I didn't. Okay, so why did you add that I don't care?
Speculate then, because you don't care how to speculate.
No, I don't. I choose not to speculate.
Okay.
Yeah, it's
but
not going to get us anywhere. Yeah, I don't know. I don't know, man. Just for fun, for fun's sake, I don't know. There's no way. I'd just be guessing. It's not going to get us anywhere. I mean, I would say logically, if you want me to speculate, that to have a large body of water, you would have to have a container. It's probably not a crazy claim, right? Like if you want to have a large body of water, as far as we can test, that needs to have a container, whether it be a pond or a puddle or a lake or a sea or an ocean. Then it would have to have a container. So to have a contained body of water, it's going to have a shoreline. So I would speculate that there is a shoreline to the world ocean, and we live in basically like a pond, a big pond with islands being the continents. We have a magnetic field system. We have restrictions to how far we can freely travel beyond the south. Yeah. Water is flat on the surface.
Why are those restrictions there then?
Well, I don't know. That's called the Antarctic Treaty.
I know what the treaty is, but why do you think? What are they hiding?
I'm not sure what they're hiding.
Why would they hide anything?
Saving penguins.
Yeah, maybe they want to save the penguins. I don't
So you
know,
don't
man.
know. You don't-
I
you-
don't.
you-
I
you-
can't get into the minds of people
because you're
and
not part
prove
of
to
the
you.
elite.
Well,
I
don't-
told you why they're
Yeah.
saving penguins. Now, why is that not good enough for you?
Nah, that's not good enough. That's not a good enough
You're
reason for
asking us to prove
any
why
countries to
people
do
would.
anything.
Yeah. Why do other people do something? And what's their motivation behind it? I don't know. Go ask them.
Who's them? The United States, Europe,
The people that you're talking
China.
about. The people that you're talking about.
Who are those people? Governments?
I don't know. I didn't make any claims to it. I just said there's a treaty that exists.
Yeah, no,
You,
but
and
who
you
are the
said,
people
yeah,
responsible?
I know all about the treaty. So you need to go and talk to the people in the treaty and find out why they're trying to protect penguins so badly. Ask them that.
They're not protecting penguins. They're protecting
Really?
resources, aren't they?
I don't
That's
know.
what,
Go and
that's
ask
what you
them.
say. You said
Yeah.
you're asking us what they're protecting, and now you're telling us what they're protecting.
I don't know. I just tell you what I read at some point. I'm not an expert like you guys. I don't claim to be an expert.
Okay.
We're not
I'm
an
just
expert on
inquisitive.
Antarctica. We don't give a shit about Antarctica. The only people who care about it is Globers. They're the only ones who care
Yeah,
about
but
it.
you should, because that is where
I should not.
that proves everything. What's
No,
there and what's
measuring
beyond
the
that.
ground proves everything.
No, Antarctica proves everything.
What does?
The South Pole would prove everything you say.
Okay. Well, we don't need to do that. We can already debunk the globe quite easily by
No,
checking for the
no.
curvature. Yeah.
What
it has to be
happens
there.
if the South Pole is not is a continent? So it would.
Who said it's not a
imply-
continent? Did anyone in here say the South Pole might not
How
be
do
a
you
continent?
know it's not a continent?
I
How
didn't
do you
say
know
it's
it's
not
a
a continent.
continent?
Nobody
Nobody
said
said
that,
that.
dude.
How do you know it is a continent then?
I don't. We just said that. We said we
Okay.
don't know what it is. We can't. We haven't checked, and you haven't checked either.
There are pictures of it, but those are fake according to you.
Which picture? Find me a picture. Go type in picture, photograph, aerial photograph of Antarctica from space, and find one that's not CGI. And post it in the side chat.
There you go.
Yeah, go
That's
ahead.
what you think.
Find one find one that isn't
No, for you,
obviously.
it's all CGI or
No,
they're
no,
stitched
go and
together,
look.
and that
Okay,
that
no,
doesn't
no.
prove that proves it.
Okay, go find one that's claimed not to be CGI.
It will be stitched though, obviously. Probably.
Oh, really? So there isn't one then? It's just a bunch of stitched
Why would it
together.
have to be stitched together?
there you go. You see, that's
all you
the
have
problem.
to do is go farther away from it and take a picture.
Or travel around it and see what happens.
Yeah, who did that?
Why don't you flat earthers do it? You don't have
Because
money?
we don't need to do that. We don't, like Professor Triangle just told you, we don't give a shit about that. We can just test locally for what would have to be present locally if the Earth is a globe. It's not
But
present.
if the South Pole is a continent, how
Yeah, we
does
have
it,
families and lives and jobs and stuff like that. So we don't really care about going to do something that no human has ever been validated to do. That's not our job. We don't care about that. You guys are the ones making the crazy claims that the Earth is a spinning space ball and that you don't have any empirical evidence for.
We guys don't care. We just laugh about you guys.
Yeah,
And
like
I'll
a
just
cope
go on.
laugh.
I'm gonna
It's like
go
a cope
myself,
laugh.
get
Bro,
myself
you've
a
been
pizza,
here. You've
and
been
then-
here
and
for
then I'm-
like 6. You've been here for like 6 hours, just coping like crazy, telling me that you
6
you
hours?
don't care.
No.
It's been a long ass time, man. Just coping like one point to
I'm
the
not
next
coping.
point.
I'm having fun. I joined this.
You're
You
just
can
laughing
see,
at you
you can
guys.
see I joined this server today, and I saw this channel. And thought, oh yeah, I need to
Yeah,
go.
I'm gonna
in
go
there.
cope for 4 hours with the flat earthers
And
freaking
he
out.
thought he was going to come in here and have a good time, and he found out that he came in here and started.
I'm having a good time. I'm having a good time,
No,
man.
dude, all you said was look in the sky, Antarctica, dumb shit, nothing to do with the Earth curve.
Because you can't prove it. You can't go there, so it's convenient.
We're not making
Why
claims
do I
about
have
it.
to go there? What is there? And tell me what's there, and I'll go there next year.
If it's a continent, how does the flat Earth look then?
It's measured flat
Is
in
it a continent?
Antarctica. That's how you get angles to a sun. That's how they measured the angles
If
to
it's
the
not
sun.
a continent,
Okay, so what is it if it's not a continent?
maybe a circle, like I saw on some of your maps. It's
Well, what
Our
determines
maps?
if it's a continent or not?
Oh,
We don't have maps. We don't
it's a
have a
continent. It
single
goes
flat Earth
around.
map. You might have
No.
Yeah, you might have a strawman map that you're trying to plug on us. Probably the AE
No, I don't.
projection.
That's not my.
He
That's not
said
we
if
don't
it's
have
a
a map.
continent, it goes around.
Well, you need an edge. You said the body of water needs an edge. Otherwise,
No, a shoreline of some
a
kind.
shoreline is an edge.
Yeah, you could call it that. Yeah.
Well, okay, so there you go.
Yeah, but edge has multiple meanings. Like you could fall off the edge of something. An edge could be like a shoreline specific, right?
A shoreline is the containment for the body of water, right? So
As
that's
far
an
as we
edge.
can test, yeah, body of water needs a container.
Yeah, like a bathtub.
Yeah, or any body of water. Yep. Welcome to flat Earth.
I
Or
know,
you think
I
it can?
can play
You think it can
Minecraft and
stick to
I can
the?
see
No,
how
you think
water
it's
physics
sticking to the?
work.
Yeah, or you could go out in reality as well and see how water physics work.
I don't need to go. In my bathroom, I can make that experiment. I understand.
Yeah.
You're right.
Uh-huh. Yeah. So
And the body of water, they have
conforms.
they have a containment, the continents.
No. You think that all the oceans are stuck to the outside of a ball that's spinning at 1.5 million miles per hour through space.
And that's why you think all the water has to fly off.
No, I didn't say that. You can't have water in a vacuum. You think it's in a vacuum as well, right? That's another crazy claim that has no evidence at all.
No, they say it's inside the atmosphere. That's not a vacuum.
Yeah, which is inside a vacuum, right? Inside the vacuum of space with no container.
Yeah.
Yeah. Yeah, that's not possible. Violates natural laws.
But you can't disprove it because you don't have an
I
experiment.
don't need to disprove it. It's not my claim.
Mm.
What am I going to disprove? What do you need me to disprove, dude?
Yeah, he owns a vacuum chamber.
Yeah, what do you want me to disprove?
Mm.
Yeah, that's what I thought.
Yeah, we can disprove it very easily, but just by showing that there's no curvature of the Earth. Every single heliocentric claim is completely out the window if you don't have that primary requirement, which would be the curvature. It's always going to come back to that.
Yes, all those videos are correct. Yeah, I just need to experience it for myself. Do you still have such a flat Earth convention?
Yeah.
I have no idea. Yeah, there's different conventions. Yeah.
They just did one in October. They did the largest turnout ever. Like before, like last couple of years, it's been in the hundreds.
In the United States?
Yeah, they had it was in the thousands.
obviously.
This last one. This last one was like it was like standing room only. Like they were so flooded with people showing up. They didn't know how to handle the amount of people there.
There's one in Mexico too, in Acapulco. It goes on now in about a week or two.
Mexico, okay.
They have them all over.
So what happened to this Mark Sargent? Why doesn't he appear anymore at all?
We don't talk about celebrity gossip. Yeah, celebrity gossip is not a topic of the channel.
Mark Sargent has a YouTube channel. He does shows all the time, every week, multiple times. What are you talking about? Has hundreds of thousands of subscribers.
He just doesn't. There was a time when he appeared on interviews.
What? He does live shows. He does live shows every week. He's
on
got
his
hundreds.
Channel.
He's got hundreds and hundreds of interviews. It's called Flat Earth Clues Interviews. Okay, so
Yeah,
if you want to go to his channel, you don't hit
that.
videos. You hit live. You hit live, and you'll see that every single week He has a live stream with a guy called DJ Curious, and a bunch of other people. He had
I
Angels of
meant to
Light
say
on last week as
interviews
his
by
guest.
people who are not flat earthers.
Yeah, it's
There was
called
a
Flat
time
Earth Clues. Flat Earth Clues interviews. He does them all the time. Just go to his channel and you
on
can
his
check.
channel. Yeah, I'm talking about other platforms.
Yeah, they're on other platforms, but he also uploads them onto his own
There
channel.
was a time
as
when he
well.
was like all the rave, but
Okay, well, who cares? What's that
in
got
the
to do with
outside world, I
anything?
mean.
Does that mean the Ursa Globe because he's not doing as many formal interviews?
No, I'm just wondering about him.
Okay,
He's like the
all
Tom
right.
Cruise of flat earthers, isn't he?
Is he? Is that really?
But that's the impression I had.
Tom
Or do you have
Cruise,
any other?
crazy Scientologist.
Well, that's
Mark
true.
Sargent. Yeah, no, Mark Sargent. I don't rate Mark Sargent that high. I mean, neither does he. Like he said, he's just kind of a guy that sort of gives people like a brief introduction to the topic, and he's not very good at the technical arguments and that kind of thing. He's kind of like a goofy, geeky kind of guy. Yeah, who cares? What's that got to do with anything? Well, you're talking about people right now instead of trying to present.
Nothing. I'm just curious, man. Why do you?
Was this like
have to be
some
so
weak
defensive?
attempt at like an ad hom or something? I don't know what you're getting
Man,
at.
it's no attempt. It's just conversation.
It's like the Tom Cruise, Flat Earth, Mark Sargent.
Yeah,
I don't think so,
that's
bro.
the impression I had. That's the only fact.
What does that mean then? So he's
nothing.
a Tom
It's just
Cruise.
conversation.
So it's completely vacuous, just without form, function. It's like, hey, this
It's
guy
just
over
conversation.
here.
Nothing more.
Celebrity gossip, dude. This is brain rot. Celebrity gossip, brain rot.
He's
And
not
you're
a
wondering why
celebrity. Not anymore, at least.
Tom Cruise is not a celebrity. He just did like.
I'm not talking about Tom Cruise. I'm talking about Mark Sargent.
Okay, so he's not then. Like you just contradicted yourself. You're like, hey,
No, I
here's
said
the
he was. There was a time, but that's why I asked. Like, I don't see him on BBC
Okay, good.
or any other.
That's probably a good thing.
Yeah, maybe. Yeah, I was just curious, like, what you guys think of
Yeah,
him.
yeah. I don't like his little
That's
snow
all.
globe model that he pulls
I
out
don't
of his
ever
pocket.
watch him, so I wouldn't know what to think of him. That's weird. You would ask.
I don't know anyone, man. I just thought he's like a famous flat earther, but
Cool.
apparently maybe not.
Not really, no.
Well, famous from the perspective of outsiders.
Okay.
Oh yeah, it's just conversation.
Yeah, still no. Still not famous.
All right, cool. I don't know.
That was my take when they wanted to do the final experiment. I had talked to one of the members. I'm like, don't do this. And they're like, why? Because they're going to turn you into a celebrity. And once they do that, once you've got a credited role on a basically reality TV social experiment, you're now a public figure. And once you're a public figure, the same laws that protect from like, slander and libel are no longer apply, because your public persona will now be mixed in with your activism. They're doing this on purpose. It's a way for them to usher in this sort of dehumanizing the flat earther. Like, oh no, it's not like that. It's not that serious. I'm like, what happened after the Netflix special? The same thing. Once they're able to make these people public figures, and they said and did all kinds of crazy shit.
Well, it was pretty funny when Logan Paul did that video. Yeah, I gotta admit that.
What was funny about it?
You follow a lot of flat Earth people, don't you?
What was
Logan
funny
Paul
about
is not a flat earther.
You follow a lot of anti-flat Earthers, don't you?
Not anymore. That was 6 years ago, that video.
Oh wow, it's crazy that you ended up here as a goof, but yet you know everything about these anti-flat Earthers. That's weird shit, dude.
Who? I just Logan because he's a Logan Paul. That's because he's a YouTuber. I don't know anyone else.
Yeah, dude, you can have like on a flat Earth, it's a fully inclusive, open space for everybody. If people want to identify or not identify, they can come and go as they please. Meanwhile, on the globe side, you've got basically brain rot YouTube celebrities, Pokemon hat wearing goofballs. That you guys can
Yeah.
have that. No problem.
I don't
You
care, man.
keep
Like I don't
you
defend
keep
Logan Paul,
Logan
man.
Paul. He can be your Globe Tom Cruise.
Nah,
You
nah,
can
nah.
keep
He's a
you can
dumbass, man.
keep all
But that video was funny though.
keep
Anyway,
you can keep them. Have at it. That's your side.
I don't want him, man. Like I don't watch his videos, man.
Yeah, you do.
After what he pulled off in Japan, nah,
That's what
I
I'm
don't
talking
watch
about. The
his stuff.
Japan one was about as bad as it gets. Walk around wearing a Pokemon hat, acting like an other clown. That's
Not
your
even
side.
that, okay? When he went to the forest,
That's what I'm talking about.
that-
He's wearing in the forest. He's walking around like he's gonna catch Pokemon. Like he was implying that these people who, we're not gonna talk about it, TOS violation, but they went off into the forest. He wanted to like collect them all.
yeah, I agree with you, man.
So
He's
keep
not. He's
him.
not a
That's
respectable
your
person.
guy.
I just thought that video funny though. There's nothing to do with him. But I don't find him funny otherwise. Not anymore. That was 6 years ago.
If it as a nonsensical behavior, you know, scammy behavior like the Globe fits that Logan Paul is a Glober, promotes the Globe, and these weirdos, scammers, the scam, promoting the scam. Yeah, makes sense to me.
Maybe he's not a globe. I don't know, man. He maybe made that video just for money. Never know with those guys. And he made a lot of money, I'm sure, with all the millions of views he got, regardless of what he believes.
Yeah, but as a scammer, he pushes that he believes in the Globe scam. You know, he's a scammer. Don't forget about that. The Globe is a scam. He's a scam promoting individual. There you go. It fits.
That's cool, yeah. You can believe that, yeah.
He's a public figure. We're allowed to. That's what you get to do with that.
But he's a goofball, yeah. Obviously, yeah.
Did you
That's
buy
what he makes
into
money
his
with.
like Pokemon crypto game?
I never bought any crypto of any kind.
Do you remember when
So
he was
no.
going to do that? You could buy eggs, and these eggs would hatch.
I'm sure he did something like that. Yeah, fits his bill, yeah. But anyway, this is not a channel about Logan Paul.
No, it's a channel about anti-flat earthers right now. We're talking about a lot of anti-flat earthers and how you're a fan.
What I've named one video, and before that I talked about Mark Sargent. I didn't talk about anti-flat earthers. I don't know any.
Okay, let's drop it then. No celebrity gossip.
No, okay, fair enough. That's cool. Why do all these other people never say anything?
Ask them.
Who are you talking about?
Everyone in this channel. It's like only
Yo,
few
what
people.
up, Tron? What up, Tron?
What do you want me to say, dude?
Anything.
Yeah, we're all listening.
Tell us your
Yeah,
life
if
story.
everybody talks at once, it'll be audio chaos, and we try to keep it to the room topic only.
Yeah, so someone else bring up something
I'm just waiting on
on
Globe
the
too.
topic.
Yeah, if you have no questions, I mean, yeah, you could head to the home server. You could peruse through some of that information. Yeah, but yeah, we're not here to make small talk or try and drum up conversations about what Globers believe.
Or flat earthers believe.
Or we just talk about the nonsensical belief, the Globe belief.
Yeah, then talk about it. Let's go.
Why will anyone believe that nonsense?
Why not?
Yeah, why not, right? So it's being promoted, right?
But does it harm you?
Well, people believe that stuff because they trust the source of the information. It's precisely what it's called, a belief. It's not based on any personal knowledge. It's just trust that the information you're receiving is correct.
Yes, but is it
Does
harmful?
does it hurt the overall humanity? You know, like when they push this scarcity fear system of special war against your neighbors, scarcity of oil, war for oil. You know, yeah, the globe is definitely it definitely affects the people. Yeah, it does. It is harmful. Yes.
Wait, so you
You know,
can't have wars over resources on a flat Earth?
yeah, but you convince people to believe in an absurdity, you can convince them to commit atrocities. And that's the globe, the absurdity. People are in this nonsense, methodological
Wait.
belief system. And then when the authority that brought them the globe believe, tell them, let's go to war against the neighbor, they just do it.
So the Second World War happened because they believed the world was a globe?
The Second World War, that's probably what, the third or probably the fourth one, the one that you call the second? Because before that, there was, you know, a bunch of world wars before that one, for those ones.
You didn't answer the question.
What's the question?
That wars are caused by people believing the world is a globe?
No.
Yeah, you missed it.
You implied that it's harmful because inculcating this.
It's the
belief.
brainworm, Tron. It's the brainworms.
Yeah, but you're implying this has an effect on all the other human decisions.
Yeah, because they promote this viral mindset, and it spreads like brainworms.
They promote the world is a globe, and that's why the United States kills other people over oil.
No, the
That's
United
why
States
the
doesn't
Second
have
World happened. The
people
First
do
World
that.
War. The people do that, exactly. It has nothing to do if it's a globe or flat or whatever.
Yeah, people do it.
Okay, so
convince people to do it is the tricky part. And with the globe, you can convince a whole bunch of people to believe nonsense.
Convince it. All it takes is to betray your neighbor or sleep with your neighbor's wife to make your neighbor want to kill you. That has nothing to do if it's a flat earth or not.
Yeah, but to convince all of your neighbors around your house and away from your house and people you never met to come to your house and try to kill you for nonsense, that's the tricky part.
Yeah, that's why it doesn't happen. Well, in some places it does.
Oh, it doesn't happen. Okay.
In some places it does happen, but
it does happen. So when you say it doesn't happen, that's basically an assertion.
not the way you. The cause of that is not what you are implying.
No, but the cause of the belief is that it's a nonsensical idea that people, because it's presented or whatever it is, and their state of mind is not found. Is not fundamental. When they can just believe a scammer, like Logan Paul, he has these followers, right? He can promote the scam. People are following the scam, just like the globe, and that's a dangerous way of behaving.
That's human nature. Stupidity is part of it.
It's human nature to scam.
No. To fall victim to scams. Just because you're so smart doesn't mean that has nothing to do if you're flat earther or not. You know, you're still human. We can all agree on that, I guess.
Yeah, you can fall for scams. Doesn't matter.
I can fall. I haven't fallen for one yet, but I can fall as much as you or anyone here or anyone else.
You fell for the Globetard.
Yeah, but it didn't cost me anything, even if
Yeah,
it's a
it cost
scam.
you everything.
What?
That it was going to be a giant leap forward for all mankind. We're going to settle all these past conflicts.
Huh? Because of the moon landing? No, they never. I don't think that. What does it
If you
cost
didn't
me?
think that, then you're in heresy with what they said. Because Nixon said, we land on the moon for world peace.
Because it's symbolic.
Kennedy
Yeah.
said, we do it because it's hard.
Kanye also said, why climb the highest mountain? Because it's there. Or he quoted
And then
someone
after
else.
the Apollo program, no one gave a shit.
No, because what was the Apollo program? It was just a race against
A
the Soviet Union.
giant leap forward for all mankind. This was going to usher in a new age, a space age. You had like the Stone Age, prehistory. Then you had like the Bronze Age. Then you had the Industrial Revolution. Then you had like the or Age of Enlightenment, and then the
And now
Industrial
with the
Revolution.
globe,
Go
we
ahead.
got the scam age, the scammers age.
Yeah, you got the information age that's hallmarked by disinformation and disinformation agents like Logan Paul. That's
The
what your
Apollo program.
information age is. The
The
space
Apollo
age
program was
abruptly
political, man.
dies. The space age abruptly dies in 1972 and is replaced by an information age that's hallmarked by top-down governmental misinformation and clickbait bullshit by scam artists. And you clap. Wow, what an amazing
What
advancement
was
for
the
humanity.
purpose of getting to the moon, according to the United States?
For you to clap,
No,
and be
to
happy.
do it before the Soviet. They wanted
But this
to be
is what it's
first.
cost you. This is what it's cost you. You're demonstrating what it's cost you right now. You don't
Cost
have
me what?
critical thinking skills. That's a huge important part of life, right? And you don't have any. They've basically told you to just believe and regurgitate all of the bullshit that they give you, and you just do it blindly.
And even so, I have a good life.
Yeah, ignorance is bliss, is it?
I'll take it if that's the case.
All right, bro. Yeah, there you go.
Just
This
like
is what it's
Cypher in
cost
the
you.
Matrix.
Yep, you're just happy. It's like a cuck mentality in a way.
That's cool.
Yeah, you're happy for them to bullshit you. It's fine. We got a bit of Stockholm syndrome. No problem. That's fine. I'm happy with my Stockholm syndrome.
Yeah, as long as I have my PC and a good internet connection.
There you go. I rest my case.
Yeah. Do it. Rest your case then. That this still doesn't prove or disprove anything. You just think you're superior to me. No one
Okay,
else has
that would
anything to
be
say.
it wouldn't matter if somebody thinks they're superior to someone else or not. Because on the flat earth, all men are created equal. They're endowed by their creator with certain unalienable rights, life, liberty, and happiness. So someone can think so. They can think that not be the case, that all men are not created equal, that some people are created better. It doesn't matter. They will conduct themselves as all men created equal. So you could be like, hey, over there, some weirdo I met on the internet today. You think you're better than me. So what? Doesn't mean anything. They could
No, it doesn't
think
mean anything.
pineapple belongs on pizza. Doesn't mean anything.
No, it doesn't. That's disgusting.
On the globe, flat earthers are lesser than humans. No, they're not created equal. If you believe in the globe, flat earthers are, lesser.
So all of you guys, you don't go to church either, I guess.
Lesser than monkeys.
You don't believe in a god.
I don't believe in your God.
You think
Who's
we
my
have a
god?
hive mind? You think we have a hive mind and we all think the same thing and believe in the same thing? We have Muslims, we have Christians, we have all sorts of different people. We're just all individual people.
I said a god, not the god.
A god, yeah. So not every single person's religious. You'd.
No, that's
There's
not about
millions
that. I'm not
upon millions
religious.
of flat earthers. How would we know what they all think
No, I'm
and what they
talking about
believe?
people here, not.
See, I mean, if you're looking at that, you can have that idea, like a god, because what you've got then is like, why are all the astronaut, every single person in the astronaut corps is Christian conservative. Every single one of them, 100%. Meanwhile, on the flat Earth, you've got a fully inclusive group of people from all walks of life, covering all demographics, who all value us being equal. Each person has their unique strengths and weaknesses, and we're stronger together.
Like apes.
No, like people, like human beings.
You didn't get the joke. I guess
Yeah,
you never
it's
saw.
like communism.
You've never seen
it's not
Planet of
funny
the
as
Apes.
everyone.
Forget it. It was a joke, man. You didn't get the reference. It doesn't matter.
Yeah, if it's like a communist joke, unless everyone gets it, it's not funny.
Planet of the Apes, man. You've never seen that film?
No, as he left.
Okay.
So you probably won't find many flat earthers that think this is how things happened, right? Like this meme that I just put in the side chat.
No, that checks.
Yeah, but that's what they kind of teach people in the mainstream education system. Just that they're just insignificant specks, essentially, that are here by mistake, lost, going nowhere for no reason at all on a spinning space water ball in a and one day the sun's going to burn out and everything will be ended, and that's it.
But why does that make anything insignificant?
Well, you're just a mistake, right? It's just you're just accident. You just hear, just a little speck of bacteria. Essentially, you're just like
why
a disease on the earth.
Why would that belief make your own life insignificant for you? The time that was given to you.
Yeah, the reasons I just
said. Talked about it. I suck. He said his read of the heliocentric model says that Earth is a speck.
Yeah.
It's just a speck.
So?
Doesn't mean anything, like a speck of sand on the beach. And the sun is a speck. The galaxy, the Milky Way galaxy, is a speck. He goes all the way down to like at the cosmic scale. He says you're a speck on a speck on another speck and even another speck floating around in absolute specklessness.
Yes. People were are fighting on this little speck.
You've got this educator who is in the in the high school classroom telling teenage kids they suck, that there isn't any point to life. And he does.
That's what you believe, maybe.
No, he believes that. It's called the I suck speech. He went around America telling teenagers their life sucks and it doesn't matter. Everything is pointless. That's dangerous. And they probably, some parents would be like, if they had the gall, be like, yeah, my teenage child had some sort of chronic mental illness because the scientific communicator told him he sucked.
Well, I don't believe that.
Welcome to Flat Earth.
No.
You are a very unique,
I'm a human
special
being.
snowflake.
If you believe your existence is meaningless because you are on a globe, well, then that's your problem. You're referring to the pale blue dot thing from Carl Sagan, I guess.
Yeah, the pale blue dot, that's where Gemsy was talking about, but you misunderstood it, so he abandoned the conversation. He's probably like that. He said basically brainworms. Carl Sagan said quite the opposite, that Earth is superpositioned in the universe. There's nothing else like it. This is all you got. This one special place. For some reason, which he did, later on, he said it was God of the Bible. God of the Bible made the Earth special. So you've got this idea where you are special, you are created, you're one of a kind. Earth is one of a kind. The solar system is one of a kind. All this is one of a kind. It's not sucky. It's infinitely valuable.
But he also said that's why it's so important to protect the Earth, because this is, as far as we know now, all we have.
Yeah, all you'll ever have.
Well, me too. I'm going to die in 20, 30 years, so I'll probably, yeah.
This is it, yeah. This is
yeah,
all
so
you've
what?
got. This is it.
Yeah. And
now
what's so
you know
negative
why
about
that everything you do, everything you say, should drive into that point. Just how important every second is.
Yes. What has that got to do with the globe or a flat Earth?
Okay, we're back to brainworm logic again. It's called environmental conditioning.
No, you said I can't believe what you just said. I can't believe that I am not insignificant because I think the world is a globe. And I listened to that Carl Sagan speech.
If you think I said that, go back and listen to the live stream.
No, I'm not going to do that.
Okay, you hallucinated. You just hallucinated. You're hallucinating, dude.
What are we talking about?
You said I said something that I know I didn't say. Then I said, sure, if you think you heard that, go back and listen to the live stream. Get the sound clip. Where did I say that?
All right, let's
and
just
you
go
just
on.
doubled
I'm not
down.
do that.
You just doubled down and said, I did say that. Okay, go back and
what
listen.
are we talking about then? Let's reset. You paraphrased Carl Sagan and the speck in space, and Earth is unique. So
yeah, so is that true or false?
I don't know. I'm not.
You don't know now. Okay.
So let's reset. Hey, let me ask you, Tron. Do you think like all of your ancestors and everyone's sincere ancestors, who that the Earth wasn't this globe that is presented to us today? Do you think all of our ancestors were like just dummies because they didn't know it was a globe?
I don't think they even cared about that. They just cared about getting food on the table.
They didn't care. They aligned megalithic landmark structures of the world in every continent.
You
the
mean
luminaries. You think they didn't care? They didn't care?
People believed in something. Yes, they wanted to believe in something.
So they knew better.
Knew better what? To believe in
About
something?
the foundations and the facts of reality. They acknowledge and work upon it, right?
What, you think in the Stone Age they knew if the world was a flat or a
You
globe?
see, when you say the Stone Age, I think that's the mind virus or the brain worms working for you, making
I
you say that.
I know. Yeah, that's why you believe everything is wrong that is taught. Okay, that's fine. I don't know. That's
What?
what was
Okay, tell
taught.
me what is the Stone Age? What is the Stone Age? What's that?
Whoa. That's not the topic on this call, guys. The topic is why is the flat Earth?
Why is the Earth flat? You mean?
Yes,
Okay,
that's what
weather report.
yes.
What weather report? Why did all of your ancestors and everyone in here knew that?
No, what?
Wait,
How do you
wait,
know
But
they knew that?
wait. You say you're not flat Earth. You don't believe in flat Earth. You say the Earth is round.
Who?
MC.
round? When you say round, you mean like a pizza?
No.
Like a
What do
hockey
you
puck?
think? No.
Like a CD? Oh,
Potato.
like a round table?
Like an orange. Do you think the Earth is like an orange, like a
Oh,
ball?
spherical. No, if it wouldn't be like an orange though, because we know that oranges don't hold water in vacuums. They don't do that.
Bro, what do you like? Do you think the Earth is flat or round, like a sphere? I don't know in English, but what do you think? So I know who to
Yeah,
debate.
that's probably what you meant sphere, right? You
Yes.
asking sphere. No, I don't believe it's a sphere because that will be nonsensical. The sphere claim is an impossibility.
Yeah, but what do you claim? What do you think is the Earth
I
shaped?
think Earth is Earth.
Yeah, but brother, how does the Earth look like? But I have to know
Flat.
if you're on
It
the
looks
same
flat. The
page as
Earth looks flat.
perfectly. Thank you. We have someone who is smart enough to say the Earth is flat. Thank you.
But he tells you that's the way it looks, right? It's also orientated that way because flat is not just the meaning of it's a
Yeah,
description. Listen, it's a description of the surface. Remember when you say round, the round table, you can
it's
say
like a
that
round table.
you can say that round table is flat, right? You can say
Yes,
that. So
yes.
flat is also a horizontal, an orientation,
I know.
perpendicular to vertical.
Yeah, but, look, the funny thing is the Earth is not flat by the meaning of it's not. It has mountains and so on, but I
It
mean
is.
it's round. It's round, and it's if you look above, it's three-dimensional. So if you drive out, if you I don't know fly out, you get to the end of the Earth. You don't do a roundabout like how people say the stupid people. You know, normal people say if you start from India and fly west all the time you get back to India. That's wrong. That's wrong. If you fly to west from India, at a
Hey, buddy, weather report. You know
yes,
Oh,
that
here
the
we go.
airplane. You know that the airplane is designed to work on a motionless horizontal plane.
I don't know, and I don't want to know it, but okay.
Oh, have you ever? Do you ever travel in airplanes?
No,
You don't want to know it, but you want to talk about it. That's like a contradiction
no,
or something.
no. I want to talk about why the Earth is flat. By the
Yes,
meaning of
the airplane is constructed to work on a flat, motionless.
you're teaching me an argument. I understand.
And what is a globe that moves when you fly above it?
The globe that moves, you will only find it like at a retail store.
No,
Like
I'm
you buy the
talking
globe
what
or
geometry. If you take that plane that's designed for a flat surface, what does a globe that turns around itself become when you
no, you
fly
cannot do that
above
though.
it?
That cannot do that because if
Don't
you
talk about
try
what you
to
can't do. I'm
no
talking
no if you
geometry.
try
What
you
does
can
it become?
listen. You said airplane. If you try to use a globe to use an airplane, you'll crash. And you don't want to have your family or yourself in the airplane if it's gonna crash, right? So, and when engineers build it, and when the pilot is about to fly it, they have to ignore the globe. because they want to make it home safe and they want their families to make it home too. You see how that's very important? It has consequences.
I guess I didn't get my point across correctly.
Oh, you trying to make a point, not to get the point?
Nah, it's okay. I give up.
He keeps up. Go ahead, guys.
So you guys don't talk unless someone is here trying to push your buttons?
Are you trying to
I'll
push our
push a
buttons?
button.
Is that what
No,
you're trying to do?
when I'm not talking, no one else is talking. It's like, okay, what is the purpose of this channel then? You don't talk amongst yourself?
Okay, so we are looking to have good faith conversations with people about the topic of the room, whether they want to present evidence for the globe, or if they want to see empirical evidence for flat Earth, which we have a shit ton of. Okay, so
We've seen it in space. It's a sphere.
oh wow! See, here we go. Okay, so
It's
we when you say
astronauts
we,
are taking pictures. Like, what are y'all
But you
even talking
never
about?
talk amongst
well, hold on, we've
yourselves.
got a guy here. Yeah, what do you mean? You've been here one time, and we've been talking to you the whole time that you've been here. So, what are you talking about?
And when I don't
It's
talk,
a
no one else
sphere.
talks.
Oh, okay, cool. Well, pop yourself on mute, and we can talk to this other guy that thinks pictures from space. Right? How did you validate any pictures from space? You just believe what NASA's
Yeah,
telling you.
man.
NASA would
Like,
never lie to us, would they?
dude, there's like satellites in space right now taking
Really?
pictures. Yes.
Okay,
You
pick
guys
one
think that
and
that's
validate it.
fake?
No, I'd say
You'll
that
think
I
like,
could say pick any satellite in space and validate it, because when
well,
I
do
go to
y'all,
Google and I type in photograph of a satellite in space and I hit images, I just get pages of obvious cartoons. Right? So
no, like,
go and do
do
it
y'all
yourself
believe
if
the
you want.
moon landing was fake too? Like, is that what this
You
group is
think the
trying
moon
to?
land? You believe in the moon landing? I thought most
Here
people
we
were
go.
kind of clicked onto that already. Have you looked into it?
Yeah, dude. No, all of your like conspiracy theories have already been discredited.
Conspiracy.
Like,
Or
Oh,
maybe the
really?
old trolls.
no,
Yeah, really. Yeah, maybe you guys are being trolled by a spy
no,
agency,
dude.
an intelligence agency, which is what NASA is.
Why would they lie though?
Oh, why would they
What?
lie? Why
So
would the government lie? Yeah, they would never lie, would
You don't
they?
have an answer to that. You
What?
don't even have a
Where will
speculation.
scammers lie? Why will scammers lie? Why?
what
But
what
scammers
would
means
be their purpose? Like,
exactly.
tell
Do
me
you
like
guys
what their
think the
purpose would
governments
be.
do you guys think governments don't lie?
No, I believe
No.
governments lie, but what
Why
would
would they
be like
lie?
their?
Why would they lie?
No, you're
Prove to
cutting
me
me
why
off.
would
Like,
they would
what
lie.
they would lie to protect themselves, but what is there to protect about like lying about the Earth being a sphere? Like, what
So
is
you
there
can
to like?
assert that you know that that's the only reason why they would lie is to protect themselves. You know that for a fact. You can prove that.
That governments have lied many times to like protect their interests, but what is there to protect in like claiming
So do
that
you know all of their
the Earth is
interests?
a sphere? No, I don't
So
know
do
all of their
okay.
interests. I'm
So
just I'm
why
trying to
would you
theorize
expect
with
that
you
we
guys.
know
Like,
their interests?
I'm trying to theorize like what could be their
Listen,
end game in like lying about the Earth not really
listen.
being flat.
Most of people are not lying. Most of people just believe it, just like yourself, though. Like, you mean your teacher when she told you Earth is a globe, spinning globe. You know that she wasn't lying. She believed it too. So when you
Yeah, but
ask people,
So
he's welcoming us to speculate about why somebody else
yeah,
would
I'm
act
trying to
in a way that
understand like
somebody else would
why
act.
do you think that this lie there's this big lie
Well,
that
shouldn't
the
you be
Earth is
asking a
round?
bigger question? How do we know that the Earth isn't curving? Right? Wouldn't that be a better reason to
Okay,
move forward in this
so
line of
all
questioning
right,
instead of
so for
making
the sake
assumptions about things that you can't verify?
All right,
and
so
you're making
I've
assertions that can't be
floated.
verified.
All right, so I've never floated into space and seen it with my own eyes. I've trusted the pictures. So to your guys' point, let's say all those pictures are fake, the moon landing was fake. Like what's their motivation to lie about it being a sphere?
Okay.
Like
Who are you
Why
talking
not?
about?
Why wouldn't they lie to you?
Well, hold on. I want to know who he's talking about. Who are you
Yeah.
claiming is lying about it?
well, you guys claim that NASA is lying that the Earth is a
No,
sphere. Like those
you
pictures
brought
are
it up.
fake.
Yeah, you said that. No one here said that. Okay, I think the people that work for
Uh,
NASA, okay, just because they fake the moon landings doesn't mean that they're lying about the flat Earth. It doesn't really have anything to do with that. You can believe the Earth's a globe, right, and lie about going to space, or you could know that NASA faked the moon landings and still believe that the Earth's a globe. It's unrelated to flat Earth. Okay, we're not claiming, or I'm not claiming that they're lying about that. Okay, I think most people that work for the government, professors, most scientists, these kind of people, they're just repeating information that they learned throughout their life, and they've probably never tested the Earth, right? They have been taught it since a young age. They probably never had counter evidence presented to them. And what we're talking about is empirical evidence when we actually go out and put the math that we're told about the globe to the test in reality, and we can see distances that would be impossible on a globe consistently. Right? That's one point.
okay. But haven't there been like explorers that have like seen the curvature of the Earth, or don't like I don't know, don't people that survey lands have to account for the curvature of the Earth? Like hasn't been
No.
scientifically proven to your point, like through
No, that's
measurements that there's a curvature of the Earth?
exactly. You would think that people would have gone out and measured the curvature and validated it, throughout all of history. The more you look into this, the more you're going to find that's absolutely not the case, and that's not how the globe became a thing. Now, surveyors, they take plane surveying measurements, okay, and then later on, they adjust the mathematics to make it fit onto a spherical coordinate system. No one's gone out and actually physically measured any curvature or validated that the surface of the Earth's curving. And we're not claiming to know the shape of the Earth, but when we go out and test over large distances where there would have to be X amount of curvature, which we can calculate, there's zero. And there's a huge amount missing over these distances. And we're just showing people, hey, check these out. Okay, put on your critical thinking cap, have a look at this observation where we shoot a high-powered laser, a $30,000 laser over 40 kilometers, just above the surface of the water, and it hits a target at the same height on the other side, and there's 400 foot of missing curvature over that distance. And then they do it 5 more times, and it hits the target, and then we go do it again in different places, and then we acquire all of these different tests showing that, hey, the thing that would have to be there if the Earth were a globe is never there.
So okay. So if I'm like staring at a ship on the horizon, which I've done like on the beach, like I live pretty close to the beach, like when it disappears,
Mhm.
it's not all at once. Like the ship doesn't disappear all at once, right?
It
And if I
depends
zoom
on.
in with the camera,
Yep.
if I zoom in with my camera, it doesn't bring the whole of the ship doesn't come back all at once. It's gone. So that matches like a curvature perspective, right? Like on a flat plane, in your guys' argument, if I'm staring at that ship, the whole ship should shrink like
Yep.
uniformly as I'm staring off in the distance, but a ship doesn't disappear like that. So, I mean, that's my like
Yeah, but
observation from a naked eye. Like when I'm on the seashore, like
okay.
trying to with my binoculars, like tracking the ship, like disappearing in the distance.
Gotcha. We got the
I,
argument. Yeah, most people have the same argument. Okay,
Yeah, here
and
comes the answer.
yeah,
okay.
so I'll put a few videos in the side chat. Now, if you
Oh,
don't
here we
have,
go. Here we
you know what
go.
ocean swells are, right?
Yeah.
Yeah. So obviously, as the ship moves away from you further and further, it's going to get smaller and smaller just due to the way perspective works. If we have
Right.
ocean swells, obviously those ocean swells are still close to you in the foreground because they're constantly rolling in, and the ship will look like it's disappearing bottom up as it continues to shrink in angular size, but you still have those ocean swells in the foreground. Okay, if we take away the ocean swells, what you actually suggested does happen, and the majority of the time, we can just see the ship getting smaller and smaller and smaller, and then you can't see it anymore because it's too small for the human eye to resolve. Then we can take out a high-powered zoom camera, a telescope, binoculars, and we can zoom in and see the whole boat again. And then occasionally we can have different types of miraging effects, which you're probably aware of. One of those is called an inferior mirage, where it looks like something is like obstructed bottom up. Even though it's physically not obstructed, it appears to be, right, according to the definition of an inferior mirage or sinking refraction. Now have a look in the side chat. Okay, here's a giant ship.
Mm-hmm.
Now as the guy zooms out, as the guy zooms out, you can't see the ship at all. Even halfway through the zoom, you can't see the ship. When he zooms in, you can see the whole ship again. Now picture this ship close to the observer, and he doesn't have a camera with him. He watches the ship go out. It's just going to do what you said would happen. Okay, it would just get smaller and smaller and smaller. This is what happens most of the time. You'll notice there's no waves, no ocean swells, and no obvious miraging effects. This is what happens most of the time.
But
Okay, if you
the
added
ship's not moving away from the shore.
Yeah, no,
Yeah,
I
so
see your point. I mean, I definitely
I
have
think this guy
seen
gets it.
swells like play tricks on my eyes before. Like, there's definitely that effect to your point, but
Yeah, so if
all
we
right,
added
I
ocean
was just
swells into this,
like,
But he wanted to say but.
huh?
dude, we don't need your help chatting with the other guy. You've been in here coping for like 5 hours straight now.
Coping?
Just put
No.
yourself on mute for a bit. Go get a glass of water or something.
But what he said is bullshit.
Sorry, what?
What?
Who said
He
it's
didn't
bullshit?
say the ship gets smaller. He said the ship disappears, but not uniformly. Your
Yeah, but
gift there, that ship is not moving away from the viewer.
Dude, do you
That's true.
seriously,
That's
like,
true.
you lack logic, okay? So let's just, okay, so when
He
he
said
zoomed
it's
out, you
true.
can't,
Okay, I'll let him
yeah,
talk.
so when you
Yeah,
zoom,
no, like he brings up a good point. Like,
it's
we're
not a
not
good
talking
point.
about
I'm
isn't
going to
necessary. That ship's
explain
just
that.
chilling out there.
Yeah, okay, so why can't he see it when he's zoomed out? When he's zoomed out, why can't he see the ship?
Because he has human eyes only. He's not a
Right.
people.
Yeah, okay, so if that ship was close to him and you watched it going out, it would just get smaller and smaller and smaller until you can't see it anymore, right? And then he zooms in and you can see the whole ship. Can you reverse engineer this situation? It's pretty
The ship
simple.
didn't go away from him.
Oh my god,
It's a
why can't you see the
90-degree
ship?
angle to him. You see
So
the ship.
if the ship, okay, this same ship here, if the ship was close to him, he sees the big giant ship in front of him, and then it sails out to the spot where you can see it here. He can't see the ship. It doesn't disappear bottom up, does it? It just gets smaller and smaller and smaller until it gets below 0.02 degrees, which is the angular resolution limit of the human eye. Then, right, he can still see the horizon, but there's no ship. Now he can zoom back in because we have amazing technology to do that now, and he sees the whole ship again.
Show me that video then.
It's in the side chat at 42
No,
minutes
that
after
ship
the hour.
is not moving away. That ship is in 90 degrees.
Oh my god,
to
are
the
you
viewer.
this dude? You cannot possibly be this dumb. It's not possible.
What?
I mean, he brings up a good point. The
In
ship's
what
just
direction is
chilling
that
out
ship
there.
pointing? Huh? In what direction is that ship pointing?
It's
Yeah,
oh
it's
my
not.
god.
It's not moving away to this
Say
guy's point.
it.
Like, he
Say
brings
in
up a
what
good
direction
point.
is that ship pointing now?
Are you guys really this thick?
Say
You
it.
can't-
Say it. In what direction is it
Wow.
pointing?
It's
Just say
anchored
it.
out in the ocean. It's sideways.
It's sideways.
Yeah.
So
Yeah.
this video doesn't show it moving away.
Yeah. So when he
Yeah,
zoomed
you
out,
gotta
you
get one
can't, you
moving
can't
it
see the
away.
ship. You can't
Show
see
me
the
a
ship.
video where it's moving away, just what you described, the way you described it.
Yeah.
What do you think
I
would
agree.
happen? What do you think? Okay.
Just show
How
it.
are you
No,
guys?
doesn't
Hey,
matter
bro.
what I think. Show it. Is there a
Shush.
video like that?
Tron, shush for a second. Okay? Can you guys not visualize what would happen if that ship sailed out to that spot and he was watching it? Can you not picture that in your mind and picture that it would get smaller and smaller and
I
smaller?
think just looks like a donut.
Wow, they're getting smarter by the second.
A donut? No, it doesn't look like a donut. But I want to see. Well, to that guy's point, like I want to see one like I was saying, like traveling away instead of one just kind of chilling out there on the horizon. So y'all need like a better video
No. Oh
example
my god.
to argue
Okay,
your
so
point.
if it was sailing away to that location, if it was sailing away, would you see it disappear bottom up?
If my eyes were that good, yes.
So with normal eyes, 20/20 vision, would you see it
No,
disappearing bottom up? No, you wouldn't, would
probably
it?
not, because
What would
I can't
happen?
look that far.
Yeah, what would
I
happen?
can't
It
look
would
that
just get
far.
smaller, wouldn't it? It would just get smaller and smaller and smaller, and then you can't see it anymore, and then you can zoom in and see it again.
No,
So
I don't
in
think
my
you can see
experience,
it
what
again.
disappears first is like the main body of the ship, like the part that floats in the water and then holds the rest of that top part up. That's the part. That's my point.
You
Like
saw that. You
that's the
saw that with
part.
your
If
own
you're
eyes.
zooming
Did you
in,
say that? You said in your own experience. So you actually saw that happen.
yeah, dude. Like I live on the ocean. Like if you get binoculars and you're watching a ship and you're trying to like
How long did you watch
track
it
it,
for? You
all of
just
it's
went, I want to watch
all the
that
way,
ship.
dude.
I'm
Like
gonna
the
stand here
same
and I'm
thing.
gonna
Like
watch that ship. How long did you watch it
dude, it's
for?
the same. Like it's this. If
Yeah,
you're
I think you're
chilling
full of
out
shit, bro.
there,
I think you're full of shit.
you're not even giving me an what? I'm full of shit.
So
Like
why do you
Yeah,
guys
dude,
not
like
make that
how long
video?
did you watch it
Make
for?
that video.
How
Tron,
long did you watch it for?
just put yourself on mute, bro.
Why don't you
How
until
long
make
it
did
that
you watch
video
the
then?
boat
disappeared,
for?
man. Until it
Okay.
disappeared. I'm explaining like until it
How long was
disappeared.
it? How long did it take?
How long did it take to disappear?
Yeah.
I don't know. I wasn't timing.
Yeah, I think you're
What
full
does
of
the
shit.
Okay,
time as
what
to
was
take to
the height?
disappear have to do
What
with
was
Why don't you
anything?
guys make that experiment and video it? Huh?
we just
Okay.
showed you.
Yeah.
We just
Next
showed you
time.
one
No, you
where
didn't show that. You didn't
No, you
show that
yeah, we
didn't.
did.
that
You
exact
showed one that's
scenario.
just
Actually did.
chilling out there on the horizon. That
All right,
one's not
That
sailing off
scenario.
into the distance.
Okay, all right. Look, now it's time to just tear your globe apart. Okay, with
There you go.
with an
There you go.
observation. Here we go. Here we go,
The
Mr.
scenario.
Coke. Okay, Mr. Coke boy. Here we go. Let's see if you guys can focus on this. This debunks the globe once and for all.
No. It's
Yeah,
a video of
yeah.
that
You're gonna
scenario that you
listen to it.
described.
Okay, so here we have an observation where the camera is placed 1 meter above the surface of the water. And we're zooming out on a windmill farm that's a known distance away from the shoreline. We see
That's
6 windmills.
stationary. It's stationary though.
It's stationary, so we could easily calculate how much should be hidden behind the curvature of the Earth, right?
You assume that
Right?
the Earth is a perfect circle.
It's okay. So over this distance, we can calculate how much curvature there should be because the Earth is so close to being a perfect circle. It's only 0.33% of being perfect. Okay, so according to the mainstream, we can easily calculate that there would be approximately 52 feet missing of the 11.2 mile windmill.
Where was this taken?
Worthing Beach. This is called Rampion Windmill Farm. Okay, would you like diagrams? Would you like? So this guy's called Dr. John D. Okay, he's the one that's taken the video. So I can give you a diagram of the windmill farm if you want. Google Map distance marcation. Okay, so here's the windmill farm. Okay, so we can see 6 windmills. So the closest one's 8 miles out. And the nearest one, the closest one's 8 miles, and the furthest one's 11.2 miles. Okay, now we can do some basic math. Right, on a globe with a radius of 3,959 miles, we have a distance to the object of 11.2 miles. We have an eyesight level of 3.5 foot. That means that the horizon should be at 2.29 miles away. Okay, that's why we have the windmill farm there. It serves as a distance marker. Okay, that means that the bottom 52 feet of the windmill tower should be hidden behind the horizon.
But that other video doesn't exist. That's a pity, though.
What other video?
The scenario that you described to me of a ship moving away from you.
Okay, so does it matter if this is a ship or if it's just any object? It's a known distance away. So according to the globe mathematics, okay, the
That's one
horizon.
example.
Yeah, I could keep going for hours with
No,
showing
but
you
the other
different
one doesn't
examples.
exist. There's no such video.
What other
is
one?
there?
What other one?
Why is there no such video if it's such
Yeah,
a
so we can
simple
see boats
example?
that should be hidden behind the curvature of the Earth. In fact, in this observation, we can see a boat that should be hidden completely behind the curvature of the Earth, beyond the windmill platforms.
Because of a mathematic formula.
Yeah, because of the mathematical formula that aligns with the globe Earth. That mainstream that I can send you the citations for from, say, Washington University. They will tell you how to calculate the distance that the horizon would be depending on the height of the observer. Okay, it's 1.225 times the square root of the observer's height in feet, and it's based off the radius value of the Earth. Okay, so if you're 3.5 foot high, which is 1 meter, okay, he's got the camera on a tripod at that height. That means the horizon would be 2.29 miles away, which is about 3.4 kilometers. Okay, and then we have a known distance to the windmill platform, 11.2 miles, which I think is 18 kilometers. Okay, and the bottom 16 meters should be hidden behind the horizon. And this is another thing, right? You shouldn't be able to see any water beyond the horizon line. So on a globe, the horizon's a byproduct of the curvature of the Earth, right? Right?
So you use a formula that describes ideal geometry.
No, this is
as your argument.
Yeah, so this is the geometry that would be present if the Earth were a globe.
No, but it's ideal geometry.
Yeah, so when I say, okay, we can say approximately 52 feet should be hidden. So anywhere on the Earth, if you have a body of water, okay, there would be approximately X amount of curvature over X distance. So let's say we have 10-mile distance, there would be approximately 66 foot of curvature, no matter what the elevation, no matter what the location, whether it be a lake, whether it be an ocean, right? Because of gravity and the radius value. Okay, the radius value doesn't change much depending on where you are on the Earth. They say it's a tiny little bit fatter at the equator than it is at the poles. Right, it's
not going to vary
like
enough.
6 miles or something like that. It's hardly anything to the point where over 20 miles or 10 miles, you would have to factor that in. And if you did factor it in, it would mean the horizon would be, say, instead of 2.29 miles, it would be like 2.292 miles or something like that. That's why the universities and whatnot, they don't factor the oblate spheroid difference into their equations because it's so close, it's insignificant. They also don't factor elevation in as well. So you could have a lake that's 20 miles across, that's 4,000 feet in elevation, or 20 miles across on the ocean. It's going to have approximately 266 foot of curvature over that distance. You can double check any of this stuff I'm saying. Now, what I'm showing you is it's not just a little bit off, it's orders of magnitude off. Okay, that windmill should be hidden by 52 feet of curvature if the Earth's a globe. That has to be. Physical obstruction.
And the horizon has to be at a certain distance too.
Yep, it does. And in every single observation we make, it's not present. The geometric horizon's not present. The curvature's not present. There's zero curvature. Right, I could show you more if you want to see different ones. I can show you longer ones. I could show you teams of field engineers going out with a $30,000 laser, hitting a target 40 kilometers away with over 90 foot of missing curvature. The list goes on and on and on and on and on. And there is no valid rebuttal for these. So old dude just posted the full video. Okay, Dr. John D, the Black Swan. Okay, that guy's Dr. John D. Yeah, he's a PhD in spectrophotometry. A very smart guy. He went out trying to debunk flat Earth originally. doing high-powered laser tests and long-distance observations. Okay, so he has an 1.5 hour long video where he shows you this observation on multiple different days, and he goes over all of the technical details step by step.
What
He
about
goes over
refraction
everything.
then?
He goes over refraction. He's an expert in refraction.
I'm
He
asking
has
you,
it.
not him.
Yeah, refraction. So do you know what refraction is? Okay, it's
I
okay
want
if
you
you
to
don't.
tell
Just
me
be honest.
how do you explain when you account for that?
Yeah, so if you account for, okay, so if you have nice clear conditions and we wanted to grant refraction. Okay, so standard refraction according to the globe Earth is 7/6R. So that would mean that it essentially allows you to see 16% beyond the limitations of the Earth curvature. Okay, so that would be the horizon distance of 2.29 miles plus 16%. So it'll take it up to whatever that equals, a tiny bit further. But we're seeing the horizon way beyond the 14-mile boat that's off in the distance beyond the windmills. Okay, this is not possible to be explained with any kind of refraction. Even I can show you a video now of a physics teacher explaining how, sure, we can take refraction into account, but it's 7 to 12% or something like that. Anything beyond that isn't able to, be explained away with refraction. So yeah. Anyway, there's tons and tons of these observations. Look into it. There's a full video there. He goes over everything.
How many months does it take you to learn all this by heart?
I've been looking into this for years. I've done my own tests as well.
Even with the ship?
With the ship, we can see ships that should be hidden behind the curvature.
No,
And
did
also,
you yourself do that?
yeah, you don't. It doesn't have to be a ship. It can be any object that's
So you
beyond.
didn't.
Why would it have to be a ship? Yeah, so I've done my own tests over a 20-kilometer lake.
But not that test.
Does it matter if it's a shoreline or a ship that you're looking at that's 20 kilometers away? What's the difference?
The ship moves.
Okay, so that still should be hidden by a certain amount of curvature over a certain distance, right?
Should be, but have you seen that in a video visibly with your own eyes?
Okay. What are you talking about? Have I seen what?
Have
I've
you
seen
yourself
ships.
made such a video like the one you shared? The gift there.
Yes.
Have you made
Yes.
such a video? Why don't you share that?
Well, because I'm in Poland at the moment, and all my stuff's in Australia where I grew up.
Oh, that's convenient, of course. Yeah. Well,
Yeah,
you're a
well, I'm in
YouTuber. Don't you
Poland.
have that on YouTube?
No, I don't. Okay, so I started seeing these observations, and this is what people do quite often. Okay, so they want to go and double check these things for themselves. Okay, I can show you observations that are being done by other people all day long, right? I don't have all of my stuff here with me, all of my stuff that I have back home. Okay, because I'm in Poland at the moment. Okay, and I don't need to show you something that I've done myself when I can just show you these videos that people that are way smarter than me have done anyway. Okay, and they show it in using much more expensive equipment than what I had access to.
But
Okay,
you
so it
using
doesn't
empirical
matter.
thinking has nothing to do with intelligence or equipment.
No. This has to do with what should be hidden behind something physical. Okay, so if you have a known distance of 20 miles, for example, there should be 266 foot of curvature over that distance if the Earth's a
On a perfect
globe.
geometry, yes.
Yeah. So anywhere. No, I said 200. So on a perfect geometry, if it matched up with the radius of 3959, it's 266.7. Okay, but anywhere on the Earth, right, taking the tiny difference in elevation or oblateness into account, it would be approximately 266 foot. Okay, it would be within a few points different. So it doesn't really matter because
sphere,
yes. Right.
But
So it's
the Earth is
0.33.
not perfect.
So right, and I just went over this with you. It's 0.33% off being a perfect sphere. Okay, so when I get the picture of the globe that NASA gives us, I can Draw a perfect circle around it in Photoshop and it fits inside.
At that
Okay, that's
distance,
how.
you wouldn't see the imperfections, of course.
Yeah, exactly. So over this distance of say 10 miles or 20 miles, okay, the slight imperfections in it wouldn't make a difference. So much so that you don't need to factor them in, and the mainstream
Maybe
doesn't
the
factor
10
them in.
miles is the imperfection, and that's why it appears
No,
all
because this is
straight.
over the surface of water. Okay, so the surface of water is called water level. That's why we're doing it over water. We're not doing it over land that has elevation changes. You don't have elevation changes over a body of water. It's level, right? Water is level. Ever heard of the term water level or mean sea level? Okay, because of gravity, everything's being pulled towards the center of the globe. Okay, and that means that the water would have to be curving at a certain rate. And if it's not, that's impossible on a globe. Okay, you can't have one little section of the Earth that has 10 miles of flat water. That's not something that any globe earther should be saying could be possible because it goes against the claim.
Level means it's perpendicular to gravity, yeah? Not parallel
on
over
the
distance.
On a globe, gravity means that everything's pulled towards the center of the globe, and the level,
Locally,
right?
yes.
Mean sea level means that, okay, anywhere in the ocean, okay, the mean sea level is the same distance away from the center of the globe. And then they calculate elevation above mean sea level, so you could know Mount Everest is 26,000 feet above mean sea level, okay, and this other mountain is X amount of elevation above mean sea level. Okay, so we're testing over the ocean in this one. Okay, so we're using mean sea level, and we're going over 11.2 miles here, and concluding that there should be 52 feet hidden, and the horizon should be at 2.29 miles away, and it's not there. It's not happening. Okay, and then he does it again on a different day. And once again, there's zero curvature. And then we go and do it in, say, a different country. And then we go do it in Canada. And then we go do it in Australia. And then we go do it here and there and there and there and there. And there's never any curvature. And we say, hey, guys, check these videos out. Okay. Do you guys have anything similar that you can share with us that checks out that there is actually curvature? Because all of our videos show that there's zero curvature and nobody has anything. Other than, well, why would they lie? Or what about pictures from NASA and things that you can't actually empirically test? Okay, anyone can go and repeat the tests that we're showing you.
So why, when you build bridges, you need to correct for the curvatures so it meets the other side?
That's incorrect. Okay, find me one bridge where anyone's validated that curvature was taken into account. You might find one bridge where they theorized that there's like a few millimeters or something like that. It's like, oh, this pylon's like 1/3 of an inch or something like that, like to account for the curvature of the Earth. When if you actually talk to engineers and look into it, they say, well, they have to build them with huge tolerances because everything shifts and changes with temperature and things like that. And it would be completely insignificant to even take curvature into account. I mean, we have Lake Pontchartrain, for example, that's over 20 miles across. Okay, we contacted the engineers that worked on Lake Pontchartrain, and they said, no, we didn't take any curvature into account. They don't do that.
And you wouldn't have to if you're just going by the globe Earth's natural, gravitational factors. You just establish plumb, and that'd be it. You wouldn't have to account for it. It just happened.
Exactly. Good point, actually. So
on
look,
any surface, on any surface, doesn't matter if the Earth or whatever, you don't see the end of that surface. So you measure 10 kilometers on the surface, and then to your eyes, according to that formula you use, that 10 kilometers appears almost straight. By that assumption, you then say the whole surface must be straight and flat.
No, we're saying that over this distance of 10 kilometers, there must be approximately 66 foot of Earth curvature. It cannot be completely
Only
flat.
the formula says that, but it's not a perfect geometry.
Yes, but it is water level. Okay, so
water is not level. It doesn't mean it's perfectly
flat. Water
flat.
is not level. What? We're talking about a flat surface of water. Right? So flat that you can see a perfect mirror reflection of it, for example.
Okay.
Yeah, which is
I get that.
another. Yeah. So look, here's another one. Okay, so this is the Great Salt Lake in Utah. Okay, just to show you how nice and clear the conditions were on this particular day, have a look at this picture. You can see a perfect specular reflection of the mountain in the background here. Okay, so this is the Great Salt Lake. We can see huge distances because the air is very dry at this place. Okay, so
Yeah.
what this guy does is a 21-mile observation, which is 34 kilometers. And he sets his camera up on a tripod at 1.5 meters, just above the surface of the water, on one side of the lake. Here's a picture of the camera setup. Okay, here's a picture of the location, and the yellow line shows you exactly where he's observing. Okay, he's standing at the top there, and he's going to be looking across to the other side. Okay, here's just a close-up photograph of the shoreline that he's going to be zooming the camera across to, just so you can see what it looks like close up. All right, now here is footage from his zoom. Right, take note of the shoreline, take note of the big white smokestack in the background. Now this is from 21 miles away. So he does the zoom during the day, and we see no curvature. We see no sign of the horizon over the whole 21-mile distance, even though the horizon should be at 2.7 miles. It's not there. And then he stays there. He does it again at nighttime, okay, because there's less refraction and that kind of thing at nighttime. So he wanted to repeat it. Okay, so he did it again here at nighttime. And what you can see is the exact same thing at nighttime. Now, after they did this observation, they actually replaced the camera with a high-powered laser. Here's a picture of the laser, and they shot the laser across the 21-mile distance as well. Okay, and they hit their target at the same height, 5-foot height on the other side. Okay, over that distance, there should be approximately 293 foot of curvature. Right, taking the camera height into account, there should be 223 foot of obstruction over that distance. That's like a 23-story building. All right. So just last thing quickly, I got to go in a second. Okay, here's a close-up of the target distance. Here it is from 21 miles away, which is 34 kilometers away.
But a basketball would also be flat.
No, you can calculate exactly how much curvature there should be over this distance. The answer is 293 foot. Okay, that's a skyscraper. So basically, where you can see that shoreline, if there was a 24-story skyscraper sitting on that shoreline, you would only just be able to see the top floor sticking out from behind the horizon if the Earth were a globe.
So how does that formula take into account the radius of the Earth?
Okay, so it's 1.225 times the square root of the observer's height in feet. Now, what you could do is you could have a look at the link that I could send you from Washington University. It'll walk you through exactly how to do the formula.
Answer me this now in one sentence.
Yeah, I just did though. Okay, which do you want to work out how much curvature to take into account over this distance based off the radius?
Yes, because if the radius large enough, on a small distance, it will look almost flat.
Yeah, so over this distance, maybe you could go on AI or something right now and just type in on a globe with a radius.
I did that, and it doesn't agree with you.
Oh, yes, it does. Okay,
no,
what's the answer it gives you? Right, I'm on ChatGPT right now. Okay, so
I asked how does the curvature formula they use take into account the radius of the Earth?
Over 21 miles, how much Earth?
No, that's not the right question to ask.
Would there be on a globe?
Okay, ask. Yeah, I'm curious. I'll ask the same thing.
Okay, so you can also go onto any Earth curvature calculator on Google.
What was the distance you said?
Okay, so here we go. On a globe with a radius of 6,371 kilometers, the commonly used approximation for curvature drop is 8 inches per mile squared. So over 21 miles, 21 squares equals 441. 441 times 8 is 3,528 inches. Convert that. 3,528 divided by 12 equals 294 feet. Okay, so I said 293 feet.
Without
Okay, but
any
it's
other effects, you just asked a perfect circle, a perfect curvature.
yeah, so you can then ask it, okay, based on the latitude, right? The Great Salt Lake in Utah. Okay, so I'm going to ask it this. Okay, so
why don't you ask it,
mhm.
does this prove the Earth is flat?
What's that?
Ask it now. Does
Yep.
this prove the Earth is flat?
We're doing that. Oh, dang, bro.
What do you think it will answer?
Okay. Well, I've just asked it how much curvature there is over the distance. Why
That
why
doesn't
would
matter.
that? Yeah, I haven't said anything else other than how much curvature would there be over that distance on a globe. Okay, so if there's
You
zero,
said globe. You didn't even mention
yeah.
it's Earth.
Wait a minute. So
Oh
you're
my God.
asking how
On a
much?
globe with a radius of, hold on a second, bro. Hold on, just hold your question. Okay, so on a globe with a radius of 6,371 kilometers. That's the
Say
radius,
Earth, not
isn't it?
globe.
Oh my God. Are you kidding me? What is
If you
the
say
Earth?
Earth,
You mean the globe Earth? The
no,
globe
yeah.
Earth?
Instead of using the word globe, use the word Earth. I wonder if the answer is different.
Okay, is this the same for a globe with that radius as a globe Earth with that radius?
Yeah. So while he waits for that answer, real quick. So you're asking if ChatGPT is going to give a different answer, but you just saw that there was no curvature in the images taken over 21 miles. So what does it matter if it's going to answer differently? If it tells you that, yeah, you could have a completely flat area, it's going to be a globe now?
Because if you ask the question differently, it doesn't agree
Okay,
with you.
bro. So I asked it, I said, is this the same for a globe with that radius as a globe Earth with that radius? Yes, if the radius is the same, the curvature is the same. Full stop.
If the
The
globe
curvature
is
depends
perfect.
only the curvature depends only on radius.
So you didn't you didn't get the context you have in the world.
Are you talking about the slight irregularities in the topography of the Earth's surface? Is that where you're arguing right now? That it's
If you
not a perfect sphere? What's the
if you ask
percentage
it,
that it's off? What's the percentage that it's off of being a completely perfect spheroid? Like,
Listen, you can go to any number of Earth curve calculators online, made by globers, not by flat earthers. Okay, and check this. They might vary slightly, very insignificantly, but they'll all give you pretty much the same.
that's right. Let me just give me a minute. Here.
Well, hold on a second. I've just typed it in for you specifically. Okay. So at the Great Salt, someone's got me on echo. Whoever that is, can you mute?
I don't know.
Okay, this is what I said. So at the Great Salt Lake latitude, right? This is where this was done. Okay, what would the exact radius be at that location, considering the slight variation of the globe radius? Give the exact amount. Okay, so instead of the radius being 6,371 at this location's latitude, the radius is now 6,368 kilometers instead of 6,371. So how much curve would there be based off this exact radius over the 21 miles? Loading. Okay, so the new answer is 294.3 feet instead of 294 feet. But we have 0 feet of curvature because we can see shoreline to shoreline. There we go. Have a good day. Peace out.
Have a good day, DJ.
What was the height of the camera again?
5 feet.
Okay, 5 feet. In real measurements, it's 1.52. Okay. And what lens did he use? Do we know that?
Whatever
Yeah.
lens is on a P900, Nikon P900 camera.
P900. Okay. What? So is the live stream over?
Yeah, we're all still here, right?
Well, who's live streaming?
That would be the bot at the top left.
Okay. Cool.
Are you trying to figure out something else? Because the P900 has 3 times off. What are you trying to figure out?
Why you're wrong?
Wrong about?
That experiment, the Salt Lake experiment.
Yeah, why is it wrong?
I'll let you know in a minute. Yeah. That's why I asked what those parameters.
He's researching on the spot, guys. He's got us backs to the wall.
Nah, I'm not gonna change your worldview. I know that. That doesn't matter. It's just fun.
That's fair. Take your time. Tell us what you come up with.
I'm not gonna read it all. I'll just paste it in here, and then you can make up your own lights or whatever.
Forget that. Everything that DJ said to you is going against the globe radio. Going against your plane.
You need a better microphone, man.
Yeah, I know.
Yeah, he was audible though.
I hope you can hear me.
Yeah, I could hear you. It wasn't the clearest audio, but you sound better now.
Yeah, I know. I don't normally talk much on mics. This. Hopefully, you pick out what I'm saying.
Might be a settings issue on Discord. Might have to turn down your noise cancellation or your input sensitivity.
I'll do that.
Hey, T-Dub, how you doing, man?
Change my noise suppression on Christmas in a minute.
I always put the input sensitivity down. It usually helps with the cutting in and out, and shut off all the extra stuff. Just go into advanced settings and voice.
How does this sound? Any different?
That sounds perfect.
Okay, I'll keep it like this for now.
I'll catch y'all later. Y'all have a great rest of your day. Cheers.
No. Okay, why is it so quiet in here? Anyways, I'm going to make some noise. For all of our FE guys who know Flat Lloyd's redone version of Sound of Silence, which is the sounds of 24/7 Discord, I redid the tune to it, and I'll play it. And yeah, technically it's what was considered 80s white rap, but it's got a catchy little beat to it. But yeah, we'll have a listen to this. And don't tell me it's not going to play. You're joking, aren't you? It's not going to play. DJ, I'm blaming you.
Off with his head.
Oh, what a shame. Don't tell me Musox is doing weird stuff. Well, if it doesn't want to play, I'll upload it directly so you can play it for yourselves. Yeah, it's got a catchy little beat to it, so enjoy that. Anyways, guys, I'm going to duck off to work, and I'll hopefully catch us all this afternoon. Peace.
Have fun.
I was just going to tell him how to fix it.
Sunfade, you got a mic, bud? Maybe you would like to use words to tell us how the Earth is a sphere. Sunfade. I'll let you have gravity. Okay. Gravity pulls all the water to the center of the sphere. Okay. Can you show the curvature rate of the sphere? That is the measurement we require. You need that drop over distance measurement of the curvature of the Earth in accordance with the geometry that they claim. So 1.2 times the square root of the observation height in feet gives you the distance to the horizon in miles if the Earth is a sphere with a radius of 3,959 miles. If you see farther than that, you are not looking at the geometric shape of the sphere. If you claim that you're seeing farther because light is bending, then now you're admitting that you don't see the curvature rate of the Earth and it appears to be flat to you, and you just believe it's a sphere anyway.
You don't. You've never seen that. I've never seen that. People that claim to have seen that, right? Get them in here to let them prove that. Let them defend their claim of an experience of going so far away from the Earth they saw the Earth as a sphere. Get them in here. You can't defend that claim. It wasn't you.
You're not going to outer space.
Better hurry though, because most of them are dead.
Yeah, for real.
Of
Was it
Apollo astronauts.
less than 26? So that's
Oye, mira.
is that 8 18 for all of the Apollo missions? Because it's 12 that claim walked on the moon. They would officially have been the ones who's officially seen the Earth as a sphere. If they've gone and went in low Earth orbit, they've seen less than 3% of the Earth. They did not see the Earth as a sphere. So you need your moon mission, your moonwalkers to come in. Is on these moonwalkers.
This topic is going to require you to do some research, investigation. We don't expect you to just believe us, just like we don't expect you to just believe them when they say they've been to outer space. Right? You shouldn't just blindly believe someone's story just because they said something or showed you a picture on TV, the internet. It's crazy. Right? Investigate, scrutinize, analyze.
Yo, hello.
What's up,
Hello.
bud?
Was this the flat Earth VC, right?
Yeah, fact.
Can somebody explain to me why you guys believe in the flat Earth?
Well, I'll start off with it's not a belief because it's something that I know. Earth is measured flat, just like you know your shoe size because you measured your foot, or you know how tall you are because you measured yourself at the doctor's office, right? You don't believe that the Earth is flat. You see, experience, and measure the Earth is flat.
Right. Okay. So you believe that this is the reality.
I don't have to believe in reality.
When I say believe, by the way, I just mean know it to be true, not blind.
No, it's acceptance without evidence.
You can believe in
You
something
trust
with evidence.
have evidence. You just trust it. That's belief. I know it because I'm not believing, right? I know the tree is green. I know the grass is dry right now because it's winter time. I know that the sky is blue and there's clouds above my head. I don't have to believe that those things are there. I don't require faith to know that the sky is above my head and the ground, the earth is underneath my feet. I know it is.
Okay, interesting. Then could I ask a couple of questions because I'm completely uneducated when it comes to the reality of our planet. I don't really know.
Earth's not a planet.
Whatever you
Yeah.
want to call it. I don't know, but this is what this is what the status quo is, that it's a planet and what have you. Whether it's true or not, I don't know.
Yeah,
So
okay. Well, a planet is a celestial body that moves in different patterns from the rest of the stars in the night sky. That's what a planet is. Because its original root word comes from the Greek to wander.
okay,
And the reason they call these planets, wandering stars, is because they do retrograde motions. So instead of going east to west like all of the other stars, they'll go west to east and make a loop over a period of nights. And then they'll return to going east and west. And they do that periodically, like clockwork.
okay,
That's why they're called planets and not stars. The Earth is not moving. The Earth is not a light in the sky. The Earth is not a planet.
right, okay. So when you look at the night sky, right, and you see those lights, right, those constellations, right? Why is
Yeah.
it that in the northern hemisphere, right, you see the North Star, but in the southern hemisphere you don't see Polaris at all. You don't see the North Star.
Uh, Well, as you walk away from Polaris, it stops being directly above your head. Like, let's say you can be directly underneath Polaris in the night sky, right? That's 90 degrees above your head. And you travel away from north, you start traveling south. As
Yes.
you begin to travel away, Polaris begins to become closer to the horizon, right? And then eventually it's beyond the horizon. You can't see it anymore.
You can't see it when you go beyond the horizon.
When you've gone far enough away from Polaris and
Yeah.
Polaris has reached the horizon, you are not seeing the Polaris in the sky anymore.
Right. Sorry, it's hard for me to grasp. So is that okay? So
Okay,
that would
stand in
that's,
in a
that's so
hallway,
that
right?
wouldn't
You have
work.
a
Yeah,
hallway in your house? Do you have a hallway in your house?
I do. Yeah.
Okay. Well, when you stand in the hallway with the light that's in the hallway directly above your head, right? And then you walk away from that light and you keep your fingers pointed at the light, right? Your hands begin to come down, right? Because now it's gone farther away from you. So its angle to you has changed. You walked across a flat floor, but the angle from that light has changed. If you did that with a street light and you walk down the street, right? Eventually, you would be looking a lot closer towards the horizon in order to see that street light.
Yeah. Sure, but
You get that?
can't someone
But you
say that?
traveled across. Yeah, you traveled across a flat road, and
Yeah, but
the light, its angle to you apparently has changed. It's gone closer towards the horizon.
So
And
in that
eventually you
example,
won't see the streetlight no more, right? Because if you get far enough away, you don't see the streetlight no more.
but can't someone say that you can't see the street light anymore due to the curvature of the Earth?
You could
'Cause
say that, but I'm going to ask them where did they get the measurement that the Earth is curving to cause the streetlight to go away.
Mm,
And then if somebody's smart, they can pull out like a map and they just be like, here, see, that's a hill. And this hill is in between you and the streetlight. So the hill caused the blockage of the streetlight. And then I'd be like, all right, cool. Curvature of Earth caused the streetlight to go away. And then if you was going to be like, no, 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 it actually went far enough away from you that it actually went down the sphere, right? And you'd be like, well, how far away would that be? Do you know how far away you'd have to be from a streetlight that's 20 feet tall in order for it to like get the fuck away from you and then like actually curve down and around the sphere?
I don't know, maybe 8 kilometers. I have no idea.
Okay. Do you know what the distance to the horizon is? Because that's where, they typically say, yeah, the boat on the water has disappeared bottom up and it's gone
Ye-
out of view because it's gone down the curve, right? The horizon where the Earth appears to the
Yeah,
sky.
yes, yeah, I'm aware of that. Yeah, experiment. Yeah,
Well, it's not an experiment; it's an observation. But do you know the distance?
I don't know the exact distance now.
Well, since I'm an American, I'm going to say this in empiric. 1.2 times the square root of the observation height in feet gives you the distance to the horizon in miles. If the Earth was a sphere with a radius of 3,959 miles, I'm sure you can find this on a metric calculation and get your kilometers from meters. But I know feet and miles. So if I'm at 1 foot observation height, the distance to the horizon should be at 1.2 miles. If I'm at 6 feet, then the distance to the horizon should be at about 3 miles. If I'm on an airplane at 32,000 feet, the distance to the horizon should be at 219 miles. If I'm at 44,000, it should be at 252 miles. If I see beyond that, I am not looking at the geometric curve of a sphere with a radius of 3,959 miles.
Hmm.
What I would then have to do is use trigonometry and take what I'm actually observing and try to derive a radius value. Do you know how big
Right.
the
Okay.
radius value would be? I got a question. Do you know how big the radius value would be if you was 1 foot high and you was seeing the horizon beyond 10 miles?
No.
The radius would be 262,000 miles. And they
200
claim
and what?
262,000 miles.
Okay. Right.
1 foot,
So
1 foot high, horizon 10 miles away. Magnitudes larger than what they claim.
right. So this is the observation side of things, right? So I have a separate question then from that's a bit irrelevant from that. Is the main how would I phrase this? Is your main um what's the word? Your main reason for not accepting the heliocentric model is it because it appeals to the authority? That's the fallacy there, that people believe in this
No,
because because this is what's been propagated by the authority, by people who claim to be authoritative figures in this particular topic,
No,
or is it purely based on observation?
it's on experience. The heliocentric model claims that the Earth is a sphere.
It
It's
does.
a specific-sized sphere. You can't identify whether or not the Earth is curving at the rate they're claiming for the sphere. They even build a framework saying that the Earth will appear to be flat to you, right? It's just too big.
Guys.
You can't experience it. Then they also claim that the Earth is spinning and orbiting. Hang on. Spinning and orbiting the sun, right? So now the Earth has motion. And they'll tell you that you cannot identify the motion of Earth. You cannot use an experiment to identify the motion of the Earth. You are in the same reference frame. Any attempts to try and measure the motion of the Earth will be null.
Mm.
So you cannot verify if the Earth is in motion. Another major claim that the heliocentric model claims is that the Earth is a gas and water covered ball with no barrier inside of a vacuum of outer space. That's orders of magnitude greater than any vacuum that you can create on Earth, right? And it's all of the water that you drink, the air that you breathe does not evacuate off into space like you experience in reality. You have 35 psi in your tire, you get a hole in that tire, now the container is open. And the high pressure tries to equalize with the lower pressure outside the tire, and you eventually have a flat tire, right? You breathe, you expand your chest, that makes a low pressure inside of your chest. The air outside your chest now fills the void. You breathe in, you now breathe out. So by compressing your chest, you create a smaller volume, you create higher pressure inside your chest, and that higher pressure releases out of your esophagus into the outer air, and then you repeat the process. This is entropy. This is opposite of what the heliocentric model claims.
That's interesting, actually. I mean, most of it I'll have to look into because it goes way above my pay grade. I'm not educated when it comes to this, so I have to look into it myself.
Any other questions? Or did he leave? Because I heard somebody leave.
No, I'm here. I'm just I'm trying to think about what you said.
All right. You want any more examples?
No, I'm just trying to think of other ways I could prove the curvature of the Earth, just to see what your response would be.
Okay.
The curvature of the Earth was never discovered. Was made up, fabricated. If you're asking about the curvature of the Earth, it's a made up story.
Sorry, I left by accident.
No, it's all good.
Oh, how are you?
What's up, Deb?
Hello everyone.
What's up, Yemen?
Hi, how are you?
Good.
Always forever to be good.
How are you?
I am over the moon, thanks bro. Thanks for asking me. Where are you from, bro?
I'm from Earth.
From America?
Yes.
Yeah, that's good.
Do you believe that the Earth is a sphere?
I can't hear you. Please raise your voice and speak. Clarify. I don't hear you good.
Do you believe that the Earth is a sphere?
I believe Earth is what?
A sphere.
Spear?
A ball.
Spear? What's the meaning of spear?
S-P-H-E-R-E. Sphere.
Spear. I know actually I know the letter, but I don't know this meaning. What's the meaning of spear?
Globe.
Global?
Football.
I can't hear you, bro. You're sure you're from America?
He's from America, but he believes he's Mexican, so that's why.
Yeah.
Yeah.
Yeah, you need
I'm a
to get it?
Mexican, not a Mexican.
Yeah, I don't believe anything. I believe Earth in the like football.
Yeah, that's what I meant. That's what I said.
The cartoon enemy? Why all silence? Why? I don't know.
Hey, what is
Yeah,
the rooster? Is there a rooster or a chicken?
this chicken.
Does it make
No,
good
no.
chicken broth?
Yeah, like chicken. Chicken.
Chicken
Big
soup?
chicken. Big chicken.
We know what's for dinner.
What
Yum.
about eggs? Good eggs?
Good eggs. Yeah.
Yummy, yummy.
Mhm.
So, do you have any evidence that the Earth is a sphere, a football, a globe, a ball?
Or an egg.
Yeah, or an egg, or a pear.
This topic about this room, about egg, about chicken, just about egg, about chicken. This is the topic.
No.
Yeah, we are very quiet and lazy people. Why? I don't know, but this is life. I know.
What do you think the Earth is? Do you think it's do you think it's
I don't think. I
When
don't think
when
about that.
chickens lay
Plans.
eggs, when chickens laid
Like
eggs, the eggs fall flat on the floor.
lore. I think is misguided schemes like stereotype like about that. I don't believe. I need to eat. Just eat. Okay, slaughter and eat. Just I don't need anything more. Life is easy, not complicated like you think about that eggs from chicken or eggs or what is there? Mr. Muhammad, don't reply on the mail. Why, Mr. Muhammad, don't reply on me? Why? What the fuck, Mr. Muhammad? I will send you another mail and I will call you again. Please reply. Okay, Mr. Muhammad, answer.
Does the rooster sings in the morning for you?
You call me or you call what?
The rooster, does it go good? Oh, like in the morning before the sun rises?
Yeah, but sparrow, you know sparrow? Small sparrow or owl, not rooster.
Ravens, sparrows,
Yeah, sparrow in the morning.
the blackbirds.
Blackbird, yeah. Not black, but
What
it's a
about
small
predators?
owl.
What predators are there? Do you have foxes? Is there anything that could harm your chickens?
Yes, him. He eats the chickens.
Yeah.
He,
What?
he
Yeah,
is the
natural.
predator.
Talk about other animals. Yaman?
Hey,
Yeah, I'm here.
Mohammed.
I'm here.
Mohammed, do you have any predators that eat the chickens? Do you have any predators?
I listen anyone to call me. I am here, bro.
Yes, I was asking you. Are there any dangerous animals that could, like, kill your chickens, eat your chickens?
Like danger element, like about.
Like cats, foxes, anything like that? Predators?
Yeah, you tell me you mean I said before.
Yeah.
Yeah, I said fox. I said dog, danger dog. I said lion in the zoo. I saw the snake
No, I mean,
in the desert.
I
Oh,
mean, your chickens. I mean that eat your chickens. Have you had any animals eat your chicken?
yeah, la, I don't say it, but I have dog. The name of the dog Bahr, and I have 3 chicken. And the Bahr, so one day he ate, forget eat, and catches the chicken, and I will solve this problem immediately because dog can to eat chicken immediately in the same time.
Ah, okay, that's unfortunate. Are
Yeah,
you in the Middle East,
I am from Jordan. I am
Jordan?
Africa,
Okay. Ah,
Jordan.
cool. Hey, you're near the Dead Sea?
What
The Dead Sea?
did say?
The Dead Sea? Yeah. Are you near the Dead Sea?
Dead? What's the meaning of dead? Is a
You know
chicken or
the sea that's very salty and you can float in it.
you mean what I say before?
No,
Sodom
there's
and
a
Gomorrah.
I
yeah. You
don't
know
I
the
don't I don't get it. What to say, bro? Could you elaborate
Dead
more? I need to
Sea,
see your point.
Dead
Yeah, yeah.
Dead Dead Sea.
No, no. I said
You,
don't say before. No.
it's okay.
He he calls it a different name in his language. So names are more formal. So many times they don't translate, so people don't know the name in English, you know?
Right.
So
Yeah,
whatever
translate
they
from
call it.
English to English. No problem. It's your fault, not my fault, because I am listening carefully with you. And you say that I don't understand what you say, but you say another point. I am here to listen and
Okay.
respond
You
after
know
that.
you know
There is a place that has a lot of water, big body of water in English called the Dead Sea. But he said that many times and you don't know what he's talking about. Therefore, I'm
Yeah,
concluding that you
yeah,
call it
like
a
idiom.
different name.
Yeah, yeah, yeah. Okay, okay. I don't catch it. No problem. Okay, is it my fault now?
have you been there? There's a big body of water, big large like area of water, and it's very salty. A lot of salt, and you get in it and you float. Many
Salty water.
tourists go there, and so that they can float in the water. You know what I'm talking about?
Yes, yes, I know,
Okay.
Tito. I know what you're talking about.
Yeah. This is I don't know how to say it in English.
That's what you get for messing with his chickens.
What about the Red Sea?
Is the Red Sea red?
I don't know. Why do they call it the Red Sea? Yeah, man. Why do they call it the Red Sea?
Ask AI. Yo, Tito, in the Spanish community, some people have been talking about. I mean, I've heard some people just there's a video and saying that the maps are upside down. I'm just this random thing out there. He's saying that the north is the south and the south is the north. That kind of that kind of thing, and the continents are upside down the way it's presented. Have you heard that before?
Yeah, I have.
Yeah, it's
It's
doing the
about
rounds.
time.
It's doing the rounds in some videos out there.
Hey, you know what'd be cool in here? Like, I might talk to Vivek about it. Is a bot, right? So you get a bot, and you know how we got the music bot, and you can play audio. Well, you can type into this thing a command, right? And it will translate it into whatever language you want, and it'll play it like in audio in the voice chat. What you're trying to say, that would be
That's a
cool.
good one. You will speak to the bot in text, whatever language, and then the bot will speak it in voice to the voice channel in English.
In English or whatever or whatever language you choose. Like just then, I could have like typed it in English and told it to like translate into Arabic,
So they'll
and then
hear it
it'll play.
in their language.
Yeah. Or even just a text version would be good.
Sounds like a good bot if we will do that. I mean, it's just keeping you going to Google Translate, just texting in the chat, and it will be translating for you. Yeah.
Yeah, as long as it doesn't get heavily used, because then because the idea is to this service to get people to learn other languages. Well, another language, English. And people might get lazy and start just using the bot all the time. But we've pretty much got, like, cause, like, how, the Star Trek, like a lot of that stuff is sort of like we see it now in our lifetime. We see the technology that they was, of course, not with the spaceships in outer space and all that, but like their little devices, like flip phones, like in the original Star Trek series, they flip it open and talk to each other and then flip it back. Like, my grandparents probably never thought in their lifetime they'd see flip phones, right? But then now, they've got the auto translators in the later series, so just auto translate everything. Oh, pretty much got that now because the device, you can get apps, and then someone will speak into the app into your phone, and then the phone will translate it into English for you. Whatever. That's pretty cool.
What they need to do is figure out how to manipulate gravity so we can prove what the fuck it is.
Well, they say on the NASA website that if they could control gravity, they would make breakthroughs in all sorts of things like propulsion. And, yeah, it's in the realm of speculation, and they like to say and it's trickling over into practical science, but that's nonsense. It's not.
If we had this amazing thing that will do amazing nonsensical things, if we had it, amazing things with it, yeah. Yeah, we had that. Just
Right,
it's
because
just
they say that
yeah.
they could create environments on Earth, right, like in buildings where you just walk in and you start floating around. It's like zero gravity, and they could do astronaut training in it.
Yeah, you could relieve people of their compressed discs, and you could make swimming pools and bathtubs without needing walls.
Hey, wouldn't that be cool? Like, yeah, instead of a patient laying gurney or trying to, life-saving operation or something, just have them floating horizontally in midair, and then if you need to turn them over, you just turn them over, like just give them a little push, a little nudge with your finger. There we go. Be like putting them on a hoist,
Yeah, somebody has massive car wreck. They'll have the vehicle roll over top of them. They can just lift the car up off of them. They wouldn't need heavy machinery. They wouldn't need multiple people to pick the object up. Just whoop, done.
Right? Yeah. There's all sorts of potential uses. Yeah. All right. Counteracting gravity. But I think to do that, right, because gravity is this non-physical, magical force thing, so they need to somehow come up with an anti-magical, visible, non-physical force. Australia, you know, East Coast, to experience the aurora. Don't quote me. I think I'm seeing it to the north. And it's a very strange occurrence. I heard something out on saying something. It's due to these solar storms. But yeah, if it's to the north and people, that's unprecedented. That's real. We have a fair bit of cloud cover where to see it, but some people not far from here did, pretty high up. I guess they had range, and they didn't much. Did any of you guys in the north see anything like that? In the States or Europe? Yeah.
Hello, guys.
Hello. What's up, Elias?
Hello. Um, so, are you guys flat earthers?
I don't think most people could say
Okay,
they're flat earthers.
so because I saw a video where um some flat earthers spent a lot of money to try to build something. I don't know what it was. So, and um they basically uh they proved it was a sphere. Actually, I accidentally proved it was a sphere. Um. Yeah.
You're probably talking about the Netflix documentary.
More on the weather.
This is extremely dangerous to our democracy.
I wonder how many Globies know that.
What's extremely dangerous?
The sharing of bias and false news without checking facts first.
What they really mean is it's dangerous to their reliance of the public's perception of authority.
Right.
It's like, yeah, it's like, I don't really care why they lie. Why should I care why they lie? If I was an American citizen, I'd be in an uproar about the fact that they have lied. I wouldn't really be demanding an answer why. I would wonder why, but it wouldn't be the primary concern. The fact that they have lied, tax dollars have gone towards fraud. That would be the major concern.
Yeah, that's massive laundering. You know, if you think about it, let's say like Boeing, for example. They got their contracts with the Department of War. They've got their contracts with other countries who use all of their equipment, right? They've got, you know, commercial airliners flying their products, and then you get the space program giving them however much money, whatever the portion is of the, 62 million a day. And then they don't have to actually uphold giving the product, right? Because the product is in the mind of the populace, right? So they shape some metal and they give it this outrageous price tag and nobody questions it because it goes to space. You know, outer space is so terrible, it's dangerous. We need our people who go into outer space to be alive and survive. So I don't care what the price tag is for some cylinder metal, right? Just keep our boys safe. They don't actually have to do that. I mean, they could supply the people who's manufacturing and putting the parts together, but typically Boeing is not actually building the aluminum. They have the mechanics or whoever with NASA using Boeing products. So they're only ordering what's necessary to build the project at hand. Just overprice the fuck out of it. Nobody questions it. It's unnecessary. And then, like, SpaceX. We're going to provide you internet from the vacuum of outer space as these objects orbit around a sphere. They don't have to actually do that. They could put a couple of things up, make people believe that, hey, yeah, they're sending something up into the sky, but then they're still giving you the same internet off the same networks that they've got and have been using for the longest time. Just reification fallacy.
So
Nobody's in it.
how do they get internet in Antarctica?
I don't know, bro. How do they get internet in Antarctica?
Through satellites
Opa, what's a satellite?
orbiting metal thingy in outer space.
Outer space, orbit, metal thingy. Okay. What if it's something that's just flying?
What is it propelled by?
Stuff? I don't know.
You can look for it through your telescope.
If I make a balloon, am I propelling it?
Yes.
Am I forcing it into the sky?
Yeah.
How?
With the force from the balloon, you're forcing it.
Yes, but what's the method? What's the process? How am I forcing it?
You got a balloon, yeah?
Yeah.
Which uses a pressure differential from within itself and exerts itself to pressurize the satellite up in air.
Yeah.
You
What is
agree with
this
that?
theory about, brother?
You agree with that?
I
Okay.
don't
This
know.
balloon, I got a piece of fabric. I fill it with gas.
Yeah.
I agree with that. Now what?
Yeah.
How am I propelling it into space, into the
You
sky?
you tie the satellite to it, right?
All right. The satellite's tied to the balloon. I got the fabric. I got it full of gas. How am I making it go into the sky?
By tying it to the balloon.
Okay. How am I making the balloon go into the sky?
You're asking me how the balloons work.
Yeah. Is that propulsion?
Yes, it is.
All right. How do balloons move in the sky?
With buoyancy.
Opa.
The
Now,
gas inside is lighter
now
than
the
the air
balloon is
outside of
moving.
it.
Now the balloon is suspended into the sky. How do I make it move? How do I make it travel?
That's for you to say. I'm telling you how you create upward lift with it.
Yeah, but that's propulsion. But you're saying that's buoyancy. So, I don't call that propulsion. I say that I'm exercising something that naturally happens.
Um, yeah, and I'm asking you if satellites are not what is the regular claim they are. They're like using the Earth's gravity pull. What are they using to propel themselves at like 28,000 kilometers per hour?
No, not 28,000 kilometers per hour.
You can check if they're going 28,000 kilometers per hour.
Yeah, I can check an application and it'll tell me and
No,
readvise
no
things
application.
happen. No, I'm talking about like the
Yeah.
actual natural, the shit that we know happens, right? Because Google they wanted to give people internet using balloons, and they manipulated the travel of the balloons by changing the altitude and exercising the different wind currents that exist naturally.
Hmm. So how is it possible if you get around like group of 10 people and they track, let's say, for example, ISS across the sky with their satellites? How is it every time you check the location of ISS, it always matches with the location you can get on a tracking website for ISS? How is it always correct?
How are we going from this? Okay, wait. We went from how does Antarctica have internet to now trying to reify satellites as this orbiting thing, right?
Because
Like
Antarctica is using
you
Starlink.
said,
They're
how is
orbiting.
it Antarctica has internet?
Yeah.
And I'm saying not objects orbiting around a sphere in a vacuum of outer space. I gave an alternative as to how they can have internet in Antarctica, and now we're going into tracking ISS with an application that
Not
calculate and
not
reifies the location of the ISS.
not no application. I'm saying you track it with your own eyes through telescope with 10 other people
Oh,
around the Earth.
damn. So how fast is the ISS moving?
28,000 kilometers per hour.
And you see that with a telescope?
If you got 10 people across the globe, yeah, each and every
I got
other,
If I got 10 people across the earth
yeah,
watching a light move in the sky,
yeah.
how do you now prove that that is the ISS that the people are pretending to be in on TV?
You can take a distance between yourselves, yeah, and calculate how
Okay.
much time.
Okay. No, you're talking about the light in the sky. I'm talking about how do you prove that the people on TV are on the light in the sky?
What? What
NASA
TV? What
has
TV?
ISS live feed, right?
We're talking
They
about live
have
feed.
people on YouTube taking video from NASA's ISS cameras, projecting it onto so-called 24-hour feeds.
Yeah,
And
yeah,
you
yeah.
also have where NASA has, recordings where they interact with children in elementary schools.
Why are you bringing up that now?
Because now I'm trying to get you to take, how do you know that these people are actually on the light in the sky?
Why are you saying? Why are you talking about people being there now? I'm talking about the
You're Yeah,
speed of ISS.
you're tracking a light in the sky.
Yeah,
You say, "Yeah, I see it with a telescope." Okay, cool. You see it with a telescope. You
yeah,
see it in the sky. 10 people across the earth, they see the light in the sky.
yeah,
Cool. There's a light that exists in the sky that moves, and these 10 people across the earth can see it in these
yeah.
patterns. Cool.
16 times,
I
16
agree.
times per day.
Now, I need you to verify how the people on TV claiming to be in the ISS are actually on the light in the sky that these 10 people are looking at.
How do I prove there are people there?
Yeah, that's the question.
Well, don't you have like a video feed from the rockets when they go and board the ISS?
Well, that's their claim. Now that you're saying boarding the ISS, and this is exactly what I'm talking about, the people on TV claiming that they're on the light that's in the sky that these 10 people see. How do you prove that they're not giving you some lie?
I mean, you can basically call them at any time, can't you?
Sure, but them saying, yeah, that's them, they're there.
And they have
Doesn't
that observatory module
Yeah.
in ISS which watches over the Earth at all times. Yeah,
Yes. And then they're
and you,
projecting it to you on TV. Cool. Now, how do you prove the videos that they're giving you
yeah.
are actually from that light that these 10 people saw in the sky?
Well,
And
I
it's
guess you
not
could.
just fabricated somewhere.
Well, I guess you could take like a feed from a weather satellite and compare it to
Oh,
a time when they're giving interviews in that observatory module in ISS, and compare the clouds over the Earth where they're flying above it to the weather satellite feed.
All right. Have you done that?
Have you done it? You're asking me how can I prove it? There you go. That's how you can prove it.
Let's do it. Let's figure it out.
Let's figure it out.
All right. Talk at you later, bud.
Yeah, cool. Where's DJ?
He's busy.
Huh?
He's busy.
He's busy. I got him some. Me and him started talking about the Great Salt Lake video yesterday, and I noticed something in that video that destroys it. You want to talk about it, T-Dub?
What's up?
So let me give you the correct time in the video. Give me a second. I'll post it in the chat. So at 5 minutes and 57 seconds mark of this video, you see the famous close-up of the copper smelting plant. He is recording, right? Can you open the video, man? Yoder, I would like for you to do this too.
Yeah. His friend is near the smokestack. Films it.
Yeah, so here
Yeah.
he's so pause on 557 on the smokestack. So I need you to tell me if you do know what is the height, what is the what's the altitude of the base of the smokestack?
No idea, man.
I'll save you some time. It's 41 meters. Yep. And the height of the smokestack from the base to the top is 337 meters. Yep. And in that still image of the video at 5 minutes and 57 seconds, the close-up of the smokestack, are you really telling me that little sliver of land at the bottom is 41 meters and then the smokestack is 337 meters? Does that look correct to you?
I don't know, man. I don't know.
What do you mean you don't know? There's a little sliver, on the video. It's a liter.
What's that in? What's the 300?
It's
feet?
the height of the smokestack from the base to the top, 337 meters. And
Yeah.
the
What's that in
altitude.
feet?
What? Yeah, feet, whatever.
Yeah, how many feet is that?
What?
How many? What is it in feet?
Hold on. I don't know, man. We use normal metrics here in Europe. Hold on.
Well, okay. What's 290 feet meters?
It's I think 337 meters, like 1,000 feet or some shit. It's like 1,000
Yeah,
feet smokestack.
yeah, because yeah, you shouldn't be seeing that much of the smoke.
Yeah. Let me finish.
There should be water. There should be a water horizon.
Yeah.
You shouldn't be seeing any of the land heights
Sure.
around. Nothing.
So
So that's enough. That's enough. That's enough.
no,
That's the globe debunked. Globe debunked right there.
let me finish my point. So, if the altitude of smokestack is 41 meters, yeah, 41 meters is the smokestack is 41 meters above sea level, yeah. So why in that close up you see a little sliver as being represented of 41 meters of altitude, and you see the whole smokestack? Why is that? Shouldn't you be seeing
Seriously, man, I don't know what you're trying to say.
I'm saying, shouldn't you be able to see the whole 41 meters of the of the altitude of the land of the bank? You have 41
You do.
meters.
You see the bank. See the bank. You see lights.
Yeah, but that's not representative of 41 meters of altitude. That little sliver of land, it's missing.
What do you mean 41 meters of altitude?
That's smokestack, yeah. Listen, that's smokestack, yeah. It's a 41 meters above the beach, above the sea level. Yeah.
Yeah.
So if there's a close up from 21 miles, he's recording it. Why is there not a representative amount of land for those 41 meters in that close up?
Who said there isn't? You know, it's a
Where is
long
it?
way away, right?
Why is it? Yeah. Why did it disappear?
21 miles away.
41 meters over what distance?
21 miles.
No, from sea level.
What? What? What did?
Yeah, 41 meters high over what distance from sea level?
You're saying how much is a smokestack distance from the beach or what?
Yeah.
I don't know how many meters is smoke.
It's going to look quite flat when you're zoomed in, and your focal length is squishing everything.
No, but listen, this is the point.
Yeah.
If no, it's not like that. If sea level
It is like that.
If sea level is, if the altitude, yeah.
I don't mean flat Earth. I mean like you lose depth perception of that depth, like 41 meters high over what depth of distance?
Oh, so
you don't know. Well, won't go do some research. It's your claim.
No. You do some research, because if you lose, so the altitude of the smokestack is 41 meters. There's more than 10% of the height of the smokestack, and if you have on a close up 41 meters represented as not even 1% of the height of the smokestack, how does that how does that happen?
What does the globe predict?
The globe predicts just what we've seen. You see a mirage. You see
No, it doesn't, bro. No, it doesn't.
Yeah, you see a refraction.
No, the globe predicts a horizon, a water horizon of about 2.7.
You see a refraction. That's why you guys still didn't answer. Why doesn't? But on a flat Earth, you think you wouldn't see the 41 meters of elevation?
I don't know that you even have the 41 meters correct. Like how does?
What do you mean? I don't have the. Go
41
look at the
meters
video.
from what? Sea level? Is it Salt Lake at sea level? I don't know.
Yes, so
No, he's
what are you talking?
he's just saying
What,
that the
what?
base of the
Yeah, the base
smokestack
of the smoke, the base of the
is
smokestack
41 meters.
Yeah, above sea level. Yeah, that's what I'm
Okay.
saying.
No, not above sea
Above
level.
sea
Above
level?
the lake. Above the lake's level.
Yeah, that's what I'm saying the whole time.
Who's this? Oh, it's Plain and Truth. You need to mute up, dude.
Plain and truth. Yeah, hot micing, man.
Yeah, Mike.
All right, so claim number 1, it should be 41 meters above what? Sea level or local level above Salt Lake?
Local level. Yeah,
Okay. How do you know that?
it says in the video, man.
Yeah, I know, but how do you know that?
What? Am I gonna take his word for it or not?
Why? I don't know. Should you?
Yes.
And then where's the globe curvature horizon supposed to be relative to the viewer?
Why are you changing the topic?
It's the same topic.
It's not the same topic.
I don't see the problem. What you're saying?
I see the problem. You still didn't answer it. Why?
Okay.
Why is there?
You tell me.
Is there a
Tell me
globe
what it's
horizon or
supposed.
not? Where should it be?
This is my problem.
Tell us what it's supposed to look like. Tell us what it's supposed to look like.
It's supposed to look like just like it looks, but I'm asking you guys, why did the land disappear? The 41
Tell
meters
us
of
why
elevation.
it didn't disappear. You can see it. You can see the
No,
shore.
but you
can
cannot
see
see it because listen.
Yeah, I see what T-Dub sees. I see the land going right up to it. I don't know what your problem is.
But
tell us what
listen,
41 meters. Tell us what 41 like.
How can 41 meters look like less like 1% of the smokestack if smokestack is height is
Tell us what it's
1% of a
supposed to look
smokestack?
like then.
It's
Tell us
supposed
what
to
it's
look like
supposed to look
more
like
than
then.
10% of height of smokestack. The land. It's supposed to look like more than 10% of the smokestack. Because it's
For globe
41
curvature
meters.
or what? Are you talking about globe curvature?
No. This is a good
No.
question that T-Dubs asked. How is it supposed to look like? It's supposed to look
Yeah,
like
on a globe.
no.
Okay, so it's supposed to look like this. Where's the globe horizon at?
No, hold on. Just stick with me for a second
Yeah,
here.
hold on. Where's the globe horizon?
Why are you attacking me? Let me finish my
Where
point.
is the fucking globe horizon?
Why are you mad, man?
Where's the globe horizon?
What globe horizon? What are you talking about?
Yeah, shouldn't there be a globe horizon over the water? Don't you have an equipotential of gravity that's causing a hump of water?
No,
Where's that horizon line?
You see a refraction, man, just like every other place.
Oh, what? No, you're claiming refraction now. So how you can't tell that there's a globe due to refraction?
Oh, there you go. We can just use that too. Refraction. There you go. That's why. The 41 meters doesn't look like more than 10% of the total elevation.
Yeah.
So
Are you denying refraction, Mr. Glober? Gumslanger?
No, but you guys are agreeing with refraction there, yeah?
I've never denied it. So where's the globe horizon?
So what is the point then? Every
yeah, that's a good question. Why are you talking
that's a
gumslang?
great
Why are you
question.
slanging those gums?
That's a great question. So every observation you guys did on a flat Earth, you can make it up for a refraction, yeah? So how do you have any?
No, not
any
every observation.
You just said it. You guys are claiming observation.
No, not every observation. Nobody's claiming that, dude. Putting
You
words
just
in our
said
mouth.
you're claiming.
You're making a straw man.
You just claim refraction for it.
Well, I mean, I don't deny the atmospheric effects of bending light. Do you?
No, but you guys just claim refraction for the missing land there.
No, it's just an idea, right?
Yeah, just
because
like
if
you
you're
do.
going to claim refraction, why can't we claim refraction? Are you holding yourself to a double standard or else?
No, I'm not.
Exactly.
But if you guys claim
okay, then
refraction,
fine. Yeah, okay, cool. Then just accept it. Then accept
cool.
their
But
answer.
then
so we both have refraction. How much of this is globe curvature versus not globe curvature? 85%, 30%. Make some shit up.
Do the curve calculation and you will get how much refraction you get there. But
do the curve calculation to get how much refraction there is.
Yeah.
Yeah, it's exactly what you globies do.
Yeah,
you don't
but
see the curve, but you say it's refraction instead. That's exactly what you do.
But
Well
you
said.
understand. You understand. If you guys claim refraction for that, then every other observation.
We're not necessarily claiming refraction. You're the
You
one who
just did.
So if you're
You
going to claim
just did it. What
refraction
do you
without
mean?
evidence, why can't we claim refraction without evidence?
Well, you did it, right?
No, we did it. We did it to illustrate a point. You're claiming refraction without evidence. So if you get to claim refraction without evidence, can we claim refraction without evidence?
I don't know what you guys are doing, but we know what we're doing,
Well,
buddy.
we're pointing out your double standard, fucko.
Hey,
May I
boys,
inject?
cool down. Cool down, man. Bottom line is, but that shouldn't happen on a flat Earth. You know why? Because at 21 miles, if we have a flat plane, you should be able to see those 41 meters of local sea elevation as more.
Oh, it's just compressed due to refraction.
No, yeah, but on a flat Earth that
Easily.
wouldn't be the case.
Oh yeah, why not?
Because that wouldn't work on a flat Earth. You could see with a
It
great
wouldn't
zoom.
work because it wouldn't
Why?
work. Great
Because
circular reasoning.
Yeah,
because
just
on a
don't just declare it. Give us a reason why it
on a
can't work.
flat plane with a hard enough zoom at 21 miles, you should be able to see simply and clearly the land being represented as it is.
It's not. It's not that good. Okay.
You think it's not that good?
You zoom in to things that are at that distance with the P900. Things are blurry. They're not clear.
Because it's a shit camera.
I'm saying they're not. I'm not saying they're like.
Listen, it's
low
great.
quality.
It's great. It has great zoom capability. It doesn't have great resolution at those distances.
Yeah, I'm not saying
those
resolution, but
Exactly,
why
yeah.
doesn't it? What I'm saying about the image should represent the land mass as more than 10%.
Yeah, you're looking through lots of air, bro.
Oh, there is now.
Temperature
We're looking
changes
through
and
air,
shit.
yeah. Oh, nah,
Yeah, of course there's going to be distortions.
That's
Yeah,
why
we
isn't
agree
why,
with you.
horizon.
why,
There's no
why isn't the
horizon, bro.
smokestack? Why isn't the
Okay.
smokestack distorted?
Look at the image in the side chat. Okay, this is a close up versus 34 kilometers away. We still
Is this
see.
DJ? My
this
boy
is,
DJ came in, man. What's up, DJ?
That's not the same angle, though. You know.
it is the exact same angle.
That's not the same angle,
No,
bro.
it's not. It is not.
This is from.
I looked it up. I looked it
Yeah.
up on Google
DJ
Earth.
is
It's not
lying.
Every
DJ
single
Gutpod lying.
so
DJ Gutpod lying.
every single thing, right? 223 feet should be hidden behind the horizon. You should be able to see water.
Yeah,
and
great.
then you should be able to see a portion of the smokestack. You shouldn't be able
Great.
to see the bottom.
DJ, let me ask you this.
Shut the fuck up.
That is not the same angle, though.
It's almost the same angle. It's the
No,
same
it is
thing
not.
that we're
I can
looking
show you
at.
on the map.
No,
I
I'll
looked at
show
the
you. I'll show you
coordinates.
the angle. I'll show you the angle.
I'll show you. I saw the
No, I'll
coordinates
show
on the
you.
video.
Yeah, I have the
And
coordinates.
another point: the stack is 150 feet above the camera.
The stack's 44 meters above.
Where's the fucking globe curvature horizon?
Yeah. So so there's much more than 44 meters of curvature that should be present of obstruction. Okay, so the bottom of the stack, the very bottom of the stack, which we can see, is only 44 meters above the surface of the lake. Okay, there should be over 100 meters of curvature over that distance. Okay, you're missing a huge amount. And what should it be hidden behind? The horizon. The horizon should be at 2.7 miles away. We don't see a horizon over the entire 21-mile distance. That's not possible on a globe.
No, DJ, maybe he wants to put it at 19 miles instead of 2 miles.
Huh,
Maybe that means it's a globe.
Well, it isn't there either, is it?
Look, no, it definitely isn't. But we'll give you a horizon at 19 miles. How about that? You don't think that's a problem for a globe?
It's right just before the shoreline.
Yeah, now you got a globe radius of like 100,000 miles. Good job. It went from a radius of 4,000 miles to about 100,000 miles. You don't think that's a problem for a globe? We'll give you a horizon that doesn't exist, but we'll put it at 19 miles, or you seem to claim that there is one.
I looked at the topographic.
Yeah, I mean, what the fuck?
Map. I looked at the topographic.
What kind of
map
crack
that
are you
area.
smoking?
Topographic map of that lake. The camera was standing at ground level elevation of 4,000.
Guess what? Topographical maps don't curve the Earth.
Wait.
Topographical maps assume a flat Earth
4,200
from peak
feet.
to peak, valley to valley. The contour lines are drawn with the perpendicular to vertical.
4,200 feet.
Yeah, would you still like to use that topo map, Chief?
Yeah, show us an elevation profile.
Yeah. Please do. Please pull up a topographical map that doesn't show globe curvature and use that to prove your globe. That'd be genius.
And the stack
Got
is
any more whiz-bang
150
proofs?
You didn't let me finish. So the
I know,
camera
because
was
you're retarded off the bat, and I'm tired of listening to it.
4,200
This is
feet
one of the most
You don't know what a
brick-shorted-
topographical map is, Chief.
and 4,335 is
Just
the
keep
bottom
talking.
of the stack.
That's not part of the observation, dumbass, right? That's just something that's in the background. This is shoreline to shoreline. Okay, it's a 21-mile observation.
But they're not the same height.
What's not the same height? The shorelines?
No, the camera and the bottom of the stack.
Yeah, it's 5 foot high. The camera's 5 foot high. We're not talking the stack. The stack.
know that.
Just cross it out.
No, that's what you showed there.
No,
And
it's
not,
in the background.
It's not even the same
It's
angle.
shoreline
I
to
looked
shoreline.
at the video.
Oh my god, you're an idiot. Okay,
He
it's
talked
not
about
part of
stacks.
the
He
observation.
in the video, he
you
says, "Oh
moron.
look, I can see the bottom of the stack." That's his
Yeah, we
exact
can.
words.
You shouldn't be able to see the. You shouldn't be able to see the bottom of the stack. So how much? How
Because
how,
the
how high?
bottom of the stack is 150 feet above the camera,
Yeah. So how much curvature should there be over that distance?
and not as much as you're saying. Still
Yeah,
a
there
little.
is actually.
But
Do you want to see the exact amount?
But did you take the elevation into account now?
Yes.
You
Ready?
didn't before though, because he
Yeah,
doesn't
I did
say
take
that
the
in the video.
Yeah, it does say that in the video. It absolutely says that in the video. Okay, you want to
Really?
see the
Well, let me
screenshot?
check again.
Yeah, here you go. Here's the screenshot from the video. Okay, let's read this out, and then you can say you were wrong, right? If you're here in good faith. Okay, so eye height 5 foot.
That's not what I'm talking about.
That's you just said the
It's
elevation.
necessary.
I'm talking
Yes.
about ground elevation, not the camera height.
Okay, this is so the target distance is shoreline to shoreline.
I know that. I've seen the video.
Yeah, so the smokestack is beyond that. It's just something in the distance.
Doesn't matter. He uses it as a reference point there.
As a reference point.
That's the first thing he said. Oh, I can see, and then he
Yeah, so you shouldn't be able to see the bottom of
He puts in
it.
that photo.
Okay, so the target hidden height's 223 foot.
Because
So how high is
why?
the bottom? How high is the bottom of the smokestack? 44 meters. Whatever that is in feet.
44 meters. What? What are you saying? The bottom of the what?
The bottom of the smokestack, okay, is 44 meters above the surface of the lake.
Yeah.
Okay, what's 44 meters in foot? Let me check.
I don't know.
44 meters in foot.
It's
Yeah,
150
shush.
foot according to this
Shush,
map.
it's 144 foot. Okay,
Feet,
so yeah. Okay, so the target hidden height. Okay, so that's the other shoreline. So it's actually a greater amount because that smokestack's 2 kilometers away from the shoreline. Okay, so 223 feet. You shouldn't be able to see any of the bottom of the stack, but not only can we see the bottom of the stack, we can actually see the shoreline underneath it and all of the features underneath it leading down to the bank, which is basically 4,210 feet or something like that at where the shoreline is. So you shouldn't be able to see any of that.
I
So
would
this-
like to see that video with a better quality. That would be nice.
Well, it's in high definition.
No, I mean a better camera, not a shit camera.
Okay, what's a better camera that could be used? We can see it quite clearly, actually. Like,
Yeah,
are you blind?
but
Are you blind
now
or
imagine
something?
that same image with actual high resolution.
Yeah. So look at this. You're not going to get anything in high resolution that's 34 kilometers away. Looking
With a
through the
big
atmosphere.
lens, yes.
Okay, look at this. This is very clear. Okay,
Yeah, I
so
see
this
that.
is.
I don't see
this
the
is it.
bottom of the stack there.
You don't see the bottom of the stack.
How do you know the bottom? How does the bottom look?
Okay, look at the one below it. This is how the bottom looks.
I've
Okay,
seen the picture. I've seen the
see
video.
how you don't see.
You don't see the bottom there
So
because
so,
it's a
so
different
what-
angle.
dude, I'm convinced that you're like.
It's a
You're
different angle.
trolling.
Though.
You can't possibly be this thick.
No, I looked at the map. So I show you. I can share my screen and show you.
It's wild that he had to come back. Trying to
You're just coping, bro.
Nah, I went to buy some donuts and then I came back.
Tron,
soy milk or
you're
something
doing
like that.
a little bit of
Then I can share my
I've been
screen. I
listening
can
to
show
what's
you.
going on.
Huh? I can share my screen. Then
Well,
we can go
is
through
it going to be
together.
helpful? Is what you're doing actually going to help?
Help you? No, just fun.
Are you going to prove anything with it? Like, are you wasting everyone's time?
I'm just gonna prove that's not the same angle. The first thing.
It's from the same observation, right? He has his friend across on the other side of the lake.
It's not true. He said that's from the marina. That photo.
It's not from the marina. I'll show
That's not
you.
true. I watched the
Shut
film.
the fuck
I
up.
watched the video.
Shut the fuck up before I mute your dumbass. Right? This
Mute
is
me then.
where. Yeah, I will if I need to.
No,
right
mute me
now I
now.
don't need to because you're just gonna show. Yeah, you'd love that, wouldn't you?
I watched the video.
So there's no marina here, right? This is where the image is from. I cropped it myself. Okay, so
Yeah, it's a different
I'll
angle.
do it again right now. I'll do it right now. Okay, it's the same thing, you moron. Okay, so this is what I did. I took this image, and then I hit print screen, and then I posted this image. Okay, then I went to the video, and I took a screenshot.
And it's not the
of
same
this
angle,
of this image. It's the same thing that we're looking at from
But not the
very,
same
very
angle.
slightly.
It's not the same angle. You very slightly. You already said it.
Oh my
there.
god, you should stay on the globe side, bro. You're too dumb for this. Okay, you
I
don't
get-
get.
you
Okay, so
but-
now
I got you. You said oh very slightly. You said I'm
you
a
shouldn't
dumbass
be
because
able
it's the
to
same
see.
angle, and you already
You
said
shouldn't
yourself
be able
oh
to
very
see.
slightly.
Oh
shut
my
the
god,
fuck up.
you're an idiot, bro. You shut the fuck.
No, you just confirm
Dude,
what
you
I
are
said.
the
You said you confirm
most
it's a
bricked
different
glober
angle.
we've had all week. What distance should the horizon
Yeah, I
be
think
at? Yeah, Reductor.
I think
Yeah,
he's
what's
a
up,
little
man?
bit
Good to
bricked
see
right
you.
now.
He's been bricked for
Like
the last 6
Tron, there are
hours.
questions. Oh my, really?
Yeah, he's been here for 6 hours, just getting slaughtered, and now this is what it's led
Why?
to.
Is it a
full-blown
different angle or not?
spaz.
Is it a different
Yes.
Tron,
angle?
wait.
It's just
No,
slightly
just
different.
answer
Okay.
yes or no. Different angle?
Slightly.
Okay, I say yes. Good.
Slightly, yes.
Wait, I'm
No,
confused.
slightly,
Make a
slightly
difference.
Okay,
is
as an
yes.
onlooker, I'm confused about like if it's a different angle, what would that matter with respect to whether you should be able to see the object or not?
Because they're different distances as well. One guy is
'Cause
closer
it
to
could
the
be
stack.
obscured, or like if you said, "Oh, they changed the height," I would be okay. We'll do the recalculation then. But
Because look,
Yeah. So
even at the daylight
Shush.
photo, you cannot
Shush.
see the
Shush.
bottom because
Shush. Okay, so the first photo is just to give you a general idea of what it looks like on that side of the lake. Okay, just so you can see it close up, because when he zooms in from 21 miles away, it's kind of hard to see all of that detail. Okay, the second image is showing you from 21 miles away where there should be more than 223 foot of curvature. Okay, so you shouldn't be able to see the bottom of the smokestack at all. You shouldn't be able to see the bank below the bottom of the smokestack, and you shouldn't be able to see any water beyond 2.7 miles. Everything that you can see in the distance should be hidden behind the horizon. So it should be water, and then you can see a bit of the mountains and some of the smokestack if the Earth were a globe. But that's not what happens.
well, does
during
Tron
the
even
day.
does Tron agree with even that much? Like that's kind of the
No, the guy's
setup.
bricked. Let's see. Tron? He doesn't listen anyway. Okay, so the
you wanna throw that
horizon.
formula again, me?
The horizon should be at 2.73 miles away.
Yeah, I guess
That's
your
the maximum
formula.
distance. That's the maximum distance that you should be able to see the water. Okay, because that's the line in which the sky and the ground should meet. And then you shouldn't be able to see the bottom of the smokestack, the shoreline on the other side. Okay, you should just be able to see a portion of the mountains and a portion of the smokestack hidden behind the water horizon that would be at 2.73 miles. But that's not what happens. That's not what we see during the day, during the night, and then they do a laser transit as well after that. Okay, so they do 3 different tests. Okay, this is where the horizon should be, 2.7 miles. You shouldn't be able to see any more water beyond that point. So you can cope all you like.
What about the compression from the lens?
What compression from the lens? Yeah, so the compression from the lens is going to mean you're looking at a little bit more of a shallow angle because you're looking over such a long distance, right? Kind of like if you look at a chessboard from up higher, and then if you get down lower, it's kind of hard to see all of the squares properly because of the angle. Do you need a meme or a diagram of this? Right? Do you know how angles work and how you can
How
lose a
about the
bit of
atmospheric haze, though, which is apparent in that video?
haze? Yeah, so there's always going to be haze, especially when you're
Especially
looking
on a
over
cold
34
winter day.
kilometers. Yeah, so there's always okay. So it's extremely uncommon to have even visibility that's this far. Okay, so this is a nice dry environment. It's not very humid, so we can actually see much further than we would normally be able to see. Say we were in Florida or something like that, where it's much more humid. You can't see as far. So it's nice, clear conditions, right? Considering
I almost want to help him out. I want to give him the globe answer.
So if you redo this experiment on a hot summer day, will the results be exactly the same?
exactly the same. Well, it doesn't get that. I don't know. I haven't seen it done on a different day, but yeah.
Why
you're
haven't
gonna
it done
get
it on different
fluctuation.
days? On different temperatures, different weather conditions? Maybe that would be a good.
I don't know. Maybe it's a long drive for him or something like that. But he did it. He did it during the day, and then he did it again during the night.
On a
It
cold
looked exactly
winter
the
day,
same.
yeah.
Yeah. So some days you can see further than other days. You know, in fact, I actually went onto Google Earth and just took amateur pictures off Google Earth from this location, and you can see an island that's 50 kilometers away, every single one of the pictures, which should be almost completely hidden behind the curvature of the Earth. You can see it in every picture. And these are just amateur pictures taken straight from Google Earth. You know how you can hover the little yellow man and then drop him down on a place where someone's taken a photo?
Yes, I did that.
Yeah, so we can see back from the target side of the lake where the smokestack is, facing out back over towards the lake. We can see an island called Vermont Island. It's over 50 kilometers away. We can see it in every picture, pictures from 2018, 2019, 2020, just taken by random people. So every single time that anyone ever goes out to make observations, it doesn't match up with the globe, not even close, right? Where's your observations? I could sit here and keep presenting one after the next, right? And you can keep coping. But when I ask you to present something,
what kind of evidence would actually prove curvature?
Yeah, so you should have a horizon at a certain distance, a physical geometric horizon, and then things should be hidden by a certain amount behind that horizon. So you would need to validate that there's such a thing as the geometric horizon. And then you would have to validate that something is hidden behind a geometric horizon. And you would have to take the variables into account because you're making a hyperspecific claim.
Hey.
Which is impossible.
How is it impossible? It's impossible because there's no curvature. Yes,
because
you are correct.
There's so many effects, refraction, weather, temperature, heights.
Oh, so you're saying you don't have any measurements of Earth curvature then?
Hello?
Me?
Hello
Personally,
there.
no. Hi.
So does
Hey,
anyone... Hold on a second, Selma. Just a minute. Okay, so does anyone that you're aware of throughout all of history have one?
I'm here to improve my English.
Okay, well, this probably is a good channel to listen into. Right? Because you're
What do you
listening to
mean?
native English speakers for the most part, and some
Yeah,
terminologies you're
but you talk
probably
very
not used
fast.
to.
You talk very
It
fast.
is
Yeah.
absolutely not a good channel to learn English, and these guys are spouting some really strange flat Earth theories. So
Really?
take it with a huge grain of salt.
Yeah, name one thing that was strange that we said. We're just showing observations.
Empirical observations.
Yeah.
It's so strange to say that water lies level.
What are you talking about?
Yeah,
We're
we're
talking
talking
about the flat Earth on top of a
flat.
turtle.
Yeah, don't believe any of this shit.
I know we don't think it, we observe it and
Oh
measure.
yeah, look, we've got Captain Globes here to try to save Save the day.
Captain Planet. That was a
Yeah,
good
here he
cartoon,
is.
man.
It's you, bro, in the side chat.
Yeah. He's good.
Yeah. He's here to save the globe, but he doesn't have any
He's
evidence to
actually
submit.
rough.
He's just here to whine about flat earthers.
It's gonna
So
take flat
what
earthers
what
down
evidence is there
to
that the Earth is completely flat?
No one said it's completely flat. We have hills and valleys and mountains and all sorts of things, right? But most of the surface area of the Earth that we know about is covered in water. And when we test over large distances over the water, there's no curvature, which would have to be there if gravity is real. And if the globe is real, it has to be curving. And it's not curving, so you don't have a globe.
Yeah, I don't know
Okay,
what
yeah.
sounds nonsensical about that.
I guess. Yeah, well, that's good.
Yeah,
Yeah.
it's just
I guess that's it then.
some coping. Yeah, pretty much it, bro. No curvature, no globe.
So there's an
No
observation
model,
being posted
nothing.
that we've been discussing.
Your
No,
whole
we
I don't
just
world
know if
destroy.
you guys are aware.
exists only of a flat Earth and everything else.
Yeah, we just destroy your model, right?
And
And
When
that's
did he get
what
here?
model? You don't have a model. You just have a.
you don't
just
have a model
table.
either. You don't even know what a model is.
Well, there's a model that people agree on.
Really, like
You
a
don't have
desktop
model.
globe? Like a desktop globe? Is that what you
You
think a
just have
model
a
is?
table and a container, a glass dome,
What?
whatever, and that's it.
No,
That's
no
your
one said
model.
anything about a glass dome or a
So
table.
There
there's
are
no
lots.
model.
There.
You
Hey,
said
bro.
there needs to
One
be a
sec,
container.
bro. Hey. There are lots of flat Earth models. Flat Earth models get used by institutions like NASA, and then other people, like in surveying and navigation, all sorts of fields, bird migration. There's flat Earth models everywhere,
Flat
bro.
Earth, you mean a
Do you know
two-dimension model?
when they
Okay,
measure
yeah.
when they measure magnetic field lines, they use a flat Earth model. They're using flat Earth everywhere.
Because a map is two-dimensional. Yes.
Astronomy uses Earth models when taking elevation angle measurements to stars and azimuth and zenith. Yeah, both.
Yes,
It's
a map is
everywhere, bro.
flat.
You're just
I'm not talking about maps.
This guy doesn't even know what a scientific model is.
How does the magnetism work then?
Magnetism? Well, definitely not from a molten iron core.
How does it work?
That would
I didn't ask you how it
defy
doesn't work.
Curie point
How does it work?
limitations. Did anyone make any claims about the magnetic field
does it
or
work?
core or anything like that?
How does it work?
I don't
Why
know.
do you
You tell me.
expect people to know these answers to these questions that you have?
Well,
dude?
you don't have flat Earth scientists?
Yeah, we have we have plenty of them actually.
Yeah. So
And
what do you
they
think?
never tried to explain this?
So the better question to ask, right, is what of the people that have been entrusted with these jobs with the funding of their people? What have they done with the money? If the Earth isn't curving, what have they been doing? Squandering all the resources.
They
If they were
built
the one charged.
rockets and lying to
Oh,
people about lunar landings, apparently. So
Well,
okay, so
that's
those
probably
flat
one
Earth,
thing.
you're saying flat Earth scientists, they don't have enough funding.
Or the questions that you're asking are unknowables. There's no way to know.
They don't
That
have
could also
enough
be
funding.
So to just quickly, Tron, I was listening to an interview with a scientist that works for NOAA the other day, .gov, right? You know NOAA? So anyway, he was saying that, yeah, there's all sorts of anomalies with the magnetic field and they can't predict it, right? It's something that they don't know everything about. They said even 12 months from now, we have no idea what's going to be happening with the magnetic field, like the way it drifts, the way it works, the anomalies behind it. They don't fully understand it, even according to the globe side. Okay, so you're expecting us to explain things that your side doesn't even claim to have perfect explanations for. We didn't make any claims about that, but you know what? There's no curvature, so it's not a globe, right? That's going to sting you to the core, I know.
Even then, even if that's true, where's
Yeah.
the rest of the system then? How does the rest work?
Yeah, we don't claim to know how everything works.
Why don't you want to find out?
Who said we didn't want to find out?
Because you're not a scientist? You don't want to
Define
find out,
scientist. Define
so
scientist.
you just want to.
Anyone can do science, right? If they do a scientific experiment, but you probably don't know what the scientific method is anyway, I'm guessing.
To measure what's observable?
Yeah, so I told you much earlier in the conversation that we don't claim to know everything. We don't even claim to know the shape of the Earth. But guess who does claim to know the shape of the Earth? You do. Okay, and when we test your claims and your model and your maps and your maths, it doesn't work. It doesn't fit reality. Not even close. And I
How
know
about
that
space?
hurts. Second law of thermodynamics violation. Impossible.
So Jupiter doesn't exist.
Nobody said that. Okay, so Jupiter, as you've been told, right? The story that you've been told about the celestial that we call Jupiter, yeah, that's bullshit because it's a natural law violation. And you just believe
Neptune
it
doesn't
blindly.
exist.
Nobody said that.
Mars
okay?
doesn't exist.
Nope.
You said space
They
can't exist.
No, space as you think it is in your fantasy
How does it work
heliocentric
in your world
model. How would somebody test that?
There you go. Oh, you can't.
Yep.
So you.
Yeah, so we
you
don't make claims about it.
You
We're not claiming
disprove
to know.
something without.
Yeah, falsification. Falsification
Yes, exactly.
is independent of replacement. Retard.
So there you go. So how do you want to convince people of what? Just the world. The world is not.
I don't really care.
Yeah, we're not here to convince people. We're here to show people the Earth isn't a globe because the things you would need to have a globe don't exist.
To what end?
Sorry, what?
To what end? And what's the purpose of?
Who
Obviously, you
cares?
care
Just out of
because you're
interest.
here.
Yeah, we're exposing that the Earth's not a globe. That hurts you so much, doesn't it?
No.
It
I'm
does.
just curious.
Why are you so emotional, bro? You've been in here just spazzing out for 6 hours or something like that.
Because I like to talk. I like to.
This is what you do for fun, is it?
No, this is the first time on this server. Like I said, you can check my profile. I signed up today, and I saw
Cool.
this.
Straight to the Flat Earth channel.
Of course, man.
Best
It's
channel
better
on the
than
server.
Netflix.
Yeah, it's better than. Yep, it is.
Well, it's either that and go to feminism, but I'd rather stay here then.
Yeah, it's the best channel. Sure.
Because feminism, yeah, I would cut my wrists there.
Anyway, it's not like we're all in in sync with some sort of like overarching agenda.
I
mean,
understand that. Yeah.
each you have to take it individually, right? So case by case, each person's going to have different reasons for wanting to be here and discuss this topic. Some people might want to change the world, and have visions of like grand change, right? Societal change. Others might just topic and like discussing it, just like you said you do.
But hey, Flat Earther, tell me how every single thing in the whole universe works.
Yeah, mysteries abound, bro. Mysteries abound. Even your own astrophysicists will say we're 90 dumb in the entirety of the physics of the universe. Yet flat earthers have to explain everything.
So how thick is this flat Earth?
No idea, bro. What's the deepest hole anyone's ever dug to check how deep it can go down?
So when you saw James Cameron going down to Mariana Trench,
Tron, one second. I just have a question or like a statement, I guess. I've been thinking about this for a while.
Mm-hmm.
With all these observations, like the long distance ones, I think they're cool and all, but I think one of the quirks I have with it is that like never when these are shared are like any of the APA measurements or pressure or humidity, like none of those are included or even done. I don't know if they're done, but I haven't seen
some of them they're
with it.
done. Yeah, some of them it's absolutely done. And look, some of them, right? So
that would do. Yeah,
go ahead. Sorry,
you could
man.
share them if you want. If you have them, but yeah, because what it would do is it would say, okay, well, we obviously know refraction plays a role, and so we correctly counted for it. And yet, even after factoring that in, we still see too far. Then that's like that's going to convince a lot of people. But if
Yep.
you just show an image and say, well, we don't know what the refraction was, like it could have been anything, but we still think you might see too far here, but we're not sure because we didn't take the measurement, then it's like it's hard to go. Yeah, it's less compelling for me. I don't know if you guys are convinced by that, but that's not convincing to me.
Yeah, well, if you study into what the meteorological conditions would have to be for the right, for the hidden height to be possible on a globe, you would have to have extreme, like extreme refraction to the point where you would have optical chaos off in the distance, right? Like heavy,
I
heavy
don't know what.
distortion. Well, just let me finish quickly.
Yeah, I don't know how bad it would look because I've never seen it. Like I don't know what it should look like if there's heavy distortion or not. Like I'm
Well, I
totally
can show you
agnostic
an
there.
image. Yeah, but look, I'll answer. I just want to answer all the things you said. So just quickly. All right, here we go. Like here's the kind of things we would be seeing when you've got extremely heavy distortion from refraction. Okay, so you're going to start having things like crazy Fata Morgana effects, superior mirage effects, that kind of thing, right? It's going to look chaotic. Any AI will tell you that if you
mirroring
look
and
it up.
inverted mirroring.
Yeah,
As well.
because you're going to have extreme bending of light, basically, or deviation of light. Deviation's a better word to use than bending. Okay, so you're going to have really, really extreme vertical temperature gradients, which are going to change the optical density of the so the refractive index is going to vary quite a lot. So you're going to have all sorts of crazy stuff going on in the distance. It's going to be crazy miraging looking effects and things like that. Okay, it's not going to be consistent. It's not going to look crystal clear like we're seeing in the observations that we're presenting. Okay, and then it wouldn't happen during the day, and then again during the night, right? And then again on a different day. So there would have to be
some
so
of the
much.
crazy. Sorry, what did you post as the crazy effects? Because in some of the images, you've got like portion of the top of like of a oil rig or a ship, right? You'll see it, and then it'll be inverted and flipped, and you see a mirror image upside down, and then another one above that of the same thing above, like, and almost like it keeps like stacked layers of mirroring going on.
Yeah, exactly. Look, this is the thing, Reductio. We do have tests that have been done where they took weather stations and they did measure the vertical temperature gradient, right, which is the primary controller of the optical density gradient or the refractive index. Okay, and they put it at point A and they put it at point B, to check how
It's
much
pressure and humidity too, right? Like those
yeah,
are it's all three.
humidity will actually lower refractive effects because the water vapor is actually less dense than the nitrogen and oxygen. It's primarily the gases in the air that cause miraging effects or light to deviate. You can look that up if you want. Okay, because they're much more dense. But look, this is the thing. It's tied to temperature. Okay, so it's the temperature.
I'd still prefer all three. Like, do you understand why? I mean, like,
yeah, but they're
those go into the calculation, and
they're intertwined.
For me, this is just me personally. What would be compelling?
Right. Yeah. So the primary thing that
and we can
causes
still see too far.
The primary thing that causes refraction is the temperature gradient. Okay, so it's the temperature that changes the refractive index. So the pressure is caused the pressure change is caused by the temperature change, or the density change essentially is caused by the temperature. Okay, because cooler air is more condensed, so it has a higher refractive index. Warmer air is less condensed. Okay, so the light will deviate towards the denser portion of the air every single. So it is literally completely impossible to perfectly measure what's going on with the refractive index over a long distance between point A and point B because it's constantly changing. It is literally impossible. That's why it's the worst nightmare for the globe side to make hyperspecific claims. Okay, but what we're seeing is clear conditions and we have certain meteorological conditions that would have to be present if you were to have such extreme refraction, which would mean you would have to have a large temperature gradient change vertically between point A and point B. Now we're able to take the temperature of the water and the temperature of the air. If you don't have a change between the temperature of the water and temperature of the air to create that lower layer of cooler air that you would need to have the looming effect, then it's not possible to be able to explain this with refraction, because you don't have the meteorological conditions present to have such extreme refraction. It's impossible for the temperature to be there that would cause that refraction effect, which would be so much refraction that the Earth would look flat. Okay, it would make the radius so
thought it
big.
was I thought it was the temperature at different vertical points. So like at ground level, then like 5 meters up, then 10,
Yeah.
15 meters up. Like I thought that was the
Yeah, well, you'd
gradient,
need that to
not
remain
the water
consistent.
versus the air.
Yeah, and you need that to remain consistent over tens of.
Yeah, so usually what it's caused by is whether you have warmer water than the air temperature or cooler water than the air temperature. Okay, or if you're doing it over land, usually you'll have inferior miraging because you'll have hot concrete or a hot road surface, and you'll always get an inferior mirage. But over water, it's
I can agree that. Yeah, I
Mm-hmm.
can agree with that. Like that can be a contributing variable. I just, like when it's like usually that's the case, is like not compelling enough for me. For you guys,
Well-
maybe like it's
well, here-
everyone has their own standard, right? For me,
So
I
here's
would just like
the-
to see
here's the
a
agreed
proper
upon
measurement along with the observation.
Yeah, so we have that. I can show it to you in a second. So here we have the definition, right? This is like the go-to definition glossary for meteorological terminology. It's all peer-reviewed by meteorologists, and it's been dating back for 60, 70 years. It's the American Meteorological Society. So it's basically says in all of these that it's primarily dominated by temperature. That's what's going to be causing the change in the refractive index, especially like at lower altitudes. So that's the thing. That's the main thing that's causing it. Okay, and we can vary and manipulate this on a smaller scale, right? To show the same thing. But like FE Core, they did their laser test. Just one of them. They did 5 different laser tests, but one of them was over 40 kilometers. Okay, and they put a weather station at point A and a weather station at point B, and they, like the group of engineers, they calculated exactly how much refraction, right? How much the laser would deviate over that distance based off the vertical temperature gradient. Okay, and
I think that one, there was one, I'm not sure if that's the one, but they did like a horizontal gradient. They didn't know how to take the measurement, and they did it wrong. Like they did a horizontal versus a vertical.
No, this one they did horizontal. So they had 2 weather stations, and they measured the temperature down lower.
A and B.
Yeah, they actually says in their paper, they have a 180-page paper that goes along with it. So they said they took the reading at a lower height and then a higher height, so they could see how much the temperature gradient fluctuated vertically at both points. They wanted to take more, but they thought that the lake would be frozen at that time of the year, and it wasn't quite frozen, so it wasn't possible for them to put more weather stations. But the laser hit the target in all 5 of the tests. So that's kind of crazy. I mean, that's 92 meters of missing curvature that would be present. Indio 007 did an awesome observation recently, which mitigates the refraction claim.
I think that's the one, the laser hitting the target thing. I think that was the one that I was looking at. Like we can pull it up and look at their methods, but I think that was, they took a horizontal gradient and they calculated it entirely wrong.
No, I just read the paper recently, and it's a vertical gradient. Maybe you're thinking of a different test. I'm not sure. But yeah, I can show you one that was done. Yeah, I can post it. Just give me a second. I'll post the paper as well. So Indio, while I'm bringing this up. Okay, so Indio did one recently where he waited till there was a day, where the water temperature and the air temperature were exactly the same, and this reading was taken off a buoy that was right where he did his observation. He tracked a ship that was 10 miles out, and he had his camera set up at 15-foot height. And he also had a infrared conversion, which also mitigates the refraction effect by a lot. So the meteorological conditions that you would need to be able to claim refraction as a cause definitely weren't possible, because the air temperature and water temperature were exactly the same. And he also used the infrared. Okay, and he zooms in with the infrared, and he can see the base of the boat, and he can also see the like the little whitewash waves that are coming off the boat as it's moving along. And he has all of the additional information, the time of day, the ship tracking, the water, the buoy temperature readings, the air temperature readings, everything. So it's not possible to explain that one away with refraction. Right, I got the FE core here. Okay, here's the
I think I'm just having a look here.
yeah, me too.
Scrolling down through the PDF.
Mm-hmm. Yeah, so more humidity will create a lower refractive index.
Okay, so measurement 1, they ignored refraction, and well, they assumed they didn't have to factor in refraction. 2 degrees water, 3 degrees air. Which again, I
They
think
don't.
Yeah, so when
that's
you
reasonable,
when you
but that's
factor it in,
They
you
don't.
get zero. So what are you going to do now?
They don't.
Factor
They're
in,
they
already
set the
giving
refraction at
you.
wanting to factor in
They're
the
all.
zero.
They're already factoring in the curvature, which is giving you more than you deserve. Right? I mean, they could just do the test and say, hey, no comparison to any other geometry. We did the test. The light hit its fucking target. Game over.
The light
It's
always
you
hits the
guys that have to
target,
come in and explain away why it hit the target. Right, you've got two options for you. The light followed the curvature of the Earth in order for it to hit its target, or it just went straight because they're both at the same level horizontally, right? Now you have to try and explain how that works on a globe. That's why you want us to account for your special refraction. Oh, account for the thing that you're trying to prove.
Well, no. Well, first we're just trying to figure out if the calculations are right. Like if they factored, they did the measurements correctly.
Factored in what? Refraction that has to exist in a manner and operate in a manner which conforms to the idea that the Earth is a sphere. Why would you do that?
So if we have lake
To
temperature, if we have a
excuse
lake
it?
temperature of 35.6 and an air temperature of 37.4, it's not possible, right? You don't have a strong enough temperature change to have anything close to, this working on a globe. It wouldn't be meteorologically possible.
Right.
There actually isn't any conditions that have ever been validated where you've had such a strong change in the refractive index that any of these observations would even be possible at all. So if you put this into Walter Bislin's Begging the Question Earth Curve refraction slider on his advanced Earth curvature calculator, you have to slide it up to the setting of 1, a refraction coefficient of 1, which on Walter Bislin's page even says that there would be so much refraction that the Earth would just appear completely flat. And that's the case for pretty much every single observation that we put into the calculator. You have to have so much refraction that the Earth would look flat. And then if you go digging, it's like, so what optical phenomena would you see in the distance if you had a refraction coefficient of 1? Okay, and AIs will tell you, oh, well, that's not possible, right? Like the meteorological conditions aren't possible. And you ask it, okay, well, what would it look like if it was possible? And it says, oh, it would be crazy. You would see like things floating in the air and inverted images, upside down images, and extreme Fata Morgana effects. It would be extremely short-lived if it was possible. But yeah, we're not getting that. We're getting laser tests where the laser hits the target, and then they did 5 different tests, and then we got someone else that does it with a different spectrum laser beam in a completely different weather environment, and it hits the target, and then that gets done over and over again in all these different places all over the world with different weather conditions. And somehow there's this crazy extreme refraction that somehow allows the beam of the laser to hit the target every time, like, which would have to bend around the curvature of the Earth.
Yeah, tell us, Inductio, how do you know that a changed direction? The light's path is deviated from straight. How do you know?
Oh, sorry, your voice was like really low for a bit of it. A few words cut out.
How do you know that a light's path has deviated from straight?
I guess you'd have to factor in.
Or factoring. So you just use math. You just keep
It's like we don't.
stacking math on top of
Well,
math, and eventually something will math out. Mother mather.
well, let me reason through it, right? So, because we don't have something straight that's right next to it,
Well, you
like a
make
ruler to
you
hold up
measure
to it to
you
say that
measure
it's
something.
whether it's
Yeah, you
bent or
measure it.
straight.
You measure it, and then you make it straight that way, and then you can go ahead and calibrate it with your laser if you need to. You can start on one side, and if you're hitting straight across, your laser's level, correct?
Well, the light itself could be bending, and we if
Whoa,
we
so
don't
now
factor in refraction and
know what I heard? You said the light is bending straight.
curve. right? Because like if there's curve, then you'd expect it to be higher than otherwise, and then if there's refraction, then it could be exaggerated even more.
So yeah, I think I took pictures of the guys shooting lasers through our new plant. So those guys, I should tell them to stop. They should just be using all chalk lines.
I think at longer distances, it does become more complicated. Yeah, but they know that.
Who knows that?
Oh, like the longer distances, like they make standard adjustments. But
Who does?
Like surveyors or
no, the planar surveyors don't put curve in for no reason.
Can I ask you? Okay, all right. Let's think of it another way.
Right?
Let's think of it another way, Inductio. All right. How do you know that the path of a bullet deviated from straight?
Well, it's going to. I mean, eventually it drops, right? Like sniper will factor in drop. But how do we know that
its trajectory deviated? Yeah, because you're pointing it at something, right? And you're trying to hit something. So how do you know that it deviated in its path?
Because it gets slower.
Because it missed.
I mean,
because you didn't hit the target.
Well,
you're now in this instance, in all these instances where the laser hits the target, you guys say it deviated. That's why it hit the target. Usually, you can tell something deviated in its path because it misses the target.
I think that example, it has different covariates to factor in, but it does work nonetheless. Like you would have to factor in wind. Depending on how far it is, there might even be the Coriolis to factor in. There's the drop, right? And then, yeah, of course, like Earth curve as well. Like once factoring in all that,
that's what everything
you could
surveyors
say. And also
factor in.
the site itself might have to be calibrated. Like there's a lot of things. But let's say you did all of that and you shot. I mean, it just should hit. If not, then
Humphreys.
But if you missed, you factor in something wrong. If you missed, right? Like some part of your calculation was wrong. Maybe you calculated Earth curve, but there was no Earth curve, and so that's why you're missing, right? For example, right?
I've never heard one of them say they calculate for Earth curvature, though.
Nobody's ever done that in their life. Say we have to make sure that we calculate for Earth curve. No one, never in human life, never in human life, in the whole human history of life, has anybody said we have to calculate for Earth curve before we do this.
Yeah, that's not even a claim.
Well, because most
at the
snipers
world
don't shoot
record
that far. But for artillery, for
think
example,
about this shot. Think about this shot. 4.4 miles.
They factor in
Okay, that's the
Coriolis
world
for
record.
artillery, right?
Hold on a second, just before we move away from snipers. Okay, so Shepard Humphreys holds the world record for the longest sniper shot. 4.4 miles. He hit the target 3 times in a row. That's such a long distance that the bullet stays in the air for like 30, 40 seconds before it hits the target. If not longer, I forget the exact amount, but some crazy amount of time after he takes the shot until it hits the target. We contacted him and asked if he factored in Earth curvature or Coriolis. He didn't factor either of those things in. Okay, and that's 4.4 miles. That's quite a distance.
But he aimed higher, didn't he?
Yeah, they have to factor in bullet. They have to factor in.
Was he shooting east to west or north to south?
I forget exactly. I'd have to double check.
Because if he was shooting north to south, then you do.
Right, we're talking about the Earth.
Right?
The Earth curvature is the main thing that I was talking about just then. Because so they do account for spin drift. They account for spin drift of the bullet, and they account for the drop of the bullet, and they account for the wind. And we've got interviews with other snipers, that are flat earthers, showing their qualifications, like showing their certifications and stuff, and saying, look, nobody in my field actually accounts for it. It is, although it is in some of the manuals as a technicality, when we put it to use, it's not possible even to factor that in. There's actually some funny videos because if you think about it, right? How are you going to do the calculation you're not always shooting in a specific direction, right? You might have one target here, then you'd have to move to the left, move to the right, right? The angle that you're shooting when it comes to your direction is going to be completely different. It would be near impossible to make all of those calculations, especially on the field.
Yeah, I get that. Yeah, like all in your head, you're trying to calculate wind and drop, and then all of that.
And
But
like trying to work out how much to adjust
like
for Coriolis when you're shooting like not exactly southwest.
I'm assuming
but
he didn't. I would
I've never
assume
heard
he
one.
probably was shooting horizontally.
Well, yeah,
because it is
I've never
harder to
heard
shoot
one ever
that
claim to have
distance.
accounted for Earth curvature. Hey, just I don't know if you want to see an interesting observation. I don't know if you guys have seen the Netflix documentary Behind the Curve where Jaren did the torch test. It's kind of a ridiculous test, but this guy does a flashlight test over a big lake, and I need to take some clips from the video, but this is some screenshots. Okay, so this
why
is
is it different from a laser?
Just the flashlight.
That experiment.
The one that I'm talking about now.
Yeah, that one.
Well, this one's just about being able to see the source light. Okay, whereas the laser is actually a beam, like a beam that's going to hit a target. Okay, this is just being able to see a light in the distance.
But still, the curvature should be as well visible there, then, according to your formula.
Well, yeah, the light should be hidden behind the curvature, so you shouldn't be able to see it. So this one's 13.
Wasn't.
Yeah, so this one. Okay, so this one's 13.7 miles away. Okay, so this guy sets his camera up. Okay, so I don't know if you're talking about the Jaren one in the Netflix one, because it doesn't show the setup. It doesn't show the distance. It doesn't show the observer height or anything like that. It was done at nighttime. So I don't know how they could even set it up at nighttime. And then apparently they went back there the next day and he said, oh, shit, it could have been this tree that was blocking it. Like, seems like the dodgiest test that you could ever do. But anyway, here's like one that's been documented properly, where he measures the observer height. We can see the location. Okay, it's Utah. It's in Utah at a different lake, not the Great Salt Lake. Okay, he's measuring his camera height, 5.5 foot. And in the video here, this guy has it's like a really high-powered flashlight. Okay, and he has it set up on his tripod there. And then the cameraman is on the other side, 13.7 miles away. And you can clearly see, here's the side-by-side footage. You can clearly see the flashlight 13.7 miles away. And then the guy on the other side, he's like, hey, put your hand over the flashlight and block the light. Right, so he puts his hand over the light and then all of a sudden you can't see it anymore. And then they do that a bunch of times. And then he actually lowers the flashlight down to, I think, 9 inches or something above the water. And you can still see it in the video. And then after that, they actually do a laser test as well. And they hit the target with the laser. I need to find the link again for that video. It's another good test. But it kind of shoots the Jarenism flashlight test out of the water.
How come we don't have people running around about this? You know how they run around about Jaren is 17 feet tall or 23 feet tall, and he proved the Earth is a globe. How come they're not running around talking about this one that shows that's false? They should be running. All the Globers should be running around talking about this one now, but they don't. I don't understand.
Yeah, this one's done a huge distance compared to the one in Behind the Curve that doesn't even show the distance.
Globers,
So
any Globers out there want to explain that, the reasoning behind that, where you guys should be celebrating this one, which is very far?
So here we have 107 foot of missing curve. 10-story building. Here's the math.
Yeah, people bring up the Jaren one all the time and don't ever want to talk about anything but.
Maybe flashlights bend, or don't bend around the globe, but lasers do. Maybe that's what the difference is. We just don't know because we're too stupid.
Oh, that's so good.
Yeah, I mean, like I'll say this again, the way you don't measure refraction is by measuring the sea versus the air on top of it. You measure a whole vertical gradient across the entire viewing range.
Yeah, but that's impossible.
You could take multiple
Also,
points.
Well, no, that's all right. That's all
You
right,
take
DJ.
multiple
He
points.
just nullified Jesse Path of
You can
Lies.
take
yeah.
multiple points, right?
Dude, you just threw out your
And
one of your famous globe proofs now. Just because you said that. He didn't do any of that.
Surveyors don't even do that.
sure,
Rodopium.
if he didn't do that, then we're throwing it out, right? We're doing it
Yeah.
correctly.
Well, no one's ever done that.
And
No one's
so,
ever done that.
yeah, but if you guys did
For
do it,
anything
it
ever.
would be proof. If you did it
For anything
right, like
ever, dude.
not
For
a
anything
decoy.
ever. How are you going to grid out in a 3-dimensional cube air temperature?
You can
It's impossible.
you could also like, for example, here I'm trying to find this PDF. There's a PDF where they did artillery strikes and they show their calculations where they factored in the Coriolis, and had they not, it would have been almost a kilometer miss, but it was a
No.
hit, and it was
How do
only
you
hit
know?
because they factored.
No. How come they're the only ones that have to do it?
Because, oh, I mean, when you're firing
How come they're the only ones,
vertically,
but if you shoot 4 miles, you don't have to?
I've spoken to
well,
artillery guys
because
from the
maybe they were
military that have
firing
come in here.
horizontally.
I've spoken
But
to
you don't
military
have to
guys that have come in
factor
here, and
in
they said
horizontally.
he's like, no, we don't factor in earth curvature, we don't factor in Coriolis. You know, he's
Yeah,
like, damn. He's like, I never even
got out
thought
of high
about it.
school. We barely got out of high school. Are you kidding me? We don't factor that shit in.
He said he's never even considered that. He's like, oh, that's weird. He's like, he was a globe earther, right? He just came in to have a chat. He was like, I thought this would be an interesting channel. I'd heard about flat Earth from some of the other guys that I work with, and I just wanted to have a chat. And then he says, yeah, I do ballistics. I'm like, asked him how far he shoots usually. He said like usually like 30 kilometers, 40 kilometers. He's like, yeah, we hit our targets, but yeah, we don't factor any of those things in. He's like, that's interesting. I have to look into that. Never even considered it.
So how do they calculate the distance then?
Well, he might like in his because he probably just has a pulse for it, right? Like he's trained. He kind of knows on his scope how far it is, and then he
Oh,
forms a
that's
line on his
hilarious.
scope where, and then so it's kind of like already baked in, where like he whether there's curve or not, he's baked it in. So he's going to hit based on the line he draws on his scope. Like that's usually how it works. So that's not too interesting. But
So
what is
Coriolis is
interesting
baked
is
into their scope. It's baked into their scope. So when they sight that thing, it's
no, it's
already
baked into
baked in and
it's
curving.
baked into their mind because yeah,
So
like a
Oh, so
sniper when they're
they use
calibrating.
their mind. They use their mind to turn it.
Yeah, it's like their experience. They know how much higher to
Wow.
aim versus how far they're shooting. Yeah. Have you never fired a gun?
Yeah, so
No,
if you're talking
not with my mind, dummy.
if you're talking 30, 40 miles, right? They're not going to see it through a scope if the Earth's a globe. Okay, there's like a 1,200 foot of curvature over 30 miles or something like that.
It would. What actually would be also compelling is to do some kind of like artillery math where you don't factor in Coriolis versus when you do, and see which one hits. Because if one of those were to miss, it would tell you, okay, well that globe math was wrong then, or you know what I mean, or oh, we missed.
We have a
But
military guy.
Why not
we
just
factor in
hover
Coriolis.
in a helicopter until another town shows up? If the Earth moves underneath a bullet, it's going to move underneath a helicopter. Just wait for the next town. Just hover there.
We have a military guy. He knows a bunch about it. AI Overlord. I don't know if it's a shame he's not here at the moment, but he explains how it works, how they do their targeting. Makes perfect sense. Has nothing to do with the globe. But usually with the long range stuff, I think they have some kind of spotter or something like that, like an external source of being able to spot, which gives them the coordinates. Okay, and then they have like a specific range. It's like a circle. I forget. There's a specific name for it. Okay, and then they'll shoot towards the target, and then if it misses by a certain amount, they'll be like, all right, 30 meters to the right, something like that. Until they get it right. Anyway, isn't it interesting how many observations we have on the flat Earth side? Okay, that would have to have these extreme refraction conditions to be able to work without any miraging effects in any of them. And then the globe side doesn't have a single observation where the geometric horizon is present anywhere close to where it would have to be present if the Earth were a globe. Okay, like not a single observation. Like they're always screaming refraction, 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 but there's not a single observation where they actually have measured what's going on with the refractive index gradient. Okay, even surveyors don't do that. Okay, they just guess standard refraction. They're like, oh, just add standard refraction in, even though they have no idea, right, what it's doing.
Well, because they're not doing it. I mean, yeah, they're surveying. Your guys' observations usually always over water, where the effect of refraction is amplified. Like there's a lot of pressure and humidity differences over water where it meets land. So you always conveniently go there, but you always conveniently never actually do the math right. Do you see the pattern?
No, we always do the math right. Okay, and to say
No,
that
this one, the math was wrong.
In what
The
one
one you
was the
linked.
math wrong? Which one was the math wrong?
The FE core where they did two measurements, both of them were wrong.
No.
One of them they didn't even factor in refraction at all. They just assumed that
No.
the
They
water
had,
and the air above it's the same, so we're not going to do any math at all.
No, they had weather stations.
They skipped it.
They had weather stations. Okay, which is more than any globe earthers ever have in their observations. And you know what? The laser hit the target.
Yeah, it doesn't matter what the weather was. It could be a tornado. If it hit the target, it hit. Ding dong.
No, but here's where I'm coming from is they measured the water 2 degrees, and then they measured the air above it 3 degrees, and they said, we're just going to factor in zero refraction then. Like, we're just going to assume it's zero.
You want to
and then they
factor in what was the
all
proper
of the
number? What was the proper number?
I wasn't there.
Well, get that number,
I
and then we'll factor it in for
Well, all
you,
I'm asking-
and we'll see if it hits the target.
I know, but it's fine if that's compelling to you guys. It's just not compelling to me. Like I have my own personal. It's a personal thing.
It's just due to your lack of knowledge in what meteorological conditions would have to be present for such deviation to occur. It's not possible when you have, right? You have to have an extreme change in temperature vertical saying to even happen? Like a huge change. What's going to cause that change between point A and point B to have this vertical temperature gradient?
Figured it out. It should be around 250 degrees in order to bend it that far.
When have you ever gone out and the air at your feet is like burning your feet, and then at your knees it's freezing cold? It's ridiculous. It's never the case. Okay, the more extreme conditions we get is when surveyors will go out actually, and they'll do it over hot concrete or over a hot road. Okay, and you have a extremely warm surface on the road because the ground's being heated up like crazy by the sun. And so you have a layer of warmer air above the warm ground, and then it cools down as you go up vertically. But then they'll put in 7/6R, which requires the opposite refractive index. Okay, so that not only are they just guessing the refraction, right? They're blatantly getting it upside down. Anyway, we got
I
teams of
feel
field
like
engineers
it's
going out with
fair
a
for me
30,000
to ask for, like,
something
it's
that's
fair for me to ask
impossible.
for standard adjustments, right?
Okay, so whoever did that in the history on the globe side, how do you account for refraction and name one person that's ever done it over a distance?
As far as I know, like what I've looked at in terms of observations, I haven't seen any like Glober showing an observation long distance and pointing to say, there's the curve. Like it's usually flat earthers that do that. That'll show images. So like
What?
the burden is not really on
Flat
them.
earthers are dead. We debunk the flat Earth. That's what you said. We show the globe. You sound almost like your brain is turned into mush.
No, I'm just saying if it's used for evidence in either direction, it would be nice and compelling if there were the correct standard adjustments
You know
done.
why the Globers don't use any additional information at all besides a picture, and we usually have the temperature. We have all kinds of information that goes with it, all kinds of data. Do you know why flat earthers have all the data and Globers do not have any of the data? Do you know why that is? I do, but do you know why?
I mean, I guess that's your anecdote. I've never seen a Glober come to the table with it. Sometimes they'll do like the GIF of the boat going over the horizon. I've seen that one.
Yeah, no context with it. So, yeah, you can't use it because they didn't measure a vertical gradient like you said. So we can't use it.
Yeah, no, I would be consistent with that. I would say, well,
Yeah,
we
so
don't know
really, with
one way or the
you,
other, just
for
based on
you,
that.
nobody can actually do anything now. Planes can't fly because we can't see anywhere. Nothing is actually where it is because you just don't know. It could be 250 degrees, 50 feet in front of you because you don't know anything. You're all of a sudden like a
Yeah, no, what I'm saying
moldy
is,
rock in a pond.
if we're going to make an observation that is extremely susceptible to refraction, then we have to make proper calculations when we make observations, right? And that should be the gold standard. That should be that's what I operate on. I'm advocating, I guess like you guys can not do that if you don't want. I just feel like it would be prudent. I mean, do you agree? It kind of looks bad to the standard onlooker, like if flat earthers just don't do that or refuse to, or when they try it, they do it wrong, and
So
then
so how do you
pose it
know?
as if they did
Okay,
it right.
so this is what's happening. Okay, we got different weather conditions all over the world. Every laser hits its target. No curvature can be found. Okay, we got all of these observations where we can see things that would have to be hidden behind hundreds and hundreds of feet of curvature every single time. There's no curvature present. Okay, so how do you know the curvature exists in the first place if no globers have ever accounted for refraction to your standard or at all? Okay, and no observations ever match up with the globe. How do you know it even exists in the first place?
From observations, yeah, no,
Which one?
I'm not aware of. I'm not aware of anyone doing this fully. I
Okay,
know
so
of.
how did they determine that it's a globe and that there's curvature over water?
Well, they do other means, right? They'll look up at every time they do that. You say, look at the ground, don't look up, for example, or like if they point out something about the spin of the stars or the sun,
Dude,
you
curve,
guys will
curve,
question
curve,
that.
curve, Earth curve, focus.
Exactly. That's if you guys do that, that's what I was saying. Is anytime somebody uses something else to make
Like what?
inferences, you guys say no. But when you rule everything else out, I'm
Like
just
what?
saying because
Like what?
if you're ruling out the stars, the sun, or any other thing, any other like inference you can make, then at
How do
least
they
do it
prove?
right and do it
How do they?
well.
Dude, why
How do they
rule out
prove
Because
the
it's
then
a
that would
cloud?
globe?
prove it.
No, Reductio, I've talked to you about this before. Why are you ruling out the thing in question? You want to take a measurement or an observation of the surface of the Earth. Why did you rule out the exact surface of the Earth? You want to talk about everything else. Everything
No, I'm
other,
not. I'm
you
actually
ruled
not. Like what
out
I'm saying
the
is,
only thing in question.
maybe
Like,
I
do
misspoke.
that. Why,
I
I
didn't
want
say
to know what
I
object
ruled it
X.
out.
Do I look at object X or look at every other letter besides X?
No,
So it's not A,
okay.
it's
So
not
let me
B, it's not
clarify.
C,
What
it's
I'm
not
saying
D.
is,
Why not hyper focus on the thing in question? Why not do that? Just run me through your
well,
logic here.
that's fine, but then just do the calculations, right? Like I have my standard for what on that calculation or like on that long distance observations where refraction plays a huge role in what you see,
That's a
then to
deflection.
factor it in properly.
Refraction rather than
Are you disagreeing with that?
Why would you deflect to refraction? Why not stay hyper focused on the exact topic, the surface of the Earth?
Because he
Well,
doesn't have
because it's not like
anything
we're
to submit.
taking a.
He doesn't have anything to submit because no observations match up with the globe, right? Every laser hits its target for us, and we can see things consistently where there's no curvature over huge distances. Okay, we're not making hyper-specific claims. You guys are, and there's tons of people that think they've made observations that match a globe. Okay, now you're kind of admitting
Well,
that
here's
no one throughout all of history has measured Earth curvature. Okay, and now you're saying that we should look up at the sky and just make assumptions about the ground based on what the sky is doing. This is crazy level 9,000 cope right now, Reductio.
I'm not saying you have to do that. I'm saying that other people might have different standards by which they're convinced by that, and you guys might not. That's fine. And if you want to do like the ground thing, well, we don't exactly have like a 10-mile long ruler that is straight that we could just measure it with. So we have to use observations, which optics comes into play. And when optics comes into play, especially close to the ground, refraction comes into play. And so that's
Oh
all I'm
yeah,
saying is,
yeah. We have
well, it
observations
shouldn't
from
be a
plane.
fight.
So we accounted for that.
It shouldn't be,
Okay, we have
but it
1,000
shouldn't
mile
be a fight
observations using.
to say we should factor the same.
No, because
The
what
fact
you
that it's
what
that I'm getting
we
shouted
do
at for wanting to just
factor it
do
in, bro. You're
standard.
not getting shouted at. Okay, so
I,
look,
I mean, Crit was shouting.
we're
Jay,
using
you're
infrared.
I think Crit said about it.
quietly like that.
Yeah, so we're
But like,
doing a lot more than the globe earthers are doing when we're using weather stations. We're checking the water temperature. We're checking the air temperature. We're making sure there's no optical distortion visually. Okay, we're repeating tests during the daytime and then again during the nighttime. Okay, and every single time there's zero Earth curvature detected. Okay, and there's not a single observation where there is Earth curvature detected, or they're even accounting for the things that we're accounting for. Sounds
yeah,
like
well, I mean,
you're kind of like you have double standards when it comes to your standard of evidence.
no,
I mean,
not at all. There's literally been zero goalpost shifts either, and I've been clear about from the outset what would convince me is just the standard adjustments, and I was shown incorrect adjustments, which made it look worse for me personally.
Okay, so you think that the 100+ foot of curvature would be possible for the laser to bend over just because of 1 degree water versus air temperature change. And then every single other of the observations they did over completely different distances, right, at different times, they all happened to just hit their target. We just always just happen to have the exact right amount of refraction in all of these different places all over the world, in these dozens and dozens of laser tests, that somehow it just perfectly bends around the curvature of the Earth hundreds and hundreds of feet and hits the target every single time.
Well, no, I'm not claiming that I've seen these or anything. I'm just saying, like, if I had to guess, like, I would assume, yeah, like, if you did do a proper vertical continuous gradient, you would, like, it would line up. It's going to line up
Oh,
with
yeah?
your observations or your expectations or mine, right? But the fact that it has just never been done with flat Earth stuff is, like, I think that's a huge hole in
Oh,
in
it's
your
been
guys'
done with
argument.
Globe Earth? It's been done with Globe Earth stuff, has it? It's been done by Globe Earthers,
No,
has it?
Globers don't usually focus. Well, Globers don't make this like long distance argument.
Yes, they
They
do. There's
usually
people that
talk
have
about the
whole
stars and
channels.
stuff, right?
No, there's a whole, all right, people going out with theodolites and saying that this thing in the distance is 2 inches lower than it should be, and that lines up with the curvature of the Earth. But they didn't account for refraction, but that's okay because it's they don't have to. Only flat earthers have to do that. Right. So okay, so
Well, I mean, if they
you
didn't, then
anything. So you don't have a
yeah,
single
throw
observation
them
that you
down.
can show us. You don't have any counter
Yeah.
evidence. Okay, you
No,
just
no.
have
Look, I'm saying if they did it wrong as well, then I would be consistent and want their shit thrown in the dumpster and told, if you want to do it right, come back, like do it
okay. So
again,
has
right?
anyone ever made an observation or a laser test or anything like similar to that validates that the Earth's a globe throughout all of history?
I'm not aware of it. No.
Okay. All right. So how do you know it's a globe without looking into the sky and making assumptions? How do they know it's a globe?
Yeah, like that's the thing is, for me, the moon and stars and sun, those observations are good enough for me because there's clear and convincing evidence.
Really? How so? What's the
Yeah.
sun? What's the sun?
Well, I mean, let's just take like the closest object, like the moon.
What's the moon?
As it goes across the sky, it's the same size all the way across the sky, and
Okay.
no matter where you are on the planet, you still see the same face. Which, if it were flat, you would see different angles of that face
You don't even know what the moon
through the
is.
sky, and it would shrink, and then it would expand
No,
as
it
it
wouldn't.
becomes closer to you, closer
No,
overhead.
no, no. So when you
On a
see
flat plane?
the moon set or the sun set, right? You're on the globe and you're moving away from the moon, right? You're spinning hundreds and thousands of miles away from the sun. So it's getting further away from you as you're spinning backwards faster than the speed of sound on your globe, which makes it appear like the sun's setting. It doesn't reduce in angular size, does it? Because
No, I just like the moon
of
is
why?
way closer, so that's why I'm
Well, how
talking about
close
the
is it?
moon.
Yeah, okay. So why
It's
would it
always the
reduce in angular
same.
size? No, it changes. It changes by half a degree.
The moon, like
So
across
yeah,
the sky.
you don't understand how perspective works and how we have an azimuthal grid of vision. Right? You can even set that up in stellarium. Okay, it's the way that we see. So something that's already outside of your range of vision. Okay, you're going to see it converge with the horizon. It's a huge distance away. It's already way outside, but you see it in your personal azimuthal grid of vision. So all of the celestials fall into that category. It's not like a plane or something like that, or a cloud that's not far away from you. We're not saying that the moon is like the height of the clouds or the height of a plane or something like that, where you would see that noticeable angular size change, right? It's far enough that it doesn't appear to reduce in size as it moves away, because that small range of vision that you have doesn't allow for that to happen. It's completely different. It's not like you're looking down a hallway or something like that, something that's close to you, or looking at a plane. Just like on the globe, you would even know that
you
you're
would
moving
still
further away from the moon or the sun as it appears to be setting. Okay, but you say it's so far away that it doesn't look like it changes in size because of the distance. We're not saying it's a certain distance away. It's still extremely far away. What we're looking at.
you would still be able to see. There's a very slight angle of like depending on where you are on the planet, you'll see teeny tiny bit of a different face.
That's a
But you would
lie.
expect more on a flat Earth.
That's a complete lie.
Yeah, so you can't
What do you
validate
mean?
what the moon is. You can't validate what distance the moon is. You can't validate what the moon's made out of. You can't validate the size of it. You don't know what medium the moon's in. You don't know any of these things, right? You just chose to believe a story about it. But yet you think that that's okay. So you obviously haven't accounted for all factors. That's what I mean by you're being so hyper specific when it comes to all of our observations that show there's no curvature. But then all of a sudden, right, you don't need to know the distance to the moon or validate the distance to the moon. You don't need to validate the medium that the moon's. You don't need to validate the second law of thermodynamics violation the moon's meant to be in. You don't need to validate what it's made out of, the size, any of these. All of these things you can just take it all in good faith. No one can test it. Just believe it, and then you think that that's better than what we're doing. Actually, empirically, testing the surface of the Earth for the curvature that would have to be there.
With these conversations, like where if we talk about the moon and I'll say, okay, well, why does it not appear to get larger, or why, like, as it goes across the sky, whereas on a flat plane you expect it to become like,
no, you wouldn't.
Depending on how close it is,
No,
maybe
you
even
wouldn't.
twice as large.
No, you wouldn't.
Directly overhead, and
No,
then
you
like
wouldn't.
shrink back half the size as it goes away.
Okay, what
Now,
size would it have to
if you
be
want
to
to say
do
it's
that?
like
No,
further,
what distance and size would it have to be to do for that to happen? Did you do the math?
I don't have the exact math, but what I do know is at a certain point, if it's far enough where you're not going to expect to see that effect, then you would expect something else, which is that you'd be able to see it 24/7 worldwide, and it just wouldn't set or go away. You'd be able
No,
to
because
see it from the plane,
you don't
no matter
understand
where.
you don't understand how perspective works. Then it seems.
No, it's that if it's, let's just say it's like a million miles away, and if it goes a million and like however many, when it's setting away, like 500 more miles away, that's not going to make that big of a difference because you're already seeing it just perfectly fine when it's a million miles away, and then 500 more miles isn't going to be that much. You expect everyone to see it 24/7. And now if it's closer to us, then it could be, maybe in the clouds, and then it could go away, right? Because there's different clouds across different areas of the planet, so you could see it go to one area, then another, then another.
Dude, you're just saying words at
So
this point.
there is a catch-22 here.
Yeah, it's called Globe Earth.
And I'm just saying, for me, like, I don't have the long distance stuff down, but things like that, or things like, the Coriolis effect, things like the
What
stars
Coriolis
spinning clockwise in the southern hemisphere and counterclockwise in the northern hemisphere, things like that are like compelling enough to me that it's a globe.
Wow, it's such a crazy double standard of evidence that you have there. So you can just make a whole bunch of assumptions about things that you see in the sky, just completely ignore the ground, which is the only thing that we can validate. Okay? Say that every single one of our tests just shows the Earth's flat because of some magical perfect refraction that just happens to be the exact right gradient every single observation for hundreds and hundreds of observations. I just think you're either lying to yourself
I never said I was
or you're
closed
being
off to it.
dishonest.
Yes, you don't even know. You don't even know if you clockwise, clockwise storms or whatever you want to, is in a southern hemisphere. I mean, that is circular
I guess you could say
reasoning.
that, but to to DJ, I'm totally open to these observations, the long distance stuff, as long as they're like the proper math is provided. Then I'll.
Oh yeah,
But
really?
for now,
So
I just haven't looked
how
into it.
many vertical temperature gradient readings do we have to take over 20 miles between point A and point B? How many?
I'm not aware of, I haven't memorized what's standard there.
Yeah.
I would assume more is better,
So
but
Go
like
ahead and look up the
we do
standard
every.
word for that, please, and then post it in
Because
there.
for
I'll read
example,
it over. I'll read it
for
over, and I'll develop a test, and we can all sign off on it. Okay?
actually that would be great. Yeah.
What about seasons?
I'm assuming, because for example, if you did it every mile and then you had kind of like similar readings across every mile for 20 miles, then I'm pretty sure we could say, okay, in between each mile is also probably
Oh
similar.
yeah.
So I
So
think
you
that would
think
be good.
they could be a okay, so we got the same water temperature as air temperature, but you think somehow there's going to be some crazy freezing cold air down low to the water and warmer air above it, even though the water temperature and air temperature are the same. Somehow there's going to be a crazy vertical refractive index.
Yeah.
How would that be possible? And we're
Because
using
if you're
infrared.
going 0 meters up above the water and then 15 meters up and then
No,
5, 10,
this
15.
is an observation from 15-foot height. Okay, we're just looking at a ship.
Yeah, but
It's
you're
out in
gonna
the ocean. We can see the whole ship.
you're gonna want to take 5, 10, 15 meters and then do that across enough,
Really, what
enough times, whatever it is,
could
every mile.
happen? What could happen that would cause such a crazy refractive index gradient? Because it's controlled by temperature. So what could possibly be causing this crazy heat change vertically over 15-foot height between point A and point B?
Just
What
take
that possibly
the
be?
standard. Well, just take the pressure, humidity, temperature. Just take all
It's the
those so
same.
that no one can complain. All I'm saying is
Yeah, the
do
temperature.
this
That's
so
all you
that
need to
no
take.
one has there is no rebuttal for a globe earther if you do this. And
There
I'm
is no
saying this is
rebuttal. There is no
your
rebuttal.
secret weapon.
Well, there is no rebuttal because the meteorological conditions that would need to be present for that to work on a globe are impossible. Never even been proven to exist at all. Okay, you guys don't have any.
I
You
gave you that.
don't have any evidence
With
that
planes
there's
that have
any
done it.
curvature in the first place. Now you've thrown
Well, we
every
have
You
single.
shouldn't need exactly. You shouldn't have to be trying to defend anything. You have to be trying to refute these.
Hello, guys.
Well,
This is my first
okay,
day to leave the Earth.
He's having a good time. He's new
It's
here.
flat.
So
Yes, you're correct.
I've given you 2 papers. One of them, and these were planes that took it. So they used radar to take the measurements through the whole gradient. And they found that, yeah, you do achieve those numbers that you're saying never happen. And I've shown you papers where it does happen.
No, you're talking about radio wave propagation, and they didn't measure the vertical refractive index gradient between point A and point B the way that you're up to your standards. There's a huge difference between the wavelength of radio waves and light.
No, they took the measurements required to do the math, and then when you do the math, it comes out
No, they
as
didn't.
near
Show
1.
me. Post it.
Yeah, ducting. Yeah.
No, ducting.
You
You're
want
talking
the
about
exact same
radio wave propagation ducting. You're not talking about light. You're not talking about the path of light. You're talking about radio waves, completely different wavelengths. Okay, and that's absolute bullshit that they used equipment to measure the vertical refractive index gradient between point A and point B. You just made that up. They didn't do that at all. I know the paper you're talking about. I have a paper. I have a whole bunch of citations.
Rare.
No, it doesn't happen. It's never been validated to happen, and they didn't take the readings that you said they took anyway. Also, it's not analogous because it's not light that they're even talking about in that paper. It's completely different. It's radio wave propagation.
Here, let me pull this up. But you hear what I'm saying. I'm not saying you guys are wrong. well, the FE core one is wrong, but I'm saying if you want to compel the masses, then it's simple measurement. Just factor it in so that you can shut them up when they. That's what they say every time, right? Refraction.
Nah, just compel the masses. Nobody's trying. We're trying to get through to people one at a time, basically. I mean, and all we're doing is just saying, here, look, these observations and these measurements don't match the globe geometry. If you want to see if you can replicate this and find the globe geometry in any instance, go for it. That's up to you. Otherwise, just here for a simple discussion.
Yeah, we're not making hyper-specific claims. We've got orders of magnitude of Earth curvature missing every single time we do these observations. You guys are the ones that are making hyper-specific claims about Earth curvature. Okay, you guys don't have a single observation that proves that it exists, not one throughout all of history, all of this funding. Okay, everyone throughout the last, 2,000 years or whatever. Not one observation that matches up with the globe, right? Just assumptions based on some lights in the sky that you can never validate. And we're trying to get through to intellectually honest people, right? Not people that are just like having absolute double standards of evidence, giving false analogies, right? Just fallacy after fallacy after fallacy. And then requesting completely unrealistic, impossible tasks from us, even though every single time we're just detecting zero Earth curvature. We're not making
Here's
claims.
2 papers.
Are any of them about the propagation
dusting
of light?
events in the Canary Islands.
Is it about the propagation of light through a medium or not?
I'm reading it here. These conditions dictate the modes of
So
signal propagation, which can be classified as
our signal, so
standard
not
and
light.
normal, subrefractive, superrefractive, and conductive conditions.
So not light. So not light propagation through a medium. So it's not analogous.
They're talking about refraction here.
Yeah, but they're talking about refraction of radio waves, which are completely different wavelengths. Right, so
I'm assuming radio
you're talking
waves
about frequency
might not be-
ranges from VHF and UHF bands. Completely different.
Right, but I'm
radio
assuming that
ducting and optical refraction are fundamentally different phenomena. Tropospheric ducting applies to long wavelength radio signals and can extend range to thousands of kilometers, but does not apply to visible light. Ground level, long distance optical observations across great distances cannot be explained by radio ducting principles. Radio ducting explains radio.
That
visible light is not radio.
Visible light and radio are both affected by refraction. So this paper is about refraction, right?
No, the wavelengths are completely different. They're not comparable. Okay, because you have 400 to 700 nanometers for optical refraction.
You
visible
think that
light. Okay, so radio ducting or tropospheric ducting is completely different.
So wait, let me get clear here. So if a radio wave gets trapped in a duct and goes way further than normal, than what's expected, you don't think
that doesn't. So just because it
somebody
doesn't
just
work on a
looking at the
globe,
same time,
just because it doesn't work on a globe, right? They have to lie and say there's a duct. Show me that there's a duct. Show me the readings that they took between point A and point B. You're talking about thousands.
They have all the measurements here. Yeah.
Oh, really?
They have all
Where
the
are
measurements.
Yeah, okay, let me have a look at it. Which one are you talking about?
Yeah, like
they pinpointed the area of ducting.
The first one or the second one? Which one? First or second?
I mean, either of these are great, but like my first question.
Which one should I look at?
A radio wave.
I just asked a question. Which one are you talking about where they accounted for the refractive index gradient vertically between point A and point B? Which one is it? Which one do I click on? One or two?
Well, they're looking at pressure, humidity, and temperature and height.
Okay, so how
In
did
the
they
second
measure
one, yeah.
that? And in the second one, okay, all right, thank
With
you.
a plane.
Okay, sorry, how did they measure it vertically with a plane?
Because the plane is above it, so they scan down
How high is the duct?
their instruments.
How high is the duct?
Let me scroll
What are they
down to
using?
their
LiDAR.
methodology here.
They're using LiDAR.
I mean, yeah.
Using LiDAR. They're using light.
So they're saying the duct is 3,000 meters tall, 3,000 meters high. And you think that they're measuring the vertical temperature change with a plane. What? Dude, come on, man. Be honest. That's ridiculous. Okay, come on, dude. Right, firstly, it's not analogous to light propagation through a medium. Okay? Secondly, they're not doing what you said they did. Okay, and the duct height is 3,000 meters.
I am very perplexed why you're just hand waving it away. Like if
Hand-waving it
there's a radio
away.
wave that gets trapped in a duct, and I don't know why that wouldn't affect your normal observation as well, and even so would draw enough skepticism where you would say, well, maybe when FE is, providing these black swan events, we should probably factor in as well. Right?
No, they didn't do what you said would have to be done by measuring the vertical refractive index gradient to validate exactly what's going on with the refraction. They didn't do that. So you're
I'll
completely
tell you
full
what
of
should be
shit,
done.
bro.
If academics really want to take this seriously, they need to go back to the drawing. Is Earth actually a globe? Be honest, intellectually honest. Go back to the drawing board and start seeing if they can actually definitively come to the absolute 100%, no doubt, beyond all doubt, Earth is actually. That's the intellectually honest thing they should do from these. But they won't, because they hold this bias, just like you. I want
I
the
don't
best
understand
explanation
why
for all this other stuff.
your best attack is not to say, okay, they didn't do the exact thing that we're doing, so it's disanalogous. Like, which I think is your argument. Just
No,
to be
you said
clear,
no.
like,
You said right that they had measured and accounted for refraction accurately. Okay, and okay, you told us that the vertical temperature gradient, right, the pressure and the humidity would all have to be accounted for between point A and point B to make a claim about refraction. And then you posted something, right, that's not even about the propagation of light through a medium. So firstly, it's not even analogous. Okay. Then after looking into it,
exactly. That's what I'm saying. I was trying to steel man you.
Shush,
Yeah.
bro. Hold on a second. Okay. And then I'm reading the paper and it doesn't do anything that you said it does at all. Now I just think you're dishonest. Doesn't even mention
No reason
anything
that
about measuring.
nothing I've given
Well,
you
it
that
doesn't
you should
mention
include that.
dude, it doesn't mention anything in this whole paper about measuring the vertical refractive index gradient at all.
Now this is the part where you say, yes, it does. It's here on page 50, paragraph 3.
Well, they actually the thing is they actually outline it, right? Like if you just control F vertical, it'll show the explanation for vertical gradient. But here's your best reply to this, in my opinion, is you could say, okay, well maybe we just need better instruments, and even if this like quick example you found off Google didn't do exactly the same thing we're talking about, I see your point, Reductio, and
No, you don't
we
have
as
a
flat
point.
earthers will
No, you're full of
factor this
shit,
in the
right?
future.
And I just did control F and typed in vertical. The only time it says vertical, it says generally the refractivity of the atmosphere decreases with height. Thus, its vertical gradient allows for the analysis of atmospheric conditions. Okay, so they didn't measure anything, and it doesn't even say what you just said. They said, dude, liars get banned.
I said they gave an explanation, and they did. You read the explanation.
No, you said that they measured.
No, you just read the explanation.
You said they accounted for refraction, but they didn't. Guessing isn't accounting. They didn't take any. They didn't take any. You said they flew a plane. You said they threw a plane. Okay, so you've got a duct of 30,000 meters. Sorry, 3,000 meters. Okay, and you're telling me that they flew a plane through it, and that was how they measured the vertical change in the refractive index, measuring the temperature, pressure, and humidity between point A and point B, because you wanted to be all hyper specific, right? And now you're not able to admit that they didn't do that. So now you're lying, and it's pretty clear in our
you didn't
rules.
read the next sentence. Okay, so there's a whole paragraph after what you read, right?
I read the whole paragraph.
The whole paragraph.
Yeah, I read it.
Okay, well,
I read it
for everyone else who didn't read it, can I read it just because, the first sentence in the explanation where I said they mentioned this, where you claimed I lied. I mean, that. If we continue onward, you're going to see the full explanation, which is these conditions dictate the modes of signal propagation from the vertical gradient, which can be classified as standard, normal, subrefractive, and superrefractive, and conductive conditions, which they explain in Figure 1. Each condition is defined by a specific value or range for N and M, and I'll continue onwards. When these conditions are met, extreme superrefraction occurs in the lower regions of the troposphere, which is known as the tropospheric ducting, which is what this paper is covering. And this phenomenon is caused by sharp variations in refractive index with respect to height. Do you understand? Here's the explanation I'm telling you. With it, sharp variations in refractive index with respect to height. So what I've been talking about from the very beginning, how to do this correctly, and the standard way of doing it, which confines the rays between two horizontal surfaces. As a result, signal propagation through the duct can travel long distances, which is if you go to the figure.
Show us the measurement now. Where's the values of refractive index?
Where's
you can show it, or you can just fuck off.
If you say if they're saying they measured it, then show where's the values they measured.
So scroll down to number 4 results. Are we all there? So after processing the atmospheric and AIS data, tropospheric ducts are studied and analyzed for different periods, and they show the position of received messages, and some of these get trapped in ducts, and the signal goes way further, right?
Yeah. So this isn't even about an observation. Okay, so this is like a study of ducts in general. That's why it says that they studied and analyzed for different periods. Various statistics are extracted corresponding to the months of February and August 2017. Since the atmospheric data obtained by radiosonde correspond to 2 daily samples, the information is limited in time. It doesn't say anything about taking any specific measurements for a specific observation or test that was done. Right? There's no temperature readings, there's no pressure readings, there's no humidity readings that were done.
And are there refractive indices values?
Right, but okay, just to be clear, what the paper is going over is what the paragraph I read out, but this is an application of it. Have you read the conclusion yet? Have you gotten there yet? So essentially, they're saying there's variance over warmer and colder months with respect to where the height is, and if it gets trapped in the duct, how far it goes, and then there's probability graph of ducts.
Great job with Duckio.
the distances.
Great job, bro. Yeah, good
Yep.
stuff. All right.
Hey, he just
Okay,
debunked
great.
all
So we understand
the long distance theodolite claims. Dude, thank you for doing that. We can clip it now.
So we awesome
Thank
clip
you.
it. So we understand the concept now, right? So all that I
Dude,
want
just stop.
is if you guys
just stop. You just
all I'm saying is a
this
suggestion,
is
which
just laughable.
if
At
you want
this
to compel more people, just do the
Dude, nobody
Yeah,
nobody is going to
you have
go
an
back to the
excuse.
globe after listening to you. Okay, we bring tons of people from the globe. Okay, you're not going to bring anyone back to the globe from flat Earth with this level of bullshit that you're doing right now. Okay, we
Basically,
were specifically
be in
talking
agreement.
about an observation. We were specifically talking about an observation of light traveling through a medium, right? And then accounting for the deviation of the light due to the change in the refractive index. Okay, you gave us specific conditions where you said the vertical refractive index needs to be measured, right, between point A and point B at different points along the path. Okay, then you said that this had been done. Then you posted something about radio waves, which is not analogous to light. Anyway, we granted you that, and we're like, okay, show us how they did what you claimed they did in this test. Okay, and that's not what any of this paper shows at all. Maybe you should just be humble and just say, yeah, okay, maybe like it doesn't show what I said that it was going to show at all. And I'll try to do better next time or something. I'll find something different. There's no measurements. There's no measurements of refractive index anywhere in this paper.
Yeah, I agree. This is more of a demonstration or application of it rather than a measurement. It must have been in a different one that I was looking at, so I can see there. But my intuition is that we're going to agree at the end of the day about we should do good measurements and we should factor in, all of the variables like refraction properly and not make mistakes.
it's not our responsibility when it comes to proving the Earth is a globe. If someone is claiming that the Earth is a globe, that's their responsibility. Because what I hear from you is, I believe I have what I feel and I believe is good reason to believe that the Earth is a sphere. And based on that, if these certain conditions existed, it could possibly explain why we make these observations where the geometry of the sphere is not observable or measurable. That's what I hear.
Anyway, it might be in the first one I linked here. I'm just going through it if this is the right one. But there was one where they did the.
Am I wrong, Reductio? Am I wrong?
Planes.
Was that a bad analysis of your position?
That I'm just suggesting that if you're providing black swan events, you should pair it with.
No, there's no. You're the one that needs to find a black swan. All swans are white when it comes to long distance observations, right? Meaning that there's no curvature. Okay, if you want to find a black swan, the first black swan, then you're going to have to find that geometric horizon or that curvature. Okay, so far all swans are white.
Okay, in this other one, by the way, there is the measurements, aircraft measurements, air temperature, static pressure, surface temperature, total water contents. And they also did ship-based measurements. So aircraft and ship, by the way. And they found 200-kilometer ducts. But you guys get what I'm saying, right?
There's no refractive index gradient measurements in that paper at all. It's actually comparing a bunch of different things over a period of time. Okay, you haven't even validated that. Like this is completely different to what would be considered ducting for light propagation over a short distance. This is completely different. Like it's not analogous at all.
He's
right?
just saying words anyway. Yeah, he's just saying words. You can hear it.
If you want to present something, it has to be analogous. We're just going to dismiss this because it's not analogous to what we're talking about? We're talking about the propagation
Well,
of
you
light
shouldn't
through a
dismiss
medium.
it,
Well, this is not analogous.
right? Because you could plug in the measurements they took to see what the refraction coefficient is, and this is
What's a
near
refraction
ducting. So,
coefficient? What's a refraction coefficient?
I did this a while ago when I found this paper. This was months ago. I would have to do it again if you want me to do it on the fly.
Does it
I don't
assume
think
a
that'll be the
globe?
most.
Does it have
Does it have a radius?
No, like calculating the refractive index doesn't assume any
That's
shape
not
of the planet.
that's not what the refraction coefficient is. You could calculate the refractive index in a room, a square room, okay, with a flat floor. That's completely different to a refraction, like a coefficient, like Walter Bislin's refraction coefficient slider in the Advanced Earth Curvature Calculator.
The coefficient does represent the
Yeah,
Earth's
but
radius and the path of light, or the path of the curved light across the surface. Yeah,
exactly.
DJ, so you agree though that I have not done the Walter Bislin's fitting the refractive coefficient to whatever we want it to be, right? Like in this
You haven't
conversation, I
presented
haven't approached it in
anything.
that way.
Well, you haven't presented anything that's analogous
I
to what we're talking
I
about.
presented this paper measured ducts of up to 200 kilometers, like in this paper that I linked. And this is just to show that this does happen. It's why when you take long distance measurements, we already know refraction plays a role. Like in some of the images you guys have.
no, we don't. You're just
severe
assuming it. Yeah, based off of the bullshit, because terrestrial
There's severe
refraction
mirage.
100% requires curvature calculations in it. You don't have that, and it's
No,
not
like-
refraction when it's not Snell's law.
You could see longer or shorter depending on the day you go out because the
Oh,
conditions
so
are
that's
different. Right?
refraction,
Like, we
is
all
it?
agree there.
Yeah, optical. That'd be an optical effect, not a physical effect. Not a cause, the cause of the Earth's curvature, the physical curvature of the Earth, controlling the maximum distance at which you could see. You're saying now that that thing in question, the curvature of the Earth, has no effect on how far you can see.
I'm not saying that, but
we're good at that point.
No.
Yes, this is an optical effect, not a physical effect, not a geometric effect. You're looking at optics rather than physics.
Because when you show long range observation, like optics come into play, right? You agree?
Dude, you haven't validated that Earth curvature exists in the first place because you don't have a single observation to show us.
That's fine. On your guys' standard,
yes,
I
100%.
haven't. Like, I agree.
Yeah,
By your own standards.
100%
No, by
optics
my standard,
play
I
a
have
part.
By your own standards, there is no
Sometimes we-
geometric horizon due to refraction, so we're never going to see it.
Yeah, but this is the
I'm
best
fine
part.
with
Why
moon,
flat
sun,
earthers
star
have done
measurements.
this.
You guys aren't. Right?
We assumed optical effects. That's why they use different color lasers. That's why they controlled for environmental conditions. They did these things.
Lasers are still affected by refraction.
Yeah, that's why they use different colors, because different color light is affected differently.
Right.
So they
Or
used
use
a red,
different
a
lenses.
green,
Infrared.
a blue. They did this. Yeah, and T-Dub. Yeah, and
No,
they
they
did
didn't do.
infrared.
They didn't do a single continuous vertical gradient. Not
They did
once.
multiple different colors to demonstrate how refraction was accounted for as a controlled variable.
No, the FE Core 1 did 2 measurements and it was horizontal gradients. And they didn't even calculate refraction on the first one because they assumed it was 0. And I'm not hearing any of you say, well, actually that is a problem. We should tell them and get them to do it right
No,
next
it's
time.
not a problem.
It's not a problem to not factor in refraction.
No, not a
Okay.
problem. Because
Well-
again, it's not refraction according to the definition or the law of refraction. And what you're requiring is something with a radius value for the path of light to bend around, and you haven't shown that. It's really simple.
Yeah, that's the main thing too. If
Well,
the first
to be
test, the
clear,
first
I'm not the one
FE4 test.
presenting the
Yeah, Reducto, can you hear
observation.
me, dude? The first test was
Yeah.
just to demonstrate that they could hit a target that would be blocked by the physical curve of the Earth. The first test was to debunk the globe Earth, or they would prove it. In other words, they're going to say, here's a target that should be completely obscured by the curvature of the Earth. It wasn't. Then from there, they went on to evaluate other topics. But the first shot didn't have to really include much of anything other than the physical geometric leading ball edge, the edge of a sphere. That should have blocked this bottom up
Yeah,
obstruction.
but you're not listening. Like, they still didn't factor in refraction to that. Like,
They wouldn't need to. It wouldn't matter. If you
My
dialed up
argument's pretty
refraction
simple.
to over 9,000, you'll never refract the surface of the Earth up, over, and around the surface of the Earth. There'd be a physical block, a wall. There'd be a wall of Earth stopping you from seeing to the other side.
Yeah, and do you think refraction could play a role there or not?
Yeah, it would play a role until you get a physical block, a physical object
And was it
blocking your line of sight.
and given it could play a role, was it factored in?
So you're saying the laser's bending around the curvature of the Earth for every single observation, for every single laser test. It's always just perfectly bending around the surface of the Earth to make it appear like it's flat every single time. Different weather conditions,
No,
different
I'm not
daytime,
saying.
nighttime.
I'm actually
That's
not
what you're
saying.
saying.
How would that work?
That's what you're saying. It's ridiculous, bro.
No.
It's
Yeah,
What
crazy.
I'm
draw also
saying is
ray trace. Do a ray tracing.
what I'm saying is it could be. That's why you factored in to rule it out.
是谁这么冷
Right?
的天气
No, it
还要
couldn't
去
be,
上
bro.
班？
No
I mean,
idea.
for it
Like,
to
what's the
work,
problem
it'd
with
have
just
to the
doing
light
it?
would have to remain within
Sounds
the
like we
same
have a new
refractive
contestant.
indices.
Okay, I can go on mute. It was a good. It was a good talk,
All right.
guys.
Yep.
Not really, but have a
He
good
needed
day, Refractio.
he needed a way out anyway.
Yeah. Lena. Lena, you wanted to interrupt the conversation, but now nobody's talking.
You're
You
the
don't wanna
next
talk.
contestant on The Price is Right, Lena. Come on down.
All right. Oh, good, Lena.
I do have a reverse question though. So let's say that there was a glober and they presented some observation that they claimed, look, it's going over the horizon. I think the first thing you guys would say is, well, that could be refraction, right? And if the glober didn't have a measurement to say, well, here
according
is
to
the
your own side.
refraction in that day.
Yeah, according to your own side, that's
No,
possible.
I agree.
Yeah.
Yeah, and suppose they did have measurements for refraction and they showed you it and they did them correctly and they said, look, we factored that in already.
Okay,
Now
you got one?
Now
You
what?
got one? You got one?
Now they're correct.
Do you
right?
have one?
So
Yeah, no one has that though. So do you
no,
have
I've
that?
said, well, I haven't researched this. I'm not aware of any.
Then we just go to planar surveying after that, and then it'll say, well, it's flat there. So what are you talking about now?
So we're just doing imaginations now. Imagine if a globe Earth measured curvature. Yeah, that would be cool, right? We could shut this shit down, right? But no one's ever done that because there isn't any curvature. You guys have to just look up at the sky and say, look at the sky. The Earth's a ball.
Well, I mean, I don't know if there's any globers who have done it, but And I could look into it, but I mean, this is not my this is your guys' wheelhouse, right? You guys do this all the time, so I was just suggesting.
Yeah. Yeah. Cool. Once again, we're not making hyper-specific claims. We just can't detect any Earth curvature ever. Okay, we keep testing for it and testing for it and testing for it. 0 Earth curvature detected. If you think that there's so much refraction in every single observation, it just makes the Earth appear completely flat, then cool. That's a crazy claim.
Well, to me, what's crazy is you're ruling out the 24-hour Antarctic sun. You're ruling out navigating around Antarctica. You're ruling out like the race that happens every year. You're ruling out
Yeah, they don't go around
travel in the
Race.
southern
Antarctica.
hemisphere.
A race, dude. Really?
You're ruling out
No one said
the spin of the
Antarctica is
stars.
or is not a continent. Okay, so no, we didn't say anything about Antarctica. Okay, it's a big mystery, right? No one's done some circumnavigation around it. They could see Antarctica or something like that, and they just sailed around it. No one's ever done that. There's huge
There's
inconsistencies,
a
and there's
sail around
people
it
that
every year.
went. There's people that went that participated in that race that say this doesn't work on a globe. Okay, the speeds don't match up. It actually debunks the globe. We can share you videos about that if you want to look into it. Okay, but they don't just go around Antarctica, right? But Antarctica, who knows? There could be a continent there. Okay, we're not claiming a freaking ice wall map here. I know some Earthers claim the AE map, that's the flat Earth map. No, that's a silly argument. We're not claiming that.
Yeah, but if it's like let's say it's flat and it's a continent, and then there's the 24-hour sun that you got to explain.
Why do we have to explain the sun? When they went there, McToon took angle measurements to the sun, and you can only take angles to the sun from a flat surface. So, did he prove that Antarctica is flat because he can measure angles to the sun? Or does the sun now become meaningless to you guys?
I think it could take angles to a circle.
Dude, you cannot stand on a basketball, blow it up to the size of your house, stand on it, and get an angle to anything from the ball. Can't go over a couple degrees and then now we're going to get an angle to something. Where are you going to set your tripod up at?
Yeah, like let's say you put a pin in the basketball to blow it up. That pin is going to be an inch over the basketball. And you could put a ruler from the top of that to where it touches the basketball, and then you would take that angle.
No,
right?
that's not
Like
how
you
you do it.
can take an angle.
No, you cannot take an angle from
Yeah,
the
you can.
surface of a ball. No, you can't. So you're going to tell me I can put a basketball on a table and you can tell me what the angle is that it's making.
Yeah, you take a ruler, you take a 1-inch pin, and you put that ruler on the pin, and you start lowering it until it touches the basketball.
And then that becomes what? A tangent point?
Yeah.
Okay, so a point doesn't have an angle. I win.
I don't think you understand.
Thanks for. Oh,
You
I
can't just say
understand.
you
Thanks for
win.
playing. Yeah, read my name. Thanks
You
for
can't say
playing.
you understand when you can't say you win when you don't understand. You agree you can do that, right?
Make a tangent point? Yes. Points are not angles.
Yeah, and then you could take, and then you can even
Can't
take
make
the
you cannot
angle
make an angle from a point. A point and a line,
Well, hold
a
on.
point and then a line, a ray straight out from a point is not an angle. That's called a line.
Okay, but
A ray.
you agree that once you have that ruler set, you can take that ruler and you can extend a 90-degree angle completely outwards from the pin, right?
No, there's no 90 degrees on the
You can't
surface
do
of a
that.
ball.
So if you have a ruler from the top of the pin to the basketball, lying down on the basketball, and then you have a 90-degree angle above the ruler. You just can't do that?
You can't have 90 degrees to the surface of a ball.
I didn't say 90 degrees to the surface of the ball. I said 90 degrees from the ruler.
And what's your reference
Which is
point?
resting on the ball and the pin. The reference point is the top of the pin.
Which is connected to what?
The ball.
Oh, so no, you can't do that.
Well, you quite literally can do this right now with a basketball today, or even just put a bobby pin into an apple and you can do it.
Go ahead. Take a picture of it for us.
I mean, I don't have an apple right now, but
If I stick a pin in an apple,
you
I can
agree
get an
that
angle. I can get an angle to the pin, to the top of the pin, to the surface of the apple.
no, but you understand you can take a ruler, rest it on the pin and the basketball, and then you can then that's a straight line, and you can take any angle from that line, right?
You don't hit. What is the pin? What's the angle where the pin
Right?
meets the basketball?
Why aren't you answering?
Because you can't answer my question yet. You're trying to turn it
I
on
just
me,
asked.
and you haven't answered
I
my
just asked you
question
a
from the
question.
beginning.
Well, I mean, this is my experiment. I don't.
You don't have. It's
Okay,
not an
so how's your
experiment.
question?
There's no
Is your
experiments.
question a
All
clarificatory
right,
question?
I have to go
Well,
to
your
my
question
computer. I think you might be
is
retarded.
gonna
We have
tear
to take
the.
a test. We
You're
have
gonna
to
open
take
up
a
the
test.
folder
I
and
think
dump.
there might be something wrong with you. Hold on.
You're gonna dump 20 images from his folder, but if your
Oh,
question is
what images am
clarificatory,
I going to
and
dump
me
from my
answering it helps.
folder? Child, what images am I going to dump from my folder?
This is the same thing you did last time, right?
What was it? Since you
Where you
forgot.
post like the 2 circles or something like that, and you
Circles.
post
That's what we're
a
talking about.
curve, and you're like,
Circles.
you can't take a line from an observer above a circle to the circle, which obviously you can.
So
And you
here's
can't
what
take
you're
and then you can
you're
take an angle
claiming.
from that,
Yeah. Okay. So
and then you take the angle from that, which is perfectly fine. Like, I don't understand. This is geometry.
here's what you're saying you can do, right? Can't answer that.
Can you do that? I mean, yeah, like you can.
So those are all angles.
There's an angle from. Oh, and there's the curve. So, but you're the one on the right, which I knew you were going to dump these images, right? Like I knew you were going here, but like the problem with the one on the right is I'm saying you're not taking the curved one on the right. I'm saying because you're straw manning. If you took an area above the circle straight down where it's resting on the basketball, that's straight, right?
I did. In the picture that's right after it, I took straight down. Well, point straight up. We'll flip that green arrow over on the right. Point that straight down at the ball.
No,
And
this is
then
the same straw
you're
man.
telling me that that's a right angle there. See what's wrong with you guys?
No,
Do you even know what a triangle
it's the
is in the
same straw
first place?
man
How is that a straw man?
because in this, like the blue circle one,
Uh-huh.
would be X would be raised up, and it would be a straight yellow line to where it touches the ball.
So straight lines
Right?
on a ball, on the surface of a ball, they're straight lines now.
Yeah, and like when you're navigating, they have to estimate that, but in
They
theory, it's a
estimate
straight
straight
line
lines on the surface of a ball. When did they start doing that?
because,
When did they
like I
start
said,
doing
like
it? Is what I'm asking.
the last hour
Not
we've been talking
why.
when they're navigating. like
So I
maritime
know, but
navigation.
when did they finally learn that they're actually on a ball and they have to make straight lines on a ball?
I don't know. I'm assuming this was like thousands of years ago. I don't know the history.
Thousands of years ago, they knew they lived on a ball, and that's when they started to
I know.
do that.
Yeah, I know. In order to navigate, they had to do this to get accurate measurements, and they had to get more accurate with.
In order to navigate, they had to imagine that the Earth was stationary and that the stars were the ones that were rotating as well. What an imagination. Why would that be the case?
But Triangle, this is silly. Like the same straw man over and over, like, has to get old.
What's the straw?
Just steel man.
What part is the straw man?
Just steel man it, because then you have stronger pushbacks. Because you can
What
say,
is the straw
well,
man here?
It's the same. Both images you posted.
Okay, so you can't tell me what it is. You just want to call it things, but you can't point it out.
Yeah, it's the
Got
curved. It's the curved line, X with the yellow curved line, and then above it, it's the one on the right. Not
What
an
is
angle of
wrong with that?
elevation.
Because it's not
they're
centered on the
technically
ball.
true.
Is it
It's just
because it's not centered
they're
on the ball? Is it because it's not centered on the ball?
No, it's that it's not raised for observer height. You're not factoring that in, and that's wrong. Now, what you're
Raised for
if you were to
observer
apply
height.
it incorrectly, then yeah, like what you're saying is true. It's just nobody's saying this, right? Like
So you don't know
they're
what
saying you
celestial
factor in observer
navigation
height.
is? So you don't know this one. I keep showing these, but you ignore these, like that one. Which one looks correct?
No, like
Which
they
one? Name the
factor in
one with
observer
the
height.
title underneath it. Curved adjacent or baseline looks correct. Just tell me which one looks correct. Just got to Google it. Well, these are some complex questions, aren't they?
Great.
I mean, neither of these are correct. That's the problem with what you're sharing. Is none of it is drawn right. It's just like in theory, there's a line on a ball. Like if you can rest a ruler on a basketball on a 1-inch pin, right? It's going to rest somewhere. And that's just the line that they're trying to estimate. Now you could push back and say, how do they estimate it right? And you can do all that. That's fine. And actually, that's way stronger of a ballpark for you to be in, but not when you just try to shoehorn the Glober into something that's like both choices are not what they're saying.
So, what are you talking about? Because you, over and over, just talk nonsense without no evidence whatsoever. Because no navigator, right, navigates on the bowl, right? The Portuguese, in my case, right, they never navigate the oceans by trying to find out where is the curvature of the earth. They look at to the skies, right? So again, you are making up stories without no evidence whatsoever.
You're right, and like I haven't claims to have a long distance measurement with all the refractive coefficients calculated and all of that. So you're right. Just for me, it just seems like all of the predictions of 24-hour sun in the South Pole and like the rotation of the stars and navigating in the southern hemisphere.
You can't
All of
tell
that
me
maps
what
onto
the
a ball
sun in
perfectly.
Antarctica has to do with anything. I've been posting and
It's just all of
posting
that
and
maps
posting. That's
onto a
the
ball.
whole reason why I got up. Is because you're making angles to the sun, and that requires a flat surface, not a ball. And you finally agree with me. You can't do it from the surface of a ball, or do you disagree with me that you still can do it from the surface of a ball? Because if that's the case, maybe we're going to have to go have lunch.
I mean, I destroyed your like
You
images,
didn't
every one
destroy
of them,
anything
right?
yet.
So you don't agree that they're strawmanning what anyone who is talking about
No, I'm
maritime
not straw
navigation?
manning anybody. I'm going by what it
Okay,
says in the
well,
books, but what it says. Angles.
you
So to
misunderstood what
get
it says in the
angles, you
books,
can't do
clearly.
it from the surface of a ball, can you? Can you take an angle from the surface of a ball?
But when you say surface, are you saying accounting
Yeah,
for
what you're
observer height?
floating on when you're in a boat, like this picture again that made you giggle. Can you take an angle from the surface of a ball, Mr. Giggles?
Yeah, from observer height.
Okay, so you're mentally retarded. Thanks for playing triangle game.
I mean, is it clear to everyone else at least that Professor Triangle just doesn't know what he's talking? He's misunderstood the textbooks.
No, he hasn't. That's why he's Professor Triangle.
I hope he's not a real professor, because that wouldn't be good for anyone.
Be great. We'd actually learn something in reality.
I mean, does anyone else in the room here understand how he was strawmanning?
You haven't managed to explain the straw man for any of us to understand, so maybe you could start there, like you were asked earlier.
Okay, I mean, like if there's really no one else who understood here, then I can go on. Is
So you
there, or
can't
literally
explain the
no
straw
one?
man? You're just going to throw more claims
No, I
out there?
can.
You're not
I'm
gonna let us...
just checking
Well,
first.
then do it.
I'll explain.
We're waiting.
Sure. So if you scroll up to he's posted a lot of these. I knew he was going to dump the whole folder, by the way, but the Glober's right angle, or if you scroll up further, there's
guys.
and there's like the first ones he posted here.
He wants
So
me to dump the whole folder, doesn't he?
I
well,
want to
there's
go and see,
like
guys.
there's the blue circle, there's the X with the curved yellow line, that one, right? X, and then not factoring in observer height, like things like that are the strum. Like when you're doing this navigation, you just factor in observer height. He refuses to do that. That's the
He's
straw
just
man.
showing you that in reality we're not measuring over a curve that's no longer a triangle. And when we take into an observer height when we're doing celestial navigation, we make a eye height adjustment down to sea level to take that measurement. So I'm not sure what else you're doing
That's
with your
fine,
eye
but
height. The eye height is
that's fine, but
adjusted to sea level to form a what? A plane triangle on the surface.
that's fine.
Not a triangle with a curved adjacent.
You're saying observer height, which is good. Like Professor Triangle just refuses to say that word at all. He's afraid of the phrase. So I mean, that's good on your
At the
part.
end of the day, the
But
observer
I
height
think you have a
is just
different
an
understanding than
adjustment.
Professor Triangle. Like
It's just an adjustment to sea level, which forms this right triangle. So if we're adjusting to sea level, how are you measuring the curved adjacent?
I mean, as long as you understand, there's an observer height. There's as far as you can see, and you just try to estimate that as a line, as a straight line, as best as you can. That's what they try to do.
No, you don't. You take an observer height, you subtract that to give you a sea level reading. Yeah, we're not making a line from the observer.
No,
Yes,
no,
yes.
no,
Would you like me
because
to prove you wrong?
you're factoring
Hold
it
on a
in.
second.
You're not subtracting it. You're
No,
not
you're
factoring it out.
subtracting.
I don't know why you would factor it out. You have to factor it in.
Are you gonna be
Wait
the
a
first
minute.
one? I'm sorry. Go ahead.
No, you're right. I'm going to just drop something for him here. Go ahead. You're right.
All right. Are you gonna be the first one who's gonna show us the curvature of the Earth? By the way, I'm just kind of curious because so far today. Go ahead. Go ahead.
Yeah, not in the way that you guys want. No, because I don't have any of these long distance observations with refraction coefficients and things like that. Like I don't have any of that.
So you don't have none of that. you don't have no pictures.
No, because that's all you
You
guys
don't have.
want, and I don't have.
No. It's not
You
that
only accept
what I
that.
want. It's not that I want that. It's just like, how can you prove something when you don't have nothing to back it up? You know.
Well, there's plenty of other observations that perfectly map onto a globe. But I personally, that's fine for me. I accept it, and you guys don't. And I know that your bar is higher.
All right. Well,
I just don't. I just
at
don't see how
36
those
minutes
would map
past the
onto.
hour,
You,
height of
can you
eye
show
correction
the?
from Astrolab sailing. If you are taking a sextant readings from the bridge of a ship, then you're going to get a different sextant reading if you're on a small yacht. Therefore, we need to make a correction to what your sextant says to get your reading converted to a sea level reading. Yeah, this is called dipper adjustment for height of eye. So when we take our height in celestial navigation, we then adjust that height of eye down to sea level to obtain the reading, just like I stated.
Oh, so everything I was posting is correct. Oh, awesome.
Yeah, it was Professor Triangle, yes.
Well, I can wipe the sweat off my forehead now because I thought he had me there for a second.
Where are you reading this from?
From Astrolab sailing at 36 minutes past the hour. Height of eye correction. D or dip. Sextant angle corrections.
What's up, guys?
Hey, Timbo. How you going, bro?
Good, man. I've been on holidays.
Your luck.
Come again?
That's awesome.
Yeah, I've been in South America.
Yeah, nice.
There's a small problem here.
Is the Earth flat there too in South America?
Sure is, man. Even with eye height.
Wow.
Yeah, there is a problem here. They're saying they're just comparing a big ship to like a
Well,
small
you can
ship.
go and argue that with Astrolab sailing in regards to eye height correction to the surface, yeah? That's the citation I provided. I would
But
believe
you
Astrolab
understand
sailing over
that-
you every day of the week.
But you understand that a small ship still has an observer height as well, right?
Yes, and then they
So they're
adjust
saying-
it to sea level to take a sea level reading to create a right angle triangle.
But even
they're
if
specifically
even
talking
if
about.
sorry, dude,
Oh no, they don't.
Even if you do have an eye height, what's that got to do with a curved surface?
Oh, it's just talking about sextant readings, not a curve. But
Okay,
again,
so you're
all of this would
correcting
be
the
wrong,
eye.
and
So
you
you're
would never.
correcting your eye to back to sea level. So got nothing to do with a curved surface, right?
Okay, I'm sensing the
Yeah.
the spiraling back into the script. We just went like I've been here for an hour. Okay, so
I know,
No one's
I know,
spiraling,
but
dude, except for you.
You're arguing.
All you do is
you're arguing.
ignore.
Yeah. You're
You ignore
arguing
what
a
everyone
point
says.
that
You talk shit.
it's
Sorry,
irrelevant.
Tim.
No, you're right. I'm just saying he's arguing a point that's irrelevant. Then, if his eye
Okay,
height's
well, he
got
doesn't
nothing
want
to
to
do
talk
with the
about.
curve, if your eye height's got nothing to do with a curved surface, then your argument's irrelevant. Yeah.
We were
Don't you
just
think?
talking about how these measurements are done by globers. So yeah,
Globers?
like
What's
if
a
we change the
glober?
topic, then if we
Not
change
done
the
by
topic, then
Globers,
the
done
current
by
topics would be irrelevant.
everybody. Hang on, not done by Globers, done by anybody who has done celestial navigation in history. Yeah, where they take a plane triangle to take their angle measurement with their eye corrected to sea level. Yeah. And like I stated earlier, they assume they're on a stationary Earth with the stars rotating, or celestial navigation doesn't work. Now, why would you assume that? Most likely because that's what's occurring in reality, and it doesn't work if you don't do that, yeah? Because that's not reality.
No, they're just taking a snapshot.
No, that's what they're
measurements.
doing. No, that's what they're doing. They're
No,
imagining a
I think
stationary
you
Earth.
misunderstand.
If we're on a fucking spinning ball, why do we need to imagine a stationary Earth to navigate on it?
Well, they don't do that because they're taking.
Well, they do that. Yeah,
measurement.
they assume it is stationary and the stars are rotating above.
No.
Or celestial
Oh, they're assuming
navigation
Polaris is stationary.
does not work.
They're assuming Polaris is stationary.
No,
right?
We're not going to assume that it is
Oh, they're
Polaris
not?
that's stationary. No, they're assuming that the Earth is stationary.
And Polaris moves, by the way. It's not stationary.
Yeah, no,
it has a little
I meant
oscillation that it
relative.
makes in the sky, and you can actually tell what season it is by what quadrant Polaris is in. So there you go. Yes, they do assume flat, stationary, non-rotating Earth to do celestial navigation. Yes, they do a dip correction down to sea level. You're just wrong, and you're digging a big hole for yourself, buddy.
Yeah, and it's all right to be wrong as well. Like if you've learnt something today in this conversation that you've had for the last hour, like you can just say, I didn't know that. Like there's no shame in not knowing something, right? It's not like
Okay, the
everyone's
whole-
going to go, oh, you're a
whole gallows
retard
to get their
because you
dick
didn't know
in.
this, you know? Like
Here's the next. Hey, everyone got their digs in. Can we move on?
No, I was actually just saying to you, it's okay to be wrong, and it's okay to say I don't know, right? You don't
Do
have
you
to
underst-
dig your heels in.
Do you understand what the celestial
Well,
sphere
like
is?
all of this stuff just ties back to what's meant by the not the geometric horizon, but the optical horizon.
Optical horizon? They're all
There is
optical
only one
horizon.
horizon. It is optical. There is no geometric horizon that you've now shown yet. Remember, you couldn't show it because refraction. Yeah, so it's not there.
Have you been here for the last hour? Because
I've been here for
when
the
I came in, I
last
was
two,
making
sitting
a-
here working and just listening in.
Okay.
Yeah. So yes, I
What
have.
did you think about what I was saying earlier about when I was talking to DJ about how when you take these long distance observation measurements or just the images and you say, okay, well, why do we see too far? That
We don't see too far.
It might be.
We don't see too far.
We see.
It might be.
We see what we see. Yeah, which is beyond the geometric limitations of the globe. That's not seeing
Correct.
too
Yeah.
far.
I mean, you know, that's what I meant. Yeah. That's what I meant. But
because you've never seen the horizon. Maybe you've never seen the horizon in the place where it's supposed to be, right?
So,
correct.
But you know what I'm saying is,
yeah. You want to know what I thought of your discussion about? Hang on. You want to know what I thought of your discussion about terrestrial refraction with DJ?
Yeah.
Okay.
Do you think like it's preemptive or not? Yeah.
I believe that you are completely incorrect because, one, the definition of refraction is Snell's law. This is not what we're seeing in the atmosphere. Yeah, it does not meet the definition of refraction. Secondly, you're talking about terrestrial refraction, where there is some very specific things that need to occur. So, one, you need to have the radius value for the path of light to curve around. You haven't shown us that. Two, you require sphere-shaped air, which air does not take that shape. Air has no shape, inherent shape, and takes the shape of its container. Three, you have no boundary in the stratified atmosphere. Yeah. Want me to keep going? I can keep going. So I completely disagree with you, and I can cite everything that I've just stated.
Well, thank you for your opinion. I mean,
Not my opinion.
Worldwide disagree.
That's just a fact.
Along with me.
Well, put it this way: if you disagree with what he just said, then can you show the horizon in the position where it's supposed to be and confirm that it is in that position?
Well, you've heard me say I don't have these. Like, I'm not aware of any glober who's done that and factored it in, like all the refraction and stuff. But I'm
So how
saying
do you
if
know
they
the horizon?
if they
How do you know
did,
the horizon is where it's supposed to be then for you to have a geometric horizon?
I don't, right? But I'm saying
You
that
don't, right?
to Globers, if the Globers wanted to railroad you guys, or if you guys wanted to railroad the Globers, then you would just bring the coefficients and measurements and then say, look,
No,
here's
the
our
You don't need
coefficient
it.
observation.
again requires
Your
curvature.
expectation
We've
is
already
wrong.
discussed that, dude.
No, it doesn't. No,
The
because you
coefficient
could still
does
have
require
reflection on a flat
curvature. Yes,
surface.
it does. Stop talking shit and just stating no, it doesn't, when I've shown you that it does.
You don't think refraction occurs on a flat plane?
Yes. Oh well,
Oh
whatever.
my
It
God, are
can.
you listening to anything?
Whatever. Doesn't matter because you don't have a geometric horizon, so it doesn't matter. You don't know it's in the place it's in, right? So I think your question's irrelevant again.
I think that's preemptive.
It's not preemptive. Show me that. Well, show me how you know that the horizon is in the position it's supposed to be in, geometric horizon. Otherwise, you've got nothing.
No, I like in this domain, in this specific question, I do have nothing. I
Yeah, I
haven't
know.
pretended to have anything.
Yeah. So why are you
But
going on about measurements of coefficient and stuff like that when you don't have anything?
because I was trying to tell you, if you want to wreck Globers, then this is the formula. And
We
then
don't.
if Globers
No,
want to
it's
We
wreck
not.
don't
you, and
need. We
I'm
don't
equally
need to
telling
wreck.
them like,
We don't need to wreck globers with a formula because they're the ones that have the formula, right? No, they
well, you
wreck
guys,
themselves
you
when they
guys
bring.
agree.
Hang on, 1 sec. When they bring out the formula, they destroy themselves
Why?
because they don't have a measurement to start with.
It
Well,
requires
okay, well
a
then
curvature
I agree.
measurement.
I agree with that. If they don't have
Exactly.
a measurement and they're saying,
So we.
"Oh,
So we don't
we're gonna
need.
dial it up as far as we can," and
Yeah.
they're just
So we don't
making it up,
need.
I
We
agree.
don't need. We don't need the formula because there's
No,
no.
you do though.
No, we don't. You need the formula. We don't.
You just need some measurements, plug them in the formula, and then you can
Okay. So what
when
measurement?
Globers say
What measurement are you going to put in the formula?
you're gonna take the pressure, the humidity, and the density, and you're going
And
to
the curvature, yeah?
And curvature, right? That'd be
The
the
no,
R
main
you
part.
value
actually
is
don't
the
need.
first part.
You actually, well, you could say, look, yeah, we are applying this to the drop in distance over,
What drop in
right?
distance?
Or the drop in observation over distance. You could, yeah, you
Which
could plug
one?
it into the
Where?
curve formula,
Where's that? Where's the drop over
and then
distance?
you could say, hey, Globers, you know this ball that you keep talking about, and you keep saying, oh, you got to factor in refraction. Well, we did that, and checkmate, because
There is
Okay,
no
so
you're still
refraction, dude.
wrong.
How many times do you have to be told? Please demonstrate for me what's required for terrestrial refraction. Because it's just a mental construct, nothing further.
Oh, he's denying
yes,
refraction,
it's
which I mean,
no, it's
No,
just
I'm not denying
no.
refraction. I've already been through this with you. Refraction equals Snell's law. You have no isotropic boundary between two media in the stratified atmosphere. It's not Snell's law.
And you're just using refraction as an excuse why you can see further than you should on a ball. That's the only reason, right? So you've got this fixed measurement of a ball, and you say I should only be able to see 3 miles, right? But you can see 6 miles, so you just counter in refraction because you believe you live on a ball. But that hasn't been proven because you don't have a measurement of it. So your refraction is just something, an excuse why you see further than you should on a globe, right? Do you
well,
agree with that? Would you agree with that?
sorry, could you repeat?
You
Can
can't.
you repeat that?
Okay, you guys use refraction as an excuse why you can see further than the obstruction, right? There should be an obstruction at a certain distance if the Earth is a globe of a certain size, right? You agree so far?
I mean, when you say excuse, I
Hang
mean,
on,
it's
one
kind of
sec.
harsh, but
Forget
let's
about the
go with it.
excuse
Yeah,
part. Forget about the excuse part.
sure,
Right.
sure.
So
Yeah, I
you
agree.
should only be able to see a certain distance based on the size of the ball, right? We agree with that.
Yeah.
Yep. So when you see further than you should, based on the size of the ball, then you say the light is bending around the ball because the ball is this size. You agree so far?
Yeah.
Yeah. Right. So whatever distance you see, say it's 10 miles, then you can put that in the equation based on the size of the globe. You agree with that?
Well, that would be. I mean, I think that's wrong. You can do that. I don't think that's. I think that's kind of baking it in.
Well, yeah. What do you think's in the what do you think's in the equation of refraction? What's the R?
An R value.
Well, because you could calculate for R given like a distance and given an observation, right? But
Yeah, but R. What is R?
what you actually should do, what you should do is already have R and then solve for distance.
Yeah, that's right. Yeah. So what's R? What is R?
Well, that's what my whole point is. Like, that's why it's the
What's
essence of what I'm
R?
saying is the refraction coefficient, but which you need
R is
to
the
go and take the
radius.
measurements to get.
R's the radius that you require
No, I
for
meant
the refraction
the
coefficient to
refraction coefficient.
calculate it to begin with.
Right, and the radius. Yeah, I mean, we're going with the Glober's radius because if you want to prove it wrong or say that this is unexpected, just use what they believe.
Yeah. So where'd they get that from?
Well, do you want to have a debate about that?
No, I don't want to debate. I want to see if you know where they got it from. Why is everything a debate? Why can't we just have a conversation about it? Do you know where it comes from? Do you know how they got the radius?
Yeah.
Yeah. Was there any assumptions baked into the equation that they used to get the radius?
Well, if I mention like Aristocrates, I think his name was.
Yeah, close enough. Yeah.
If I mention his stuff, usually what's said is, well, he was assuming there's a radius to begin with, right? So he's begging the question.
Okay,
so we can use him.
That's the first one, right? So that's the first assumption. So he assumed the Earth was a globe to start with, right? What's the second assumption?
His assumption,
there's a distance to the sun, right? So in his equation, it's an infinite distance. So that would mean light rays travel straight lines. That's the third assumption,
parallel.
right? Light rays.
Yeah, parallel.
Travel parallel.
Well, I don't think he was saying infinite, but he was saying like it's so far away that
his words were infinite.
It's virtually parallel. Like it's such a small
parallel
number
line.
of difference that it. Yeah.
Yeah. Any more assumptions? So you're starting with 3 assumptions already. How do you measure rays in straight lines? Yeah. How does he know the Earth's a globe?
Yeah, but given 93 million,
baked into the equation's pi as well. Right. So when you add pi into the equation, you're going to get a curve because you're going to get an arc length of a sphere of a circle. So it's already baked into it that he's going to come out with an arc length no matter what, right?
Mm-hmm.
Yeah.
I'm
even
fine
if
with
the
you guys
surface
saying,
is
okay,
flat,
he assumed.
even if the surface is flat,
Yeah, like.
And you put an arc, and you put
I don't think
put pi in the equation, you're going to end up with an arc, even on a flat surface, right?
No, I think that's true. Like it's technically true that Eratosthenes was begging the question with respect to those.
Okay, so
he took those as a given.
Okay, so all the numbers that we have that are based on the size of the Earth comes from a flawed equation with already baked in 4 assumptions before I even started the equation. It's pretty flawed, isn't it?
Yeah, but that gives you a huge advantage because it gives you
Who?
something as a flat earther. Like it gives you
Why?
It
something
doesn't give us
to.
any advantage. You just shouldn't be bringing it up as a glober if it doesn't
No,
support what you're trying to state. Yeah, because it doesn't. It's baked in assumptions, beginning with the Earth is already a globe. Yeah, it didn't measure any curvature. It wasn't to measure the curvature of the Earth. It was if the Earth is able, what might the radius be based off a calculation? That was assuming an infinite sun, assuming parallel rays, and that's assuming if this person ever existed, because there is no primary source documentation to support this claim. It came out in the 80s.
Yeah, good point.
Well, I'm saying you guys, something you guys probably already get, right? Like if they're saying, okay, the radius is this, and then for you guys, like if they were saying, well, the Earth has a radius, but we just don't know what it is. Then if you guys did like the black swan stuff or the long distance observations, they could just keep increasing the radius and saying, oh, well, no, we're just going to change the radius to be bigger now. We're going to slide the
they
dial
can't
Well,
do
and
up.
then
that because
everything's wrong after that. The distance to the moon, the size
Exactly,
of the
right?
sun,
So,
everything's different then.
which is why, yeah, exactly. Which is why I'm saying it gives you like kind of an advantage because it gives you something firm to argue against.
Then
And
gravity's then you got to throw your own version of gravity out as well because the size of
exactly,
everything has to change to
exactly.
sort
So,
out 9.8 meters per second, right? So
yeah.
just
So,
if you change all that, if you change the size of the Earth, you're fucked. You got nothing.
exactly. So, which gives you, like I'm saying, that gives you a leg up because then you can say, okay, well, here's some observation,
It's not
and
about
I'm
us
plugging
getting a
in all of.
leg up. We're just pointing out that you don't have anything.
Well, no, it says they have a position that you can argue against. It's not nebulous.
No,
right?
there's no position to argue against.
There's a radius. They have a position on that.
It's a flawed equation. The radius comes from a baked-in equation with pi in it. It's already a sphere.
Yeah. Yeah. And for example, like the whole quote unquote you see too far stuff or the black swan stuff, like that's you, and you guys already get that. You're arguing against that. You're saying, well, I used your stupid formula and that, like,
It'll work.
I should be able to see way further, or I shouldn't be able to see this far at all, right?